Hey folks, welcome to my stream. Today we will be going through some of the keynotes on Computex flow that happened. First, let's begin with the ARM keynote. And let's go.
There's a specific kind of silence, right before the world changes. It's that split second of realization, the moment when you know that life as you've lived it is about to become something entirely new. For more than 35 years, we've learned to recognize that moment. From Cambridge to the US, to Taiwan, to the world. We partnered with our ecosystem, solving problems together. We've been here from the start of AI, preparing the world for what's next. Powering intelligence everywhere, in how we live, work, play, and move. Together, this is our moment. Because when you know you have the power to change everything, you step forward.
让我们欢迎 ARM 执行长 Renee Haas. Please welcome ARM's Chief Executive Officer Renee Haas.
Ni hao, welcome. I apologize for the delay, but we will get moving as quickly as possible. We'll love a lot of things to share with you this afternoon. June means Computex, and June means a muggy evening and afternoon in Taipei, but it is wonderful to be back here. I think my first Computex was 2004, 2005-ish, so it's 20 plus years, plus or minus when COVID hit. ARM started in 1990, and it was not long after 1990 that Taiwan and ARM started a relationship. Taiwan has built ARM. We are nowhere without the ecosystem and partners that exist inside Taiwan. Now, going back in time, we think probably around 1993-ish, a few years after we started, the first ARM chip was designed here. Those were early days. SoCs were a kind of foreign thing. Design tools, physical design, EDA that could support SoC really didn't exist. So we were working with eTree back in the day, who did some initial work with us to test out our IP, our methodologies. Not long after that, the first ARM chip, manufactured in Taiwan. We believe it was TSMC. We were looking back, it may have been UMC. It was some early test chips. We didn't get into production really until later in the decade. But the first ARM chip was packaged and tested here. So really, not long after ARM started, we were linked to Taiwan. Some of the significant volumes, though, that really embody what ARM is all about, started in the 2000s. And this is before the iPod. If folks remember these little tiny MP3 players that had maybe 256 songs fit in your pocket from Creative, Diamond, Rio, companies like that, those were all ARM-based. And of course, then the iPod, which in many ways was the catapult for the ARM technology being everywhere, was here. And that was in a chip designed by Portal Player that went into the very first MP3 player that took volume was the iPod. But it was really in 2008 when we had the revolution that was grown relative to mobile. Here we go. The mobile revolution was really launched in Taiwan. Now, we were involved, obviously, with the early GSM phones, as folks know, from Nokia and LG, et cetera. But it was really the launch of the iPhone and then the Android phones that soon followed. And that revolution really launched the growth of ARM into a set of volumes we've not seen before. So it was really that period that was the most significant for us. And today, and I'll talk more about ARM server CPUs, 100% of those CPUs are built here. And when we look at aggregate, across everything that we've done in our history with all our partners, about 250 billion chips have been built in Taiwan, more than any other region on the planet. I cannot tell you the gratitude we have as a company for the ecosystem, the people, the talent, the partners here. ARM is nowhere without the partners of Taiwan. Now, some very cool products have come out of the Taiwan ecosystem. When we look at the Edge, products such as the Amazon Edge, Oppo Vivo phones, Apple MacBooks, a product I use constantly, I don't mean this as a promo, but these Meta Ray-Ban glasses, they are amazing. I use them for phone calls, videos, messages, all here in Taiwan. Physical AI, the humanoids, the most advanced in the world, whether it's Tesla, Figure, Techman, all the chips here built in the Taiwan ecosystem. And then, of course, cloud AI, whether it's the GPU racks, the racks by NVIDIA, Graviton, everything here, as I mentioned, 100% of our ecosystem is built in Taiwan. So without Taiwan, there really is no ARM. Thank you again. Now, what seems like a long time ago, and in the world that we're living in with AI, we're living at light year speed, we did an event called ARM Everywhere back on March 24th. And at that time, we were looking at what was going on relative to the growth of agents and agentic AI. And at the time, this is March 24th, not so long ago, showed a slide about the growth of OpenClaw relative to Linux and Kubernetes. GitHub stars on the left are exactly what you think they are. They are stars that rate the popularity or the stickiness of a certain application. OpenClaw reached levels almost beyond parabolic in terms of the takeoff. And this is back on March 24th. And what that told us was that the growth of these agentic platforms were driving demand for CPUs in a way we had not seen before. And the logic behind that is quite simple. GPUs, XPUs are amazing at generating tokens. That is their purpose. Whether it's training to generate the learning or inference to deliver the tokens, the token machine, the token factory is the accelerator. But agents, unlike humans, don't sleep. And agents beget agents that beget agents. And all of those tokens that need to be distributed, managed, orchestrated, delivered to the destination, that's only a workload that CPUs can do. CPUs, of course, in conjunction with a full system design. So we made a comment back on March 24th, and I think we were probably one of the very first to do this, that said we believe going forward that 4 times the number of CPU cores needed in the same power envelope going forward. Now, that multiplier, I ended up getting so many questions relative to show me the math and how do you figure that out, and not long after that, you started hearing numbers of 4x, 8x, 10x. It's a hard number to predict just based upon the growth rate of these agents. But what we do know is as follows. If we look at today what we're seeing in terms of agentic growth, even fast forwarding from the 24th of March, this is just exploding. We're seeing this with SaaS companies, whether it's Snowflake or Salesforce or ServiceNow, who are developing all the agents relative to running in the backplane. The explosion of Anthropic with Claude Code, Codex from OpenAI. All these agentic workloads are driving in more demand. And what that does in turn is drive a very significant growth, Clipper's doing here, in terms of where the CPUs go. So if you change the access on the Y side to units, and you look forward in terms of what the growth rate looks like, CPUs are even growing faster than we had thought. And we are seeing this across the board. It's not just ARM. Of course, I'll be promoting ARM a little bit more later, but we're seeing this from everyone who's in the CPU business. The demand for these CPUs continues to explode because the agents beget agents beget agents. Now, is the number 4 to 1? Is the number 6 to 1? Is the number 8 to 1? I don't know, but what I do know is that it's getting bigger. So the agents continue to accelerate relative to the growth, and with that, CPU growth is also raising. We threw out a number back on March 24th, around a CPU TAM in 5 years, going to north of $100, $120 billion. And again, at the time when we did that event, we had a lot of questions from media, investors, analysts saying, that number seems a little too aggressive, not sure how you got there. Fast forward, the numbers that people are talking about are almost twice that number, if not larger. What we do know is that AI agentic workloads, because the more tokens you generate, the more information that's being used, the more that they are agentic, drives demand for compute. And of course, we have an answer for that. The ARM AGI CPU. Now, this CPU, as I mentioned before, 100% built in Taiwan. I'm going to show you a video that we showed on March 24th. I'm going to show it to you again for those who didn't see it. I want to show it again because, frankly, I love it. It's a great video and says everything you want to know about the product, but also emphasizes the importance of the Taiwan ecosystem. I think I can watch that video every single day. I just get so motivated and enthused by what I see there. So the ARM AGI CPU, built in Taiwan. TSMC, our partner, we are now in production of this product. One of the things that we emphasized early on when we talked about potentially delivering solutions into the marketplace was that we didn't want to talk about the product until we had customers, the product was shipping. And equally as importantly, that we had partners who could help deliver the product to market. We understand that in this world, it's not just about delivering a chip, but it's delivering a full system with partners. And we've worked with some of the best on the planet, all here in Taiwan. I understand there are actually some that are outside there in the demo area. I think we may even have a full rack, I've heard, from Supermicro sitting out there. But whether it's ASRock or TSMC, our fab partner, Quanta, InCycle, Supermicro, ASpeed, all fantastic partners who enabled our ecosystem to deliver amazing solutions. Now, this product comes in two flavors from a system standpoint. And one of the things that we really emphasize with the ARM AGI CPU is maximum performance, density, and efficiency. Of course, our hallmark is around energy efficiency. We were born for mobile phones. We designed a custom CPU way back in the day that had to fit into a plastic package and run off batteries. And that is a mindset that sits inside our engineers in everything that we do, and it translates to amazing solutions and products. An air-cooled rack, 36 kilowatts, 8,000 cores, and a liquid-cooled rack that has over 45,000 cores, 200 kilowatts. So two different solutions. But what's key about this product line is the performance per rack, performance per watt. 2 times the performance per rack versus a comparable x86 system. Basically means same power envelope, 2 times the benefit in terms of performance. If you want half the power, you still have equivalent performance. So it's incredibly efficient, but more importantly, when you think about what goes into these giant data centers, and we're seeing announcements literally daily. In fact, the parent company of ARM, SoftBank, just announced a partnership in France for a 5 gigawatt data center. These data centers are incredibly capital intensive. The energy costs are huge. So having the benefit of performance per rack, more CPU in the same power envelope, has huge, huge benefits versus the competition. We estimate about 10 gigawatts of capacity, over $10 billion, up to $10 billion of savings. But as we go forward and we have more and more CPUs inside the systems, you'll get even more benefit relative to using the ARM AGI CPU. Now, we were super proud back in March to talk about our partners, people who embraced the solution, customers that we had signed up, Meta, Rebellions, SAP, Cerebras, OpenAI, SK Telecom. And that was just on March 24th, and we talked about our customer base and who had adopted the product. I'm proud to say that since that time, even more companies have joined the family. Oracle, huge partner with OCI. We have a long history with Oracle. They've now joined the ARM AGI CPU family, as well as ByteDance. 2 new partners, part of the family, validating that the ARM AGI CPU solves real-world problems. Now, we talked about this back in March, and I want to emphasize it again. We are now a full end-to-end solution provider. So while we do have production silicon of the ARM AGI CPU, not everyone wants to buy the ARM AGI CPU, and that's okay. We have compute subsystems, many partners who take that, and we have just standalone IP in this space. Whether it's Google, whether it's Amazon, whether it's NVIDIA, whether it's Microsoft, we have many, many customers who are on the left-hand side of that slide, and we intend to provide solutions to whatever the customers want to see. And that is very important because momentum is really increasing for us now with agentic AI and whether it's our own CPU or our partners. Very significant announcement took place last month where Google announced for their TPU 8T and AI that the head node, the CPU that interfaces into the accelerators, is going to move from x86 to Axion, which is their internal chip, using ARM Neoverse. 60% less power at the same performance. Andy Jassy had a great quote, I think one of the earnings calls, that basically said for Graviton, we had 2 customers say, can we buy everything that you have? Graviton now has more than half of their design starts are based on Graviton versus x86. From a few years ago, that was 0. And of course, NVIDIA, who announced Vera, amazing partners. Vera is an amazing product. The list of partners is far larger than here. I didn't have a slide big enough for all of them. But NVIDIA's had a tremendous momentum with Vera. Now, our intentions are very clear for the ARM AGI CPU. We intend to be in this for the long term. It's multi-generational. ARM AGI CPU 2 is already underway, and as you can imagine, has more cores, more power efficient, better performance. And ARM AGI CPU 3 is on the way. But these are all based on the compute subsystems that we intend to deliver along with the chips. And they'll be lined up roughly on the same cadence. So the CSSs that we deliver to our partners, those are what we use to enable our end devices. So that's ARM AGI CPU, which has had incredible momentum. Now, I want to switch gears a little bit because Computex to me, always, having come here 20 years ago for the very first one, was always about the old exhibition hall, floppy disk controllers, USB cables, all kinds of things in terms of IT malls. And you could go into these shops and buy almost anything under the sun. It was like a mini Fry's, 20 of them on a floor in a building that was 10 stories high. And that's how people bought PCs back in the day in terms of how they shop for them. And if you think about how these PCs were built and how we used to buy, it was very interesting. You'd have literally every single price point you could think about. Whether it was a base entry laptop, raise your hand if you remember the netbook. I knew the video guys remember that one. We had battle scars from that one. All the way up to high-end gaming machines. But literally, these units were priced at $50 price points. You had feeds and speeds, clock frequency, memory size, et cetera, and everybody was trying to position for the slice of the pie. So much has changed, obviously, not only in how we buy PCs, but more importantly, how we use these products, okay? How we use the products has really, really evolved with, obviously, what the smartphone has done, what the web has done, what applications have done, and what we see is that they've really started to bifurcate into kind of two areas, I would say. One is, and I think maybe you can identify this on the bottom left, is I need a machine that is on the go, battery life is really good, connects everywhere, and I need it to kind of look like a large phone with a keyboard where I can do work, but it maps very closely to what my phone does. If I think about myself personally, I have one of these flip phones, which I use for reading documents and reviewing presentations, and I'm a CEO, so I create very little these days. I review many things. But what I find is I go back and forth a lot between that smartphone that flips like a tablet into the PC, but it's really super important that the PC and phone are synchronized and I can do things back and forth very, very quickly. There's also an extreme performance workload, and that is I'm either running agents, I'm either running models, I'm doing some development work. I need some very, very extreme level of performance. So there's really 2 different components in 2 different areas in terms of how they all work. So only ARM really enables this for PCs. And I think that's a very, very key distinction in terms of the way we used to think about this category back in the day, where literally you had every single price point covered, every single feed and speed. Now you want two different ends of the spectrum. And whether it's long battery life, great AI experience, we're in that bottom category, but if you also want the agentic type of performance, we're there as well. Now, specifically, when we look at the units that are there, you can see that you've got the Acer device, Mac Neo, pretty interesting product, the Google Book, Microsoft Surface, Mac Studio, of course the NVIDIA RTX Spark, which was just announced, which I'll talk about. But these two broad categories are very unique to ARM. And I get lots of questions, over the years about Windows and ARM, and when is ARM going to really take place to be a significant player in laptops and compute space. I would argue that we are now actually there. Because when we look across the spectrum of the operating systems that are supported, whether it's Linux, whether it's Mac OS, which is 100% on ARM today, Chrome, Windows, only ARM can enable this across the board. And this would not be done without huge, huge cooperation from all of our partners who are listed there, the folks on the operating system side that we work so closely with. We've worked for decades with Apple. We've worked for decades with Google and Microsoft. This work does not happen overnight. There is a huge amount of effort to go off and make this happen. I want to give an applause and thanks to all of our partners to make this work. Now, I want to talk about a product that we knew was being worked on, and we are proud to be a partner with NVIDIA on the RTX Spark powered by ARM. 20 cores, ARM-based cores in a custom Grace CPU. I believe that is the most CPU cores that you can find in a laptop anywhere. But when you pair it with Blackwell, the world's most powerful GPU for agentic, you got an incredibly special product. 1 petaflop of FP4, huge amount of memory, full Windows, native on ARM. Amazing product. And of course, as you suspect, partners who are there already. Acer, Asus, Dell, Gigabyte, HP, Lenovo, Microsoft, MSI. I think I saw Surface Ultra that was announced. An amazing product. Congratulations again to the NVIDIA team for making all this happen. Now, our role here was working very closely with NVIDIA and with MediaTek using our CSS strategy. And again, for those who are not familiar with what our compute subsystems do, the CSS is basically building blocks that we use to put together everything to build a full end solution system. The CPUs, the GPUs, the system IP, the memory controllers, everything that goes into building a custom SoC. We provide these to our customers. We did this with MediaTek as either full solutions they can take or building blocks that they can start with. So we see a very significant opportunity, again, given the strategy we talked about with IP and compute subsystems around the ARM agentic CPU, very, very similar with what we're doing with the CPUs for the CSSs. And I think the PC space is going to be a very, very interesting domain, as I said, going forward, because with these use cases on the bottom left, again, the kind of use that I am relative to using the systems for creation and things of that nature, the high-end systems, when we start thinking about where agents can go, how agents interface with us, it's going to be a very, very different domain. And I think this product from NVIDIA has really demonstrated its capability. So I'm not sure the systems are available yet, but we actually got access to some of the hardware and technology, and we decided to give it for a spin. Complete Surgeon's general warning here. This following video was AI generated. So please don't have your legal teams contact us. But let's take a quick look. We're ready for you. Now, I know you're probably saying, I'm not sure it's AI because the dude always wears the same clothes, but on the other hand, those are events that I would not actually do myself. But I think it's just a small example of the kind of creation that can be done on these computers and where I think we're going to go with agentic AI. Now, I want to be able to talk more about the product, but I'm kind of thinking that there's probably someone better than me to join me on stage to talk about the RTX Spark and everything that NVIDIA does, so I'm going to introduce a special guest here. My clicker behaves.
That's a pretty cool video of Rene. Superstar. Action hero. Not just a superstar, he's an action hero.
I think the night market was the part I thought was the coolest.
Yep. Well, that's the most exciting part of your video.
Yeah, well, thank you for joining. I appreciate it. Yeah. So tell me, Jensen, congratulations on the RTX Spark. Amazing.
Thank you.
Windows on ARM is not a new thing.
Yeah.
Why is this one going to be different?
Look at his stock price. I announce a product. Look at his stock price. Every product I announce, his stock price goes up. Nothing happens to mine.
Let's also state for the record.
I'm very happy about that.
Let's also state for the record that you were a shareholder and you sold.
Yeah. Well, I needed the cash.
So
What were we talking about?
RTX Spark.
RTX Spark.
How is it going to be different this time?
Well, we wanted to reinvent the computer. You know, the PC has been here for 4 years, and the operating system, code written by hand, is now going to be replaced with applications that are agentic. Now, these agentic systems, agentic AIs, will use the PC, will use the tools in the PC. And so when we imagined this future, we thought, let's see, how would we change the architecture, and how would we change the operating system, and reinvent the computer, and you know, that's kind of where we are. And so one of the things that we realized is that an agentic system really wants to have excellent CPUs, which is the reason why we use ARM, and has a 20-core CPU, has to have excellent single-threaded performance. The parameters, the memory has to hold a lot of parameters, and so we created a new numerical format called NVFP4 so that we can compress the large language models as much as possible and fit a very smart AI into the system memory. We also wanted to unite CUDA, that is for accelerated computing, and CUDA tiles our tensor core processing into one processor. And the reason for that is because when you're operating these agents and they're thinking and they're using the tools, the agents are fast. And when the agents are fast, they expect the tools to respond quickly. And so that's why we're accelerating all of the tools. We're accelerating Adobe. Adobe announced they're going to re-architect Adobe Photoshop and Premiere so that it's CUDA accelerated and agentically accessible. And so we're accelerating applications. We accelerated Blender with RTX. We accelerated, we're going to accelerate everything. We accelerated Adobe, Autodesk, Dassault, Siemens. We're going to accelerate every tool. And once these tools are accelerated, then they can respond to the agents very quickly. And so now in order to build this computer, this SoC, unless you have the ability to integrate with the CPU and adapt the CPU to exactly the shape of the computer, it's really quite impossible, which is the reason why ARM is perfect.
Well, thank you. And then when you think about the agents running locally,
And the key word there is ARM is perfect.
the other key word is thank you. Agents running locally.
哪里要客气啦.
It's not verified at this point.
You're welcome.
Agents running locally versus agents running in the cloud. How do you think about that as a trade-off, and where do you think that goes over time?
Well, you know, when ultimately the computers, these personal computers, are going to be becoming agents that are running all the time. They're constantly running all the time. I can imagine today, if I left my laptop at home or I left my laptop in the hotel, I won't use it again until I get there. But in the future, you just pick up your phone and you chat with your agent. You're chatting with your PC in the future. And that maybe there's something that you needed to have done and sent to you. Maybe there's a speech I need to have quickly written. And so, you know, I'll be working with my agent, working with my assistant, and that is now the ARM personal computer.
So,
right?
so the PC is working in the back while you're not there. It's working.
Yeah. And so if I want to do something that requires a cloud API, of course, I'll call it into the cloud API. Yeah. But whatever I can do locally, we're going to continue to do in PC, which is kind of the nature of PC.
Sure, yeah.
The nature of a personal computing device is that whatever you can do on the device, you do. Yeah. You don't have to worry about metering. You don't have to worry about the time spent. But whatever you need to do in the cloud, you will.
And when you think about the complexities of the models, do you think PC performance and architecture can scale? I mean, you guys are doing incredible work with Blackwell and then Rubin, et cetera. How do you think that all maps together in terms of scaling the systems?
Well, you look at the RTX Spark PC, it's got 128 gigabytes memory. If it was completely compressed into NVFP4, then you can have a 100 billion parameter model working on your PC all the time. Wow. And a 100 billion parameter open model, say Nemotron 3 Super, say, that's a really, really good model. And so it could do a lot of the basic work, and whatever deep thinking and frontier model that you need to use, it's just connected to the cloud anyhow.
Do you think that changes what happens in the cloud in terms of this classic client cloud model? Like, do I need as much compute in the cloud versus in the client, or do you think there's just so much compute that needs to get done?
These agents are going to be, you have agents and sub-agents and teams of agents. They're going to be working in the cloud. They're going to be working on devices. And so it's just like today in a lot of ways. Yeah. Mobile cloud is not cloud only, not mobile only. It's mobile and cloud. And so it allows you to have a really great personal computing experience, you know, your own experience. But whatever you need to connect to the cloud, you will. And so
do you think, and this may be a bit of a provocative question, but as the agents are running in the background, they're doing a lot of the work, does the operating system matter? Is the agent really the OS, if you will, and it does the work and isn't so reliant on the hood? Where do you think that goes over time?
Well, the operating system is going to be just as important as ever before, if not more important. And the reason for that, and this is the controversial part, that people say AI comes along, software is dead. You know, nothing is further from the truth. And now people are starting to realize that. When agents are here, they're going to use tools. And so those tools are more important than ever. And so they're going to use Adobe Photoshop, they're going to use Adobe Premiere, they're going to use Canva, they're going to use Dassault tools, Siemens tools, they're going to use tools, whatever they have on the device. This is the incredible part. Today, most of us probably know 10, 15, 20% of the features of a tool. If you know how to use Photoshop, use Lightroom, unless you're an expert like my son, it's kind of hard for you to know all of the features. But now, with your agent, you tell the agent what you're looking for, and the agents know exactly how to use the tools because it's read a skills file. It's essentially read the manual of that tool. Yeah. And so now it goes and uses the MCP or the CLI connected to that tool, and it does everything you need to do.
It's going to unlock.
Yeah, so it's going to unlock all these tools. These tools are going to be more useful, more valuable than ever, and these tools run on the operating system. Yeah. So we're going to need Windows, we're going to need all these APIs and all these tools for a long time.
So NVIDIA's involved, understatement, in everything around AI. I mean, you guys do everything around the networking, the systems. You know where all the bottlenecks are. When you think about over the next number of years, where are the constraints to growth? Where do you think they are?
Well, it's probably going to be everywhere. This is at this point. If you look at our evolution, first Hopper was designed for training. Then Grace Blackwell was, of course, great at training, but we also specialized NVLink 72 for inference. And at first, people thought inference was easy, and we explained to people that MOEs, large language models, and to be able to inference very quickly and generate these tokens as efficiently as possible, you're going to need a very complicated computer. And so GB or Grace Blackwell NVLink 72 is the most efficient, and we produce the lowest cost tokens in the world. Okay, and so that was a big breakthrough, and now people understand that you want very advanced systems to generate tokens at very low cost. Vera Rubin took, of course, all of that, and we extended it to run agents. At first, when I said that 2 years ago, most people had a hard time understanding what that meant, but now they realize that an agent is orchestrating thinking, is using tools, it's accessing long-term memory, it's dealing with short-term memory, working memory, and it's compacting, doing memory compaction to remember, to think about what should I remember for the future, how do I index SQL memory, how do I index structured memory, how do I index unstructured memory, and so how do I deal with all of that? That agentic system is what Vera Rubin is, and it's a large system. And so people are now starting to understand that when we were thinking about agentic systems, we were really thinking about new computing application pattern, and that it really requires a new architecture. Well, now the big breakthrough, of course, these agents now are producing useful AI. And that's the reason why all of our growth, right? Your growth, my growth, is just so incredible, because when AI becomes useful, then the tokens that are being generated are profitable. And when token generation is profitable, everybody wants to generate 1 trillion times more token. The other part is that the agent, the application, this agent compute pattern is 1,000 times, maybe 100,000 times, and depending on the work, it's 1,000,000 times more than chatting. Yeah. And so you can see that the agents are working. They're working for minutes, hours, sometimes days, sometimes weeks. And so instead of a chatbot which responds from one click, now the AI is thinking, using tools, reading, thinking some more, planning, trying. And so the amount of tokens that we have to generate has increased tremendously. The profitability of the tokens obviously is driving demand. So the compound effect of need more compute with more demand, that compound effect is what you and I are experiencing. And so we're seeing constraints almost everywhere. In our case, we were fortunate that we planned. One of the best things about ARM is that they don't have to worry about the supply chain. The supply chain of IP is electrons, and you can use as many electrons as you need. Okay? And so I love his business model. I mean, as you know, I tried to. I tried to become ARM.
We were willing.
I was trying to become ARM. We were willing. Renee and I used to work together, and then we tried to work together again. But anyways, that was okay. I'm sad still. I'm a little sad. But this is a happy meeting. So my point is, in our case, we saw agents coming and we saw Vera Rubin coming, so we did a good job planning our supply chain. And so our supply chain can support our very robust growth. We grew almost 100% year over year this year. We're going to grow very aggressively next year. And so our supply chain can support our growth. But the fact of the matter is, demand is even higher than that.
Yeah, I was talking with Cece and Kevin this week, and they were saying, at some point gravity has to take over. They've never seen 4 consecutive years of a semiconductor cycle that looks this good. But when you look at the things that you just described, there's no reason it can't continue. In terms of
That's right. Take a step back. What's happening? Take a step back and think what's happening. What's happening is the computer industry was limited by the number of people using the computers. And now we have agents that are autonomously using computers. And so we're going to have, instead of 1 billion humans using computers, we will have tens of billions, maybe more than that, of agents and robots and self-driving cars using computers. And so the question is, how large can the computer industry be? And so, my sense is that at this point, it's a foregone conclusion that what is a $1 trillion, multi-trillion dollar industry is likely 10 times larger. And so we're on our way to.
And that's why NVIDIA is the largest market cap company in the world. And if you combine the two companies, we'd be the largest in the world.
Still, I love that. I love that. That's such a great idea. So, thank you.
Congratulations on RTX Spark. Just amazing.
Well, congratulations on everything you guys are doing.
I have a small gift for you.
Really?
Someone's going to give here. Yeah. So for those of you who don't recognize what this is, and I'm going to sign it. This is very, very real, by the way. This is the Jensen talks a lot about resiliency and sticking with things. Tegra 3 was the first Windows on ARM laptop that was announced.
How come when we were younger, I have to tell you, I think I aged better. Do you guys agree? I feel like I aged pretty well. Here.
You're my guest.
It's to me?
It's to you.
If I sign it back to you, it's a treasure.
No, you sign it back to me. There's a contract. There's invoices. We can't do that. We know that game.
All right, thank you very much. Thanks, guys. Bye, ARM. Bye, ARM. I tried.
One of those things was real up there. That actually was a real system that we worked on, and Fish and Kauster, those guys remember on that. I think I aged a little bit better than you did, by the way. So to wrap up, one agentic platform, cloud to edge. Showed these products before. It's the ARM AI compute platform that enables systems from the very, very smallest to the very, very largest. And we do this through a very consistent effort with software. 22 million developers, the largest developer community across the planet for any compute platform. But as I said, none of this happens without incredible cooperation and dedication from our partners. And again, I just want to say thank you to Taiwan. ARM is nowhere without Taiwan, the ecosystem, the people, the engineers, the supply chain managers. Thank you so much for everything you've done. Thank you for attending today.
So we got to know the details about the ARM and the history of the chips that they are building. It's just like it was kind of a marketing keynote in which they also defined what they are coming up with in the later part of the year and are collaborating with Taiwan for their whole industrial chips and ecosystem that is currently built by it by Taiwan. So yeah, that's what they defined here and detailed, and plus the partnership. So the ARM's stock price rose here just by NVIDIA's announcements because they are redefining what PCs will look like in the fall. So yeah, that's that. And I will get my hands on these NVIDIA and ARM chips. So keep an eye out as I will be streaming and we'll be talking about them more. Now let's get to the other keynote. There's this Qualcomm and Intel keynote that happened. Let's go to the Qualcomm one.
AI once lived behind screens. Now it steps into the real world. Intelligence is no longer confined to the cloud. The brain is everywhere. AI now has a body, sensing, acting, transforming the world it touches. And it's binding every intelligent device into one living network. It sees, it moves, it connects. This is where the next era begins. Global visionaries, 500 startups, 23 nations of innovation. Computex 2026. We make it happen together.
Ladies and gentlemen, let us welcome our host, Mr. James Huang, Chairman of Taiwan External Trade Development Council, TAITRA, to the stage.
For 5 centuries, Michelangelo's creation of Adam has shown God given life to man, the first intelligence on earth. In the 21st century, we have created a new intelligence. The hand is ours. The intelligence reaching back is AI, born from human hands. Good afternoon, ladies and gentlemen, and friends from the international media. Welcome to Taipei. Welcome to Computex 2026. Computex convenes in a time of 2 great waves. The first is geopolitics. The post-war order is unwinding. And until a new one takes shape, uncertainty will be the norm. The second is technology. AI is not just another tool. It is the beginning of a new kind of civilization. Language, memory, initiative, society being assembled inside the very machines that fill these halls. Computex witnessed the rise of the PC, internet, mobile, and cloud, each wave making machines more powerful and more central to human life. Now, AI has evolved from tools to actors. This is why it is more than a technology story. It is a human story. The world used to come to Computex to get updated on new tech. Today, the world comes to see where humanity goes next. Computex is no longer just a tech show. It is a conduit to the new world. That is the spirit of this year's theme, AI Together. The next era will not be defined by any one country, company, or AI model. It will be built together, AI and humans together, Taiwan and the world together. Step out of this hall, and you walk into the future being built. This year is truly exceptional. The largest Computex in our history, across AI and computing, robotics and mobility, and next-gen tech. The future is taking shape around us. In Nangang Exhibition Hall 1, Hall 2, the Taipei World Trade Center, and also at the Taipei International Convention Center, where NVIDIA will host GTC Taipei. Our CEO keynotes bring 4 global chip leaders to one stage. Qualcomm's Cristiano Amon, Marvell's Matt Murphy, Intel's Lip-Bu Tam, and NXP's Rafael Sotomayor. Together, they map the full landscape of AI computing, from edge devices to data center connectivity, to the silicon powering AI's next era, all the way to physical AI moving into the real world. These 4 CEOs are not flying here to make announcements. They are flying here because the conversations that matter for the next decade of AI happen in this city this week. And this year, for the first time, Computex dedicates an entire pavilion to robotics, the AI and robotic drone at the Taipei World Trade Center, where leaders from Intel, E Ink, Highwing, Solomon, and Texas Instruments, and many more are showing the world what physical AI looks like when it leaves the lab and walks into the world. Right inside the same building, on the morning of June the 2nd, 4 forum sections take the stage in a row, all on physical AI, with the senior executives running robotics at NVIDIA, Qualcomm, ABB, and NXP. 4 decision makers, 1 room, 1 morning. That density does not exist anywhere else in the world. Beyond robotics, our forum gathers 26 global leaders across 28 sections. Microsoft, Google DeepMind, Siemens, Synopsys, and many more, covering the full stack of AI, from chip design to data centers to industrial development. And at Innovex, nearly 500 startups from 23 countries are showing where AI goes next in robotics, healthcare, materials, and industrial intelligence. These are not demos anymore. They are deployments waiting for scale. All of this is happening here because Taiwan plays an indispensable role in this AI revolution. Computex has turned Taiwan into the AI hub of the world. Last year, I asked, when AI is everywhere, what will the world need? This year, the question deepens. When we have given life to a new intelligence, what kind of civilization do we want to build together? Pope Leo XIV put it well. The AI challenge is not technological, but anthropological. AI may be fast and precise, but without purpose. Humanity carries memory, morality, and meaning, but it may struggle with the bottlenecks of the old world. The future must be built by both machines, expanding what we can do, humanity deciding why it matters, intelligence anchored in trust, power placed in service of life. As you walk through these halls, look beyond chips and machines. Look at the beginning of a new relationship between humanity and intelligence. Look at the future we are being called to build together. Thank you, and once again, welcome to Computex 2026.
Thank you, James. Next, let us welcome our co-host, Mr. Jason Chen, Chairman of Taipei Computer Association, TCA, to the stage.
Hi everyone, distinguished guests, the members of international media, industry leaders, ladies and gentlemen, good afternoon. Welcome to Taipei. I'm Jason Chen, I'm the chairman of Taipei Computer Association. First, I would like to express my sincere gratitude to our media friends from around the world for long-standing coverage of Computex year after year. Your reporting enables the global technology industry to identify the next important direction emerging from the event. The theme of Computex this year is AI Together. This is far more than a slogan. It reflects a real transformation taking place across the global technology industry. AI is rapidly moving from an innovation showcase to a real-world deployment, from isolated breakthrough to system integration, and from individual competition to collaboration around the global ecosystem. This year, we are proud to host more than 1,500 exhibitors across 6,000 booths, spanning Nangang Exhibition Center, the World Trade Center, and the Taipei International Convention Center. This expansion, not just about scale, it signals the global AI ecosystem is gathering in Taipei in an accelerating pace. Today, AI is no longer just a race for models or computing power. It is a competition of complete system capacity, from AI chips, servers, and PCs to high-speed connectivity, data governance, thermal management, energy efficiency, and smart application. AI is fast integrated into real-world scenarios, including manufacturing, healthcare, retail, transportation, and urban governance. The trend reflects this year official Best Choice Award reinforced a shift, clearly demonstrating that global AI competition is moving from a race for computing power to a quest for system value. If I were to summarize the core focus of Computex this year in 5 keywords, they would be computing, connectivity, storage, efficiency, and application. Dear media friends, Computex 2026 promises to be extraordinary. We sincerely invite you to explore the exhibition halls, attending forums, visit the Best Choice Award display areas, and immerse yourself in Innovax. Come experience firsthand how AI is moving from model to systems. This year, we're also extending the exhibition experience beyond the venue into the city. Tomorrow night, with Taipei 101 as the international landmark stage, 1,000 MIT drones will light up the night sky, bringing together technology and art for audience around the world through a live streaming. On June 3rd, the Innovax Night Party will bring together global startups, investors, and industry partners, making Taipei an important platform for global innovation exchange. In closing, AI Together is not just our theme. It is shared direction for the entire global technology industry. Thank you once again. Welcome to Taipei, and welcome to Computex 2026. Thank you very much, ladies and gentlemen. Thank you.
Thank you, Jason. Ladies and gentlemen, this marks the conclusion of our global press conference. We're truly grateful for your continued support and for being with us today. We will now proceed to the Qualcomm opening keynote speech. Let us once again invite Taitra Chairman James Huang to the stage to officially introduce our opening keynote speaker. Welcome, James.
Ladies and gentlemen, as we move into our keynote program, I'm pleased to welcome back a familiar face, a good friend. For the 3rd consecutive year, Cristiano Amon has chosen Computex as the stage to share Qualcomm's vision with the world. The continuity speaks for itself. This year, everything Qualcomm has been building toward, AI at the edge, intelligent devices, the connected world, is becoming reality. There is no better person to open our keynote series. But first, please turn your attention to the screen for a special opening from Qualcomm.
We're stepping into a world where AI feels less like a tool.
Good morning. Here's your daily brief.
And more like a teammate.
It's day 5 of strength training, the dreaded leg day.
Okay, let's do it.
Always ready. Always learning.
You're approaching your personal best. Push yourself.
Built to keep up with real life, not slow down.
Nice work.
Intelligence that moves with you, across the moments that make up your day. Working quietly in the background, so everything else feels easier in the foreground. And when the how is handled,
Thanks.
you get more freedom to focus on the why, more flow, more creativity, more time for what you care about. This Qualcomm technology adapts to you.
Your meeting canceled, so I freed up your schedule. You mentioned needing a new shirt for the party this weekend. Want to pick one up on the way to the office?
Sounds good.
Responding to your life, your needs, on your terms. It's more than just a helping hand. It's an extra set of eyes and ears that understands the world around you.
I prepared a few color matches with your wardrobe.
That sees what you see.
The white t-shirt would also go well with your tan jacket.
Here's what you hear.
I'll take both.
Those shirts are selling well. I've drafted a social post to drive engagement and placed an additional order with the wholesaler.
Technology that meets you where you are and takes you where you need to go.
Your ride should be about 35 minutes today.
Okay,
I've summarized the latest product design feedback to review on the train.
great. Killed that photography podcast I mentioned earlier.
Done.
A network of agents working around the clock to create a brighter future for everyone. This is intelligent computing everywhere, driven by Qualcomm innovation. Smarter, faster, more seamlessly connected. Transforming the devices you rely on into partners you trust. It's computing that never misses a moment.
Looks good.
So neither do you.
Please, President and CEO of Qualcomm, Cristiano Amon. Yes. Chairman Wang, thank you. Good to have you back. Thank you so much.
Thank you. Thank you.
Thank you.
Thank you very much. Hello, everyone. Very, very happy to be here at Computex. This is a special time, I think, for Qualcomm, a special time for technology, and it's such an honor, I think, to be able to speak with you all here at Computex. So thank you so much for being here. As I said, I think we are Qualcomm incredibly excited about the future. Is there some Qualcomm folks here in the room? All right. Thank you. Thank you so much. Before I start this presentation, this presentation is not about Qualcomm. It's not about Qualcomm. It's really, at the end of the day, I think, evolution of technology is really a combination of companies. Not one company is never responsible for everything. It's really about partnership. So first thing, I wanted to say a big thank you to all our Taiwan partners. First, all of our suppliers, all of our development partners. A special thank you to TSMC, which has been an incredible partner on this journey. So thank you to our suppliers and our developers. And then also a big thank you to the entire ecosystem in the partnerships and many of you which are here today. Thank you so much. This is not about Qualcomm. This is all about you and an incredible ecosystem that exactly drives everything in technology with a wonderful partnership. Companies that are leaders in technology today, they are leaders because of those partnerships. So thank you very much, and thank you all for having me here speaking to you. Okay. We are incredibly excited because a lot of the things that we have been talking about is really starting to become real, and it's very easy to see. I have one job today. And by the way, I won't talk about a data center. So if you came here to hear about our data center projects, I'll tell a little bit, but we'll talk about this at the end of the month. But I have one job today. I want you to understand how AI is going to evolve for all the devices, because it's the new form of computing that is touching every single device. And if you walk out of this keynote today, understanding what's going to happen to all the devices of the edge and how much we're excited about it, I have done my job. So I'm going to do my best to tell you how this feature is going to look like. It's very clear to us. We have conviction of what's going to happen, and we're going to make it very concrete for you. But it's an incredibly exciting time for all of the computing technology and all the devices that we use every day and the ones we're going to use it. So about 2 years ago, we talked about how AI will change the human-computer interface. And as a consequence, will change the architecture of all of our personal computing devices. And that is starting to become a reality in 2026. That's why we call it Qualcomm. 2026 is the year of agents. And it's now how AI is really evolving and is going to get to an incredible amount of scale. It is evolved from simply answering prompts and work as a tool that augments how we as humans work with our computers into something that can take action on their own. I'm going to give you some examples, I think, what you see today in the screen. At home, you're going to have agents. There's going to basically update everyone on your activity and your schedule, all of the things that you need to do. At work, will be with you and think about what are the projects that you need to do, what are the tasks that you need to do. It flags the decision, and it's going to be working with you. And in your personal life, will give you information that is relevant to you, all of the updates that you need, work with you on a schedule. Everything's going to be prioritized, and it's going to be a little different. It's going to feel more autonomous. It's going to feel more personal, and it's going to feel like really a companion. And all of this is going to happen proactively across all of your devices. And for that to be understood, we have to go back to a very basic element of this transition. We have been talking about this, right? Which is the phone today is at the center of your digital life. And I remember when I presented something similar like this, when we talk about it at Snapdragon Summit, I actually talk about here at Computex, that the phone is at the center of a digital life, and therefore everything is around the phone. It's how we interact with the phone, with the OS and the applications, even the other wearable devices, they are around this phone ecosystem. But now this is different. Those agents become the center of your digital experience. So including the phone, and the other devices, they now are around the agent. It's not about an extension of the phone. And the digital ecosystem is no longer at the phone itself and the OSs and the applications. And what happened, those devices become endpoints for agents. And agents they are not trapped. They are not attached to a single ecosystem. And everything that connects you with an agent becomes an endpoint for AI. And that's a very important change. Once you understand that change, you understand how the whole mobile industry is going to change. The things that we take for granted today are going to be different tomorrow. And there's one thing I can tell you, coming from Qualcomm. I've been in the company for 30 years. One thing is guaranteed, the mobile industry is not static. It changes all the time. So those endpoints for AI, I am going to talk about what is really the surface area. I'm going to remind you of what are the scale of those devices. There are about 6 billion phones today, 2 billion personal AI devices, which is the evolution of wearables, and that is actually a small number when you think about those things as an endpoints of agents. 2 billion PCs, 500 million connected cars. And people will experience and interact with those agents on these devices. And as I said in the beginning, the role of this conversation today is help you understand the role of those devices at the edge for this next phase of AI. And we at Qualcomm, we actually told you about those devices running AI before it was popular, but now it's very easy to see. So once you understand the scale, one important message that I want to deliver to you is that today's devices were not designed for those experiences. They're not. It will require a different kind of device when agentic AI becomes the #1 AI function in our daily lives, especially for personal computing as we interact with those devices. All of those devices today, they have been built for actions initiated by the user, not by the agent. And I'm going to break that down for you. The agents are different. They operate it all the time. They carry context forward. They will orchestrate multiple tasks reliably and securely, but they're going to do that on your own, not necessarily with human intervention. That alone gives you a glimpse how these devices are going to change and how the architecture of those devices are going to change. And when you think about that, the agent acts on intent. As you have now AI taking a role in the man-machine interface, you understand human intentions. We'll proactively understand the text that it needs to interact with the human. We'll take a goal. We'll break it into several steps. We'll coordinate across systems, across data sets. Your own data set that lives on the device, the data set that is unique to you on your personal graph, and the data set is going to be in the cloud. It plans. It executes. You'll verify. You will keep interacting it until the task is done. And that, by definition, changes the hardware. With different kind of hardware to be able to do this, because it's not just what is initiated by the user. The agent is going to be running on its own. It's also changed the operating system and changing the application. And I think that's the incredible opportunity that we have in computing across this entire surface area of devices, which are going to be upgraded for this age of AI. You need to be able to tight integrate across all the compute domains. You have strict power and latency constraint. I cannot emphasize enough the importance of power. Think about your phone. If it is challenging to make your phone last all day with you operating it, what happens when you and the agent is operating it? That's an incredible engineering challenge for power and latency. Those devices needs to be able to support planning, reasoning, coordination across the system. And for that, you can start to understand how the compute is going to evolve. You need a very strong and power-efficient CPU for the orchestration of tasks. I think the industry now understands the importance of CPU for orchestration and where the orchestrator is going to run. You need very power-efficient and high compute density of NPU and GPU to be able to run local models. One other thing that I'm going to do today is to show clearly how AI is going to be distributed across cloud and device. I almost feel that it's going to be so obvious that we're going to start talking about it. We're going to stop talking about cloud and edge because it's all going to be one system. And for that, you're going to need the computing power in those devices to do that on the NPU and in the GPU. You need to have sensor data. Context is super important. Without context, you cannot have the agent to be useful and for you to be useful and be proactive. All of those things are going to be necessary as we think the next generation of devices for the agentic AI and an upgrade is truly coming. So, and it's not the same thing for every device. It is not. We know this at Qualcomm. In personal devices, that means all-day intelligence, very focused on sensors and context that matter to you, incredibly power efficient because you're going to carry, you are mobile by definition, you're going to carry it with you, and you need to have high-speed connectivity. In cars and robots, that means sustaining processing power on the most demanding condition and also independent of connectivity and cloud when you have to. And in the data center, inference will require incredible amount of scale, and I'll walk you through it when we think about the demand for tokens. And power efficiency is also going to matter there. I'm going to tell you something. For companies that have the benefit of being working in the mobile industry, for decades, you had a different growth rate of computing power and availability of energy. So you have to come up with solutions that allow you to get all the computing power that you need with the available energy, because the battery has to last all day and is limited in its size. That's also going to be true when you think about what's going to happen on the data center, but we'll tell you more about that at the end of the month. And that in itself is the Qualcomm advantage, because we have been working with all of those devices at the edge, all of it. And especially the new Qualcomm that had incredibly diversified, we now have ability to build systems. They're sub 2 milliwatts from an earbud with micropower Wi-Fi that connect to an agent for personal AI audio device, all the way to kilowatts, what's going to happen in the data center. And I think that is the incredible opportunity that we see for us and for our partners when all of those devices are going to change for this future of agentic AI. And for that, you need dedicated computing solution that scale all the way down to a sub-milliwatt device to a 2,000 kilowatt. And that's an incredible opportunity, I think, that we have in front of us. Leading performance per watt across smartphones, PC, automotive, computing, robots, and extending that to the data center. I think that's our mission, and that is the incredible opportunity. The last thing I'm going to tell you, as we keep moving in the presentation, there is excitement about what's happening, especially on the PC side, that with all of those agentic AI. So as we go down the presentation, I will come back to this, and I will come back to the phones, because I believe that what's going to happen on the phone is going to be a very good proxy of what could happen on PC and other devices. But hold that thought. So I'm going to break this down for you across the different categories of devices. And I want to show you how those experiences are evolving. I want to make it less abstract and more concrete for you, because this is happening right now. So I want to start with the devices that are really powered by Snapdragon platforms. You will see agents now being deployed and starting to get scale across phones, PC, and this new category of personal AI devices. I would like you to watch a video. Let's run the video.
I'm having friends over tonight. My smart home devices start getting ready on their own.
Quark, search for the same item.
Found the same suit for you.
Ask Claude Cowork to create a daily briefing for you. It can pull from things like your email, your calendar, your local files. A powerful CPU like a Snapdragon one just means all of this will run faster, more privately, and more efficiently.
I walk in, got presidential status. Pull up like honey, I'm home, always on automatic. Too many tricks up my sleeve, it feel like wild out magic. Got them jumping like rabbits, I make them go crazy.
I have this setup running on my laptop powered by Snapdragon because its powerful CPU lets me run multi-agent workflows in parallel.
It has a dedicated AI engine. I don't throttle on any long coding sessions. You just tell it what to do, and it does it.
Can I just get one item from box 3?
So this is incredibly exciting, and it's really already happening. And you can see the agent isn't tied to the device. It actually moves with the user, and is there with the user regardless of the device that you have. So that is one way for you to start to understand this change when the center of the ecosystem, especially mobile, is no longer the smartphone. It's about the agent, and the agent's going to be across all those devices. This is incredible, and as I said, it is easy to see now why we say that this is the year of agents. And adoption is really accelerating, and you started to see beginning to run on commercial devices. Orchestrators like OpenClaw and Hermes are now running on Snapdragon. Agentic assistants like Claude Desktop are running natively on Snapdragon PCs. And you see this thing only accelerating in how the users are going to use more and more of their machines. And the machine's going to be running on their own, doing things. And cloud platforms, for example, like Perplexity Computer, are now building orchestration layers that connect to the device. Google is bringing agentic AI directly into Android with Gemini Intelligence. Microsoft's doing the same. And partners even like Humane are developing full agentic operating system running on Snapdragon. It's truly incredible. And I'm going to use now this moment before I keep going to the presentation to tell you about the point I'm going to make about phones. Because actually an important point to understand, there's 6 billion phones and how user experience is going to be defined. Those orchestrators are a significant milestone in the transition of AI to agents. And I remember, for example, when orchestrators like OpenClaw became available, a lot of consumers were buying computers. They're buying Mac Minis and other computers, and they run those agents in the computer. We're doing tasks, and you can message to the computer. But this is not unique to those early adopters. This is how computers are going to be utilized by a lot of people. If you have a phone, you don't have the ability to buy a computer, connect it to a bed, or put it in a backpack and carry it with you. You're going to carry one device. And those things are going to happen in the phone. So those devices are going to have two personalities. And I'll come back to this. One personality is you're going to operate the device as a human. That's how the device of today has been designed to operate. But the agent's going to operate the device as well. And that's how devices are going to be in the future. And that's going to happen on the same device. And the same device doing both, like phone, is also going to influence how it's going to happen on PC with laptops. And those personal AI devices are going to get scale because they're very natural for agent. Glasses, for example, is close to your eyes, to your mouth, to your ears. They became very natural. And that is this incredible transition we're going to see in compute. But it's not just you.
We will continue with this. Just have to check on some emails. Let me do one thing. I should be playing it via the mic. performance, Triton fastpath for small CPU to GPUs, XCPUs, tokenization, Triton block size to 4096, deterministic sampling, KV connectors, VP aware handshake aggregation, intermediate VP numbing, Intel jobs, split groups for PyTorch, dynamic speculation length for per position acceptance, integrate torch comps, reject out of memory, fixed Quen series VL CPU, on before applying HPU torch patches, standardized KV, MOE, flash infer, torch HPU, base model and LoRa, enable prompt. My AI research and engineering labs was mentioned a few times on LinkedIn. PP, user line, quantization, TOT, Mamba, attention, model delivery factor. This is for the linear kernels. Multi-KV, PPL, of discovery on AI agents, GLM5, Chinese DeepSpeak, CODNN, XPU block, RMS norm, int8, memory leak, DeepSeek V2, V3 3.2, flash infer, video frame specialization, sharded memory, X creating, GPT-20B OSS, ALM Triton, key with parameters, GPL v3, VLM with Ray and AWS cluster, Solar Open, LoRa, DMA support, Prometheus, DeepSeek 3.2, VLM support agent, SGLang, unifying engines, Quen 3.5, 27B, reducing latency for hand tracking solutions. The rest the rest of the emails and the discussion I will do after we watch this video fully.
Unique to personal computing. This is also happening as we think about transition that we're going to have to the physical world. The physical world is one of the most exciting areas in our industry right now. Cars, robots, industrial systems are going to be also significant influence for agentic AI. And in those systems, you have other requirements. Legal, safety are measured in milliseconds, in millimeters, every single one minute. So I want to show you a demo next, and I'll walk you through it, for example, how things are going to work in a car. When you think about the car, there will be 2 layers of intelligence. So in the cockpit, AI will personalize your experience. And that, it's the same way that we just talked about it. The agent is your agent regardless of the device. When you're behind the wheel, you're going to take that experience with you, is going to interact with the agent. It doesn't matter if you're going to be in the car and personally have a device on the phone or your PC, because the agent is at the center of all the devices around it, including the car. But also the car has another task. Besides interacting with you, it's interacting with you within the context of the car. And on the road, you also have physical AI that is perceiving, it is planning, it is acting, using cameras, radar, sensors, and maps for navigation. So that's the interesting thing. You have 2 different layers of intelligence. You have the interaction between the cockpit, which is personal to you when you are within the context of the car, but you also have the physical AI that drives the car for you. And this is designed to operate as one integrated system. Watch this video of this in action, which will understand how the system works as one.
What time did it go today? Most flowers close at 5 p.m. Monday through Saturday and at 2 p.m. on Sunday. What kind of flowers do they sell? Coastal flowers specialize in nature and by design. We see new bloom.
So this is very interesting because what you can see, the cameras of the car, the radars, and all the sensors, depending on this layer of intelligence to drive the car, now also input in context for the agent for your experience. And we're just at the beginning of this. And what we actually see within Worklog, this whole transition of the software-defined vehicle is now augmented with the vehicle evolving to the AI-defined vehicle. Now, I talk about personal computing cars. I want to talk about the next big category of physical AI, which is robotics. The entire robotics industry right now is being transformed. And robotics is very interesting because it pushes the limit of computing. computing technology and incorporate aspects of what I showed you, incorporate many aspects of technology of what we see in personal computing for sensing, perception, high integration of sensors. The robot, like your glasses, will see what you see, read what you read, understand the context. At the same time, you have all those elements of technology that comes from the automotive industry. You need precision, you need industrial grade, you need safety, you need redundancy. So that's an exciting element of technology transition, which you have the best of both worlds. And to succeed in robotics, you need to understand how to design this as a hierarchical compute system. First of all, you need to understand that a robot has 3 layers of computing. There's instant execution. Someone like us, you're going to pick up something and you didn't get a good grip. It'll take you just go again and you get it again. That's instant execution. Same thing how you give your balance or everything that you need to do without thinking, like us. Then there's action. And then there's action and grounding. And then you have reasoning. You have to build a hierarchical compute system. You also have to distribute intelligence. It's not just about building the brain that they go up. You need to have a central compute. You have to have motion control. You have to have the ability to do actuation, things that are going to be very important, which is perception, dexterity. So actually bring the best of mobility, personal computing, what you see in some of the automotive and navigation is a great technology platform. What we're building is a comprehensive platform across different form factors. AMR, industrial arms, 4-leg robots, humanoids, drones, and I think the industrial opportunity is happening right now. You have to build hardware, you have to do software, you have to build an AI operations, ability to do fleet and data management, and everything that our partners will need to go from prototype to production. And the robot is another great example when battery life matters. When high-level integration of computing and sensors. If you want the robot to get scale at the right price point, you need to bring from consumer electronics the capabilities to do high-level integration. That's an exciting opportunity for us and our partners as well. And when you think about it, this is definitely evolving very fast. Those are the examples. We've been working with companies like InMotion, Neura Robotics, Digital and soon we'll share what we're doing with Figure AI as well. But beyond robotics, physical AI has an incredible opportunity in industrial. I've been saying this, industrial, it's not demand bound, it's solution bound. It's about maturity of those systems and technology. The demand is enormous. In enterprise and industrial environments, for example, vision, AI-powered cameras, they monitor security, compliance, they can monitor traffic flow on the smart city, they trigger actions, autonomy, and there's many more applications. If you want to understand what's also now in the enterprise, you're going to see new form factors of things that an enterprise uses every day, from helmets to safety glasses to badges and everything. And the opportunity is really incredible. When you think about, for example, computer vision, you can see, I think, the role of AI and agentic AI changing everything. Computer vision can run globally on devices, they can run in the cloud, they dynamically can access more powerful models on-prem or on the cloud when needed. They'll be able to see, understand, decide, take action, turning perception into real-time intelligence. And you can see that the applications are truly incredible. And we're just at the beginning of this. The input from vision and other sensors connected with agentic AI will fundamentally change how many of those systems and enterprises are going to operate. And we see this happening, for example, at retail, at warehouse. In general, I think office management and building. We see this in the oil and gas industry. We see this with energy. And of course, we can see this in smart cities. This is an incredible opportunity for agentic AI. Now, you have seen agentic AI transforming personal and computing, and those new classes of personal devices you see, cars, robots, industrial. But there's another layer coming to all of this that will change the equation. And I'm personally very excited about this. Is the next generation of wireless. And I am going to explain to you today why this is actually very relevant to the conversation we just had. At Mobile Congress, we described 6G as the first generation of wireless designed for the age of AI. And 6G has 3 pillars. Connectivity, it's distributed computing, and it's sensing. And distributed computing and sensing were new things that didn't exist before in the telecom sector. I'm going to bring each of those pillars for you. So let me start with connectivity. My simple description to you of the connectivity change in 6G is based on what we just talked about at the beginning of this presentation. If you have smart glasses, they see what you see. So the connectivity needs to enable a very fast uplink. So I know it's going to sound interesting, but I'm going to say, man, but 6G is going to make all of us into walking cameras in this world. Because you're going to have the ability to get high definition video that you see and be able to send that to the system in the cloud. It is designed for continuous context exchange between devices, machines, agents, car. And with a native interface, the network understands and adapts the radio environment. You're going to see, I won't spend a lot of time talking about it, but you see a lot of different techniques. Autonomous networks, prediction of radio signals, so you can have high speed and weak signal conditions. Significant improvements in speed and the density, but bottom line is ability to connect everything and enable even that use case of see what I see. That's the connectivity part. The second part is computing, and that's going to become clear when I get to pillar number 3, which is sensing. But that's the biggest change in the infrastructure of telecommunications in wireless since the beginning of mobility. The whole network itself is an AI network, with distributing AI computing and inference at the radio base stations to the central office and the data center. The network is part of a very large data center. The central office looks like an on-prem data center, and then you have computing in real time at the radio base stations. And that is going to be important not only for the connectivity aspects. I just spoke about autonomous network, autonomous allocation of resources, prediction of RF signals, but it's because of sensing that you need this capability. And sensing is the biggest change in the sector. That's what's going to make the telecom sector really a completely different company. What sensing will do is we'll look at the RF signals as physical AI inputs for models that have been trained on their performance. What it's going to do, each one of those radio connections are going to be like a radar that you see used on a car, for example, right? You're going to get hundreds of millions of those connections in real time. You triangulate all the data, and what you do, you will create a digital twin, not only of the neighborhood, the city, but the whole country. And what are you going to do with this? Drone detection is an example. You detect everything that moves and flies. You manage the entire low altitude and aerial economy. you're going to detect on every road, every car, every bicycle, every truck, every pedestrian. You can actually identify those objects and annotate an image. You bring this whole conversation we just had about computer and visual intelligence as an example into a large digital twin. And that is going to change everything. And what's the connection with this conversation we have about agentic AI? This is all real-time context for agents that's going to be running on the endpoints across all those devices. This is an exciting, I think, future for everything that is happening on the edge. Because AI is a new form of computing, and it's going to be how computers are going to run everywhere. So now I'm going to get to the last part of my presentation. And this is the second part of what I said it was my objective today, to explain all of you how the device at the edge is going to change with AI. The second part is trying to get a very, very simple understanding of how cloud and edge are going to work together. It's now very obvious, but I want you to get to the same conclusion that we got to how this word is going to go. So agents are now how demand for tokens is created, and it's how AI is going to get its scale, and it's defining both the architecture and the economics of AI. So let's go back and recap. Today, most of the software, the OS, the App Store, they have been designed for a human to operate. So we operate and we do things. We start an app and a program, go to the web, we do different things. It's designed for us. Now, with agents, everything changes. The agents are autonomous. They interact with software much faster. They do it across multiple services at once. That's why the device is going to have to be upgraded. And every workflow generates tokens at machine speed, not human speed. Here's an example. When you think about an application, or even the SaaS industry, you think about software for the SaaS industry. Those clients, today, they're being designed for a human to operate the client. Not anymore. You have to design your application and your SaaS for a human and an agent to interact. And the agents are going to interact faster. That is going to fundamentally change the demand for tokens. So as an example, you can see those transitions, right? How quickly token consumption is growing. So a lot of different estimates, but it looks like this. So level one, when we started conversational, you go in and you a single turn, you prompt to get a response. That's about, you can talk about 10,000 tokens on a single turn prompt response for level one conversation. Level two, reasoning. Then you now have multi-turn. And you can see an order of magnitude increase, about 100,000 tokens per task. And then we go level three, agentic AI, autonomous, multi-step, multiple protocols, is about 1 million tokens per task, and it's growing. You see the order of magnitude increase. It's about 100x increase in the number of tokens in 2 generations. Now let me give you the same data, different perspective. So this year is 2026. It's estimated that the global token demand within 10 seconds is about 31.7 billion. So the projection for 2030, for the same 10 seconds, is 1.27 trillion tokens, a 40x increase. And that's because agents are going to generate a lot of tokens. So if you think about the latest estimate, and I'm sure that's going to change, but the latest estimate for total token demand globally in 2030 is in the quintillions. I don't even know what to say the number. I'll say it's a 4 gazillion tokens, that the token demand for 2030. And that is the new currency of AI. Tokens are the currency of AI. And let's now share how this is going to work. And there's going to be a lot of people that's going to argue. There's no need to argue. That's exactly how it's going to work. We have seen this before. Resistance is full time. Okay? So let me give you some examples how this is going to work. So let's talk about coding. Coding workload is one of the most token intensive tasks today. Using a real section running flat code. An orchestrator is now intelligently routing the workload, keeping certain tasks on the computer available on the device and sending what's necessary to the cloud. When you apply the distributed agentic AI, making use of all the compute across this compute continuum, you can see you save about 1.4 million tokens, 60% lower cost for the same result. Now let's let me give you a really different example. So the next demo I'm going to show you is a task. Create a Snapdragon web page. There's a lot of specifications on the prompt about this web page needs to be created. On the left, you can see that it runs on the cloud and it generates tokens in the cloud. On the right, it's the same result. But you have intelligent distributor. Intelligent orchestrator defines this routing of the task about the compute that is available on the device and the compute that is available in the cloud. Result is you get exactly the same result, 30% fewer tokens, 4x lower cost. And that is the power of distributed AI. And this is how this is going to play out. I like to provide this example. It's interesting because we've been seeing this conversation about cloud and edge, and they're both incredibly important. And now you're starting to see how this is exactly going to play out. It's not an abstract thing. Exactly. The conversation is never about this thing that runs in the cloud can also run on the edge. No. What needs to run on the cloud can run on the cloud, needs to run on the edge can run on the edge. It's different. I like to do this analogy. It's not perfect, but it's good for us to understand it. I'm sure each and every one of you here has probably over 200 apps organized in folders in your smartphone. And if I ask anybody to do the exercise to say for each app, what runs on the computer on your smartphone or runs on the computer on the cloud, is an exercise of utility. And you know it runs on the cloud because your phone in airplane mode is useless. But you need a lot of computing. And this is how it works. AI, agentic AI is agents running the computer for you. And as the workloads starting to shift, the things that you do yourself, and the things that the agent's going to do, is going to make use of all the computing that's available. It's going to go exactly how it works today. The computing is going to be utilized, everything will be running AI, and it's going to happen across the compute continuum. And I think that's the exciting part for Worklog, because that's going to create demand for AI computing everywhere. And every computing engine becomes interesting and necessary for this agentic future. And you're going to naturally process the workloads where it's more efficient. And that is the opportunity, because we're neatly positioned across all those different devices. And it's never one size fits all. You need to have the right platform for AI for every device. As we talk about it, they're different. They have different purpose. It's about maximum intelligence and maximum efficiency everywhere. So as I get to the end of the presentation, I have one lesson that I want to tell you. So let's watch the video. So today at Computex, we're announcing the new product brand for Qualcomm data center products. We're already working with hyperscalers and local partners on real-world deployments. We're incredibly excited about this new chapter to welcome diversification. And now, with Dragonfly, our portfolio spans every single tier of the computing continuum. The smallest wearables that will connect agents to data centers at very high performance. We'll have a lot to share on Investor Day in just a few weeks, June 24th. We should hear all about our roadmap for that is coming. And in summary, I'm just going to tell you, we're incredibly excited about the future of technology. Across every single device, this is going to be transformed. We show that agents are not coming into the future. They're already here. It's changing a lot of the compute. It's going to generate a lot of demand for new classes of devices and computing, and this upgrade cycle can be one of the largest that the industry has seen. And together we're building the products and the technology that will define this era. Thank you so much for listening to my presentation. Like I said, it's a pleasure and an honor to be here. Hopefully this was helpful for you, and I can't wait to build this future together with our partners across the globe and our partners in Taiwan. Thank you very much. Enjoy the conference.
Great. So this was a kind of a keynote in which Qualcomm gave an idea of what they are bringing to the table. Cristiano Amon explained about the autonomy and what is required and what the projections will be and what they're coming up. So kind of cool. Let's go to the Intel's keynote and see what they have to say. Intel Computers we watched Intel keynote.
Silicon, the foundation.
Just a minute. Before we begin, let me go on my coffee run. I have had my protein shake in the morning, and the next is I have brewed the coffee in my French press. So let me get that, and we will continue in a couple of minutes. Hey friends, I'm back. Let me turn down my mic and let's continue from the Intel Computex keynote stage.
Silicon, the foundation of modern technology. Every transistor placed with purpose, every watt wrestled from physics, where every instruction set earns its right to execute. This is how performance gets driven, how efficiency gets built, how intelligence acts, not just answers. Our future is with ecosystems, shaped by architecture, capable of connecting technologies, tools, and partners, powerful enough to execute, efficient enough to scale, familiar enough to build with speed. Tomorrow, it's about the progress we scale through open platforms, shared standards, and partnerships, amplifying each other's strengths. A unified architecture engineered for systems. The next chapter is being written in silicon with our engineering at its heart. Built different, built together, built on Intel.
And now, ladies and gentlemen, please give a warm welcome to the CEO of Intel, Lip-Bu Tan. 让我们用热烈的掌声欢迎 Intel 执行长陈立武。
午安，大家好，非常欢迎你们大家来参加我们这个 Intel Computing。我昨天晚上9点半就爬那个象山谷，1000那个 steps。This is the Elephant Mountain, and so 1,000 steps to 184 meter, and so I survived. And then came down with one piece, so I'm here. So, but if I walk a little bit slower, then you know I'm exhausted. But anyway, it's a beautiful view. I mean, I highly recommend all of you to do that. Yep, I think first of all, I think delighted to be here, and this is an important event, and I'd like to get started. And about nearly 6 decades ago, a group of brilliant and highly motivated engineers and venture capitalists, including Arthur Rock, Don Valentine, and many others, they found companies like Intel, Apple, and others broadly set the motion, the largest economic known to mankind, create what became known as Silicon Valley. And this is a very exciting time, and that is a very same ambition and mindset with the semiconductors make across the ocean to spark the creation of Silicon Island right here in Taiwan. And I have been very fortunate to associate with the creation of semiconductor industry in Taiwan 40 years ago. Because 40 years ago, Minister K.T. Lee, Li Guoting, invited me to lay the foundation of venture capital concept in Taiwan. It's a very new concept, and people put money with you, and you play the money, and then you share the profit of 20%, but you don't share 20% of the losses. So this is a very unique venture capital concept, but I managed to do that, and then with the help of Minister K.T. Lee, and then development fund, and I set up my venture fund. And about the same time, Maurice Chang from TI came back to E3, and then set up the TSMC. So it's a very exciting time that I'm being involved in this whole science park, and Hsinchu Science Park, and the foundation will become the Silicon Island. And so I really see the benefit of, from OEM, ODM, from design to manufacturing, it's all here in Taiwan. Taiwan PC ecosystem has played a critical role in Intel growth and success. In fact, last year I was here to celebrate Intel 40th anniversary in Taiwan. I want to thank all of the suppliers, partners, and customers for 40 years of partnership with Intel. As partnership continue to grow, thank you. As partnership continue to grow and stronger every year. It has been a year since I stepped in the role of Intel CEO. To be more precise, 14 months to being CEO of Intel. And it may be the first CEO who can speak Mandarin. And in fact, a couple of customers of Taiwan, very important partner for us, is that people also very unusual if a CEO can drink liquor with us. But anyway, I'm part of this community. Execution has always at the top of my list. To do so, we had to bring focus back to the core. At our heart, Intel is an engineering company. And that's what I decided from day one. I came to become CEO of Intel. I have all the engineering report to me. So the understanding to really drive the engineering, drive success in engineering performance. Our customers and partners always already seen a shift in the Intel showed up. We are just getting started. And so stay tuned. We have a journey in front of us. Opportunity ahead is enormous. And our job is to stay focused, execute, and deliver. Every year, Intel ships hundreds of millions of SoC, orchestrating silicon across every industry, working tightly with our partners' ecosystem across each layer of the stack. From silicon to SoC to system and to software. This generates trillions of dollars in value across 4 core compute ecosystem. First, personal computers. Second, edge, agentic AI, and later physical AI. Third, foundational data centers. And finally, emerging intelligence centers that will power digital agents of the future. Each of these ecosystems represent generational opportunity. And increasingly, each of these will need purpose-built CPU, GPU, and ASIC solutions catered for specific workloads and application. The silicon we are building now will be for human use and the digital agent use. Let us begin with the ecosystem that started all. To talk more about the PC ecosystem, please join me to welcome to stage our new leader for client compute and physical AI, Alex.
Thank you. Thank you, Lip-Bu. Little story about me. The first time I came to Taiwan was the year 1990. And I was fresh out of school, first job, first international trip, first East Asia country I've ever been to. And I came right here in Taipei. And I quickly realized, even back then, that the desire to grow, the mindset of win-win and cooperation is all over all of our customers and our partners here in Taiwan. And so it quickly became one of my favorite countries to visit and work. And now, forward the clock 36 years, I'm here in my first international trip with all the great people here at Intel. And where do I come? right here to Taipei. Thank you. I can't wait to plan and build the future with you guys. So let's get started. We have a lot to cover. Intel has continuously increased the pace of progress across all PC segments. Workstations, desktops, creators, gamers, premium and mainstream laptops. Every major segment is driven by an Intel system solution. With that vast coverage in mind, we're adding another dimension to scale these products even more effectively. The Intel 18A process is now at full scale. We have a full lineup of products with hundreds of design wins to prove that. At CES, we launched the Core Ultra Series 3, Intel's first product built on 18A process technology. It's setting a new standard for premium mobile performance and battery life. The Ultra Series 3 enables great user experiences across any tasks with a very fast response CPU, a highly improved GPU, low power processing NPU, and the latest multimedia capabilities. It's a perfect blend of IP, performance, and power for any AI and agentic experience. It's allowing us to lead the way to transform every PC to an agentic-capable platform. Today, more than 300 designs are shipping across consumer and commercial segments, over 300. And to scale these capabilities even further, we've taken the latest Core Ultra IPs and specifically tailored them for the mainstream market. The result? The Intel Core Series 3, introduced in April. Let me repeat, we just introduced this in April, and it's already scaled up to 70+ designs. That brings the total series lineup to nearly 400 designs in just a few short months. Now that is massive scale. Let's look at some of the capabilities of the Core Series 3, and we can start with battery life. You know, I can go over these numbers here that are printed, and I can talk about how we measure them and things like that, but I have a question for you guys. How long is your day? 10 hours? 12 hours? 14 hours? Or more, like us at Intel? But the great user experience is if your PC lasts longer than your workday, and that's exactly what we're delivering in all segments. And we support ample number of ports for all of your connectivity needs, unlike some of our competitors who only have one USB-C interface, but I'll let you be the judge of that one. Yeah. The goal of this Core Series 3 is to bring premium feel and experiences to incredibly thin form factors for mainstream PCs. And you don't have to take my word for it. You can look at this wall of incredibly designed, sleek PCs that are here, and all of it is thanks to you, our partners, and our customers. We couldn't have done it without you, so please, a round of applause. Isn't it awesome? Super light, super thin, it's really great. Okay, now the next proof is scaling 18A IP into growing markets. And the fastest growing portion of the PC market is the handheld gaming. Let's take a look. This is the Arc G3. I think a beautiful chip, more beautiful than was presented yesterday at the keynote. Okay. The G3 is derived from the Core Ultra Series 3, and the Arc G3 is a tuned, high-performance GPU specifically for handheld gaming, and it's providing great battery life. The performance tested across multiple games is consistent and stable versus competition. We are more than 40% faster, and at the same performance, we're half the power. And on top of that, we're running all AAA games at 1080p resolution, many of them above 120 frames per second. Now that is giving gamers a great user experience. All of these devices will be available later this month, and it's just the beginning. We're going to have plenty more designs coming throughout the year. Thank you. Okay, it is indeed true that Intel has a leading lineup of processors. And with the versatility of the 18A process technology, our newest offerings, we're bringing powerful performance and efficiency to scale across the breadth of premium, mainstream, and handheld gaming segments. These same fundamentals, the same IP, the same capabilities, can deliver far beyond the PC ecosystem. The demand for our processors at the edge has been booming. As you've seen, we've already taken existing product lines and pivoted them into adjacent markets, enabling our customers to grow their businesses. Now, the edge is demanding the latest products from Intel, and that's why this year we're taking our latest Series 3 products into the edge business with over 130 designs in multiple verticals. For large-scale edge business, our customers need the best technology and chipsets, easy-to-use reference designs, and appropriate software stacks. And at Intel, we've done all of that. We have over 4,000 edge ecosystem partners deploying into such verticals such as manufacturing, robotics, retail, and many more. For those of you here at Computex, you can see some of that at the pavilion. Given that capability, given the IP, given the chipsets, given the scale that we have, there's a massive opportunity ahead of us across many segments of physical AI. It's projected to be a $25 trillion market by 2050, and it will leverage all of our scale in the PC ecosystem. Physical AI form factors will take shape across key industries, as you see behind me. We will continue growing these markets with the same strategy of leading IP and chipsets, complete reference platforms, of end-user hardware, and applicable software stacks, enabling our customers to expand into new physical AI form factors and applications. And indeed, this will be our future. Now, back to you, Lip-Bu. Thank you. Thank you.
So what Intel is doing is, like, as NVIDIA, are all following the footsteps of NVIDIA in transportation, manufacturing, health and science, smart cities, robotics, retail, energy, aerospace, and all. And they want to spread their chips all over the place. The Intel's whole stock is down, and this is the only way to revive it. And as Nvidia has shown, there was a speculation that Nvidia will partner with Intel for the chips, and like they are doing their own with the Grace CPUs and the Vera, Rubin, and other architectures that are coming in. The combination of GPU and CPU on a unified memory, like Apple has done with the M series. So that's will be interesting to see on Windows, and when you have full CUDA support there, what we can do. I don't think so Intel will be able to leapfrog CUDA's mode, but they are trying. Even AMD is trying there, and they have come out with different frameworks like ROCm by AMD, and they are giving the AIs a boost, and the unified architecture and CPUs that they are coming up with. So we need to get into the weeds of how Intel is going to transform the market. And this and all we discuss in our 2-hour primal weekly meet that we have on Fridays at 8 a.m. At 8 a.m. PPT. So like join in if you guys are interested. Search in for my tweets or my LinkedIn post and get a link and join in. We will be working closely and coding on TPUs, on GPUs, on these edge AIs, edge AI based architectural like components like the NVIDIA's what was that called? Nano. NVIDIA's edge devices, Jetson Nano, yeah. So we have played around with this, have had fun, build their computational AI frameworks and fine-tuned it to our use case and more. Now, with that context, let's get back to Intel Computex keynote.
Thanks, Alex. AI is profoundly impacting the way we use our devices. A major focus area for us is the use of AI on device. Together with partners, we are at the forefront of advancing intelligence. To tell you more about it, let me welcome on stage my close friend and founder, CEO of Perplexity, Aravind.
Arvind is a great guy too. When he was researching in his in his PhD and post PhD days, we used to have a chat about the latest research papers, what they have there, and it was all before AI in 2020, 2021. And before he was the CEO and he got the huge funding. So Arvind and I go kind of way back.
Well, Arvind, welcome. You and I have been talking about hybrid compute for a while. The reason why are clear. The privacy, cost, performance. And let's talk about how to make this work.
Yeah. So in February, we launched Perplexity Computer. Computer is an AI operating system. It creates a team of agents, uses up to 20 different AI models, and it orchestrates across models, tools, and files in one single system. The agent harness inside Computer is model agnostic. Perfectly balancing intelligence, accuracy, privacy, and cost is the orchestration problem it solves. And so this allows you to run smaller models locally on the Intel Core Ultra Series 3 GPU. And so for the first time ever, we worked together to create hybrid agentic inference. And so what we're showing today is just the start. Hybrid agentic inference is how we maximize token value per watt per user.
So should we show them how it works?
Yep. All right, so here it is. Let's say I'm an associate at a private equity firm, and I'm working on something that has a confidential project codenamed Project Falcon. Here's the query. So think of it as me trying to understand if a certain private company is worth $1.1 billion, and I'm feeding it confidential deal materials. The work begins on the laptop. It sees that Project Falcon has private deal room files, and an NDA, a local leveraged buyout financial model, a whiteboard diagram, and bilingual transcripts are very confidential. You don't want these materials to be shipped to the server. So what the local model does on the Core Ultra Series 3 is it first decides this is all very important work and shouldn't be sent to the server. It reads the files, classifies what is sensitive and what is not, and then Computer decides what should leave the device and what shouldn't, and each of these things is done with local AI. The orchestrator can spin up additional agents as necessary, and so if you need a research agent to bring in outside file materials against the local model without exposing any private files, that's what you want in the hybrid system. And so Computer acts as one single system, brings all inputs and outputs together, and so let's actually skip and see what the actual result would be. All right, so the result is a document, a research report, and sporting data, and it's being created by agents on large cloud-based models, keeping your sensitive information only on your device, and so all your local device models will take care of the private files, and the server-side models will take care of other things. True hybrid inference orchestration.
This is the architecture we both believe in. And the future is more compute in the data center and more compute on the local machine.
And so I think of this as a big milestone for engineering on both the agent harness AI side as well as the chip side. And so it's been really fun to partner with you and Intel on this. So thank you so much, Lip-Bu.
Definitely. Thank you, Arvind, and looking forward to continue partnership. Thank you. We talk a lot about the exciting new developments in the PC, edge, and physical AI space. I want to take a few minutes to talk about the foundational IP that power all these advancements. Let us talk about x86. When most people think of general purpose computing, they think x86. And that is a good reason for that. x86 is architecture that has powered data center for nearly 5 decades. And the leadership continues. According to the IDC, expect 8 out of the 10 servers installed through 2030 to be x86 based, powering modern computing from foundational to emerging intelligent use cases. Intel pioneered most of the breakthrough architecture innovation that have enhanced x86 over the last 4 decades, starting with the x86 that became the foundation of modern computing. You can see the chart. Today, we have 2 flagship CPU cores, P cores and E cores. One optimized for performance, the others is for efficiency. These are Intel's most advanced CPU cores, with the accelerator built in specifically for foundational workloads like security. Our x86 cores power our PC, client, edge portfolio, and also power our data center and AI portfolio. Under my leadership, we are committed to building the best CPU cores in the world. And we will ensure that the most compute-intensive workload run best on x86. Next, let us talk. Thank you. Now let us talk about how x86 is enabling foundational data centers. To tell you more about it, let me invite onto the stage Kavok.
Thank you. Thank you, Lip-Bu. Wow, it's so great to be here. Specifically in this point in our history, global history, collective history, and be at Computex with the blue badge. So I'm very happy, I'm very humbled to be here to share with you some of the innovations that we have. So let's talk a bit about, see what this AI thing is about. So when we say foundational, we mean the workloads that keep the world running. So currently we have data centers, and there's a number of items and workloads and entities that run on these data centers. So for example, we have 5G networks that keep us connected. We have databases that keep our data safe. We have cloud services that power our daily lives. So we expect and demand for these workloads to grow in size and capacity between now and 2030 from 80 gigawatts to about 100 gigawatts. And most of you involved in this domain understand the extent of this type of an expansion. These workloads are broad, they are mission critical, so special attention has to be taken when running them. But also they require performance, efficiency, security, and resiliency. And we can't emphasize enough all these 4 factors. That is why we are excited to have Intel Xeon 6 Plus introduced at Computex this week. It has 288 E-cores, a massive 576 megabytes of L3 cache, built with our Intel 18A technology. And we can't emphasize enough the value of Intel technology that brings to data center products. But most importantly, it delivers efficiency and density, which enables our partners to save very precious real estate, have more compact servers and the racks. So this is a leadership compute for the next era of cloud and network infrastructure. So Xeon 6 Plus launches with the strength of our ecosystem that's been built over decades and decades of data center development, both from a hardware but also from a software and infrastructure perspective. Moreover, our ODM partners are bringing Xeon 6 Plus solutions to the market today. So these range from full rack scale deployments to server-level designs. Xeon 6 Plus joins our lineup of data center processors next to our already launched Xeon 6 based on P-cores. Both of these category and class of solutions delivers new performance and choice for all the enterprises whose infrastructure backbone is built on x86 and Xeon. This is critical for enterprises that need to increasingly balance preparing for AI workloads, but at the same time running their day-to-day mission-critical applications. So let's switch gears and talk about how Intel is simplifying the deployment of intelligence at scale. It's undeniable that enterprise infrastructure today will have to evolve to keep up with the AI demand. Recent research forecasts that AI inference workloads are expected to become 40% of all data center power demand, and much more than they are today. So we have these 2 paradigms where we have the foundational data centers keep on running their traditional workloads, but at the same time, they have to figure out ways of building their infrastructures to serve intelligence at scale. And this is where Intel and Xeon 6 Plus come in. Now, up to now, training split the data center into 2. So on one hand, we have CPU-led enterprise infrastructure, and the other hand, we have GPU-heavy AI factories. And that was a very clear divide for a while, right? And we've all been accustomed to that reality. But as agentic AI moves into real workloads, data, tools, governance, the needs change. The next wave is not just about training models, it is about putting AI to work. So let's look at why agentic AI changes the infrastructure equation. The way AI inference works is straightforward. We take a prompt, it gets fed into an LLM, where it spends most time reasoning about the prompt. And we've all seen this, we've done this thousands of times. And out comes an answer. In this case, a lot of time is spent computing the large language model, which is mostly GPU and compute intensive. Now, the way agentic AI works is radically different. It's given goals rather than prompts. So we all seen the different types of loop that people are running on this agentic AI. It's also very iterative in nature, but also prompted by automation. And thinking, planning, acting, and reflecting are a natural way of these agents interacting with us. As it works, it uses tools, reads and writes files, checks rules, and other aspects that were in the traditional realm of CPUs and x86. And then for each step, the type of underlying compute needs is very different, and we'll show that in a bit. This is particularly important as agents scale up their work, spawning new agents that work concurrently. And the category and the complexity of agents are going to be very different depending on the complexity of the work. That's the main reason that there's such a rapid increase in CPU demand. For agentic AI, the CPU orchestrates the show. Now, what we're seeing is, we're also seeing the balance and the ratio of 1 CPU to 8 GPU and more is coming much closer to parity. So let's take a look at a real example. John?
Thanks, Gabor. You talked about how agentic AI is changing the compute requirements. Let's take a look at a real example. I have a traditional AI inference setup on the left-hand side of the screen. Let's send a request. Write a Python function that calls an OpenAI compatible chat completions API. The model gets the response, generates code, and sends the request back. Take a look at the slider on the top of the screen. GPU dominates nearly 7-to-1 GPU heavy. In contrast, let's take a look at an agentic AI system. Across the top, look at the pipeline stages. Green is GPU work, blue is CPU work. Linting is happening on our Xeon 6 Plus processor with efficiency cores. Web fetch and compile is happening on our Xeon 6 performance cores. And unit testing is coming back and running on our Xeon 6 Plus efficiency cores. The right class CPU for each stage of the pipeline. Take a look at the slider across the top again. We're near parity, but CPU heavy this time. What's this look like when we multiply that by millions of queries a day? As you mentioned, each Xeon 6 Plus processor has up to 288 cores. That's 576 cores per 2-socket server. When we look at that from a rack scale perspective, that gives us over 36,000 cores per 32 U's of compute space.
Thank you, John. Wow, this is pretty amazing and some data to ponder on.
This is awesome.
By far, the density of CPU we showed has the highest density per rack ever. But also, looking at the number of agents, these are the new metrics that are emerging. We can safely say that that particular rack can run up to 150,000 agents. So good news to all the CIOs in the audience. Now your very expensive GPUs can see more utilization because of our solutions. Now, both Xeon 6 with P-cores and E-cores are built for intelligence at scale. There are different cores, of course, but we've seen the workloads that require very high-performance cores pushing the frequencies, but also there's a need for very high-density, power-efficient cores. So we've seen all the workloads, we run all the analysis, and we are delivering these solutions to all of you. Now, having said that, we are working with our customers and partners to make sure that each solution is tailored to your needs. So I'd like to welcome Lip-Bu back on stage to talk about the server and rack scale solutions that our partners are working on. Thank you.
Thank you, my friend.
Thank you. Thank you.
Thank you, Kavok. It is great to see the momentum in the data center. As we look forward to see that is for intelligence at scale. Discrete compute alone is not enough. Our customers are asking us to think of system level to help them serve real agentic workloads at scale. It pushes us to rethink how we deliver our compute beyond the socket and to the rack. That is why we start the initiative called Rack Scale Blueprints, working with ecosystem partners to develop rack scale blueprints built on open standards, so customers can rapidly scale their intelligent infrastructure with confidence without proprietary workarounds. Behind me, as you can see, 2 examples of these blueprints. One is for agentic performance based on Intel Xeon 6 with P-cores. The other is agent density with the Intel Xeon 6 Plus with E-cores. We are working closely with our partners ecosystem, including Foxconn, SambaNova, to expand our rack scale offering. Let me call on stage one of our partners, Chief Product Officer of Foxconn, Jerry Xiao, to talk about how we partners on rack scale solution.
Thank you, Lipu.
Thank you, Jerry.
I'm so excited to be here today. Wonderful product and amazing event.
Jerry, Intel and Foxconn have been working together for many decades, and Foxconn has been instrumental in driving technology innovation in Taiwan and around the world.
Yeah, that's right, Lipu. I'm proud of the work we have done together, from AI servers to data centers and to edge computing all together.
And today, we're excited to announce the next step in our partnership. Intel and Foxconn are working together to develop rack-scale products built upon Intel Xeon processors. Together, we will focus on exploring the development, integrations, and commercialization of differentiated rack-scale AI infrastructure solution, leveraging complementary architecture to address diverse AI workload requirements.
Yeah, together, we will continue to deepen and expand our partnership, unlocking new opportunities ahead. Through this collaboration, we will deliver system-level AI solution to our joint customers, enabling more integrated and scalable computing environments. This marks an important step ahead, and we look forward to unveiling more in the near future. Thank you, Lipu.
Today is an exciting milestone for our continued partnership with Foxconn. Jerry, thank you for joining us.
Fantastic. Thank you for having me.
Thank you to the many partners in the audience today that is helping to bring this rack-scale vision to life, providing choice through the ecosystem power. We do not believe one-size-fits-all approach for intelligence centers. Each enterprise will run unique workloads, so their infrastructure needs will also need to be unique and purpose-built, as you can see from the screen here. Just look at the server in front of me. This is a whole series of partnership we have. Intel is working with a lot of partners to provide servers rack-scale solution designed to fit your existing infrastructure ready for AI at scale, as you can see in front of you. We see token usage exploding. Agents now consume 1,000 times more tokens than single event reasoning. In addition to building the best CPUs, it is critical that we deliver compute solutions optimized for token consumption and token generation. The bottom line, AI at scale will require heterogeneous computing. To this end, Intel recently announced a partnership with SambaNova. To talk more about this, let me call to the stage founder CEO of SambaNova, Rodrigo Leong. Rodrigo, welcome to joining me today.
Thank you, Lipu.
And over the next few months, we have announced few updates on our joint development partnership. Can we talk a little bit more about the work that Intel and SambaNova are doing together?
Absolutely. We've been busy. Earlier this year, we announced a multi-year collaboration to deliver high-performance, cost-efficient AI inference solutions based on Xeon infrastructure. We've been building something really special and excited to show you today. This is the SM50 Samba Rack we announced earlier this year, rack-scale AI infrastructure built for agentic workloads. It uses Intel Xeon 6 processors with SambaNova SM50 RDUs and shipping to customers later this year. Today, we're also excited to demonstrate the world's first heterogeneous disaggregated inference using SambaNova's RDU with Intel's CPU and NVIDIA GPUs. What you're about to see is the same prompt, the same model running side by side, 2 different stacks. So the one on the left is GPUs, RDUs, and CPUs disaggregated inference. And this one on my right is GPUs on their own. They both get fed the same prompt in the same model, just different stacks. The disaggregated inference stack is taking off, and what's happening here is you have the Xeon 6 processors doing all the tooling execution, you have SambaNova RDUs doing the decode and generating all of the tokens, and then you've got the GPUs performing the prompt caching and the faster prefill, reducing overall time. When all 3 chips are working together, you dramatically reduce the end-to-end latency and the agents for the fastest need for agentic AI. And the other side, the GPU stack, is still working away. So the initial result of our work is disaggregated inference is the GPUs, the RDUs, the CPUs, that's the fastest. And artificial analysis and our test found to be 2 to 3 times faster than just the GPUs alone. And this gives us an early look at how fast this can be.
Rodrigo, the most exciting part about all this is that we have tremendous customer interest in these solutions.
Absolutely. So let's see who comes next. So we'll turn it back over to you.
Thank you so much.
Thank you.
To continue this conversation, I'm delighted to invite my good friends. Robert Smith is a Vista Equity Partners Chairman, CEO, and the partners, and Roger Smith, to tell you more about how they plan to use these racks from Intel and SambaNova. Robert?
Great, thank you. Lippo, good to see you.
Same here. Thank you so much for joining me.
Pleasure. Thank you, my friend. Thank you, my friend.
Yes. So, Robert, AI is driving huge demand for computing, and it is reshaping the silicon system software and all at once. What are you seeing and hearing from the enterprises that you work with?
Yeah, first of all, I'm excited to be here at Computex to join you at this wonderful event. For us, it's been quite incredible. There's been a huge focus right now to bring AI to enterprises around the globe. We want to make it usable, we want to make it impactful for the organizations that we work with. We have over 90 portfolio companies, and well over half of them have now have converted to agentic solutions. And with over 750 million users of our software, that really translates to over 10 billion agents. That's why we've launched Vector Core Computer, VC2, with our partners at Cambium Capital, to offer the world's first commercially available architecture for disaggregated inference. This novel agentic neocloud is built to deliver the fastest enterprise inference throughput of any architecture to date. The demo you just witnessed with Rodrigo was conducted live in our Los Angeles data center. We have over 50 deployments planned in the US, which are targeted to convert existing data centers to inference data centers.
This is very exciting. And as we saw from Rodrigo a few minutes ago, we are already starting to see strong momentum for these offerings. Can you talk a bit more about how Intel, Vector Core, Compute, and our partners like SummerNova are bringing this aggregated inference to life?
Of course. I'm excited to share that first, Together AI is the first commercial customer and is excited to use this architecture as a service to accelerate inference workloads. We expect many of our enterprise software companies and their customers to quickly follow as the demand for inference keep growing, and it is more efficient than anything they previously have had access to. Most critically, VC2 is built and utilizes the SummerNova stack, which is an air-cooled data center. We believe it will deliver what enterprise customers and communities are asking for, which is reliable, low latency, low-cost inference at scale. Partnering to advance AI is one of the best ways to develop this transformational technology, making it usable and economically viable for enterprises worldwide.
We are excited about that. Thank you for joining us today, and delighted to have you here.
Always a pleasure, Lip-Bu. Thank you. Congratulations. 14 more months. We're excited to see what you're doing.
Thank you.
Thank you.
As you just saw from Rodrigo and Robert, picking the right silicon architecture for your needs is critical. For enterprises today, there's a broad range of architectures to choose from. As large workloads increasingly become strategic assets for companies, they are increasingly looking for silicon built around their exact needs. Next, I would like to invite Srini, a semiconductor design veteran and a leader of our purpose-built silicon team, to talk more about the work we are doing in this area. Srini.
Hi, Lip-Bu. Thank you. Thank you so much. A very good afternoon to you guys. Purpose-built silicon it is. This has been a journey that the industry has been using almost for the last decade or so, and especially the hyperscalers have tapped into this to its full potential and shown us the benefits in every way possible. Lip-Bu, last year you challenged us to see, in this space, given the fantastic assets and the breadth of assets that we have at Intel, how could we be relevant to this? Not just be focused on the stuff that we do internally, how do we bring this out to the external world and do something more? With that said, we had a proposition, we've been working on it, and today I'm very happy to share a couple of good outcomes that we have. The first on the hyperscaler side, we have Google and Intel have gone into a partnership wherein Intel is delivering what's called as the infrastructure processing unit. I would call it Intel processing unit actually. But infrastructure processing unit, which is a piece of silicon very vital for hyperscalers' performance, and the journey continues. And by the way, this is a deployment today, so it is not just something that we're doing, but it's already designed and being deployed. While this is working on, Intel as a company has been pretty active in the telco market, and in this telco market, another marquee customer, Ericsson, has been partnering with us, and Ericsson chooses us wherein we deliver, or Intel delivers, the next generation infrastructure silicon at a global scale for them across the board. This just gives you a very sneak preview at the highest level to see the kind of work that's happening in the purpose-built silicon space, which is a very exciting space, and more importantly, a high-growth space. And I was just thinking, what better place than Computex and Taipei, where custom silicon really is the name of the game here, to announce that Intel has officially entered this market. So looking forward to working with many of you guys and see how we can be relevant to some of your aspirational goals in silicon. Okay? Thank you, Lip-Bu.
I'm super excited about all these partnerships that you announced, and more to come.
Yes, absolutely more to come. Yes,
thank you so much.
Thank you so much. Thank you.
The work Srini and the team are doing with purpose-built silicon is really important. I'm super excited to be partnering to build custom silicon with many leading-edge companies, as well as some of the most dynamic startups across the industry vertical. I would like to highlight some of this partnership today. One of the most exciting areas where we can deploy advanced silicon is biomedical engineering. For years, emulating the functionality of the human brain has been the holy grail of computing. One company that is in the forefront of brain-inspired computing is Echo Neurotechnologies. Let us hear more from Eddie Chen, founder CEO of Echo Neurotechnology, and also one of the world's best neurosurgeons.
Hi, I'm Eddie Chang. I'm a neurosurgeon at UCSF and co-founder of Echo Neurotechnologies. For decades, AI has been brain-inspired, meaning borrowing ideas from neuroscience at a distance. Neuromorphic computing has carried that vision the furthest. It built silicon around the brain's core principles like spikes, sparse, communication, memory, and compute, all in the same place. That architecture is right, but what's been missing is direct evidence of how the brain actually performs the computation. That's now within our reach. For the first time, we can study how the human cortex computes language in real time at the resolution where computation actually happens. This opens a whole new possibility. Algorithms that are not just brain-inspired, but new ones that are trained on the brain activity itself, measured against the brain itself. That's the shift in our collaboration with Intel. Together, we're developing brain-trained algorithms for streaming speech that approach the efficiency of biological computation. The payoff runs both ways. AI that's faster, lighter, and closer to how we actually think, and new tools to restore speech to people who have lost it. Together with Intel, we're building AI that learns from the most powerful computer ever discovered, the human brain. We're excited about what's ahead. Thank you.
Thank you, Eddie. I'm amazed by the work you're doing. I'm confident that our work together will help lay the foundation of highly efficient AI computers in the future. Another company doing work at the cutting edge of biology is Greenstone Technologies. We are partnering with Greenstone to establish scalable reference architectures applicable across the broader life science imaging ecosystem. Dr. Joseph Wu is the head of cardiology at Stanford and the founder CEO of Greenstone. Let's hear from him.
Hello, my name is Joseph Wu, and I'm a professor of medicine and director of the Stanford Cardiovascular Institute, as well as the co-founder of Greenstone Biosciences. Thank you so much for including me in Computex. Intel and Greenstone are working together to speed up the development of new medicines. Our partnership combines state-of-the-art human genetics and biology from Greenstone with advanced AI computing from Intel so that we can scale data processing, storage, and analysis. Greenstone has built the world's largest biobank of human-induced pluripotent stem cells. From just 10 cc's of your blood, we can make your brain, heart, liver, kidney, gut, and any type of organoids in your body that are genetically identical to the patient. This will then allow us to test existing and new medications more quickly and at a lower cost. I believe the combination of human biology and AI computing will help shape the future of biomedicines in the next decade. And this is why we're so excited about the partnership between Intel and Greenstone Biosciences. Thank you very much and enjoy the event. 谢谢大家.
Thank you, Joe. I'm amazed by the work you're doing, and I'm excited about the potential of our partnership. Another key partner is Hitachi. They have a wide range of capabilities that help accelerating our work, our plan around foundry tools and quantum computing system. Let us hear from Hitachi CEO, Tokunaga-san.
Hello, Computex. I'm Toshiaki Tokunaga, CEO of Hitachi. For decades, Hitachi and Intel have worked together to solve key challenges for society. And today, we are bringing our strength even closer. By combining Intel's advanced computing with Hitachi's industrial strength in the physical world, we will create intelligent solutions that will benefit both businesses and society. Thank you, Lip-Bu. I look forward to our future together.
Thank you, TT. We are really looking forward to working with you. Finally, if you look at, we have the brains-inspired computing, biomedical medicine, and then energy. The last one is industrial automation. Finally, one partner I would like you to hear from is known for their pioneering work in industrial automation. Let us hear from my very good friend, Roland Busch at Siemens.
Hi, Lip-Bu. As a customer of Intel, we all know that global semiconductor demand has hit a high record. In 2023, Siemens and Intel already joined forces to meet it. And now we are taking our collaboration to the next level. We are expanding our partnership across the entire value chain, from design to manufacturing to chip applications in Siemens products. We improve design quality through EDA automation and software solutions built with agentic AI. We partner on all areas of the manufacturing process, including product lifecycle management, automation, electrification, quality, and sustainability. And what makes this even more relevant for us, the chips created in this value chain will be used in our own Siemens products. Looking forward to what's coming up.
Thank you, Roland. We are delighted to expand our long partnership with the Siemens groups. I'm looking forward to disclose more about this partnership in the coming months. And we are working with several other partners to keep pushing the boundary of what is possible. I would like to close by returning to where we start our conversation. The opportunity for Intel and for our partners is immense. PC, edge, agentic, physical AI, data center, and emerging intelligence center, from silicon to SoC to system and applications. This opportunity is only made possible by all of you. Look at the list. And the largest ecosystem of partners, suppliers, and customers. Intel is an iconic company. We laid the foundation of modern-day computing. And we're proud of our heritage. But we do not want to rest on our honors and glory. A year ago, I joined as a CEO. I challenged my team to work with me to build a new Intel. That is exactly what we are doing. We are not incumbent by the past. We are building something wonderful. It has been a year of transformation for Intel. We ramped our 18A to high volume with multiple products. We are executing well on our advanced packaging milestones. We make tremendous progress on engaging customers and building our foundry business. We introduce new SoCs for all major compute platforms, from premium mobile to high-density cloud and 5G. We are rebuilding and strengthening partnership across the ecosystem. We are double down on creating new business opportunity across existing and emerging domains. We are working at the forefront to reimagine computing and make it highly efficient for the AI era. And this is just the beginning. I'm super excited to continue executing at hyper speed.
Before the lights go out, the race begins. From simulation to strategy, performance begins with compute, with electrons that power pace, and data that backs decisions. The race never ends. Engineering never stops. Intel, official compute partner in McLaren Racing.
Ladies and gentlemen, this concludes the Intel Computex 2026 keynote. Thank you for joining us this afternoon to witness the future of technology. We look forward to seeing you again at future Intel events. And please don't forget your personal belongings.
This was cool too. I was wanting more from them, but let's get back to my emails, capture Python profiling, extra body, DCP supports hybrid attention, CPU offloading, KV offloading, KV cache allocation, PP aware handshake aggregation, ZP550, migrate MOE WNA16 method quantization, VIT chronograph, torch compile, Quen, engine crash on concurrent image requests. Go here too. So this is happening from June 15th to 19th. Mooncake Store KV events. Upgrade Torch XPU to 2.12. Multi-group distributed. DeepSeek Mega MOE. This is Crafter. On scaling of PEFT. Towards million-person models for trillion parameters. This is from Mind Lab. Scale up, scale down, scale out. There's maximum probability distribution on Moonlight 16B A3B and Quen 3 30B A3B. You can see the mean rollout probability difference. Yeah, cool. So this is a kind of a PEF-based reinforcement learning. And in the post-training steps, the rollout and training, they are doing Standard deviation of the rollout probability is mean rollout probability difference and maximum rollout probability difference per step. Training stability, PPOKL, and training stability of gradient norm. Metric original packed effect. This is multi-rollout served in Minty. This is VLLM and LoRa merge, full time tuning, mini T, multi LoRa. Start from the top again. Deep Sick V3, give me K2. Model politics score mean gain my rank. This is the middle and low ranking regions. Quite good analysis, like they have gone through the batch sizes too, the seed level reliability, and the rank of the LoRa's, as well as the mean best separation, low token, and the training steps that are required here. This is the memory, the compact online memory state. Attention computation, the backbones. This is the memory and the writing granularity. So this memory paper is quite famous too. Like, you guys need to go through this. Let me add it to my Mendeley. Now this is also by Minds Lab and Declare Lab. So they had this memory mechanism that arguments a fully frozen attention backbone with compact online state of associative memory, enabling historical information to be dynamically maintained and directly coped, coupled with backbone's attention computation. And they show this, and they did benchmarking with memory heavy tasks such as memory agent bench and locomo. These are the memory projections, the qt, kt, and vt. These are the three vectors to corresponding to reading and writing the memory. Query Q are the queries, while kt and vt describe how current information should be written into the state. And this is the retention gate, the write gate, and retention gate. And this is how it came into play. Okay, now getting back to this research. With context distillation, writing context gain into parameters. Good research. They have gone into multiple different directions and into this direction too. Diversity and sample noising. Infrastructure for populations. Three axes need a system layer, policy identification, training worker, overall worker, scale down. Mm, 43 pages. This is a multi-agent harness for editable scientific figure generation from diverse inputs. So this is a harness-based approach to scientific figure, and the benchmarks look good too. What was the okay on based on archives, papers, CVPR posters, and highlights and awards, iClear and Lillian Log beats blogs, Lillian Weng's blogs. These are the mass completions that you can see. You can see the skeleton, the layouts and icons, the removed text plus arrows. Sketch condition generation. These kind of look good, but I do not know the edge cases on which this will fail, because since the data is too low that they have fine-tuned on, I don't know how much reasoning it aligns itself with. This is from the infographics and the sketches. I think so you guys can see. This is theirs versus. So what the scoring mechanism is, I don't know. Here they are giving themselves score of 9.2. Nine dot three. 7.47, 9.3. Dot 27, 9.3. Dot. Well, this is the ground truth, and this is what the mismatched and conditional inputting dropped panels, infill, mismatch infill, and skeletons. Okay. This kind of looks cool, but I'm not too sure about the numbers, like how they have benchmarked it. There are other papers too, but I will take a look at them and researching towards that particular direction. Because if I give all my time here, I won't be able to get through everything which I have planned. I think I've gone through this end-to-end security and the age of agentic AI. No need to repeat that. ALM, Triton JIT modules. Flash info. Transformers V5. Claude 4.8. This is daily dose. Surya OCR, Collapse CRM. Workflow columns, chaining columns, training it further. Cache TP slicing and mapping redesign. Yeah, so this is kind of like cool too. On the distributed systems, how will the tensor parallelism kind of work here? Refactor. This is from any scale. This is with respect to any scale on Azure. And 305. Plus tensor, FP4. Microdose. We've used MOE auto tune. Aksha invest $10 billion in Alphabet. Oh, damn. Aksha Hathaway is to buy 10 billion worth of shares at roughly 6% discount from the Monday's closing stock prices. Now these are the design award winners of Apple. Let's take away one view.
You want it, I shot it, get on it, I got my hand enough, spending a lot.
Telework. Playful app, meatballs, blippo, games, inclusivity, guitars from India. Fine Hearts, NBA games, innovation, blueprints, interaction, moonlit, phase tracker, Sago Mini, Janata Garden, social impact, consume me, tide guide, against cyberpunk. Cool. So these are the Apple Design winners. This is the webinar. Lambda. Multimodal data processing. Sumant. GitHub, GitHub's plan for AI agents. We'll be analyzing that too. I've gone through the emails. There was somebody from UK and US who was trying to send me to. Yeah, this is the guy. I don't know how many times that they have. I've added it to the task. Let's go through the Google I/O videos now. And I think so we reached on the 60th video in the series. This is build intelligent Android apps with Google AI.
Let's get started. My name is Jolanda Verhoef, and I will be joined later by my colleague Thomas. Our approach to AI on Android is based on 3 core pillars. So first of all, the Android operating system is evolving into an intelligence system, and you can expose your app's capabilities to that system. Second, you can bring intelligence into your app using cloud and on-device models. And finally, you can use developer productivity to use intelligence to build your apps. Now, together, these 3 pillars represent our commitment to embedding intelligence throughout the Android ecosystem. And while all 3 of them are crucial to the future of Android, today I want to focus on this middle pillar. So together with Thomas, we're going to make sure that you learn everything about in-app intelligence today. Now, if you want to learn more about the other 2 pillars, you can watch What's New in Android to learn more about the first pillar, the intelligence system, or you can watch What's New in Android development tools if you want to learn more about developer productivity. Now, for today, we're going to, at a high level, cover 5 different areas. So I will start with on-device inference, and then Thomas will be here to talk about cloud and to talk about hybrid inference, and I'll be back again to talk about agents running in the cloud and how you can connect to them. And then finally, we'll have a sneak preview into running agents on device. So how are we going to talk about those? Well, what we want to do is we want to take a travel app called Jetpacker, which our team has been building over the past weeks/months. And we're going to start with a very basic travel app. And throughout the talk, we're going to make that more personalized, intelligent, and agentic. And so right now, the app already looks quite nice, but it isn't yet using the newest intelligence APIs. So I actually have the app running on my device. So without further ado, let's have a look at it. So let's have a look. We should see my phone. There we go. And as you can see, we have the Jetpacker app running there. So let's open it up. And you can also see in the right top of my screen that I'm actually currently in airplane mode, so I don't have any internet connection. And as you can see, I have my current California trip right here. We can look at our upcoming trips. I'm going to Ireland later, and then later this year I'll be in Paris. And we can have a quick look at our past trips as well. So here we have an overview of all our trips. We can go to our itinerary screen to have a deeper look at what each of the days looks like. And then we can also go to the detail screen as well. So far, so good. Basic app, but it isn't yet using any form of intelligent APIs. So let's go back to our slides and have a look at the first feature that we want to build. So during today's session, we're going to walk you through not one, not two, but 7 different intelligent features. And so I think we should just get going with the first one. So for our first feature, we're going to look at our itinerary screen. We know from our users that that screen can actually be quite overwhelming, especially when you have a long trip coming up. There's a lot of stuff happening. So what we want to do, we want to create a card at the top of the screen that summarizes the upcoming trip, and that includes some information on how the user can best prepare for that trip. So for this, what we'll do is we'll access a model, and we'll give it some input, and we will get some output. So in this case, we will give it the full trip itinerary, and then as output, we will get a short summary, and we will get some tips on things to pack and phrases to learn. So this setup is actually a great candidate for using an on-device model. It has shorter input, it has shorter output, making sure that that on-device model can run really fast. Now, when you use an on-device model, of course, you have no additional cloud inference costs. And we don't have to worry about internet connectivity, since the model is going to be consistently working even when we have spotty internet or if we have no internet connection at all. And given that we're traveling, that's quite a nice feature to have. So if we're going to want to build with on-device features, we're going to have to use Gemini Nano. Gemini Nano is Google's most efficient model that is optimized for mobile devices. We first introduced Nano a few years ago, and by now we have over 140 million devices running versions of Nano. And our latest version, Nano 4, is based on the same architectural foundation as the recently released Gemma 4 model, and then got further optimized for maximum battery and performance efficiency. Now, Gemini Nano 4 is coming to consumer devices later this year, but as a developer, you can already preview and prototype with it. And so for today's demos, we're going to use Gemini Nano 4 for our use cases and show you how capable that model actually is in a whole range of different scenarios. So let's dive right into our code using the MLKit GenAI prompt API. This API gives us access to that Gemini Nano model that runs on device. So with this API, we simply take our trip itinerary, and then we add it to our prompt, and we ask our model to generate a summary of our trip, along with tips on preparing for the trip. Now here what I did is I just wrote a prompt myself. I just sat down, thought, what would I ask this model? And that's great, but we kind of want to iterate on that. It's always good to kind of test out a prompt before you bring it to production and kind of see how you can make it fit well with your use case. So let's switch back to our phone and let's do just that. So in order to do that, I'm going to actually close my Jetpacker app for a second, and I'm going to go into the AI Core app. So as you can see, there's an app here that's called AI Core, and you can get that app if you join the AI Core developer preview. So this is not something that every Android user sees, but if you join the developer preview, you get access to this app. It is available on all devices that support AI Core, and if you don't have a physical device with that model running, what you can do is you can actually also go to Android Studio, and you can use the Gemma 4 model there. So let's have a look at the AI Core app. As you can see, we have Gemini Nano 3 there, but we also have Nano 4 Fast, and we have Nano 4 Full. So here we can choose which of the models. Now, I already downloaded them, just to make sure that this talk isn't taking an hour on this Wi-Fi. So let me open the Fast model and have a look. So let's start with the prompt that I thought of myself originally. So I just copied it over, and I put in my Paris trip. So when we do this, as you can see, this is generating a response, but it's generating quite a long response, right? This is taking quite some time. There's a lot of information, and we were trying to make things easier to parse for our users, not more difficult. So we want to make sure that we're not spending this much time generating this much text. So this is where we start iterating. Now, I did some of that iteration, and I actually came up with the final prompt that might be useful for you, for us to look at. So here, what I did is, let's first take a look. We got a very fast response. And as you can see, I added a little bit more kind of guiding for the model. So I told it to use 1 sentence, less than 15 words, etc. And this is kind of a good way to guide the model into the response that we actually want to have. And with that, you could see that it started immediately generating a response, and it took only, 1.6 seconds to generate it. Now, let's have a look at that in our Jetpacker app. So I'll go back to the app. I'll go to my secret debug menu, turn on the feature, and I'll go to my upcoming Paris trip. And pay good notice, because this is going to be fast. So there we go. We immediately have it coming up. Amazing. Let's switch back to our slides. With that, we can mentally prepare for our trip, and we can move on to our next feature. And for me, if I'm traveling, one of the things that I really don't like to do that much is budgeting, and is managing how much I'm spending on souvenirs, on food, on all those things. So I usually end up with like a whole bunch of receipts that are all in my backpack and in my pockets, and then I have to sort through and tally all of them. So for such a tedious task, wouldn't it be nice if we had AI to help us with that? And since receipts might contain sensitive information like credit card numbers and addresses, this is another great use case for using an on-device solution. So users can be confident that private information will actually be processed locally on the device without any of their data being sent to the cloud. Nano 4 excels at multimodality, and so this especially includes image understanding for tasks like OCR and visual data extraction. So naturally, it will excel at extracting information for our receipts as well. So let's have a look at how this works. In our last example, we only passed in a text prompt, but in this example, we'll pass in both a text and an image to be processed. And then for our text prompt, we will specify that we want 3 pieces of information here based on the receipt. We want to generate a title, we want to get an amount, and a category. And to make sure that the returned result is consistent, we'll also tell the model that we want it to return a certain JSON object. So let's see this feature in action before we continue with the slides. Let's go to our phone, and let me quickly turn on this extra new feature. I have to shake my phone in order to go to the debug menu. There we go. I'll turn on the expense management, and I'll go to my current trip. So we'll go to the California trip. And actually, this morning, I was very, very tired because I'm from the Netherlands and I got a jet lag. So I got someone to bring me a coffee, and I actually got the receipt. So let's take an image of that receipt. So I here have my expense menu. I already went for dinner. I already did some stuff while I was here in San Francisco. But now let's take a picture of our receipt. Here we go. Say hi, everyone. Yay. And let's take a picture. There we go. And this is taking a little bit longer because for this I'm actually using the Gemini full model. So you saw that we had a fast and we had a full model. And in this case, we want to have that full image recognition, so we're using that more complex model for us. And as you can see, it recognizes that we did an espresso blend purchase, which was $5.94. That is correct. Amazing. Cool. Let's go back to the slides. I'm always so happy when demos actually work. This one was the scariest one, but hey, there we go. And as you saw, this is already working pretty well, right? But you might have noticed that we had to explain to the model what kind of fields that we need, and we had to give it a JSON example of what that then actually looks like. And then after we wrote that whole prompt, we then had to go and parse the return data, which we hope is at JSON, into a data class that we can use in our app. This is a lot of manual steps, and all of those manual steps can go wrong. So it's kind of scary. And this is why we're introducing a structured output API. This API is going to land soon, but let me give you a quick sneak preview into what it will look like. So with our structured output API, we can mark any data class as generable, and then we can further describe the class using guides for each of the properties. So these annotations basically guide the model and tell it what kind of data it should generate. If we do this, we can actually now, for our request, simply simplify our prompt. We don't have to guide it anymore there. And then we can use a method called generateTypedContentRequest that takes the parsed receipt class name to restrict what the expected output should be. Let's make sure I don't lose my receipt. And now our response simply contains this parsed receipt instance, or it will return null if it wasn't able to find one. So with structured output, we can be more confident about consistent outputs, and our code is much, much simpler with Kotlin data classes that integrate seamlessly with the Android code base. Now, during this talk, we prototyped some pretty cool features with on-device APIs using the latest Gemini Nano 4 preview model, but this is just the start. We already have seen lots of apps using the prompt API in production to leverage the power of Gemini Nano for use cases such as classification, summarization, content inspiration, those kind of things. If you want to learn more about how you can get the latest in on-device Android, you can check out this talk, where we are going to go more in depth on how you can ship on-device use cases to production. Next, I will hand it off to Thomas, who will walk you through the next couple of features.
Thank you, Yolanda. So yeah, Gemini Nano 4 is pretty impressive, and it's really exciting to see how on-device models are getting better and better every year. So we talked about Gemini Nano that is basically optimized to run on your Android device efficiently. But sometimes you have use cases that require an AI model that has either a greater world knowledge or a much larger context window, or sometimes even the greater abilities in handling complex tasks. So let's take a look at what we can build with these cloud models. So we are going to use them to build our next feature in the Jetpacker app. So we are going to build a museum assistant. So it will be a chatbot that is powered by Gemini Flash and enables you to ask questions to plan your next visit to, let's say, Le Louvre Museum in Paris. So first, you need to add the Firebase AI logic to your project. And once you do that, with just a few lines of Kotlin code, you can directly call the Gemini models that are running in the cloud. You will start by instantiating a generative model, and you will pass the specific version of Gemini that you want to use. And then you basically just have to call start chat to create a chat. And the cool thing about the SDK is that it will actually manage the chat history for you. So the communication between your app and the model is actually fully handled by the Firebase AI Logic SDK. There are 3 series of Gemini AI models that are running in Google Cloud that you can use. So there is Gemini Pro, which is really good for complex tasks. There is Gemini Flash, which has a very low latency. And there is Gemini Flashlight, which offers a really good intelligence-cost ratio and also has a very low latency. So we want to build a chatbot that is really knowledgeable about the museum. And earlier I mentioned that cloud models store massive amounts of world knowledge. So you can assume that Gemini already knows quite a lot about Le Louvre, but it doesn't necessarily know everything there is to know about it. So for example, if you ask the model about the current temporary exhibitions that are happening at the Louvre, the chatbot will basically tell us to go to the website and search for it ourselves. So it's not super helpful. So what we can do to prevent this is use a technique called grounding. So in the context window, which is the full input that is passed to the model, we are going to add some relevant content to help the model answer the user's query better. So grounding techniques are also used in the context of retrieval augmented generation, or RAG. So you can implement it yourself, but we also made it easy for you with the following APIs. There is URL grounding, which enables you to use a document at a specific URL. There is Maps grounding, which uses the data from Google Maps. And there is web grounding that is using real-time web data. So let's see how we can use them. We're going to start with URL grounding. So let's imagine that you want to prioritize some data from a specific page that is hosted on the web. So you will start by adding the URL context tool to the list of tools when you instantiate the model. And then in the user prompt, we will tell the model to look at the specific page at the URL to ground the response. And so you can see that here we are actually using the FAQ URL of the museum. So here we are only using one URL, but you can actually use up to 20 URLs per request. And so now, if we ask the chatbot about, for instance, criteria to get discounted tickets, for example, Gemini is going to actually use the content of the FAQ page to answer. So if I say, for example, if having a cat named Mona Lisa grants you a discount to get a ticket at the Louvre, you will see that basically the chatbot is saying no, and as accurately outlined in the FAQ, that is not enough to get a discount. If we want to give the chatbot the ability to retrieve some information from Google Maps, we can use the Google Maps tool. So that will, for instance, enable the chatbot to search for cafes or restaurants around the museum after our visit. So if after adding the tool, when I ask what are best restaurants that are good for children next to the Louvre, we will actually get a pretty comprehensive response from the chatbot. It will query the data from Google Maps and return a list of restaurants. And it's actually anchoring on restaurants that are clearly known for having a children menu. And so we can also use web search grounding to, for instance, let the chatbot search for more recent information on the web. So we now have a pretty competent museum chatbot to enable us to prepare the visits. And so the cool thing is that we built all of that with Gemini Flash and Firebase AI Logic. And actually, the Gemini Pro and Gemini Flash models are perfect to build, let's say, the first iteration of your AI feature. So whether you need multimodal understanding, JSON generation, function calling, or even image generation, you can quickly build everything in Kotlin without really needing any server code or any backend resources. And the cool thing is that if your feature actually doesn't rely on your own backend infrastructure, you can really go to production with it and scale it. You can use AI monitoring features in the Firebase AI Logic SDK. You can use server prompt templates and app check and basically scale to your whole user audience. And if you think about it, you probably already have some features in your app that are good candidates to use Gemini and Firebase AI Logic. So I strongly encourage you to look into it. So it's actually used already by hundreds of apps in production. So for instance, the Redbus application, which is a ticketing platform, uses the Gemini audio understanding capabilities to create a voice-first multilingual review system. It's also used by Carrot, which is a marketplace app that basically uses it to translate messages between buyers and sellers. Gratitude, a journaling app, is using it to suggest journal entries. And finally, UltraHuman, which is a fitness tracker app, is using it to build a logging feature, food logging feature using the Gemini image understanding capabilities. So a lot of interesting use cases. OK, so let's take a step back for a second. So we saw that many of you want to build with Gemini Flash and Gemini Pro using cloud inference. And earlier, Yolanda showed all the cool things you can build with Gemini Nano on device. But we also heard some feedback from you. You basically need to support users on devices that don't necessarily support Gemini Nano just yet. So what if we could just combine both, right? That's actually the promise of hybrid inference, and I think I have a really good use case for it. So reviews are a pretty key element in most Android applications today. So in your app, maybe you're asking your users to rate other users, or rate a business, or even a piece of content like, I don't know, a song or a show. And so you're often asking your users to basically write a review. Or sometimes you're even asking users to post a review for your application in Google Play. And it's important for you, but it can be sometimes tedious for your users. So we think Gemini Nano can actually be super helpful for that. But you also need to have this feature available on devices that don't support Gemini Nano just yet. So in the Jetpacker app earlier, the chatbot museum recommended restaurants. And so what if we were to implement a restaurant review feature in the app? So here you can see that we have a list of topics to choose from about how we basically felt about the restaurant. And we will let the model draft the short review for us. And the user is always going to be able to edit it later before posting it. So here you can see we are selecting some topics. And once we're done, we are clicking on generating the review. And basically, if Gemini Nano is available on the device, the review will be generated by Gemini Nano. But if not, it will default to Gemini Flashlight in the cloud. So it's completely transparent for the users, and it's also very easy for you to build as a developer. So to build this, we're actually using the latest API from Firebase AI Logic. So to do that, you need to add the on-device Gradle dependency to your app dependency to your project. And then, so you can see here that we basically generate a review with a prompt that is interpolating the selected topics. And then when we instantiate the model, you can see that we are passing an on-device config object, where we define the inference mode that we want to use. So here you see that we are saying prefer on-device, so we will prioritize on-device inference. So this API supports 4 inference modes. So there is prefer on-device, prefer cloud, and there is also only on-device and only cloud. And it's actually available today, so you can try it out, and you can learn more about it in the Firebase documentation. So we just talked about a very simple routing logic. Here it's basically 2 criteria. Is Gemini Nano available on the device, and is the device online? But sometimes you want to build something that is a little bit more complex. So you can imagine having a pretty advanced custom routing logic. So for instance, you can monitor the system health of the device, and you can decide to use a cloud model if, let's say, the CPU is overloaded or if the battery of the device is below a specific threshold. And another thing worth checking is also the latency. So if the latency is above a specific threshold, you can decide to focus on device. Another thing too to keep in mind is that not every single query requires a very advanced model running in the cloud. And some do. So it can be interesting sometimes to use a lightweight LLM, like for instance, the Gemma 3 model that is only 270 million parameters, to basically route those queries based on their complexity. And at the end of the day, I'm just listing 3 criteria here, but there are many other criteria that you want to take into account based on your app's needs, or also the user experience that you want to provide. So if we go back to the Jetpacker app, let's say that we now want to implement instant messaging translation for a chat feature between the hotel staff and the customers. So the customers and the hotel staff will basically use their own language to chat, and we'll use the AI for translation. So let's see how we can use hybrid here. So let's imagine that we want to prioritize on-device to save on inference cost. We also want low latency, so we provide a really real-time experience to the users. And we also want to make sure that we basically support as many languages and on as many devices possible. So we know that on-device translation capabilities are getting better with Gemini Nano models. But we also want to be able to fall back to the cloud if the model doesn't support the language. And so in this case, we'll use Translate Gemma, which is an open-weight model based off of the Gemma model that can be potentially fine-tuned if you want. And so here is the inference stack that we are going to use. So for on-device inference, we will use Gemini Nano models through the MLKit prompt API. And for the cloud inference, we will use Translate Gemma that will be hosted on Google Cloud. And we will also use the on-device MLKit language identification API that will be able to detect the language used in the conversation. So we will implement the appropriate routing logic based on the version of the model that is available on the device, the language that is used, and also the latency of the network. And so here in this diagram, we are basically implementing the routing logic in code, but there are already experiments to use AI to actually define the routing. And in a minute, Yolanda is going to show us how the agentic approach can help us with that. So let's see the translation feature in action. So let's say that I'm typing in Dutch, but I'm basically talking to a hotel in France, and the staff speaks mainly in French. So I will send my message, and I will receive a response that basically enables me to translate, using hybrid inference, translate the message in Dutch. And on the other end, the staff can also have the same setup where they can basically translate the message that was sent by the user to their language. And so here, the translation will either be on the device or on the cloud based on the criteria that we talked about before. It will be, again, completely transparent for the users, but we'll have a very high-quality translation feature that is running via hybrid inference. So this custom hybrid inference approach is already used by several applications in production. For instance, the Gboard app is using that. It's also used in the Pixel Screenshot application, and the Kakao Mobility app also started using it. And so with that, I will pass it back to Yolanda to talk about agentic systems.
Thank you, Thomas. OK, for our next feature, we want to take our app to the next level, and we want to connect it to our cloud backend. So we have a Jetpacker backend running in the cloud that is able to reserve flights, hotels, and activities on our user's behalf. Now, in our app, we simply want the user to be able to go to the booking screen and then automatically kick off that booking process. And it will automatically book all the things that that user wants to do. And then the booking process will be running fully autonomously. And our Android app is just showing the progress of all of these different booking agents working. And it will let the user provide input when needed. So before we show how we can build this, let's go back to the phone and look at it in action. So in order to run this, let me first turn off my airplane mode, because we have a backend this time around. So we have internet going on, I hope. And we'll open our Jetpacker app again, and we'll turn on the booking assistant. There we go. Now, if I open my current app, let's say, or my current trip, I can go to the booking screen, and I can start our booking. And as you can see, it is connecting to our booking server. Now, while this is connecting, as you can see, this is taking a little while, because I need to connect to this server that is running, that is doing a whole bunch of stuff. I do hope it will connect in time before the end of the talk. It might be that my Wi-Fi is not as strong as I was hoping it would be. Look, there it is. OK, amazing. So as you can see, what we did is we basically just sent our itinerary to that server, and it started up a session for us. And it's then kicking off all of these different booking agents for me. So it's kicking off 4 agents to run to book activities. So here I see like my lunch and my dinner and like all kinds of bookings there. Same for my hotel, and then the same for the flights. But all of those need some kind of information from me. So for example, let's say that for my SFO to Amsterdam flight, I will confirm that indeed that is the right time frame for me. I can confirm the selection, and I get to choose a chair. However, in the meantime, while all of these agents are running, if I'm not doing anything else, I quit the app, I go do something else, and I come back tomorrow, and I come back into the app, I can reconnect to that existing session. So now if I go back to my ongoing connection, as you can see, it will just reconnect, and it will like find all of those agents that were running, and if surely it should show all of them. It is, again, maybe not the fastest Wi-Fi here. But in the meantime, as you can see, it's still asking me, it still remembered where I was in the process, so it's still asking me for that seat number. So I can confirm that seat number, I can say I confirm my whole booking, and there we go. As you can see, I think my internet is fully out now, but this would normally show the full confirmation and we'd be done. There's not a full talk that you can do without having like one demo hiccup, right? So this is the one. I already assumed it would be the one where I'm actually using the internet. So this is why we have on-device inference people. OK. So before, Thomas was already speaking to you about Firebase using a managed backend. And this is ideal for getting started or when, as a mobile team, you want to develop in isolation. And it provides and focuses on direct client-to-model inference, which makes it kind of fundamentally stateless. And so for our trip booking, we instead use a custom self-hosted backend. This server, which we fully control and gives us full flexibility. And so when we book sessions, even when the user closes the app, that system can just continue running in the cloud. It also gives us complex multi-step orchestration, and because it's running in our own backend, it gives us access to our company's data. So how would we architect such a solution? Well, if we go and take it all the way back to its core, we basically have a cloud backend and we have an Android app. And they somehow communicate with each other. Now, we want that to be basically a server or a event-driven communication that goes both directions. So some ways of doing that transportation would be to use server-sent events or to use WebSockets. Then we have our connection set up between the two, but then what do we run in the backend? So we wanted to have a complex multi-agent booking system, and we chose to use the Google-built ADK, or Agent Development Kit, which is a flexible and open-source framework for developing and deploying AI agents. Now, for Android developers like you and I, it might be a little bit scary to look at backend systems, and it might be a little bit intimidating. But just to give you an idea, let's actually look at the implementation of the backend that we wrote. So we can define an agent by setting their name, giving them the model that they should communicate with, giving them an instruction, and then giving them a set of tools. That's all we need to set up like one simple agent using ADK. Then we can make a top-level orchestrator that can delegate work to several sub-agents. So here, for the restaurants, for the hotels, and for the museums, I'm making a bunch of different sub-agents. So when we have such a backend set up, there's one question that remains. It's running in the cloud. We have an Android app. How do we communicate? What kind of messaging protocol do we use? Now, we could be making our own. We could set up our own kind of communication pattern, decide what are the requests that we're sending, what are the responses. However, once you start adding more complexities to such a backend system, it can become quite unwieldy and difficult to deal with. So instead, we can use the AGUI protocol. This standardizes communication between agents and UI clients. So the protocol predefines a set of message types that have been designed to best represent agent-to-client interactions. So the agent can inform the client about, for example, its lifecycle events, text messages, tool calls, state management, etc. And the other way around, we can have our Android app that is sending text messages, providing tool call results, and sending custom events. Now, most agent frameworks have an AGUI adapter module. So that allows them to interact using that AGUI protocol. And similarly, there's also several AGUI libraries for clients. So for example, for Android, there's a Kotlin SDK that gives you a great Kotlin API to communicate with any AGUI-enabled backend. So as an Android developer, at that point, all that you kind of need to do is set up the connection to your backend, and then decide how you want to visualize those AGUI messages that are coming in from your server. So in our use case, we're parsing the messages that are coming in, and we're showing them in our nice UI. This is already quite great, but I believe we can do better. So if we're deciding, so the step 2 that we just mentioned, deciding how to visualize the events coming in, that is actually quite a lot of work and quite a lot of kind of like figuring out, right? It doesn't really scale that well, and there's some version dependency complexities, like what if my backend is updated, but my Android app is still older, etc. So what if instead we could have our app describe a set of UI components that it is able to render, and then let our AI model speak UI instead? So what do I mean with that? So A2UI is a protocol that allows agents to render UI in a client. It works really well together with AGUI as a transfer protocol, but the client simply informs the agent which components it can render, and then the agent that's running on the server decides what is the best UI components that I can use, the best tree, the best hierarchy, to then do what I want to do, or ask the user for input, or kind of like to reach my goal, basically. And as an Android developer, that means that the only thing that we still have to do is define our set of components, which might be composables that you already have in your app, provide them to your server, and then render them. So let's have a look of an example of what that communication looks like. You can see the component tree being passed from the server to the client to be rendered at a given point in time. And you can see that A2UI supports both basic components, like we have column and text here, but it also supports custom components. So for example, here I added support for a MyProgress spinner. You can also see that we're not actually passing actual data at this point. Instead, the server is just passing variable names. And then in a separate message, after it sent the components, it can actually give you data associated with those variables. So all of this is pretty cool, but at this point, we're just passing JSON, right? Like it's just JSON coming in, JSON going out. What does that actually mean? That's not UI on a screen yet. So how are we going to render that, specifically on Android, right? So on Android, we are currently building a Jetpack Compose renderer. It will allow you to automatically render those A2UI messages that are coming in from your server. This A2UI renderer has a set of basic components that will give you great out-of-the-box experiences, so you don't do anything special here. And when needed, you will also be able to provide your own custom components based on the composables in your app. So that's what we did in the app to constrain our model to generate our custom booking-related components. So now we can build beautiful UI and let the agent show specific components when, for example, we're choosing a seat. Now in our code, we create an A2UI message processor and pass our custom catalog to it. From the processor, we then retrieve active services. And in our UI, we simply retrieve the services that are coming in and display them in a column using the material A2UI service composable. So to summarize, we have AGUI on the one hand, which is our transport layer communication protocol, and it provides an event-based communication pipeline between agent and client. And A2UI is our independent protocol that helps an agent speak UI, which can then be rendered into native components on the client side. Now, A2UI is just message passing, and it works over any transport, right? So it could also use REST, MCP, A2A, or AGUI. Now we're at the start of these protocols, so please do give a look at a2ui.org to learn more and stay posted. OK, let's get to our final feature. So we already saw how we can connect to an agent running in the cloud. What if we want to instead run an agentic system on our device? Now, this is very early and experimental, but I did want to kind of give you a heads up of what we're thinking about and what we're developing and what we're moving towards as Android. So let's see if we can build an agentic system that hosts multiple agents that all communicate with each other, orchestrated from within our Android app. Let's switch to our app and quickly show it in action, hoping that the Wi-Fi is fixed by this point. So I'll turn the feature on. This is called the Genius Assistant, and our Genius Assistant is going to help us during our trip to understand what's going on. Now, it will first go to our cloud, and it will go and try to understand what's going on in the trip. So it passes the itinerary, and then it understands that I have a hotel and a car reservation. So let me check my hotel reservation. What it will do is it will actually understand that there's multiple agents running, and it can understand that it can transfer to our hotel agent. Now, our hotel agent is a sub-agent that runs on device, because I have my personal data running on my device as well. So I have some personal information here. I have my passport, and I have the hotel reservation, and the model will actually compare the two. So here there's multiple agents running, and I'll show you later how this is set up. But this is pretty cool, and we have a way to understand that for my hotel reservation, actually, I provided the wrong passport number. So there's a lot going on here, and I'll show you how that actually works. So let's go back to the slides and dive into it. So one way of doing this on Android is using ADK for Android. This is a brand new library. We just released version 0.1 this week, and it takes all the learnings that we had from ADK on the cloud, which we've seen in our previous section, and it applies them to Android. ADK manages all the complex orchestration, context handling, and error handling for you. It allows you to build an agent with just a few lines of code, easily swap out models, etc. Now, for our trip assistant feature, we first designed a main orchestrator that uses cloud intelligence. It then calls tools to get information about the trip, chooses to offload work to a sub-agent that we run fully on device, and then each of the sub-agents runs a set of agents in a sequence and shares the data between them. So we only ever return the final results to the orchestrator that are stripped of any privacy-sensitive data. So in our code, what this looks like is we have our trip assistant orchestrator, which uses a cloud model for its intelligence and has a set of sub-agents. And we give it a tool, as we saw before, and we give it some top-level instructions, so it knows when to offload to which agent. Then each sub-agent is defined as an on-device sequential agent. And we have various retrieval agents that can use the device nanomodel to retrieve the correct data from our user's document. Separately, we have that last validation agent that we saw that can compare the data coming in from those retrieval agents. And together, we have a whole set of agents set up with just a few lines of code, using both on-device and cloud, working to build something that is highly intelligent for your user. Now, as I said, ADK for Android is just starting, and we're looking forward to see what you build with it. Check out adk.dev for more. Now, with that, we completed all 7 features, and we made our app so much more useful. So while we're working on making the Jetpacker source code available to you soon, in the meantime, please go to developer.android.com/AI to learn more. And with that, thank you for joining, and have a great I/O.
Hi, Matthias. I hope you're having a wonderful time at I/O. I'm colleagues with Yuna and Bramus, who were on stage just right before me. And together with you all, I want to do a deep dive on one of the announcements we made on the developer keynote stage yesterday. Chrome DevTools for agents. In the next 20 minutes, I'll cover what it is, what it's useful for, and how you can get started yourself. So first, for those who are new to this, or new to the web track at Google I/O, welcome. This here on the screen is DevTools. It's what opens when you right-click in Chrome and then select Inspect. DevTools is what you'll trial and error around in to find the right combination of CSS properties to make your things look as splendid as in Jonas and Brahma's talk. In September last year, the same DevTools you know and love got a new UI surface, additional to what you'll get when you right-click and inspect. Chrome DevTools for Agents. Let's dive in. We're going to start with a general overview of what Chrome DevTools for Agents is, where it lives, how it relates to your other tools, and how your agent can use it. Then we are going to look at the foundational technologies that enable the capabilities of DevTools for Agents. Having a basic understanding of this will be the foundation to understand the actual capabilities and use cases. Before we look into the various configuration options, and finally, how you can get started. But first, we're going to do some time travel. I want to take you on a virtual trip back in time to the beginning of your career. Whenever this was. Maybe it's been a couple of months, 3 years, or decades ago. That doesn't really matter. Just try to think how it was as an absolute web developer beginner. For me, this was in 2014. This was me back then. That's my first corporate profile picture on the day I joined as an apprentice web developer to learn web development. I was part of a team of around 20 other engineers who were taking turns in teaching me web development over the course of 2 years. The one thing all my colleagues had in common, they used DevTools to show and demonstrate things to me. For example, I learned that the static HTML from my code editor turns into a dynamic living thing called DOM by clicking through the Elements panel. Later in my career, I learned about web performance by running Lighthouse audits over and over again and just blindly following the advice it gave me until the scores turned green, without really understanding the background. So for me, DevTools enabled a closed feedback loop during my learning journey. Through DevTools, I could inspect the live page I was working on, fiddle with it, try and break things, and debug issues. And this has been true for me, just as millions of other developers out there, including you, before and after us. But there are a few developers who learned web development without ever touching DevTools. They are over 3 years into their career now, and they're doing a fairly decent job, I would say, but they never touch DevTools. I'm talking about coding agents, obviously. We think they're missing out and could do more if we give them the right tools. We believe that giving your coding agent access to DevTools through DevTools for Agents enables the same closed feedback loop for them you benefited from your whole career. Let's look at a debugging example. The way you would manually handle it, even with AI in the game. This is a sign-up form using a company's internal auth provider called Showtime. It's not publicly documented, so no AI model knows about it. When I try to register and it fails, I only get cryptic error messages like app error 1003. Your out-of-the-box coding agent runs into a bunch of dead ends debugging an issue like this. First of all, it would rely on you to manually surface the issue. But then also, if you actually surface the issue already and you prompt, please fix app error 1003 in sign-up form TSX when trying to sign up with your coding agent, it can't do much really. It will search for app error 1003 across the codebase and then just spiral. If it got lucky, after some digging, my coding agent might find this lousy to-do comment I left for it. To do, handle specific error code. Excellent, right? Little does my coding agent know that the solution is actually not too far. Any wild guesses where it is? Is it A, in the training data of the model? Or is it B, in the source code? Or is it C, in the runtime data? After you listen to my heartwarming story of how I learned web development, you will know it's C, the solution is in the runtime data. Let me show you where. When I'm submitting the sign-up form, a request is being sent to an API, and all network requests sent from a page are surfaced in DevTools. It's the same here. So when we look in the network panel in DevTools, inspect the failing request, and look at the response, we see there is actually an additional message that we can use to give the user more information. And not only can we use those network requests, but our coding agent as well. Giving your coding agent access to this information through DevTools enables this closed feedback loop I mentioned before. But let's see if that's true by giving it a test run. Before we can do that, though, we need to tweak our prompt just so slightly. Instead of asking our agent to look at specific files, we ask it to look at the runtime. As DevTools for Agents has access to source maps, it will be able to guide your coding agent to the right file anyway. So we are going with go to localhost, sign up, debug and fix the error when signing up with test and 1234. Using this prompt with my coding agent, Antigravity in this case, and DevTools for Agents enabled, we'll start a full end-to-end fixing flow. The agent will open the page in a real Chrome instance, try to log in, capture any console logs or network requests, and combine all the pointers to actually fix the code. That's the power of DevTools for Agents. All right, so after you've seen this first example of what Chrome DevTools for Agents can do, let's briefly look into the foundation of it all, as this will help you get a better understanding of the use cases we'll explore in just a minute. While DevTools for Agents is new, it's actually built on a pretty solid and long-standing foundation. Using tools the same team has been maintaining for years, Chrome for testing and Puppeteer. But let's break it down. At its core, DevTools for Agents is an NPM package that you can install on any machine that has a recent Node.js version. This is what your coding agent is using. May it be anti-gravity, Gemini CLI, or whatever you prefer. Your agent might either use it through the MCP server or the CLI, which both ship as part of the same NPM package. The CLI enables your coding agent to script against DevTools for agents, which can be more token efficient compared to using it through the MCP server. The third and last key thing that brings it all together is a set of skills, which teach your coding agent how and when to use Chrome DevTools for agents. For now, Chrome DevTools for agents ships with a total of 6 skills, which can be roughly put in 2 categories. The troubleshooting and the Chrome DevTools and Chrome DevTools CLI skills help your coding agent to understand key capabilities, concepts, and general usage. The accessibility debugging, the memory leak debugging, and optimize LCP skills include expert knowledge in that specific area, which makes your coding agent act as the same expert. As part of modern web guidance, you might have heard about in the keynote yesterday or in Phil's talk, this skill set will expand over the coming months to help your agent debug the web's newest features. To learn more about modern web guidance, find Phil's session, Unlock Modern Web Capabilities in Your AI Coding Workflows from yesterday on YouTube to learn more. Now, from skills, back to the overall architecture. DevTools for agents is an NPM package with skills, an MCP server, and a CLI. The thing we haven't looked into yet, how does any of this talk to Chrome? Through Puppeteer, the same library from the Chrome tooling team that you might have used in the past to run tests, automate an annoying workflow, or scrape something. While this layer is mostly invisible when you're using DevTools for agents, it's helpful to know this, because ultimately, it's Puppeteer giving DevTools for agents its capabilities. And before we get into those, knowing Puppeteer is the layer in between might also help you better assess security and when to use Chrome DevTools for agents. For example, under one of our recent YouTube tutorials, someone recently asked, does DevTools for agents have access to my passwords saved in Chrome's password manager? The clear answer is no. DevTools for agents does not have access to passwords saved in Chrome's password manager. It is not using Chrome like you are as a human user. It's only using a vetted and tested set of tools through Puppeteer. And Puppeteer doesn't expose that as a capability. But also, DevTools for agents uses a separate, anonymous browser profile by default. And while this largely reduces a few of the most common security risks around giving agents access to a browser, the advice to always carefully decide what you give agents access to never gets old. No matter how boring it sounds, it's critical to protect your personal data. Awesome. So now that we've fully explored how it works under the hood, let's dive into some examples of what it can actually do. As you just learned, DevTools for agents inherits its capabilities from Puppeteer. But when you prompt in your agent doesn't directly use Puppeteer. Instead, we wrapped key Puppeteer capabilities in a set of distinct tools properly described, and by this, easier to consume by your coding agent. Those tools can be divided into 6 overall categories. In this section, I want to walk you through 3 different use case examples, exploring how tools from multiple categories play together to fulfill a certain user prompt. The first example is the one you've already seen. With a prompt like go to localhost, debug and fix the error when signing up with test, and 1, 2, 3, 4, we had the coding agent navigate to the page, fill in the form, and then fix the underlying error and validate its own fix, all in a real Chrome instance running on my machine. This example combines input automation, network, and navigation automation. Our partner CyberAgent has brought this use case to the next level when they set up an agent with access to DevTools for agents and let it audit over 230 stories in Storybook across 32 components in just 1 hour of runtime. To learn more about this, find the case study on developer.chrome.com. For the next example, we are going to combine emulation tools, which allow DevTools for agents to change the viewport size, for example, and debugging tools like taking a screenshot. Combining them enables your coding agent to do one-off bug validation. So before you manually go through a bugs verification process, let your agent work for you first. For example, if you have a report about not all navigation items being visible on all devices, you can prompt. Go to developer.chrome.com, check the same navigation items are visible on desktop, tablet, and mobile viewports. After you send, your coding agent, again, anti-gravity, will open a Chrome window and use the emulation tools to resize the viewport to desktop, tablet, and mobile, one after another. As a sign of this, in this screencast, you see the page occasionally overlap the window bounds. Then, in this example, anti-gravity took screenshots, interacted with the burger menu on mobile, and cross-checked everything before it will ultimately return the response in the screencast. The response will be something along the lines of the same 4 main navigation items are present across all 3 viewports, while the items themselves remain consistent, their placement and presentation adapt based on the device. There you see the final response. So with this prompt, I could automate a testing journey across 3 viewports and nested menus, including the interactions with them, sparing me all manual work and the back and forth to remind myself what actually happened on each viewport. Okay, let's look at one last use case, and to be honest, it's really my favorite one, because Chrome DevTools for agents enables you to scale your expertise. For example, let's imagine you don't know much about web performance and only have a 57 points Lighthouse score. Or imagine you don't know much about accessibility or SEO. Now you could go in and ask your coding agent to improve any of the areas mentioned with a generic prompt like improve the performance of this project. With a generic prompt like this and without DevTools for agents, what will likely happen is that your coding agent just slowly starts burning through your token budget, reading all of your project files and only fixing random things it might find along the way. Ultimately, that wouldn't help your website performance. But with DevTools for agents, it's flipped. With its specialized tools to run performance traces, analyze included insights, and run accessibility, best practices, SEO, and the new agentic browsing audit in Lighthouse, it can actually test for known problems instead of trying to guess them from your source code. This allows you and your coding agent to improve your websites in areas you're not inherently familiar with. For example, you can work on real performance issues by letting DevTools for agents actually measure your current performance and then work against an actual target, and use performance insight in the trace to start where it matters. All through a prompt like go to localhost, run a performance trace, and act on all findings. Or you can use the same pattern to improve accessibility. Instead of your coding agent and underlying model, just sprinkling in a couple of labels. Or you use the same pattern to ask your coding agent to work on SEO. While all of these examples you've just seen work with the MCP server and the CLI equally, some of them are perfect for the CLI, because the CLI can also run outside of an agent loop. This allows you to persist your agent's actions to shell scripts. Here's how it works. After you're done with your debugging flow with Chrome DevTools for agents, just prompt, persist your previous actions in DevTools to a well-named script file using the DevTools CLI. When you try a prompt like this, make sure that your coding agent has access to the DevTools CLI and the related skill, which teach it how to use the CLI. For the previous example, where we validated the navigation on developer.chrome.com, this, for example, could yield a script like this. It's opening the page, emulating the viewports, and taking the screenshots. The only bit that is missing here is the actual comparison of the results Antigravity has done for me in the screencast earlier. With this approach, using the scripts, that would be on you, the human, again. OK, let's wrap up all use cases that we explored. We saw a prompt to automatically fix complex UI flows, one to scale your expertise running performance traces or Lighthouse audits, one to validate bug reports, and one to persist your prompted actions to scripts you can rerun outside of your coding agent. Use variations of those prompts in your own projects to achieve the same results you just saw on screen. To explore more use cases like this and more examples from other tool categories, learn more in our documentation on developer.chrome.com. Now, there is one last topic I want to look into with you: configuration. While DevTools for agents works for most use cases out of the box, there are some configuration options you can use to tailor it to your own needs. To configure it, when using Chrome DevTools for agents as an MCP server, find the file that has your MCP server's config. For Gemini CLI, this is usually a .gemini/xJSON. For Claude, this might be in your project root at .mcpjson. For other agents, it is in similar locations you already know. In this file, just add a new entry to the args array with the option you want to configure. If you're using DevTools for agents through the CLI, make sure to explicitly include your desired option in the prompt. For example, through the channel configuration option, you can specify whether Chrome DevTools for agents should connect to any other Chrome channel than stable. Or you can use the configuration options to enable experimental options you're still working on, like the experimental support for screencasts through experimental screencasts. And for the MCP server user specifically, there are configuration options to turn off certain tool categories to save tokens. But there is one configuration option I want to particularly highlight, which is useful for both users of the CLI and the MCP server. It's AutoConnect. Think about AutoConnect as sharing your screen with your coding agent, because AutoConnect allows your coding agent to connect to an already running Chrome instance and pick right up where you left off. Let's look into why this is interesting. For this, we're going back to our initial example. We asked our coding agent to go to a specific page and sign in with a certain set of credentials. We did this so our coding agent could get to the same page state that we already reproduced in our running Chrome. But if I am already at the same state with the error right in front of my eyes, why should I waste mental energy just to write a prompt that gets my coding agent into the same state? Or even worse, manually copy and paste error messages from the browser console into my coding agent. This is what AutoConnect is for, and it works fairly simple. All you need to do is to go to Chrome, inspect, select remote debugging in the sidebar, and then toggle the allow remote debugging for this browser instance checkbox. Then make sure to use AutoConnect in your MCP.json config, or explicitly prompt for it when using the CLI. Now, the next time you use your coding agent, it will connect to the Chrome you've just been using, and will also let you know if it has trouble connecting to it because you forgot to turn on remote debugging, for example. However, this is the right time to repeat the earlier advice. Carefully decide what you give agents access to. Because with AutoConnect, depending on what Chrome instance you're connecting to, DevTools for agents might use your personal Chrome profile rather than the anonymous default one, which puts your personal data at risk. Because technically, connected to my personal Chrome profile, a prompt like go to google.com shopping an order 999 colorful balloons has a high chance of actually succeeding and incurring unintended costs and consequences, like a lot of balloons ordered to my doorstep. Because in this example, I might already be logged into the shop site the agent ultimately decides to use, and the only thing it needs to do is click next and continue and check out all the time. So carefully consider what you prompt for when using AutoConnect with a personal profile. And with this, you really have everything to get started. You know how DevTools for Agents works with the MCP server and the CLI. We explored a couple of example prompts from bug validation to persisting DevTools actions into a reusable CLI script. And you learned how to configure DevTools for Agents to your needs. On top of all this, we are happy to announce that since yesterday, DevTools for Agents is available in its first stable release, version 1.0. However, my team might have shipped minor fix releases in the meantime, so let's say around about version 1. I think we're at 1.01 or something. But anyway, stable and good to use. Now it's time for you to get started. In the next few slides, I'm going to share resources for you to install DevTools for Agents, learning material to set it up, and how to contribute back to it if you want to. First up, find install instructions for over 20 coding agents, more use cases, including the AutoConnect feature you heard about, and in-depth documentation through this link on developer.chrome.com. If you haven't seen enough of me today, you can also learn more about setting up DevTools for Agents with a video tutorial on YouTube. Find it at Google/DTA setup. This video is also the beginning of a series of YouTube videos explaining use cases for DevTools for Agents that will expand over time. If you have particular use cases in mind or want to learn more about, please find me on social and reach out with your idea. And don't forget, DevTools for Agents is a thriving open source project. If you see something that doesn't work, want to peek into future discussions, or straight up contribute, find the project on GitHub. Now, that's it. Thanks so much for listening and spending your time here at the Chrome tent. This was a comprehensive overview of Chrome DevTools for Agents, and we can't wait for you to get started. Enjoy the rest of I/O and your lunch, and see you all soon.
These couple of sessions were good. The use of agent and LLMs to inside your Android SDK will bring on many good use cases, and the Chrome's MCPs were good too. These are fun, and with this new MCPs that they have introduced, it will be easier for people to directly embed websites with MCPs, and like in the web MCP part of it, and directly ask or like give a simple API call or a simple LLM call to the particular website to get information instead of scraping through the whole and the entire site. Next is the ABCs of agent building.
Hello and welcome. I'm Chris Overholt, a developer relations engineer in Google Cloud. I work a lot with Agent Development Kit and its growing ecosystems of tools and integrations. Today, I want to walk through 6 protocols that can help make your AI agents more capable in terms of working with external systems, remote agents, payment processing, and real-time interactive front ends. AI agents by themselves are surprisingly limited in terms of what they can do. With just a simple set of instructions and a few tools, they can answer questions and maybe call a tool or two. But the moment you need them to collaborate or pay for something or stream results, they hit a wall. And if you're like me, you've seen the growing list of agent protocol acronyms and you've wondered, why are there so many and what do they actually do? Traditional APIs assume a person is on the other end. A person clicks buy, but an agent doesn't know how to check out. A person can browse a storefront, but an AI agent doesn't have a catalog. A person can read a form, but an AI agent produces text. Each protocol that we'll cover today addresses one of these specific problems. Now, to make this more concrete, we'll build a kitchen manager agent that orders food for a restaurant from wholesale suppliers. And we'll use Agent Development Kit, or ADK, which is Google's open source framework for building and deploying AI agents. Now, here's what happens when you give your agent no protocols and no tools. You ask it to check inventory and place an order, and it confidently fills in the blanks with made-up inventory data, prices, and order confirmations. To understand these protocols at a deeper level, I spent the last few months building agents with them, asking really hard questions, and figuring out how they solve real problems. We'll start with a plain agent and add one protocol at a time until it can check real inventory, place orders, authorize payments, and stream interactive dashboards. By the end, you'll know what each protocol does, what the real code looks like, and when you'd actually reach for it. First, let's start with something probably familiar to you, MCP, or Model Context Protocol. This helps us connect our agent to tools and data. So the first problem is my agent needs to use external tools. Without MCP, every API endpoint needs its own custom tool. And a few services in, and you're already managing dozens of tools. That really doesn't scale well for you or the agent. MCP solves this by letting your agent connect to an MCP server that dynamically exposes its available tools. Now, instead of hard-coding dozens of tool definitions, you just point at a few MCP servers and the agent discovers what's available at runtime. For our Kitchen Manager agent, that means connecting to 3 MCP servers, one for inventory databases, one for recipes and procedures, and one for supplier emails. In ADK, this is just 3 lines of code per server using MCP toolset. You don't have to write a single API call. So the agent has real data access now, and adding a new data source is just adding another MCP server URL. And where MCP really shines is prototyping. When you're still figuring out what your agent is capable of doing, MCP lets you quickly plug in new data sources and see what the agent decides to do with them before you actually start optimizing with individual tools. Next up is A2A, the agent-to-agent protocol. MCP gave our agent data. The next problem is expertise. Our Kitchen Manager can check inventory, but it doesn't really know today's wholesale prices, supplier quality grades, or delivery windows. That knowledge actually lives with different agents, potentially built by different teams in different frameworks. A2A solves this through standardized agent discovery. Each agent serves an agent card at a well-known URL that describes its capabilities. Your agent then fetches these cards, discovers what each specialist can do, and talks to them via send message. In ADK, you can expose any agent as an A2A service with one line using the toA2A method. On the discovery side, you point to a remote agent's URL, fetch its card, and send messages. The agent doesn't need to know how the remote agent is built or even what framework it runs on. In our example, the Kitchen Manager discovers 3 remote agents, one for pricing, one for food quality, and one for logistics. So when you ask it, what's the price of salmon, what's the quality grade, and can I get it delivered by 5 p.m. today? The agent actually routes each question to the right specialist without knowing anything about how they're implemented. And the real value of A2A shows up at the organizational level. When every team in your company is building their own agent, A2A gives you a standard way to discover and delegate tasks to them. Adding a new remote agent capability just means adding a new URL. Now, our agent needs to order supplies. This is where UCP, or Universal Commerce Protocol, comes in, and it standardizes how it discovers merchants, how to place orders, and how to track order status. A person can browse a storefront, but an agent really needs machine-readable information about a merchant and product discovery. UCP provides this through a well-known endpoint at well-known/UCP, so now the agent can discover a supplier's catalog and send a structured checkout request with line items, quantities, and payment details. The agent doesn't have to browse a website, no parsing HTML, and it doesn't have to guess at the checkout flows. Here's what that looks like in code. It's all just standard HTTP request following the UCP specification, but now the typed request format means the agent doesn't have to guess at what a checkout request actually looks like. For our Kitchen Manager agent, this means discovering the supplier's catalog, placing a typed order for 10 pounds of salmon, and then getting back a confirmed order number. The agent goes from supplier discovery to a completed checkout through a structured set of steps. UCP lets your agent place orders, but who authorized the spending? There's no audit trail, no spending limit, no list of approved merchants. That's where AP2, the Agent Payments Protocol, comes in. AP2 introduces typed mandates. A checkout mandate defines the guardrails, like which merchants are approved and what can be purchased. A payment mandate enforces spending limits, specifies approved payment methods, and it records the actual user authorization. And finally, signed receipts create the audit trail. Here's what that looks like in code. The restaurant owner can configure guardrails like only buy from these approved vendors, auto-approve orders under $500 on the company card, and require manager sign-off above that. When the agent tries to buy from an unauthorized supplier, the mandate rejects it. When it places a legitimate order, it gets a signed receipt with the full authorization chain. Instead of telling your agent, don't spend more than $500 in the instructions and hoping for the best, you're actually specifying conditions in a typed protocol with enforceable guardrails. UCP and AP2 together give you the full commerce lifecycle: discovery, checkout, authorization, and a complete audit trail. Now, at this point, our agent can check inventory, consult specialists, place orders, and authorize payments, but every response comes back as a huge wall of text. A2UI, or the Agent to User Interface Protocol, helps our agent generate the right user interface at the right time, all on the fly. Now, when you need a reorder checklist or an order form or a supplier comparison, you'd normally build a separate front-end component for each one. Instead, A2UI defines 18 primitives like cards and buttons, text fields, date pickers, and sliders. Now the agent can actually compose these primitives into whatever UI fits the user request. And then a client renderer like Lit or Angular or Flutter turns them into real native components. So the code is a JSON payload with 3 parts. We have a rendering surface, a component tree built with primitives, and a data model that fills these components with values. So now the agent doesn't generate HTML or front-end code. It simply generates a declarative JSON payload that any renderer can interpret safely. Back to our kitchen agent, we'll try this with 3 different prompts. So now if we send show me what to reorder, we get back a checklist dashboard. If we send set up an order form, this produces a form with a date picker and an urgency slider. Or if we send compare to suppliers side by side, it actually gives us comparison cards. So we get 3 different UIs, 0 changes to the agent, and they're all composed from the same 18 primitives. So A2UI kept the layout and the data separate. The agent sends the component structure once, and then you can update the data whenever you need to. So that's why the same payload works across different renders like Lit or Flutter or Angular. Last up is AGUI. So we covered what the agent can do. Now the question is, how does the user actually see it happen? Think of a scenario where the agent finished thinking 30 seconds ago, but the user's still staring at a spinner. AGUI standardizes what those streaming events look like. No matter which agent framework you're using, your front end gets the same typed events: what tool was called, what it returned, and what the agent is saying. Under the hood, it's sending typed streaming events like text message content, tool call result, and run finished. And if you're using ADK, this is just 3 lines of code. So you wrap the agent that we've been building with ADK agent, you mount it on an API endpoint, and now everything the agent does streams to your front end in real time. For our Kitchen Manager agent, the user can actually watch every protocol fire in sequence. First, MCP checks the database and finds 3 pounds of salmon in stock. Next, A2A queries the pricing and quality agents to get the latest information. And now that we have pricing and quality confirmed, UCP discovers the supplier and actually places the order, while AP2 authorizes the payment and returns a signed receipt. So the user sees all of this streaming in real time, not after the agent finishes, but actually as each step happens. Here's what's happening in this diagram. Our Kitchen Manager pushes events through AGUI, and the front end receives them as a standard typed stream. The agent does the work, while AGUI handles the delivery. That's all 6 protocols in a very short time. Let's take a step back now and look at the big picture. Each protocol that we covered today was created because traditional APIs assume a human is on the other end. In our agent, real data and real expertise came from MCP and A2A. Structured commerce with signed payment authorization came from UCP and AP2, and interactive dashboards streaming in real time came from A2UI and AGUI. We started with a plain agent that made up inventory data, and by the end, the same agent can fetch real inventory levels, discover specialist agents, place typed orders, get payment authorization with signed mandates, render dashboards from 18 primitives, and stream it all back to the front end. Keep in mind, these protocols don't actually depend on each other. You don't need all 6 to get started. So if your agent needs real data, start with MCP. If it needs to talk to other agents, add in A2A. Pick the one that solves the problem you have right now. If you're looking for ADK tools and integrations, you don't have to start from scratch. You can check out the tools and integrations page in the ADK documentation, where we have a growing library of tools, integrations, connectors, many of them with ready-to-go code snippets. For MCP and A2A specifically, the generative AI repo on GitHub has notebooks that you can run today. For the other protocols, you can go to the official repositories: A2A Python, UCP samples, AP2, A2UI, and AGUI. They all have built-in examples, and many of them use ADK. Now you know what problem each protocol solves, what the code looks like, and exactly when to reach for it. Thanks for watching.
This was a good demo of what A2A and ADK build, and how can you go into the ecosystem and the agent AI ecosystem and get to. So this is the A2UI and AGUI and different protocols. These are the tools and integrations which are large in number. You can see Atlassian data agents, 11 Labs, Datadog, GitLab, Google Search and all. W&B, Weave, Google Cloud Skills. So these are all the integrations with the ADK. And all the workflows. These are all the community resources. Like, you can directly join the ADK community group, and if you are facing any issues, you can directly contact them in trying to integrate it into your apps. And startups like kind of use this all the time. This was the model context protocol. The agent to agent protocol, A to A. These are the blog post of starting up and how you can code it up from scratch, discover and call. So publisher subscriber pattern that go that goes way back in the Gang of Four book. If you guys have any idea about that, Universal Commerce Protocol (UCP). This is the Model Context Protocol, agent to agent, embedded protocols, or for browser-based flows. Agent payments protocol. Yeah, so this is a new protocol that came in. So this kind of plugs into the UCP ecosystem, the Universal Commerce Protocol ecosystem, and yeah, can directly ask your agents to create payment bindings. So, and the merchant confirmations and the others. So you can use it here. This JWT or biometrics scan can be used for securing it. Then there is agent to user interface protocol. And yeah, this is creating the bindings, surface updates, data model updates, and others. So this is how it looks. Your components are rendered natively. The checkbox, the text fields, the datetime inputs, the cards, with no additional front-end code. So yeah, it's all dynamic. Let's explore some of the A2 UI samples. So these are the demos. Renderer is Flutter, and these are the dev tools that you can use. So you need to start the service, and the demo video is being downloaded. I don't know why, but yeah. So this is how it looks. Also, this can easily be used by anyone in the developer workflow to make sure that it can be integrated in the web UI part of it. Submit reservations, and your restaurant is ready to go. Scan neighborhood, vegan. This is the landscape design example. Yeah, so this is the landscape design example, then the catalog gallery and the composer. And next is the agent user interaction protocol, AGUI. Putting it all together, agent in action. This is using Nano Banana, MCP, A2A, ECP, AGUI, A2UI, A2P, AP2, sorry. These are the 6 protocols. If you need more information, this is the generative AI sample repository in which there's many examples. You can just take examples from RAG or grounding, from vision, from audio, from other resources, directly build upon it. So let me give you a couple of examples that I have. So they use here VStart and Gen Media Live for video prompting on so VO prompting and evaluation. So yeah, this is a simple one of a kind prompt generators based on subject, action, scene, lens, camera movements, camera angles, visual style and aesthetics, temporal elements, sound effects, dialogues, however you will go to that. This is Gen Media. This is real-time multimodal creation enabled by extending the Gemini Live API with image and video generation tools. So these are the 2 sample apps and some of the use cases. This is virtual try on. This is the code of the batch generation pipeline for it. The RAG and grounding. This is hallucinations and quick definitions and how can you use Vertex AI to on the RAG engine that's present inside that as a feature. Let, let me take you guys through it. Yeah, this is the RAG engine on Gemini Enterprise Agent platform. The Vertex AI has been renamed to Gemini Enterprise Agent platform. So you can do all of this here. Ingestion, transformation, then embeddings, indexing, retrieval, and generation. Everything is in here. I think so. There might be some ways to evaluate or add in your hooks to others. Like these are the notebooks that you can go on. So these are all the projects that you can build using just the orchestrator and the RAG engine that you can use here. Then building the vector databases, AlloyDB, BigQuery, Redis, name it, it's there. Like each of the vector capabilities you will be able to find in one of these so this is a tutorial using LangChain AlloyDB for PostgreSQL. Okay, this isn't available. There might be some issues and the movement. This is code RAG, multimodal RAG, LangChain, Files must have been moved here. Grounding. Drag engine Pycon, drag engine evaluation, Vertex AI search, backend prompts, routers, index managers, node read anchor, Vertex search. So you guys can build it and feature it in one of the and why what was the name of the file again? Multimodal. There might be a different branch on which they must have moved it. Yeah, this is it. It's in the different branch. So this is simply private endpoint, IP endpoint, initializing Vertex AI, importing libraries, partitioning PDF tables, text and images, extracting that, unstructured document, model name, using Gemini 1, then getting and deploying Vertex AI, vector search, index and endpoint, the simple way to retrieve and load documents. So this is easy to start up, get a hang of what things look like, and then you can customize it and go do according to the use case that you want. Like many companies, startups, and organizations have built it, open sourced it, and there are many ways to go about it. So, if you want to talk about it in more detail, then I will invite you to come on the Triangle Generative AI and Impact call that we have on Fridays. Let me give you folks a hang of what it looks like. Uh, Yeah, so this is the Triangle Generative AI Problem Solving Research and Impact Meetup that we have every Friday at 8 a.m. PST. So we discuss it all. Yeah, welcome to join and ask anything. Okay, moving to the next.
For example, by human execution, the front end is going to get a stream, a signal, and it's going to refresh the screen. So I have auto save here. I'm going to refresh both sides to make sure that I have the latest JavaScript code. What I do here is I'm going to buy another tree, right? Nothing happened, but if I refresh the screen, I can see the prices changes. Pretty magical. And the reason it changes is because I force a refresh as a human. Pretty cool, right? We can make it a little bit better, or a lot better. Another thing we introduced in SQL Connect this year is the refresh directive. So now I can tell this query, which is called get dashboard data, to automatically refresh every time a mutation happens. So for example, every time someone buys stocks or sells stocks. So I'm going to make this change, and I'm going to deploy the production. What this is doing is literally scanning my database, compiling the queries, making sure that the schema is correctly structured, making sure that my queries are correctly structured, making sure that there are no schema changes, that it has to automatically push to the SQL database. So this is going to take a few more seconds. Give it one more second. It's almost there. There you go. So I'm going to go back to my app. I'm going to refresh on both sides. And now I'm going to buy a coffee. So buy another one. There you go. Woo! Pretty magical, right? Very, very cool. Another feature I wanted to show you is, as I said, now you can write SQL queries. Now you can use the full expressiveness of SQL. So we developed this screen. That's geolocation. So basically, based on coordinates, it shows me on a map where people are buying emojis. So imagine having to write this using either like a manual GraphQL or having to use extensions to this. What you now can do is just write this using SQL. And using, for example, the GIS Postgres SQL extension. As you can see there, I can pass to the extension. I'm using the Postgres GIS extension. I'm just passing longitude and latitude and doing a search based on that. So imagine the power of this now that you can write SQL and you can use any extension available in the Postgres ecosystem. The last thing I wanted to show you is this capability. So for example, for a particular emoji, I like the fire emoji. I'm a little bit biased. I want to be able to show some more complex metrics, right? So I have the live price of the emoji coming from my SQL database, but I want to show pre-computed, metrics that have been pre-computed. Does any service come to mind that is more suitable to do pre-computed metrics than SQL? How about BigQuery, right? So what if I could combine data from SQL to BigQuery through Data Connect? Well, now you can do that through custom resolvers. What custom resolvers is going to do is we give you a method that you can run, which is Firebase init data connect resolver. We need to rename that to SQL Connect resolver. And that's going to generate a few things for you. The first thing it's going to generate is a base schema. Here in this base schema, you're going to define what the data, the input and the output for that custom resolver is going to look like. The second thing it's going to generate for you is going to stab out something in a cloud function. So for example, here, you can see how through a cloud function, I'm directly calling into BigQuery through the BigQuery Cloud SDK. So now imagine the power of this, right? Because I'm executing this in a cloud function, and I'm using the SDK, but you could be calling whatever API you want, right? Whatever cloud service you want, whatever API you want, either part of Google Cloud or a third party. And the last thing I do here is just use that on a query. So I have this get emoji analytics that it's basically calling to my custom resolver, passing the emoji as a parameter. And within this query, I have data coming from SQL, as well as data now coming from my custom resolver is calling BigQuery. Pretty powerful, right? All right, we can go back to the slides now.
I'm ready to buy a few emojis myself. And I've seen this talk before. I think there are even more database updates.
There are a few more I want to share with you. So when sometimes SQL is the best solution for you to build your app, sometimes NoSQL gives everything you need and is the right solution, right? For that, we continue evolving Firestore, particularly in its enterprise edition. We recently went GA with query pipelines. With query pipelines, we completely reimagined our query engine to help you write applications more efficiently. And today, there are a few more things I want to share with you. The first one is data manipulation language, or DML. DML condenses the number of steps you need to write changes to your pipeline. For example, if a user leaves your application, you can delete all the user-generated content with just one pipeline query. The second one is subqueries. Subqueries give you the ability to combine multiple documents and filters within one query, unlocking complex querying scenarios, like, for example, in this case, grabbing all the reviews from a collection for a particular book and inserting the data into the book's collection. Subqueries can be used for both querying data and modifying and inserting data. GeoSearch. With GeoSearch, now within Firestore, you can use geofields, like longitude, latitude, and distance for sort and searching. And last but not least, is here, folks. Come on, give it a round of applause. You've been waiting for this one. I'm excited to share that Firestore Enterprise now supports full-text search natively. Full-text search lets you search through your collections and documents for things such as exact words, phrases, or semantic matches. Now, you don't need an extension or a third-party service anymore. Very, very excited.
So much database goodness. These features will accelerate the way humans and agents develop. Firebase also helps you bring AI experiences to your users. Firebase AI Logic helps you bring the power of generative AI to your users without any server-side setup. Raise your hands if you've ever thought of adding an AI feature to an app that you have. Doing these features can be very engaging. However, doing it correctly is non-trivial. And Firebase streamlines the process of adding AI features to your app and allows you to use the languages that you're familiar with, like Java, Kotlin, Swift, Flutter, Android, and others.
The next slide. There you go.
Gemini models are truly multimodal. It's a huge value prop for Gemini. They accept multimodal input, and they support multimodal output. And Firebase AI Logic supports them both. It enables delightful experiences for your users, making it simple to implement things like chat, image generation, with advanced model features like tool use and function calling. They also support streaming input and output. Protecting your Gemini resources from abuse is a key value proposition for using Firebase AI Logic when implementing AI features in your app. Server prompt templates help protect your prompts from being exposed on the client side. Integrations with Firebase AI Logic help prevent non-app access to your models, and built-in user rate limits prevent a few users from abusing your app's AI quota. Gemini models have continued to advance, and Firebase AI Logic has expanded its capabilities to ensure that your apps can take full advantage of what Gemini has to offer. At I/O, Firebase AI Logic is rolling out a series of updates that improve model support, provide even more security for your AI features, and greater efficiency for the AI features in your app. Firebase AI Logic now supports the latest Gemini 3 GA models. We've added support for Google Maps grounding, allowing Gemini models to connect with geospatial data from Google Maps and build location-aware AI features. Nano Banana image generation controls are also available from AI Logic. This brings programmatic control over aspect ratios and image sizes. We're also exposing finish reasons. So image generation, when it completes, whether it's a failure or a success, you can handle that within your app. Firebase AI Logic continues to emphasize the security of your AI resources. At I/O, we're launching one-time tokens to help prevent malicious actors from capturing and replaying tokens to drain your app's AI quota. Template-only mode limits AI Logic to only execute prompts that are stored on the server, ignoring custom prompts that come from the client side. You can also restrict your AI Logic calls to authentication-only mode, limiting your AI Logic executions to only calls with valid Firebase authentication tokens. And my personal favorite, local and hybrid inference across iOS, Chrome that's now generally available, and Android with Gemma 4 support. With Firebase AI Logic, you can implement AI features that run locally and can automatically fall back to the cloud when necessary. Who has to fill in any expense reports?
Man, I said this morning struggling with a very faded piece of paper.
It was a very important sandwich. I needed to make note of it. But seriously, let's look at how we can use AI Logic and a local model so that we can save some of our cloud quota for when we really need it. This code snippet is all that is needed to configure your app to prefer using an on-device model when available, is all that is needed. Some of our cloud quota for when we really need it. This code snippet is all that is needed to configure your app to prefer using an on-device model when available and fall back to a cloud-hosted model. So I have a receipt scanning demo app here, and given that receipts are pretty standard, we can use our local model and save our precious token, our precious cloud tokens. As you can see in the demo, the business name and the final total of the receipt are both extracted from the image without sending any of that data to the cloud. You can configure hybrid inference in several ways. to correspond to the way you want your app to prioritize the use of on-device or cloud models. With Firebase AI Logic, the power of adding AI features to your app is yours. Woo!
And with great power comes great responsibility. That's not my phrase, in case you wonder. So historically, enterprise customers have faced complexities when managing their Firebase deployment alongside the rest of their cloud infrastructure. To solve for this, we're introducing Firebase integration with Application Design Center. ADC offers a unified model for deploying and managing the resources used by your client apps alongside the rest of your cloud infrastructure. So for example, you can use ADC to deploy things such as AppCheck, Firestore, and authentication in the same way you manage the rest of your cloud services. ADC also seamlessly and natively integrates with Cloud Hub, App Hub, and Gemini Cloud Assist, and offers a myriad of AI-assisted tools to standardize best practices and deploy templates. You can start using Firebase in Application Design Center today.
Woo!
Do we have any Flutter developers in the room? I'm really excited about this one, really excited. So Firebase Dart and Flutter have always been a match made in heaven. You've been asking, we heard you, and today I'm happy to share the preview experimental release of Dart support for cloud functions in Firebase.
Woo!
For you, our love Flutter developers, there is no more context switching between your front-end and back-end code.
We love Flutter developers at Firebase, a match made in heaven.
Well, man, it's the only relationship in my life that lets me code over the weekends.
Another passion of Firebase is authentication. Most, if not all, apps need some type of authentication, and SMS is a popular option. SMS works, but we thought we could do better. So last year, we launched Firebase Phone Number Verification, a fast and secure way to verify users' phone numbers. Firebase Phone Number Verification, or FPNV for short, provides several benefits over SMS alone, starting with the fact that no SMS messages are sent, which eliminates SMS phishing attacks. FPNV works over any internet connection. So whether it's cellular, Wi-Fi, wired, or a hotspot, this allows you to access all of your connected users. Carriers are the source of truth. So your app can get the phone number directly from the carrier. You don't have to depend on anybody typing it in. And phone number verification can be used standalone or with an ID provider. Sometimes you just want a valid phone number. And other times you want the user to actually use that phone number to create an account and sign in. Phone number verification supports both scenarios. As of today, we have over 10 carriers on board, and we're expanding that all the time. We recently launched a brand new SIM-free testing mode to reduce friction when testing the Firebase phone number verification flow. And last but not least, phone number verification is now generally available. Woo! Since we're all traveling this week, I thought it would be helpful to demo reserving a table using FPNV. My demo concierge agent is built with Firebase AI Logic, as you might expect, and uses FPNV to help me book a table at my fictional restaurants. Could we switch to the phone? Hi, I'm trying to book a table for dinner tonight. Can you help me?
I can certainly help with that. Do you have a particular restaurant in mind, or would you like to see what's available?
Let's see what's available.
These are our options. Do any of these sound good?
Sure, let's try Agave Algorithm.
Great choice. For a reservation at Agave Algorithm, what date, time, and party size would you like? And whose name should the reservation be under?
For the reservation, let's go with Seba, since he'll pay the bill. It's a party of 5, and we want to have dinner around 9:30 tonight.
Please check your screen for the phone verification pop-up. Once that's done, the booking is confirmed.
Woo!
Your booking is confirmed. Enjoy your dinner.
So that pop-up allowed me to approve that my app could send my phone number to the server side or to the restaurant. So when I get there, they will have my phone number, and I can verify my identity. Could we go back to the slides? Verifying your phone number only takes a few lines of code. Note the enable test session with the test token from the Firebase console. It allows you to test this flow, like I just did, without actually using a real SIM or a real phone number. I also want to thank Seba for volunteering to pay my fictional dinner bill tonight.
Let's make sure we save that receipt.
Sure. We could scan it. Let's talk about agents. Agents can do some remarkable things. Vibe-coded apps are amazing. I'm sure that many of you are vibe-coding apps. Maybe even some of you right now during this talk. Sometimes you want your vibe-coded app for a proof of concept or just as a demo. But other times, you want your vibe-coded app to stick around with real users and real persistent data. Let's see how Firebase can help you build full-stack apps with Google AI Studio. We recently announced that Firebase is natively integrated into Google AI Studio. With a single prompt, the anti-gravity agent can proactively identify the need for Firebase integrations. The anti-gravity agent, using an appropriate prompt from you, can identify the need for user-specific features and enable Firebase auth, or the need for persistent data and enable Firestore, together with well-written security rules. Here's the prompt that I use to build my next viral application. It's going to be a crowdsourced emoji translation app. Here's the prompt. Create an emoji translation app that allows users to submit common phrases in prose, and other users submit emojis to best represent them. Users should be able to vote on their favorite translations. The app should be colorful and playful. As you can see, there's no reference to databases or authentication in this prompt. The anti-gravity agent using this prompt recognized the need for both Firestore and Firebase Auth. And thus, I get this dialog to ask me to confirm the enabling of Firebase. After enabling Firebase, the anti-gravity agent goes ahead and builds my translation app with Firebase integration. Users can sign in with Google. Their phrases, emoji translations, and votes are all stored in Firestore, aligned with their user IDs from Firebase authentication. The data is securely stored with strong security rules, written by the anti-gravity agent. Starting today, AI Studio now has the ability to link to your Google Workspace so that users can use their data in their Google Sheets, Docs, Gmail, or Calendar in your app. Firebase authentication powers this integration flow with Google Sign-In and lets users securely grant access to their data for personalized features like document-to-slide translations or inbox triaging, or emojis that represent my calendar. As always, you can go to the Firebase console and view all the users of your app in Firebase Auth.
Arthur, thank you for bringing us up to speed with all the launches in AI Studio.
No problem. My pleasure. Could you give us a sneak peek of what else is coming to Firebase Studio?
It's like we had a script to this talk.
We did.
And the jokes. All right. So a quick follow-up. These are some follow-up features that are going to be coming to AI Studio in the coming months. So the first thing we're going to release is the ability to create real Android apps with Firebase services.
Woo!
The second feature we're adding is the capability of adding AI features to your Android apps using Firebase AI logic.
Yeah, this is cool. AI features, Android apps, just using Firebase.
And third but not least, every AI logic call is going to be protected by default using Firebase App Check to help you prevent any token abuse. Very cool, right? So make sure that you follow along, make sure that you check our blog to make sure that you get the latest updates on what we're releasing for AI Studio. Now, if you want to use a fully featured IDE like Anti-Gravity, Android Studio, or any other popular option, we got you covered as well. For Anti-Gravity, Firebase is integrated in the onboarding flow, so you just need to check the box, and Firebase agent skills are automatically installed. In Android Studio, Firebase skills are there by default. So if you ask your Android coding agent to add Firestore or Firebase Auth, it will take care of everything by itself, and you'll get a fully configured Firebase environment without leaving Android Studio. Pretty cool, right? And for the other options, for the other coding agents and IDEs you want to be using, you can either go to GitHub and grab our agent skills, or you just scan NPX and get them from the CLI. We want to make sure that
Yeah, the agent skills will be available everywhere. So if you're building an iOS, web, or Flutter app, yeah, you can go ahead and dive deeper into it.
your agents have all the skills necessary to build apps with Firebase, wherever and however you build, with less tokens and in less time. Today, I'm excited to announce that Firebase agent skills are now available for Android, iOS, web, and Flutter. Woo! And we are also expanding the service supported. Now Firebase agent skills support Crash Analytics and remote config as well. Let's read that, boss. As software development shifts towards agent execution guided by human creativity, our focus is to ensure Firebase is there with you in the new ways you build and in the new places you build, helping you bring all the power of Google Cloud to your apps and to your end users.
As we showed you today, we want to help you thrive with your development. If you want to learn more, check out the other Firebase-related sessions at I/O, and don't forget to check out our blog and code labs to get hands-on with all the things that we launched and featured today. Thank you.
Thank you. Flutter is everywhere, every day. And it's built by everyone, for everyone. Thank you so much to all the Flutter community members and Showcase partners for helping us with putting together that incredible video. Hi, all. Welcome to What's New in Flutter. I'm Kate, engineering manager on the Flutter Framework team. And I'm Con, a developer relations engineer on the Dart and Flutter team at Google. We're also joined today by Lee K. Chang from Google DeepMind. To everyone in attendance here today and joining us online, thank you so much for tuning in. That theme, everywhere, every day, built by everyone, for everyone, is exactly what we're here to talk about today. Flutter, and of course Dart, which powers Flutter, similarly aim to provide the most productive development experience, building the highest quality, full-stack, dynamic user experiences for any platform.
And today, we are so excited to announce the release of Flutter 3.44 and Dart 3.12. Now, Google I/O is always one of the most exciting times of the year. It's a great time to talk about all the things that landed in this last year, and it's also a great time to share previews of all the cool things that we're working towards in the future. Now, of course, it's also a great time to talk about all the new things that are landing with this latest release. We also have two very special showcases to share with you all today from Google DeepMind and Toyota. We've got a packed slate today, so Kate, let's get started.
All right, let's talk about the state of Flutter. Our community of contributors has never been stronger than ever, this year having reached 1,700 contributors to the Flutter project. Yes, yes. In the last year alone, over 5,800 changes have landed just in the Flutter repository, which is a lot to review, so I hope you're all comfortable.
And the pub.dev ecosystem is more popular than ever, with over 1.3 billion package downloads in the last 30 days alone. Now, for context, I had originally asked my teammate to get the number of pub packages downloaded in the last 12 months, but that number was quite big, so I just had to settle for the last 30 days instead. And in both the App Store and Google Play Store, Flutter is currently the second most popular SDK for mobile app development.
It has been incredible to see this community grow over the years. And as of just a few weeks ago, there are now 1.5 million developers building with Flutter every month. I know, it's fantastic, right? Now, I will leave you with Con here to start our deep dive. So Con, take it away.
All right, thank you, Kate. All right, let's kick things off with Dart, the language that developers love and happens to power Flutter. We're committed to making Dart accessible and performant everywhere, and ensuring that it remains a joy for every developer to write and read. In last year's keynote, we teased a few features like Dart shorthands, which enables you to omit redundant class or enum names, and Dart build hooks, which enable you to compile native code or download native assets and bundle them directly within your Dart package. For many FFI-based packages, this eliminates the need to maintain platform-specific build files like CocoaPods, CMake, or Gradle. Well, both features have landed, and it seems that y'all are pretty excited about that based on feedback, so let's keep the ball rolling. In this latest Dart 3.12 release, we're making it easier to initialize and declare private instance fields using name constructor parameters. It means that Dart now automatically writes an explicit initializer list in the constructor for you. We're also adding experimental support for primary constructors, so instance variables can now be declared directly in the class header. Woo! Now, for a while now, one of the top user requests for the Firebase team has been support for Dart in Cloud Functions. Because, well, we all know developers love full-stack Dart, right? Am I right about that? Cool. Well, get excited because Dart in Cloud Functions for Firebase is officially here. You can now write HTTP and callable functions in pure Dart. Dart uses AOT compilation, so we're seeing cold start times as low as 10 milliseconds when using Dart with Cloud Functions. In addition to that, the Dart admin SDK now gives you access to Firebase services from privileged environments on the server. OK, let's talk about developer experience. Dart and Flutter has always been known for an unparalleled developer experience, and our mission has been to make sure that it keeps getting better. Well, last year, we delivered on faster Dart CLI commands by moving to AOT snapshots of the analysis server. Now, Dart format feels almost instantaneous, and Dart Analyze is about 50% faster. We've also added support for custom analyzer plugins, which means that you can now extend upon the analysis server's existing capabilities to report custom diagnostics and offer quick fixes that are unique to your team's workflows. We've also added the pub cache GC command, which identifies and prunes unused packages from your pub cache, reclaiming your valuable disk space automatically. So, hot reload is fantastic for faster app iteration. But sometimes you want to preview standalone widgets in isolation, separate from your full app. Widget previews let you do just that. You test widgets against a matrix of screen sizes, themes, and text scales in a sandbox environment. And as of this release, it now comes with full support for the Flutter inspector. OK, so we've done a bunch of work to improve upon our existing developer experience foundation. Within the last year, however, we've seen an explosion of new tools that change the way that developers are building Dart and Flutter apps. Claude Code, Anti-Gravity, Gemini CLI, these agent-based tools are evolving our roles as developers. We're increasingly architecting, delegating, and coordinating with agents to help us build. Well, that's why we've introduced new tooling to make your agent-assisted developer workflows even more productive. The Dart Flutter MCP server launched last summer, giving agents deeper insight into your Dart code, Flutter project, and provides it with the tools it needs to take action on your behalf. Well, we're excited to announce a new feature that we're calling Agentic Hot Reload. Hot Reload will now just work automatically with every coding agent everywhere. So when you prompt your agent to make a change, it'll be able to make that change and then automatically connect to your running app and reload it to show you your UI updates in real time. Whereas the MCP server gives your agent access to tools, Skills gives your agent step-by-step guidance on how to complete a variety of tasks, like how to build a responsive layout or how to add a widget preview. That's why we're also launching a collection of Dart and Flutter agent skills. These skills will help you to ground your agentic development in Dart and Flutter best practices and improve upon the overall code quality. Plus, skills use progressive disclosure, so that means your agents will only have to reference them when needed, saving you some of those precious tokens. Now, AI-driven features are becoming more prominent in everyday user experiences, from simple content summaries to fully agentic personal AI assistants that can retrieve information and take action on users' behalf. We've been focused on expanding the Dart and Flutter ecosystem so that you have all the tools that you need to build these AI-driven experiences for your users on every platform. I've personally been using MacroFactor to log my meals and macros. It's great for me because I don't want to do all of those macro calculations. Instead, all I have to do is take a photo of my plate, and the app logs it for me. The MacroFactor app is a Flutter app that uses Firebase AI logic to make API calls directly to a Gemini model, leveraging its multimodal vision capabilities to simplify the user journey for logging meals. Firebase AI logic now has server prompt templates, so that means that you no longer have to embed your prompts directly within the app. And as of today, you can provide your agents with step-by-step guidance on building full-stack Flutter and Firebase apps with the all-new Firebase agent skills for Flutter. We're also excited to announce the preview launch of GenKit Dart, an open-source framework for building full-stack AI-powered and agentic apps. It has a model-agnostic API that supports a variety of private providers like Google, Anthropic, and OpenAI. It includes everything that you need to go from prototype to production, including type-safe structured output, tool calling, multi-turn conversations, and built-in observability. Next, I want to take a moment to congratulate two Flutter developers, Tommaso, creator of Gemma Vision, and Guido, creator of Vitae Vere, who won first and second place in the Gemma 3N Impact Challenge, which asked developers to use Gemma 3N, a local on-device LLM model, to build products for a better world. This challenge gave developers the option to choose any tech stack. Well, Tommaso and Guido both chose Flutter to build two life-changing tools. Gemma Vision helps those with visual impairments to perceive the world, and Vitae Vere, which assists those with cognitive disabilities to independently complete daily tasks. Thank you, and congratulations, Tommaso and Guido. Now, I've personally been testing out Gemma 4, which has been purpose-built for advanced reasoning and agentic workflows. The way it's been able to chain tool calls together has been really impressive, and it supports vision and audio input right out of the box as well, entirely on device. It's a lightweight, capable model, and it's great because if you have cost limitations, on-device data constraints, or network connectivity limitations, it comes in clutch. But it can get complex if your app is running on multiple different platforms due to the diversity of underlying hardware. So it was no surprise that when I looked into the Gemma Vision and Vitae Vere GitHub repos and saw that they were using the Flutter Gemma plugin from Hub for their Gemma integration. Well, I'm so excited to announce that full LiDAR TLM support is coming soon to the Flutter Gemma package. LiDAR TLM is Google's production-ready, high-performance, open-source inference framework. It abstracts hardware differences away so that you can run on-device models across platforms and ensure peak performance with GPU and NPU acceleration. Not to mention, the best part, my favorite part, is that it supports all 6 of Flutter's stable platforms: Android, iOS, web, Windows, Linux, and Mac OS. Now, when it comes to AI-driven user experiences, I think we can all agree that we are exhausted by the walls of Markdown. Or worse, plain text. Generative UI, also known as Gen UI, is a UX paradigm where AI constructs and responds in real time with UI rather than walls of text. Over the last year, Flutter has been pushing generative UI forward as a project partner defining the emerging A2UI protocol. A2UI is an open-source protocol created by Google that defines how an agent and a client can collaborate together on the composition and state of a user interface. We launched the Flutter Gen UI SDK late last year. It builds upon A2UI and provides a foundation for building dynamic Gen UI experiences in your Flutter apps, like this one. Package downloads are up 500% since the beginning of the year. Another great example of Gen UI is the Finish It app by Tata Ulusoy, created with Flutter, that not only creates custom lesson plans to help users learn Finnish vocabulary and grammar, but it also composes the right UI on the fly for each one. If you caught the Cloud Next developer keynote last month, you might have seen Flutter DevRel lead Emma Tversky give the app a shout out. Tata, just so you know, I would absolutely love to have a version of this app for learning Vietnamese. OK, so a question that I hear constantly from Flutter developers and the broader community alike is, why does Gen UI matter? Well, Li Cheng and his team at Google DeepMind were pioneers in this area, building one of the very first examples of Gen UI with the visual layout experiment. Today, he's here to talk with us about his best practices and why Flutter was the perfect tool for their project. Everyone, please join me in welcoming Li Cheng.
Thanks, Con. Hi, everyone. My name is Li Cheng. I've led front-end user experiences across various Google products such as Photos, Chromecast, and Android XR. I've had the pleasure of building with Flutter when working at Google Research, Fuchsia, and most recently, Google DeepMind, where I led the Flutter front-end development of Gemini app's visual layout experiment. In a pre-LLM world, users would discover information across web pages by typing in searches, clicking buttons, and opening menus and tabs. Today, now in the LLM world, that same information comes straight at us, often in the form of text. Type text in, get text out, rinse, and repeat. The visual layout experiment sought to explore how we could replace those walls of text with a user experience that's not just usable, but also delightful. When Gemini was first announced, way back in December 2023, our team shared a video showing an early prototype of our hypothesis and interactive visual experience that demonstrated a collaboration between the user and the model that reasoned using interactive UI components, generative UI or Gen UI for short. Many of you in the Flutter community who watched the video noticed the distinctive red debug banner. Yes, we were using Flutter. Our team has chosen to build with Flutter over the years for the same reasons that you do. Beautiful UI, productive developer experience, and multi-platform support, which enables us to share fully functional end-to-end experiences across teams and devices. But we also chose it because its core architecture is quite well suited for Gen UI. But we'll talk more about that later. Our experiment, officially named Visual Layout, was intended to help users find things, explore new ideas, and follow their curiosity visually and intuitively by starting from an initial user prompt and then encouraging the user to select, click, and explore information, customized and updated on the fly through generative UI. So instead of those walls of text, users get beautiful, visually rich user experiences. Studies show that users highly prefer sites designed by human experts, but that's closely followed by the results from Gen UI. Why? Well, take a look. You can see how Gen UI enables users to break free of the constant typing and walls of text. So instead of building static screens, we wanted visual layout to balance a personalized experience, interactivity, consistency, and design guidance. So we provided the Gemini model with a predefined widget catalog. The model can then show information and respond to the user prompt, selection, tap, or click by composing dynamic UIs on the fly using widgets from the catalog and then sending it to our Flutter app. So keep in mind that most of the widgets in the catalog are higher-level templates with business logic already built in. So Gemini focuses on composing them together instead of generating everything from scratch. For example, our GenUI grid is a Flutter stateful widget with pre-baked human-authored logic and UX for consistency and predictability that fit with the rest of the catalog. That means that the AI is solely responsible for picking the grid and then choosing the components that add as children. If you build with AQI or with Flutter's GenUI package, this architecture should look very familiar. So when it came to partner with the Gemini app team and then test our app with real users, our decision to build with Flutter paid off again because we were able to ship our experiment as part of Gemini app's web and mobile experiences faster than any other solution we had at hand. We embedded our Flutter prototype directly into the Gemini app. So late last year, when Gemini 3 debuted, so did our visual layout experiment in the Gemini app. The visual layout experiment has since been completed. A lot of what we have learned has helped shape many of the GenUI developments that you'll see from teams across Google today. So I'd like to share my top 3 learnings from our visual layout experiment for those of you building your own GenUI experiences. Number 1, building GenUI apps with an opinionated, well-defined framework provides a significant advantage. Unlike more open-ended stacks where there's countless ways to achieve the same result, an opinionated structure enables the AI to narrow down its options and in turn generate more consistent, reliable UIs faster. Number 2, clearly define the responsibilities between the developer and the AI. Implement an AI critic loop to review your generated UIs before presenting the final results to the user. In doing so, this ensures that the error reported by the AI critic is actually actionable by the AI as opposed to a bug to the developer. There are many development frameworks that will help you accomplish both of these goals. Flutter's structured, clear, defined way of building apps is certainly one of them. Third and finally, when it comes to GenUI, you can choose templates, which are higher-level components with structured layouts, or you can construct components from scratch from lower-level building blocks. Consider your app's needs and goals here. The visual layout team wanted UX and programmatic consistency along with lower latency, so we chose to use templates at the time. To wrap up, I want to give a special thanks to the Gemini app, Google DeepMind, and Flutter teams for giving me the opportunity to share our experiment with you all today. GenUI, thank you. GenUI was just a theory when we started the visual layout experiment. Today, thanks to the A2UI protocol and the GenUI package, it's a reality that you can start building with right now. My challenge to you, go beyond the walls of text and chatbots. Go build rich, interactive, delightful experiences. Let's make that new standard together. Thank you very much.
All right, thank you, Lite. Let us continue by discussing the many platforms where you can find Flutter. There are quite a few. Are you ready? Are you ready? Let's start with mobile. Who's ready for Android 17? Yeah, we sure are. Flutter is proactively integrating the latest security and usability features, from local network protections to the transition to safer dynamic code loading. We are providing a cleaner and intuitive experience. In this latest release, this also marks a foundational leap in how we integrate with the Android operating system through Hybrid Composition++. This lets the Android operating system natively handle layer compositing, significantly improving complicated renderings in native Android views. This is available on Vulkan-supported devices targeting Android API 34 or later, and you can try it today in Flutter 3.44 through an opt-in flag before it becomes the default rendering in the future. Embedding those Flutter views in existing apps is now easier than before as well. On Android and iOS, Flutter views embedded in existing native apps can now automatically resize themselves based on their content. Now, previously, Flutter views required that the native parent provided a fixed size, which, of course, is difficult sometimes, like when you're embedding a view into a native scroll view. This behavior can be opted into now on both platforms, which, of course, asks the question, what else have we been up to on iOS? On iOS, we have moved to Swift Package Manager by default for all projects. Yes, indeed. This officially marks the beginning of the end in our support for CocoaPods, but as a result is providing a more reliable and modern development environment. For those integrating Flutter into existing apps, the new Swift Package Build command will enable you to consume your Flutter modules as native Swift packages. Also on iOS, you can now take Flutter beyond the app by embedding Flutter views within iOS app extensions, such as the Share extension here. This allows users to interact with your app just as they would any other, without leaving their current task or context. Meanwhile, on the web, we've been deepening our platform integrations, ensuring that Flutter feels native through improved system preferences, accessibility, and seamless text editing. We've also streamlined our workflows with a new development proxy and simplified configuration, removing the need for those complex CLI arguments to enable you to build faster and more reliably. We've also improved browser memory management here with a complete overhaul of our WebAssembly render path, introducing lazy path objects and frame arenas to eliminate jank and crashes for a consistently smooth experience. As seen here, our refactoring of lazy path has shown 25 to 40% improvement in our path benchmarks on web to drive that performance. How about desktop?
Well, yes, the desktop experience has reached a new level of maturity this year, driven by our incredible engineering partnership with Canonical, the publisher of Ubuntu. This year, we've reached a significant stage of our experimental windowing APIs. Flutter now supports tooltips and separate dialog windows across platforms, as well as that content-sized view feature I mentioned earlier. You can also find that on desktop, all freeing you from the single window constraint to create complex, multi-window apps that feel native on Linux, Windows, and macOS. Yes. Yes. Of course, this progress is fueled by Canonical's dedication, ensuring that Flutter delivers on every desktop. Is that all? No, of course. The reach of Flutter extends far beyond mobile and web and desktop. Toyota is now using Flutter to power the infotainment system in the 2026 RAV4. Yes, yes. Now, we will see this firsthand in a moment, so I will ask that you fasten your seatbelts in the meantime. LG as well has been hard at work in this area, continuing to invest in building their WebOS embedder. LG is actually on the verge of launching the WebOS SDK to help developers easily build Flutter apps that target WebOS devices, empowering Flutter for the big screen and beyond. Yes. The WebOS SDK will include plugin support for Firebase, video players, gamepads, and more, as well as all the Flutter features that you know and love, like stateful hot reload and state management, using the familiar patterns that Riverpod offers. So keep an eye out, because this exciting release is just a few weeks away. All right, I think we've made it through all the platforms. But of course, to power all of these native-first experiences, we need a fast and deterministic engine. Let's talk about it. This year, our Impeller engine has been significantly refined, featuring improved Vulkan support and optimized memory management to ensure that high performance. For shader development, we've prioritized ease of use. You can now access uniforms directly by name, and improved compilation feedback makes debugging easier and more intuitive. We've also enhanced visual fidelity, utilizing signed distance functions, as you can see playing out here, to ensure high-quality anti-alias rendering for even the most complex shapes. All of these updates ensure that Flutter remains the premier canvas for even your most demanding visual projects. All right, let's get on over to my neck of the woods. Moving up from the engine, let's get to the framework itself. There is so much that we have done in the framework this year, such as our investments in accessibility, deepening our platform integrations, and refining our accessibility toolset. But of course, the biggest effort this year in the framework has been decoupling of Flutter's core design libraries. Over this past year, we initiated the process of moving the Material and Cupertino libraries out of the core Flutter SDK and transitioning them into their own standalone packages, Material UI and Cupertino UI. As Flutter has matured over the years, there are really three architectural pain points that we've heard about when it comes to these design libraries. First, coupling these libraries to the core framework meant that design shifts, such as the move from Material 2 to 3, forced developers to absorb breaking changes, meaning just to pick up bug fixes from the framework or new operating system support, they would have to refactor their UI. By moving to standalone packages, you gain more control over your app's maintenance lifecycle, enabling you to update your framework version more often while keeping your UI pinned to a stable version. Second, tying libraries to the quarterly stable release cycle meant that new features might take months to arrive to users. Standalone packages can iterate and release on a faster and independent cadence. This is why we took a strategic pause on implementing new design language features like Material 3 Expressive and iOS 26's Liquid Glass, so that they could land in an architecture that supports rapid and continuous delivery. And lastly, at times, developers have told us that implementing their own custom UIs can feel like fighting the framework to undo these strong opinions of these design libraries. To solve for this, a major pillar of the decoupling project has been strengthening the core. We have been meticulously refactoring style-neutral logic out of Material and Cupertino to provide a robust library of unopinionated widget primitives. This work will continue to provide a more design-agnostic foundation for anyone building a custom UI. After all, there are many more beautiful bespoke design systems beyond Material and Cupertino. Perhaps you recognize some of those featured here, along with those who have pioneered Liquid Glass and Material 3 Expressive features. We are looking forward to working with you as we update Material and Cupertino in their new packages. Decoupling represents a fundamental re-architecture of Flutter. It's a deliberate shift to make the core framework lighter and stronger, while giving you the flexibility to build the next generation of multi-platform user experiences on your own terms. And it's happening right now. As of our latest stable release, Flutter 3.44, we are ready to decouple and enter into this new chapter. Expect to see the original design libraries deprecated in the following release, along with migration support through, of course, Dartfix. Now, speaking of custom design systems, I did say we would have a look at what Toyota's been up to. So let's see what's in store in the new Toyota RAV4 infotainment system built with Flutter.
You know, we want this to be as intuitive as possible, and it should just honestly feel like your smartphone.
New software, new capabilities. They know a thing or two about speed because this thing absolutely flies.
The role of our infotainment system is huge. It's what the customer sees when they first get in. The dash, the displays all light up and it welcomes you. So we wanted to create this digital experience where we can introduce technology globally. Where we started to run into challenges was bespoke platforms and suppliers that had their own way of building user experiences.
We might spec something and then we wouldn't see it for a year or two. And when it came back, often there's not enough time to make changes. So a lot of compromises had to be made.
The biggest catalyst was for us to have that touch point or control for the customer user experience. Ultimately, it was about having our hands on the steering wheel.
We were all doing technology studies to try to figure out what's the best possible solution for the next generation of infotainment. Flutter kind of came in almost as like a crazy idea, like, well, what if we try that? What really set Flutter apart is that kind of qualitative experience that everyone had just like touching it. And it really did feel more like a smartphone than like a kiosk or something like that. We evaluated based off of costs. There are a lot of platforms that are not open source and they charge per seat. We did a lot of initial sort of proof of concepts using Raspberry Pi and some screens that we could go get from the stores.
It was really important to us to build our team in a way that puts designers and developers together. That way, when there's things we realize after testing that we need to change, we can sit down together and solve the problem.
Dart is pretty familiar. It's very easy to jump in and learn Dart. The custom embedder is something, actually one of the very first pieces of technology we built in the initial Flutter prototype. We can easily create plugins to kind of support those automotive functions that need to directly be accessed by the Flutter layers.
We want to get from design to production as fast as possible. So when we make updates in our design tool, we can see those realized as fast as possible in code and then on the actual head units themselves.
Overall, our approach with Flutter has really been to leverage the developer tools as much as possible because so many of those tools are already designed with a great development workflow in mind, even if the target happens to be a vehicle instead of a phone. There's a lot of similarities, surprisingly. The pub dev ecosystem has been a huge support for us. The most obvious one we use is Provider. Probably couldn't have built our app without relying on that for almost everything.
Having Flutter as part of our design workflow now has really made us on equal footing with how fast both roles can go, both with design and development. There's no longer a big handoff moment.
Flutter enabled us to have the user experience be agnostic to hardware.
From the feedback being ingested, it is possible for us to put that into code and have it working within the code base within a single day.
We're also deploying this new platform on Rev throughout the world. We have teams in Europe and Australia and India and Japan, all building on the same platform.
The RAV4, that was our first vehicle that we launched the system on. And then in the fall, the 2027 Highlander BEV. We're very excited to get this out on a lot of vehicles. Toyota is the first company that would come out and said we're using Flutter in automotive specifically. I very strongly don't think we'll be the last.
Well, that really adds a new layer to the phrase, Flutter is going places, right? Having grown up in a family that only ever had Toyotas in the driveway, I can't even begin to express how excited and proud I am to see Flutter running in the 2026 RAV4. Thank you to the Toyota team for hosting us. Chris, I saw you walk in here at some point. I had so much fun visiting the Toyota North America HQ and test track in Plano, Texas to interview the Toyota team for that video. I mean, can you tell?
As we look towards the rest of 2026 and beyond, our vision for Flutter is focused on creating an even more scalable ecosystem. The decoupling of the Material and Cupertino design systems is just one in several pillars of our move towards a more open and sustainable operating model. We're not only accelerating design development, but also looking to improve the extensibility of the Flutter engine and the command line tools in order to enable more platforms, something that we're calling pluggable platforms. And Material and Cupertino aren't the only ones moving to their own packages. Over the years, various utilities and classes in the framework have proven vital to the ecosystem, but come at the cost of depending on the entire framework itself. So soon, these foundational classes, like Listenable, will be moving out to pure Dart packages for the entire ecosystem to benefit from. Yeah. We are also so excited to announce today an expanded partnership with Canonical, who will now serve as the lead maintainer and strategic steward for Flutter Desktop. Yes. Woo! With their deep technical expertise, Canonical will lead the Flutter Desktop roadmap and oversee the maintenance of our Linux, macOS, and Windows embedders. Which, of course, this collaboration only represents the first step in a broader ecosystem expansion. Moving forward, we are actively expanding our governance with more partners to bring Flutter's high-performance, multi-platform experience to even more environments and industries. To inquire about partnering with the Flutter team, contact partners at flutter.dev.
And speaking of our community, Flutter would not be where it is today without our passionate, driven, and vocal community of developers. We've been so excited to see the community's excitement and feedback on all the new features and announcements. So much of the work that has made Flutter great has been driven by feedback from you. So please keep it coming. If there's a new feature that you love, drop us a comment. If there's a feature that's not quite working the way that you want it to, send us a reply. And if you have a feature that you want to see that doesn't exist yet, please file an issue with a feature request. We want to hear about it. In fact, we have a developer survey going out soon, so please let us know there as well. In addition to that, our team is hitting the road this year and attending a ton of conferences and events across the globe. We're constantly adding new events to the list, so if you're close by, please come on out and see us and show us what you're building.
And of course, if you can't join us here in person, then come hang out with us online. We have more Google I/O deep dives dropping on the Flutter Dev YouTube channel in the coming days. Now, of course, before we sign off, though, think back on the stories that we shared today. Individually, these features are impressive, but collectively, they deliver on Flutter and Dart's promise of a robust ecosystem that empowers developers to productively build and ship incredible user experiences. From the infotainment systems in the cars we drive, to the tools that manage our businesses, to the apps in our daily lives. Flutter is everywhere, every day.
And look at who's building with and contributing to this incredible ecosystem. It's industry leaders like LG and Toyota, it's Canonical leading the charge on desktop, and so many more that we didn't have time to talk about today. But most importantly, it's every one of you, the over 1.5 million developers pushing code, filing issues, and shipping the experiences that define our daily lives. And that's why Flutter is built by everyone, for everyone.
It's been an exciting year in the Flutter and Dart world. I hope you are all looking forward to the next one. Thank you.
Thank you so much. Happy I/O.
Hi, I'm Kara, and today I'm going to show you how Firebase and Google AI Studio can help you bring any app idea to life.
And I'm Sam. I'll be helping to drive along too.
First, before we jump into the demo, let's recap what Firebase is. Firebase is Google's suite of services for app development. We help mobile and web developers build, launch, and grow their apps. With Firebase, you can accelerate your app development using AI, and once launched, you can improve app quality with testing and monitoring. And finally, you can drive user engagement with analytics and messaging tools. Firebase currently has millions of active developers. Firebase makes it easy to build apps. Our secure client SDKs allow you to build your apps on web and mobile platforms while sharing the same backend in the cloud. You can build your app logic just once from the client. Using Firebase Auth, you can easily implement user sign-in and manage user access to your backends. And features like real-time and offline come out of the box. That's not all. You don't need to worry about scaling. Firebase is serverless and backed by Google Cloud. The app will scale with your users without you needing to lift a finger. Finally, with AI capabilities as a core part of our services, Firebase makes it easy to integrate Gemini API calls in your app, store embeddings in your database, and much more. That's not all. I'm super excited to announce that Firestore now supports full text search. We have a new search API which allows you to query documents for arbitrary data, including strings. Search queries return documents along with a search score, so you can sort documents by relevance. We've also added some fancy knobs to the API that lets you control retrieval depth, sort order, and inclusion of synonyms.
Those are great improvements to Firestore, and we're making them available in Google AI Studio too. Google AI Studio is Google's fastest path from prompt to production. AI Studio is a vibe coding solution, which helps you build and deploy apps using Google's latest Gemini models. AI Studio helps prompt Gemini with intelligent context management and coding best practices, so you can use natural language to build apps.
Building an app using AI Studio is great, but what happens when you want to store data or let your users log in and have their own accounts? That's why we've integrated Firebase into AI Studio. If needed, AI Studio can set up Firestore and Firebase authentication to turn your prototype into a real app that's ready for users. Hey Sam, so I've been kind of stressed actually. We've been building out this talk and there's so many things to do. I can't figure out if we're behind. Not to mention, I want to make sure we remember to celebrate our milestones. Could we build something to help?
Hey Kara, yes, let's build an app. What I love about these new AI tools is that they make building apps much more approachable. It opens up possibilities that seemed too heavyweight or complex before. Kara and I have worked together on a ton of projects at Firebase over the years, and we've tracked progress in all sorts of ways, using plans in documents, plans in spreadsheets, plans in bugs and comments. One time, we tracked a project using a plan I wrote on a receipt. But my personal favorite is the Kanban board. I love moving cards from idea to in progress and in progress to done. What if we made our own tracker just for this talk? Here I am in Google AI Studio, and I've got an input box here where I can put in my idea and let Gemini do the rest. Let's put it to the test. I've got my prompt pre-written here. I'll put it in and read it out as the model gets going. Let's build out a team planning app to plan projects. Make it Kanban style. Let the users create projects, and then, within the projects, let them create tasks and move them from a backlog, in progress, and done. When all the tasks on a project are done, have a fun celebration. Start simple for now with no extra integrations. When I click Build, Gemini will get to work. AI Studio brings us into the development environment, where Gemini is interpreting those product requirements and building out an app. In the chat here, I can see a view of what changes are being made, including a view into its thinking progress and the pre-work it needs to do. Next, it installs the necessary packages and gives the app a name. I love looking at these little drill downs where I can see how it's thinking through the problem, considering the features that it needs, and building out the core functionality. As it does this, I can see the code starting to appear, like creating task and project types as the core data structures. Once more of the code gets built, I can switch over to preview mode to see the application live. And just like that, I've got my new team project tracker. Let's try it out and see how it works. I'll create a new project called Test Out the New Project Tracker. Now I can create a test task, like try it out. And there it is in the backlog column. I can move it from the backlog to in progress, and I'll widen this to see all the rows together. I then move it from in progress to done. And cool, I got a fun celebration. The project tracker seems to work pretty well, but right now it's strictly single player. What if I want to share this with my team? With Firestore and Firebase authentication, we can add a backing database and authentication flow so that folks on my team can log in with their own accounts and share the exact same view of the project. Let's try that now by prompting add Firestore to this project and store the progress in the database. AI Studio recognizes this request and presents a special UI dialog for this exact case. It details how it's going to store the data using Firestore and then starts the Firebase setup process. Under the hood, it's doing a few different things to get this working. It creates a Firebase project if needed, provisions Firestore, and enables Firebase authentication with Google Sign-In. Then it takes all of that configuration and automatically adds it to the applet. As it goes through the process, you can see the new files getting created in the code view. One of the key things it does is generates a Firebase blueprint file. This blueprint records the structure of the application, tracking the schemas and data structures the applet is using. AI Studio also automatically generates security rules and deploys them to the database. Once the database is configured, it wires up the authentication so that each user can log in and get their own personalized view of the applet. It looks like the generation is done. Let's try it out. I'll create a new project, try out version 2, and then create a task, send it to Kara. Let's see if this worked. I'm going to press the share button and share this applet with Kara.
Thanks, Sam. Let me try this on my phone. Okay, I'm signing in. Let me switch into the project called Try Out Version 2 that Sam was on. Now I see the Send to Kara card. Let's click Start Task and move it to In Progress. And now let's mark it complete. There it is. It's so easy to track how we're progressing on our project.
And awesome. Your change shows up on my screen too. In just minutes, we've used AI Studio to build an app with a database and login, allowing the whole team to share state. We're so excited about what you're going to build using AI Studio and Firebase together, and we'd love to see what's next.
With a single click of a button, our app got supercharged with Firestore, Firebase Auth, and Firebase Security Rules. These products have been around for almost a decade and are backed by the scale and reliability of Google Cloud. Using this Firebase integration means that your prototype can evolve into a full-fledged app without the need to re-architect anything. Now, did you notice that when I clicked Done, Sam saw it immediately? Real-time sync and offline functionality are included by default, so your Vibed app can feel just as snappy and responsive as what you're used to, making it a great experience for your end users. All right, Sam, I think we're ready for prime time.
I agree. Using AI Studio, you can refine and iterate on your app by prompting and chatting within AI Studio. But in this case, I think we're feature complete. Let's publish this. You can deploy to Cloud Run from directly within AI Studio. I'm clicking the Publish button, and boom, there you have it. It's been published to the web. AI Studio has a whole gallery of applets like this that you could remix to make your own, or you can start from just a prompt. Check them out at aistudio.google.com/apps today. The URL is available in the video description below.
As Firebase, regardless of where you write or create your code, we want to meet you there. This integration with AI Studio showed how easy it is to create a fully functional full-stack application with a cloud database and authentication system. If you prefer to work in a local environment with an IDE like Google Antigravity, Cursor, or Cloud Code, we also have Firebase skills available for you to achieve everything we just went through as well. Check the description below to learn more about Firebase skills and how to install it in your IDE of choice. Thanks for watching, and let us know in the comments what apps you're building with AI Studio and Firebase.
We'll take a break now, and we'll be back in 5-10 minutes. So I will have the stream going, and let's search for some loyalty-free music. And play it for you guys. Yeah, I think so. Claude's music stream will work.
I was looking forward to this conversation to sort of talk about the whole slew of updates and actually hear from folks across different parts of Google. Tulsi Doshi leads our model team inside of DeepMind and is a co-conspirator in launching all these models. Michael leads the Gemini Enterprise Agent Platform, formerly known as Vertex AI team, and is really focused on sort of bringing models to our enterprise customers across the board. And Varun leads the anti-gravity team, and lots of exciting updates. Anti-gravity was sort of, Chelsea, we were talking earlier today, sort of another conduit to bring together the Google ecosystem beyond just Gemini models. So lots of fun, lots of things to talk about. But maybe, Chelsea, we can actually start with the model and sort of Gemini 3 Flash, our best model ever.
3.5 Flash.
3.5 Flash, the most capable model ever that we've shipped. You want to give us sort of the highlight and sort of your reactions now, sort of 24 hours after getting the model out the door?
Yeah, so I don't know if any of you had a chance yet to try 3.5 Flash, but as we announced yesterday, and as Logan just said, we're really excited about this model because it is our best model yet. If you look at it compared to 3.1 Pro, it really actually does better on most of our benchmarks. But I think where we're really excited about it is actually how much better this model has gotten when you look at tool use, when you look at some of our long-running coding tasks, when you actually just look at a bunch of actually more real-world like finance tasks or as a PM, even things like slide deck creation and kind of like productivity tasks. This model is really good, and I think it has this really nice combination of performance and speed, which actually comes to bear, I think, when you're actually trying to iterate quickly with the model. And so we're really excited about it. It's an anti-gravity, so you can try it there, obviously in the API and in AI Studio. What's also been really awesome about this model is it's not just amazing from the developer standpoint, which we'll talk more about, but also it's now in the Gemini app and it's in AI mode, and so it's actually powering a lot of consumer experiences also through its amazing like scaffolding and capabilities there as well. And I think that's been really awesome to see too.
Yeah, I love that. I feel like we sort of, something that you said this morning when we were talking to Tulsi really resonated. And Varun, maybe I'm excited to hear your reaction to this. There was sort of a comment about, the tension of building a Flash model as we continue to push the frontier of intelligence. And like what sort of Flash means today is actually different than what it meant a year ago, different than even what it meant 6 months ago. And a lot of this is actually grounded in the use cases in which how people are using the model. Like the way that they used to use the model was like, a chat UI, and they were just simply asking questions. And sort of now it's, long-running agentic use cases, and people have a 24/7 agent with, Gemini Spark running behind the scenes. And Varun, I'm super curious from your perspective, like your reaction to that, but also like how you think about like finding the right balance and actually I think like software development is an interesting use case because developers are doing so many different things, and it's difficult to encapsulate software development in like a single action that a developer takes.
Yeah, I think it's interesting. Sort of when we started taking a look at some of the Flash models, they were much more, as you said, kind of like AI overviews, AI mode style chat use cases, right? Not a ton of thinking, but then able to maybe take a bunch of search results and then kind of create a good answer. I think what we're seeing now is the Flash models are also able to go for a very long time. Many steps, right? Like I think one of the things that I talked about during the keynote was building an operating system, right? This was 15,000 model invocations that the model went through. I don't think that was the case before, and I think this is a testament to our research team to be able to push these models. In some ways, actually, like, I've seen cases where the model actually will think for 30, 40 seconds on a Flash model, and in the past that was just not the case. So I think the level of intelligence, agentic capability, right, that the model can actually kind of explore the environment over a very long time horizon, it's kind of changed the way we perceive things. And I think one of the exciting things that we wanted to bring to folks externally that we were seeing internally is just the speed, right, especially on anti-gravity. I think Flash is already really fast. I think we published a number that it's like over 200 tokens a second, much faster than the other frontier models. But we wanted to give people an even faster experience, and we think this kind of counteracts the fact that, hey, the model is thinking for a while, the model is calling a lot of tools and all this stuff. So it's kind of an exciting time to see both of these things come together.
Yeah, I love that. Michael, something that I feel like the cloud team sort of grounding this moment, obviously Vertex sort of renaming to Gemini Enterprise Agent Platform is like a very intentional decision. I think it sort of represents sort of this change of how people are building with the models. I think historically it was, take a model, stick it into some product, do some, chat style UI. I think the announcements from Cloud Next and I think now coming through IO is like very focused on how do you actually build a product around this like new era of models. And I'm curious like what your sense is as the future of software development feels like you're going to need agents in order to make that happen. I'm curious how you're thinking about it.
Yeah, that's a good question. And on the topic of the models, what I'm finding is that the use case drives a lot of how we think about these models, right? It's not a spectrum of intelligence, it's not a spectrum of latency, but it's actually like an easy to describe intentional reason to use a lot of the models. Something like Pro is completely intelligence bound. Something like the modern Flash that we recently released is state of the art on intelligence. When a software engineer writes code, they frequently just like assign a Jira ticket to it. Like it's less and less frequent interacting with your IDE. So you can set it, you can forget it, you get the code back. And in that interaction pattern, the chat UI is really a matter of information retrieval, right? The agent is going along its merry way, trying to solve a problem. It realizes it needs data that isn't written down, so it has to pop up and ask a human to unblock it by providing that information. And in the enterprise, a lot of information isn't written down. I think in our lives, obviously, we don't like store our birthday in a Postgres database. You know what I mean? Like if we need to know our birthday, it might just ask us, right? And so in that interaction pattern, in the long running pattern, it's more important that chat is used as information retrieval. Whereas in something like traditional use of Flash, if you're Verizon or it's very common to transact a return for merchants using AI these days. That looks like policy application, and a very dry policy application sounds like it can take as long as you want, but in reality, you have somebody on the phone trying to figure out if you can transact that return. It needs to happen very quickly. You really have a time budget. So in that, you need to be as smart as possible in 250 milliseconds. You have to be very good at determining whether this is in policy all within 250 milliseconds, and then you lose the customer no matter what. So in that agentic use case, right, you might have sub-agents looking up what the policy are, but you're using a Flash in order to transact a return, and you're just like willing to take the risk of applying the policy incorrectly. And then on the Flash Lite side, we have a lot of customers monitoring the entire internet. You can think about, I'm not sure I'm about to name them, but the biggest companies in the world who have internet scale products that have toxic users need to moderate those things. So for that, or AI overviews on search, right, you don't know how many customers you're going to have, and so as a business, you have to restrict your budget, even if the budget is very large, and you're thinking about infinite scale. So that's how intelligent can I be over infinite scale. All three of those are agentic in nature, and all three imply different interaction patterns, but we have models for all three. Does that make sense? That's what I'm saying.
Yeah, no, I love this. And actually, it's a perfect segue to, I think even in the future of sort of like quote unquote future of software development, there's a spectrum of things that we're seeing. I think on one end of the spectrum, you have sort of, and actually Andre Karpad, I'm
stealing Andre's words, he had the best framing of this that I heard. At sort of one end of the spectrum, you have this sort of vibe coding use case, and the people who weren't building software before now building software, sort of the constraints and the requirements for that audience is actually different than sort of the person who's using these tools to build production systems. It's much more agentic engineering. And again, the set of constraints, the systems that you need for that use case is different. I think in the model side, it's actually different too. And I'm curious as you think about this whole like how to balance and whether or not there's like trade-offs between those two things. I'm not sure. Sort of like the vibe coding use case versus the agentic engineering use case.
Yeah, I mean, I think so. There's a set of foundations that I think are true across all use cases, right? You need the model to have a certain level of reasoning capability. You need the model to be able to call tools effectively. You need the model to be able to understand, for example, multimodal inputs, to be able to generate high-quality, correct code, right? Those are all things that are true, regardless of whether you're talking about the vibe coding use case or whether you're talking about a legacy code base. But I think across these use cases, you do want the model to see these different kinds of use cases when you're thinking about training the model, and you also want to evaluate the model's quality across these types of use cases because it is very possible that you could build a model that's amazing for vibe coding web applications because it has a certain level of reasoning, it has a certain level of aesthetic polish in that it can generate, but it actually really falls over when you give it a legacy system because its understanding of that type of context isn't that strong. And so you actually need to build a model to actually have that sort of variety because you actually need different things. So for example, when you're talking about a code base that is like thousands of lines of code, your ability to actually understand that context and use it effectively becomes really important, where that maybe is less important when you're talking about single prompts to web app, right? And so I think it's really for us about really breaking down these different types of like use cases and then actually walking through, okay, what does the model need to be able to do to make these use cases effective? And then how do we actually take our own experiences from the users who are using anti-gravity internally and externally, from users who are using AI Studio, from users who are using Canvas and the Gemini app, and how do we actually bring all that feedback back as we're training the model?
Yeah, Cora talked yesterday a bunch about sort of this. He made some comment to me when we were chatting, which is something to the effect of, it would be hard to actually build a great coding model without this product flywheel. Like it really is an integral part of, and we were talking with Josh this morning about this sort of product model harness symbiosis that sort of exists. And I think anti-gravity is sort of playing at almost all three of those different levels. And I'm curious your reaction to that symbiosis, if you agree, but also maybe like the challenge is actually trying to get each stage of those things right. And I think you need all three if you want the flywheel to spin.
Yeah, I think when we started a while back, I think the harnesses were pretty simple in a lot of ways. Right? They were simple in that for the most part, they were bash, maybe a couple file system calls, and then maybe like requesting feedback from the user. They've started to get more complicated, right? Like right now with anti-gravity, the model natively can ask to create subagents. Those can run asynchronously. You can run asynchronous tool calls. This is very important when you run things that are long running. Let's say a researcher spins up a training job. You can't just have it be the case where the agent is blocked until the training job completes and can't really do anything in the meantime. That and maybe like while something's running, the user wants to send a message and then override what the model is actually doing, right? So these are all interesting details that are very specific. And naturally speaking, if all you're doing is pre-training or post-training on lots of data that looks like sweet tasks, like sweet bench style tasks that are just GitHub PRs, you're not going to get those level of detail. And it's very important that we actually train the model to be capable of that. And then also the people that are building the models to see how the current version of the models perform with different harnesses. Right? So that symbiosis is very much felt at this point. So the exact product that people are consuming outside is something that researchers inside are like benefiting from, struggling with, and they're like actively trying to optimize. Right? So it's both like I guess on the research side, we're actually doing reinforcement learning on the harness, but secondarily also people are able to feel the performance, right? So now we never get into a state where let's say someone in research says we have an awesome model, the benchmarks are awesome, but then we put in the product and just immediately say, oh, this is like not very good. Right? We thought that this behavior was very good, but actually in reality when we play around with it, it's much worse. So that feedback loop is like ridiculously important, both on kind of the vibe side, as you would say, and then the real harness training loop side.
Yeah, there's definitely an empathy building exercise that I think has been really effective here.
Yeah, one of the interesting things about Michael, I'm curious. I think some of the tension of this moment that we're in is that every 6 months, the models have shifted so much that the way you actually have to go about building products and building with the products and using the products has to change. And one of the things we were talking earlier this morning, I'm curious your reaction to this, Michael, is just about like the model sort of like tends to keep like eating certain things, and like the scaffolding layer, the harness layer is maybe one example of this. In the future, it might do a lot of these things, might be more baked into the model itself. And I'm curious if you just actually, we have probably a bunch of folks who are sort of building with our models, if you have sort of advice or suggestions, how to stay on that frontier, how to make sure that sort of you're making progress with the model and not trying to work against it as progress inevitably continues.
Yeah, there's obviously a tension between what the models are capable of at any one point and trying to predict where they're going to go and building a product that won't deprecate. Because you do usually want to build a product for yourself or others now. It's hard to wait for that. But at the same time, like I said, there is this natural tension. So like the conversation over the past, call it since last February, has been all about agent building. And then more and more, what the labs are doing and what we're doing is we're providing an agent API, an agent in the CLI. Like we are providing the agent, and we were offering everybody else to provide it with tools and context and a goal, right? And by training the harness behavior into the model, it's probably better than what most people can accomplish if they build their own agent, right? And so like we did, so the conversation has changed dramatically, even in the last month or two. It went from like help me build an agent to like help me use your agent for my purpose. So both of those exist, and I think they will continue to exist, and we'll have to deal with that. I do think that a lot of the metaphors about treating the model or model's harness together as a coworker is pretty valid, right? And so thinking through how do I build something that fails today because the models aren't smart enough, instead of how can I build something that fails today because I built it wrong, that's an enormous difference. And if you're trying to interact with the model and the model is sort of behaving like a poorly performing employee that you hired incorrectly, that's sort of one thing. But we should be thinking in terms of that future term where we can like pair with the model, whether it's on Slack, whether we call the model, we GVC meet with the model, right? Whether we email with the model. These are just interactions. It should be the same harness. It should be the same model underneath, even if it gets replicated. And then we should think through like how do we want to be using it, and assuming that you three will get us there with a better model.
I love that. We can always have better models.
And that's going to happen. Like we've been all doing this for quite some time, and we're seeing the models get better faster than ever. Not, you know what I mean? Like I think we can safely bet on that happening. So we should take it as axiomatic and build for that world and fail until the model lets us succeed.
Yeah. One of the questions actually, Tulsi, just for this, part of the tension I think of the software engineering story, and I think Vern, you mentioned something to this point as well, is it becomes increasingly difficult for the actual like evals and the benchmarks that exist in the ecosystem to actually approximate what users are doing for these really, really complicated use cases. And I'm curious, sort of just in the sort of arc of where we are for coding and software development in general, like how you think that is going to end up playing out. Is it just like the way that we measure how great models are at doing all these tasks is going to like require like an actual product in order to do that, or you can sort of, I feel like a lot of benchmarks these days are almost like approximating products themselves. You have to like build a lot of infrastructure in order to like do a sweet bench these days or one of these other benchmarks. I'm curious.
Yeah, I do think. I mean, you're already seeing that to your point in how our evals are changing, right? Our evals are approximating more product experiences. They need to be inherently more complex if they want to replicate inherently complex tasks, right? Like a fun external benchmark example of this, I guess, would be something like vending bench, right? Which is like literally simulating the ability for a model to run a functional store and earn profit, right? And that's the kind of example of a very complex benchmark that actually measures how the model is able to do this over the span of days. But I also think that one thing that we're realizing, and this goes to Vern's point about like building empathy for the vibes and like really actually understanding kind of real world engineering use cases, is we're also leaning a lot more into even just like live experiments and actual like side-by-side feedback. And I think you're going to need both of these things. I don't think we can just rely on one or the other. We're going to need our benchmarks to get better and more complex, and then we're going to need them to represent a diversity of use cases. But we're also going to need to just keep putting the model in the hands of users, because actually one of the things that I think really has come out to me from a lot of the feedback we're getting from our developers internally and externally is that a lot of the feedback is actually a lot more qualitative and subjective, even in the coding space. I think we often think about coding as like, oh, it's like very verifiable. You can just like, it's either right or it's wrong, and like either you're getting something correct at the end or you're not. But actually a lot of the feedback we get, and Vern's speaking about this too, but is a lot of like the behavior of the model, right? Like how the model actually like talks to you while you're coding, right? The efficiency of the model, and so the laziness of the model or the overeagerness of the model, and like these are all things that you can sort of suss out from benchmarks, but the actual impact they have on a regular developer's experience, I think you really only see in the live experiment and from the feedback. And I think that has become like a really, really important part of the flywheel too.
I mean, one thing that I'm saying anyway is that the way people use it, and I assume that the benchmarks are looking, it's not multi-turn pre-fill decode, right? It's actually like the model will have to write its own software, run that software, get a return value, and then interleave that with sampling so that it gets more language out and continues to iterate with a workstation, with a computer, right, in the cloud. And so it's not really
it's not as linear.
It's not as linear anymore. That's right.
Vern, one of the interesting things is I feel like agentic coding is like probably the first use case where people like really spend a very long time with the model interacting. I think it's actually an interesting wedge to sort of like figure out a bunch of the other things about the model from like personality standpoint, how eager it is, how does it post, is it like underappreciating the hard work that it's doing. And I'm curious like if you sort of felt that as done all these LEs and anti-gravity and as the product continues to develop. Also how to like get people familiar with that experience. I feel like it's not a muscle that we have. So many AI use cases today. You sort of ask something, you get an answer back, you go on with the rest of your day. You ask for an image, you get an image, you go on with the rest of your day. It's not like deeply multi-turn. I feel like agentic coding is like probably the most notable exception to that.
Yeah. So I guess the reason why coding as a whole was picked was because of what Tosi said in the beginning. It's very verifiable from one perspective. Like a lot of other sort of fields of knowledge work that are in front of computers, it's not that easy to verify this in the same way. And also it's like very long, right? So you can actually, it's a great problem if you want to test the capability of your model. You can go arbitrarily long, right? Like you can go from I guess writing like Fibonacci to then building an operating system to building a browser to I don't know, building Google, right? Technically there's like a scale of what you could possibly do. I think the reason why like people see this is because this is the classic thing I think for software engineers. Actually they do three things, right? The first thing they do is they decide what to build, they figure out how to build it, and then they build it, right? And just the process of deciding what to build and how to build it is a very sort of interactive process, and something you'll need to work with a model to do, right? And I think at this point we can all say like if you have a perfect vision of what you need to do, these models have all gone to the point where they can just perfectly execute on it, right? Like if you say, hey, I want you to execute this unit test in this place with this capability, like we can do that amazingly, right? And the complexity comes from when there are details that are kind of like blurred and not filled in, and that requires some interaction between the user and the model. So you kind of get a feel of like, hey, what does it mean for a model to be well behaved with the user? And this is why this field has become like such a hot area to kind of like improve behavior and stuff like that.
Yeah, I love that. One of the interesting things to see play out, and actually, Chelsea, I think you mentioned this, or actually, no, Michael, you mentioned this, like the direction of travel is like the models are getting so good at coding. Like I think that's like it's a reasonable bet to assume the trend line continues. Assuming you keep working nights and weekends, we'll see you and Vern. We'll get better models, sort of they'll keep getting better. 18 months from now, sort of when we've gotten to the point that the models are actually like incredibly good, coding is mostly solid as much as it can be. What's your sense of like where does the bottleneck move? Because the bottleneck moves somewhere else. Like obviously, if the like actual, Vern, to your point, like the three stages of what people building software go through today, if the last stage of actually executing on the vision and the idea and how you want to solve the problem is solved, I'm curious for all three of your perspective about where do the bottlenecks end up in that world as the ability to create software happens very fast.
I mean, I think you're basically gonna push the bottleneck out in both directions of the actual building, right? So I think on one, you can almost say like you're limited then by your ideas. Like you're limited by the part about like what do I want to build? And actually, I think then the interesting opportunity for everyone in this room and for all of us is almost like taste, right? Like actually really identifying what are the problems that are really important to solve. Because when building is so easy, it's very easy to then build for problems that maybe even aren't real problems, right? And I liked how Josh said this earlier today, like really find the pain points for users. Yeah. And like I think your limitation then is like, are you finding a real pain point and are you actually able to solve for that? But then you also have a problem on the other side, and you're gonna have bottlenecks on that side too, which is just because you built a product, do you have like the capacity to scale that product? And like do you have the ability to scale that to the set of users you want to scale? How do you reach those users? How do you design the product in a way that it is like understandable and grokkable and easy to use? And I think you're going to see bottlenecks on both of those. And so it's going to be more and more important that we start building that kind of muscle of not only how do you design an amazing product, but then how do you actually deploy that product.
I love that.
I think there's a very clear bottleneck today in information retrieval, and sort of like in the future, software development will get easier and easier and easier, and at one point maybe they won't even matter, but any process bogs down, any blocking node in any process is usually because there is some sort of like authority that needs to be given or information that needs to be retrieved in order to continue the process. And that's definitely true. I mean, less true in getting a product to production, but I don't think it's that controversial to say it's much easier to build a coding agent than an SRE agent. An SRE agent has to continually query the state of an etcd cluster and make a next step and a plan based on the most recent state of the etcd cluster, of a Kubernetes cluster, right? But in software, usually all information that you need is already written down and you've given it a task and it can run for a long time without hitting a blocker like that. So there's plenty in software development that we're going to get over by solving these information retrieval bottlenecks. And there's probably plenty in the SDLC, if not in the authorship of code, that already the models are intelligent enough for, and that IR problem is already the bottleneck. That, like testing software, like deploying software and keeping it secure, and you might need access to a database in order to do a unit test with real data, stuff like that. So I think there's this like very real IR problem that the agent harness contemplates that is different than intelligence, which the model contemplates. And by solving both together, we can get a very long way.
Yeah, just to double click on this, I'm curious. Like obviously, developers have been doing RAG and sort of some amount of like information.
But that's not comparable data, right? Like again, that's not interacting with a customer to make sure that you can transact a return in a real situation, or a bank's KYC process. There are two banks that I know that are running their know your customer process with the models, which means that not only do I have to look up a very wealthy individual to determine whether or not they sit on a board with somebody from a banned country, and they might be a money laundering risk, but I actually know who that person is. I run a background check. The bank has run a background check on them, and that's very sensitive data. Not nobody actually. These two banks are credentialing their agents to that very sensitive data, but they're only doing it now because they know that data won't be exfiltrated. Before that, the model was intelligent enough. One bank did this in May, the other the next October. So quite a bit away. So that's not because the model got smart enough. That's because the bank figured out how to solve the IR problem with the right level of credentialing to run the process. You see what I mean?
Yeah, no, that makes sense. I feel like that is the where a lot of the frontier challenge is actually moving to, is how to.
And the models can write good SQL. They can even plan and say, I need information I don't have, instead of going ahead and hallucinating. But that's a software problem and not a model problem in many ways.
Yeah.
It's also it's a software problem. It's also in many of these cases like a safety and security. Like there's a number of these other layers to this that are part of the problem.
100%. So those are bottlenecks that I see.
Sure.
Yeah, I was just gonna say, I think people somehow believe with AI we're just gonna get like products that already exist are gonna get way more. There's gonna be way more stuff in them. I actually believe that it's very hard to even decide what to build, right? Like if I take any product that is good today, I can't just like add 100 buttons and be like, oh, this button does X, this button does Y, and expect my users to get the sum of all of those capabilities of button. I know a lot of products that look like this. Don't want to call them out some enterprise products that look like this. But I think that's like just a tough problem to solve, right? So you're gonna have, I think the people that are gonna shine are the people that are gonna be incredibly high agency. They can make hard calls. But these are very tough. They're tough to make. Like users cannot take in like hundreds of things. And that's gonna be what's in very short supply. And that's like what I think builders should really focus on. And that's gonna be like a hard skill that we're all gonna be trying to build. Right? What should we be building? Is the hard problem, right? And I think that's always been the hard problem. Yeah. Right? It's never been like I think a lot of crazy stuff has been built at Google. I think the hard question is not like how does this piece of infrastructure, this crazy piece of infrastructure work? We have Spanner, we have all this crazy stuff in Google Cloud. It's like what should I actually be building is the hard problem.
Yeah, that's a great question. What should people be building? I have a couple more questions that I'll ask you, and I want to make sure we get time for audience Q&A. So if you have questions for our lovely panelists, please queue them up, and then somebody somewhere will have a microphone for you to ask the question. One of the other ones that's very top of mind is sort of as the way we interact with agents continues to change. I'm curious, like this interface layer matters a lot. Vern, you showed sort of like the talking to the model. We had this with Google Docs yesterday, being able to talk to the model. Feels like audio is like obviously one of those paradigms. Other thing maybe it's just audio, like other ideas or comments just sort of about how that interface layer is actually changing and how it is actually tied in a lot of sense to not only the model capability powering it, but sort of how you can sort of rewrite the interface because
how do you like redesign
for this new era. Yeah.
And I think it contemplates both quite carefully, right? If we redesign for the model to interrupt us, to unblock it, it has to have a sense of savoir-faire. It has to know if it pings us and we were too busy to respond, should it be persistent? Should it ping us 3 more times? Or should it wait an hour and then ask us the same question? Or should it just like, this is not important to this person? Do you know what I mean? And like that interaction is going to be very tricky to get right because nobody wants, like everybody's gotten called like 1,000 times from a very persistent salesperson or something that's very annoying. And we don't want, like if we move into a fully agentic world where our agents are coworkers and we expect them to have agency and good judgments, then when should they ask us for help? I think it's a very careful question that we'll have to contemplate.
Yeah. A good push.
I guess I really believe audio is going to be very big. It's clear we haven't like completely cracked it. Like obviously I do use live voice transcription like very quickly. It's in anti-gravity. It's something I use. I also use it on other apps as well. But it feels like it could be so much more powerful, right? Like imagine a world in which you have 100 agents kind of running. I don't even know which agent is which. I want to be able to talk to my machine and for it to kind of like tell me like, hey, here's what's going on right across all of your agents that are running. We're not quite there yet, but I'm sure that's in the works. Like we'll figure that out.
I think it's also interesting. This goes to a debate we were having this morning about whether we think that the paradigm of building products is going to lead to like thousands and thousands of products, or whether it's going to lead down to one product. And I think like the question that I think is going to be really interesting in all of this is like, do we in these 2 examples, there's sort of this implicit assumption that like we'll get to a world where there will be almost an interface, right? Maybe you talk to it with voice, maybe you do something else that then can spawn off a bunch of agents that can actually go do a number of things for you and kind of come back or proactively reach out. And so there's this kind of interesting shift then that would happen from a world where you have like 20 different apps to do 20 different things for you, where you're going to app A for X and then app B for Y, to a world where maybe you actually have a much simpler view of the world, where you're actually saying, okay, I trust this interface. I'm going to ask this interface a bunch of different things that I need to get done, and I'm going to trust that it can actually find the right product solution for me. And that is a pretty big shift in design principle and a pretty big shift in how you approach product making, I think.
And not to like lean too heavily on the metaphor, but again, this is how humans work, right? A human is a person, whether they're calling you, they're the same person today. Whether they're choosing to call you and their interface is the phone, or they want to chat you and they're being very precise and you can read every letter, or they want to email you, or like there are many ways that we interact with each other, and we have good judgment for when to do it. A call is always interruptive. I'm not going to call Sundar on the telephone and expect him to pick up, right? So again, like the agent is the person, is the product. The interface should be chosen by the agent to be appropriate for the interaction, right?
Yeah. All right. My last question, and then we'll go to audience Q&A. If you could sort of wave the magic wand and sort of have a new sort of model capability or product capability, anything on y'all's sort of personal wish list. And I'd actually love to hear the answer to this from the audience as well, maybe after the session. But yeah, anything for you all that you would love to sort of wave the magic wand and be able to fix or have?
I mean, I can tell you one that is very random and probably not that helpful to a wide range of people. But I'm a dancer, and one of the things that I've been trying to do for a long time is actually like leverage our models to actually help me with choreography. And it's actually been harder than I thought. Even the parts that I thought would actually be easy to automate. Part of that is like something very simple, which is that in order to upload a video and have the model be able to do useful things with it, the model has to be able to consume a very fast set of frames per second because dancing moves very, very quickly. Yeah. And so there's like literally this like actual like physical constraint on what the model is actually able to even understand and consume to then be able to actually even give you actionable insights. And so it's one of those things that like actually is not just a model problem, it's also like a system problem. And then there's actually a model problem. And creativity in that format of something like choreography is also very hard, right? How do you help the model understand lyricality, for example, which is like a very specific thing that you would want to build. And so it's one of these interesting things that I've been thinking about in the context of Omni and in the context of multimodal understanding, both of which are things that Gemini is very good at, but actually is difficult in something where you get to like one of these more creative spaces.
2 quick plugs. We have dynamic FPS in the Gemini API, so if you want to sort of toggle the FPS for things like sports or whatever, you're analyzing a golf swing, analyzing sort of dancing, it does exist.
Yeah.
It's very effective. You should also build choreography bench. I like this. It's a good, the new hottest AI benchmark choreography bench. So I'm excited to see it. Chelsea, Michael.
I mean, mine is so much more boring than that. I feel like, but it's thematically similar in some ways. Like I talked earlier about the difficulty of building an SRE agent. I worked in a couple jobs ago at a company called Datadog, and I've been thinking a lot about our customer who gets woken up, and I'm sure everybody here has had this experience, gets woken up at 3 o'clock in the morning, and they're not the only ones in their house that wake up, right? Their spouse wakes up, their dog wakes up, their baby starts crying, their spouse hates them because they're a lawyer and they have a big client meeting in the morning. Like everything goes to mess, and they do this for long enough they get divorced. You know what I mean? Like I think about this software engineer who's on call all the time, and I would very much like an agent who can staunch most problems most of the time, who can like maintain a distributed system of arbitrary scale, something the size of a Capital One or an Airbnb. Do you know what I mean? And I think some of the limitations to that is this ability to fill the context window in real time at high frames per second, using a metaphor, right? Is to push information as it streams in about a ludicrously complicated system and spend most of your time reasoning about that, not writing queries to get the data necessary. It's like less of a query and response and more of a streaming mechanism, I think. Yeah. But either way, that's like, I'm very excited for that world because it's entirely possible and we're getting there and a lot of people are working on it. So
I love it.
Yeah, I mean, for nothing that complicated. I just wanted a personal trainer app. I feel like I'm kind of lazy, so just that kind of watches what I'm doing and tells me like you should eat that or you should go run outside.
See, that's dangerous. I'd rather not know.
Well, maybe we'll have that with glasses in the
Yeah, with glasses and
Fitbit. Gemini Live. Yeah, and Fitbit, exactly. Very exciting. Awesome. Well, I would love to hear some questions from the audience. I have no idea where the microphone is, if it already exists and is in somebody's hands.
Yeah, we have 2 microphones on both sides of the audience. You can line up back here and we have about 8 minutes for questions.
I love it. If you have questions, please feel free to go to the microphone. We're going to make you do the old-fashioned walk to the microphone.
And please queue up. Feel free to,
We'll start over here.
my question's for you, Varun. So you were saying that, in the future, like, you really like how you have audio interactions with these AI agents and stuff. What do you think, like, in the future, developer AI agent interaction is going to look like? Is it going to be more like visual, or is it going to be more audio based? Like, what's your intuition on that, like in the upcoming years?
Yeah, I think we've been talking a lot about that on the team. It's weird. Like, what is the best way to input information? I think voice is fast. Technically, you can do some crazy stuff. Like, you do voice, your hands and your feet. So you start tapping with your feet technically just to get the fastest amount of input in. I don't know if people would want to do that, but probably not, right?
Sign me up. It sounds fun.
Maybe soon.
Like a dance activity.
Yeah. So I think voice in sounds the most compelling, right? From like a data perspective, I think a lot of people are lazy to read, but reading is like way faster than listening. So in some ways, like the reason why I brought up the thing of like, hey, you can spin up as many agents as possible. It's very clear that's where things are going, right? Like the agents are going for longer and longer. You're probably gonna have many agents running for you in the background, and being able to quickly talk to it regardless of surface seems like the right play. I think there's maybe a little bit of awkwardness that if you work in an office, like you don't want everyone just talking and yelling at the same time. So we need to figure that part out. And then maybe consuming it. I don't exactly know what the best way to consume it is. Maybe it actually is like text. I don't exactly know. One crazy thing about the way you can input stuff is, I think we were talking in the office. We were saying, people that are Smash players, people that play Smash, they're really fast at moving things. I think they're like potentially as fast as you talk. So maybe there's like also a new form factor to start like inputting data into these machines. I don't really know. I think someone should do some analysis on this.
Yeah. Thank you. Second thing I wanted to ask is that, do you think gesture is going to play like a big role in spinning up agents, or like orchestrating, like how you have your Google Watch, let's say, like the Pixel Watch or like the Apple Watch, you just spin up an agent on your Apple Watch or Google Watch with just hand gestures? Is it going to be like possible in the future?
That would be cool. Yeah, that sounds awesome. Should do that.
That sounds awesome. Thank you so much.
Hey, so I have a question. So we have the text prompt and voice prompt, but what about the people that like are more visual, or have the lack of communication skills? So how the AI will overcome those like barriers that people? I mean, with other people we can use hand gestures and everything else that we can communicate, but our text or our voice we don't have that kind of skill. So how the AI will overcome those barriers?
Good question. I feel like video and image is interesting. Like I think one of the cool things is if you have, if you could, draw something out, if you could, even if you could sort of like express it like physically, back to like this like dance example. Like I do think the model being able to natively understand image and audio, and actually like we were talking earlier today about like subtly picking up on like the intonation of your voice as you sort of try to express something, even if it's not in the most perfect way, are all things that the model can actually do natively, which I think is super interesting. And yeah, maybe we need like new form factors. Maybe it's gesture or.
I mean, even with our existing form factors, right? I was working with somebody at work the other day, and no matter how well articulated you are, it's much harder to describe where on the screen to move your cursor than to just fucking point at it. You know what I mean? And I think a lot of input will look much more like tapping the screen or lassoing something, or just like gesturing at what you mean, and that'll be the kind of interaction.
Yeah, it also probably depends, like depending on the use case and also your personal style too, right?
Yeah.
So, like for me, I'm someone who very much like thinks while talking. Like I also like find myself to be a very verbal communicator generally. So I prefer that form factor. I prefer audio, right? But for someone like my sister, I actually think she would do a lot better with a form factor where she had the time to sort of like write something out or draw it or move things, and like she's a much more visual communicator and visual learner, and so that would be like a much better form factor for her. And so I think actually part of what we need to build and design is interfaces that can be flexible to who you are and how you communicate and how you engage. And then there's a lot more of that. Like I mean, there's been a lot of talk for a long time about personalized learning, but I think there's also probably personalized creating, and there's both of those that are effective, I think.
Yeah, my fun fact is my new 20% project at Google is I actually ghostwrite Tulsi's tweets now. She dictates to me, and I sort of write them down because she's very audio, and I can do the writing.
Yes, everyone, just stay tuned. It's gonna be great.
And so sometimes actually
all of your tweets are just Gemini now.
Yeah. The tongue-in-cheek comment is like actually sometimes another human in the loop. Like AI systems obviously super helpful, but sometimes you actually can get a friend or somebody that you work with to go and help. Thank you for the question.
I think we have time for about 1 to 2 more questions.
All right, so one of my biggest bottlenecks is speed, right? But the penalty for writing bad code is sometimes really big. So generally, you want to run the best model. Kind of where do you feel we are on that kind of scale for? We have a really fast model that's good enough for 99.9% of the time, and then we just optimize for speed, and then we just have one big model just reality check things at the end.
I think we genuinely believe in this idea. Like honestly, one of the things that we have in anti-gravity that's pretty awesome is we have sub-agents, but actually the model, the main agent is able to actually pick the model for the sub-agent. So I think we could totally see a world, especially given we're in a world where there's we don't have unbounded number of chips where a big model is able to kind of delegate to smaller models. I think right now we're not at the stage right now where we're purely optimizing for like how do we save everything rather than capability. Because it's kind of like what you said. Probably in a lot of workloads, you don't just only want to run the smallest model possible, right? You would rather have it be the case that the hit rate is a lot higher than have a small model look at it and then every once in a while you're like, what's going on? But 100% this is the direction of travel. Like I think we will see a world in which bigger models are delegating to smaller models to do a vast majority of work.
Thank you.
Yeah, it'll save a lot of tokens too. And our last question.
Hey guys, so my name is Karthik. So regarding the tests and how we develop our software, is there any framework or like steps that you guys recommend for using to avoid AI slop? So for example, if I build an entirely new product and then if I want to add a new feature, I don't want to break the existing features, right? Is there any ways to avoid all of that? Is it just unit tests and integration tests, or is that more that I'm missing the whole picture?
I think right now we actually think about this pretty deeply when we're building anti-gravity. How do we make anti-gravity kind of build itself? And I think you need to kind of be a little mindful at the beginning of the project. So for instance, let's say you're building like an application. I would actually make it so that from the very beginning of the application, the agent itself can spin up the application, click buttons on the apps, and you actually have these kinds of smooth integration tests. You can imagine. That's fun. Sounds like I'm in the restroom of like an airport. So I think the idea is like try to make it so that the agent itself is testing your app, and you can convert this into a pretty high quality test, right? Imagine doing that, generating playwright of exactly what it clicked, and then afterwards offline doing that, right? So you can convert these agentic tests into like more robust tests afterwards. So I think there is like a new paradigm now that agents can test things very quickly. You should be leveraging
What
that.
about existing products? What about existing products? Say if I have,
yeah, I think you'll need to re-architect pieces of existing products. That takes a lot of work, I would say. It's better when it's 0 to 1.
I think I should just echo one quick point. I think this goes back to the conversation from before about sort of this agentic engineering discipline being different than vibe coding. I think the framework that you have for agentic engineering like looks different than I think if you're just like YOLOing your own personal project where there's not users and you don't need to worry about anything breaking. I think the frameworks actually look different. I think we as an ecosystem sort of need to actually have that materialize in how we build and talk about this stuff. So thank you for that question. Varun, Michael, Tulsi, thank you for sitting down and doing this. This was an awesome conversation. And please join me in giving them a round of applause. And thank you. Thank you, everybody.
Let's begin with a quick show of hands. Who here has an amazing app idea that you just haven't built out yet? Right. So we've all been there. The biggest roadblock is friction. The endless setup, configurations, and the boilerplate. And that's what we're eliminating today with agents. By the end of this talk, you'll know exactly how to bring your idea to life. My name is Sandhya. I'm a product manager at Android Studio, and I'm here with Trevor Johns and Simona Milanovic. Gemini in Android Studio helps you at every stage of the app development lifecycle. Let's take a look at some practical examples to this agenda. Firstly, we'll look at how to prototype an app, how to make it adaptive, and how to add a new feature. Then, let's look at maintaining and testing your app. And finally, let's look at how to intelligently integrate your existing workflow tools into Studio and how to extend Gemini with new skills. All of the features we'll be looking at today apply to both new projects as well as existing large code bases. All right, let's start by beginning a new app idea to life. Gemini in Android Studio is here to help you bring your idea to reality. It used to take months, and if not weeks, and a whole team of engineers to get your app idea off the ground. Today, even a solo entrepreneur with just a little bit of time can build a working prototype. So you can use all of that time to continue to refine your app and build the best experience for your users. Let me show you. All right, I've got a great new idea for a new fitness app. We don't need to go into all of the details here, but let's just say it will be a big hit when it finally launches as part of my new startup. We'll start with the basics though. I need an app that can track my steps, my daily fitness goals, and my workout sessions. With Gemini and Android Studio's new project agent, I can build an entire complete Android application with just a single prompt. I can provide as much or as little detail as I want. And even if you're building a complex app manually, it can still set up all of the scaffolding for you. Behind the scenes, we take advantage of agent mode to plan and build out your app. It takes into account all of the Android best practices and official recommended tech stack to build out the app for you. All right, let's see it in action with the demo. All right, let's cut the demo. Right. Sweet. I'm in Android Studio. I'll kick off a new project. Click on Create with AI and put in my prompt. Build me a fitness tracker app with a step counter. All right, we'll give it a name. All right. Okay. And while that's loading, let me tell you about the agent mode's build, fix, verify loop. Every time the agent writes code, it compiles and makes sure that there are no errors. If there are errors, it continues to iterate on it until the errors are fixed. Therefore, the feedback loop is built into the agent mode. All right, sweet. Okay, so the agent mode is back, and here you can see it's come up with a project brief. So it's given the app a cool name, and it's come up with a list of features, real-time step tracking, a progress dashboard, and adaptive layout support as well. And if I scroll up, I can see the mocks. It looks really good. I'm going to go ahead and approve this. It also shows the technical stack. Here you can see it's using Jetpack Compose with Material 3 and so on. All right, you can continue to iterate on this product brief, but I'm going to go ahead and approve it. All right. And when I approve it, it comes up with a detailed implementation plan. All right. So it's listing out the features, the tech stack again, and then here are the implementation steps. And this is a checklist, and every time it completes a step, you'll see that it marks it as complete. All right. So it's setting up the theme and the tracking logic, the adaptive UI, and eventually it'll also do a run and verify and make sure that it's working as intended. And you can see how it's loading all the information, making the tool calls and so on. I'm going to go ahead and stop it right there. This can take up to 10 minutes. So in the interest of time, I'm just going to quickly switch to another project that I kicked off earlier today with the same prompt. All right. Let's try to build and run that. All right. And drum roll. All right. There you have it. So there you have our fitness tracker app, and you can go ahead and continue to refine and iterate it. All right. Let's get back to the slides. In addition, when you provide a paid Gemini API key, the agent can come up with a beautiful design mock before starting implementation. It uses the image generation model like Nano Banana for this. And the result is a much more visually stunning app with much higher fidelity. All right. In addition, agent mode also has first-class support for large-screen devices. It intelligently scaffolds your project with the components, the layouts, the navigation that are optimized for large-screen devices. Devices like Chrome OS devices, tablets, and foldables from the get-go. All right. And behind the scenes, you can see that it refers to all of the adaptive guidelines to make this happen. And it has additional logic to test out your app on large-screen devices or other emulators you have available as well. Simply configure the devices that you need, and the new project agent can test it out on those devices for you. All right. So now I've built the app, but I want to set up a database so that I can log my workouts, and I also want to set up an authentication so that I can add profiles for my family members, right? So I'm going to do that. Simply ask agent mode to connect to Firebase. It now includes all the knowledge required to connect to Firebase services. Okay? And with that, you will have a full end-to-end working app, and that's robust and has the full stack experience as well. Right. So with all these new agent mode capabilities, you'll find yourself reaching for the AI more often. And we're really excited to tell you that the agent can now multitask. Until recently, you can only ask the agent for one task at a time, but we've completely redesigned the app from the ground up so that it can support multiple conversations in parallel. Right. And while you're waiting for a really long-running task, you can simply click on the plus icon and ask a quick sidebar question, and then you can switch back and forth with the history icon. Right. As your code base gets larger, you'll want to explore more and more complex tasks, and planning mode is a really good fit for those complex tasks. Planning mode architects the entire solution and a detailed implementation plan before it writes a single line of code. So you can go ahead and refine that until you're satisfied before you let it proceed. All right, so now I've built my app, it's adaptive now, and I've added the backend capabilities. And I'm now ready to publish this app to the Play Store, up to the Google Play internal test track. We're now making it easier for you to publish your apps to the internal test track. Simply create a new app and publish it to the test track directly from Android Studio. You can now upload your new releases to Play Console test track. We're making the whole process seamless and so much easier for you to directly go from app creation to publishing when you're ready. Now that we've built our app, we are now ready to extend it and add more features to it. For that, I'll pass the stage on to my colleague Trevor to walk us through an example.
Thank you, Sandia. So you just saw how Gemini Studio can help you plan and build a new application. We're also here to help you throughout your application lifecycle, including extending features, maintaining your app, ensuring test coverage, and optimizing your application for production. So let's take a look at some of that. Jumping back to our fitness app, let's jump forward in time. We're further along in development and we want to start adding new features to our application. So in this case, let's say we want to add support for Health Connect. This will let us share our step count with other apps and pre-workout data from other apps and systems you might be using. Let me show you how you can implement this feature using planning mode. And I'm also going to add a second twist here. We jump forward in time, so we now have a development team, which means we have a bug tracker for everyone to collaborate on. So we can have agent mode autonomously work on this feature directly from our project bug tracker. To accomplish this, we're going to turn to MCP, the Model Context Protocol. This is a standardized mechanism for extending AI agents with new tools and new capabilities. You can think of it just like a USB-C port for a wide range of AI integrations. MCP handles service discovery and provides a standardized way to package and send rich, structured context into Gemini. Android Studio's MCP support means there's a rich ecosystem of tools available today that can integrate with Gemini Android Studio. You can directly connect to any MCP server, but to help you get started, we also now include a curated collection of MCP servers for common integrations. And you can find that under Studio settings in AI MCP server. You can also go and specify custom MCP servers using JSON. Once you configure your MCP servers, agent mode will automatically invoke them as needed while executing your prompts. So here, for this project, we're going to connect the GitHub MCP server to our project, and then with our bug tracker connected, we can directly delegate issues to Gemini. So for example, we can ask it to read, assess, or fix a particular bug, testing it before checking it back in. So in this case, we're going to give it a feature request that's stored in our project bug tracker. And with planning mode, Gemini will be able to examine all of our project files and come up with a concrete plan to address those requirements in the feature request for us. So just as before, you can always edit and refine it before you approve it. You're always in the driver's seat. So let's take a look at how planning mode and MCP work in action. And I have my new project set up here. Once again, we're going to go and try and connect it to Health Connect, so that way we can share our step data. But first things first, we want to connect it to our GitHub MCP, GitHub issue tracker. So we're going to go to settings, we're going to go to MCP servers, and I already have the GitHub MCP server installed, but I'm just going to go ahead and enable it here. And very quickly here, I'm just going to jump over to Pro, and you can see here that we have our feature request written up in GitHub issues as issue number 1. It's a bit more lengthy than the short prompt that we used to create the project earlier, and that's okay. Gemini can adapt to work with tasks at any level of complexity. So we're going to go ahead and delegate this over to Gemini. So I'm going to jump back over to Studio. You can see here it's now connected to GitHub, and I'm going to say work on issue number 1. I'm going to switch over to planning mode, and we're using Gemini 3 for this. Right? Now that I've sent that, you can see it's going to begin examining our project. We're going to allow that. And you'll see in just a moment here, it's now connecting to the GitHub issue tracker, and we're going to allow that as well too. And it's researching everything that's needed to go and work on this project. In just a moment here, it'll come back with a implementation plan that once again we're able to edit and refine if we want. And while Gemini works on this, you can see it's starting to do the research here, but I'm going to jump ahead 40 times so you can see the result. Right? So here it's completed researching the issue. It's jumped forward a little bit more on our task list, identified what steps it needs to take, and written up that implementation plan for us, explaining exactly how it's going to go about implementing this feature. We can read through this, and if we want to change anything, we can of course go in here and have a conversation with Gemini to go and iterate on this implementation plan. But I like this, so we'll just go ahead and say proceed, and it'll begin working on our feature for us. Right? Well, that works. Let's go ahead and back to the slides. Right, so now that we've added some more features for our app, let's talk about how agent mode is able to help with testing and maintaining our application, so that we're able to ship with confidence. Ensuring test coverage is, of course, vital, not only for your application's quality, but now to provide agents with information they need to determine whether or not their task is successful. We've been working on leveraging Gemini's multimodal capabilities to help our end-to-end tasks with journeys. This is a new feature that we launched last year to allow you to write UI tests that dynamically adapt to your application's UI. We have some journey tests that we've added to our application, and journeys allows Gemini to intelligently interact with our app in real time, following these steps to give you tests that dynamically adapt as your app's UI changes across time or across devices. So I'm going to go ahead and run this, and you can see that one of my tasks unfortunately failed there. But now, with new agent mode integration for journeys, it has the ability to interactively fix test failures as well. So you can see here that it's offered to either modify my journeys test, assuming that something in my UI has changed, we just need to change some of our test statements, or if we're confident the test is correct and we find a bug, we can ask journeys to go use agent mode to interactively, or sorry, to autonomously fix the underlying code that caused the fault. We've also added support for executing journeys directly from the command line with Android CLI. So this includes bundled AI skills for creating and executing journeys. We've also added support for invoking journeys via Gemini CLI. This also allows us to use journeys in headless environments like in a CI server. This means we're able to run journeys tests automatically on every pull request, highlighting when your app behavior diverges from your original test specification. So let's take a look at this here. We can see that we have Gemini CLI, or you can do this with any gravity CLI as well now, invoking a journey test with the help of Android CLI in the background. And just like with Android agent mode, Gemini has visibility to execution test results and can offer ETL malform tests or directly fix the underlying bugs. Right? We also have integration with app quality insights. That's to direct you into production data, aggregating crash reports from production sources like Play Vitals or Firebase Crash Lytics. Once a crash is identified, Gemini is able to analyze the user stack traces and suggest potential code fixes. The power of agent mode means it now goes further than suggestion. It's able to iterate on these code fixes and test them to confirm the underlying bugs have been resolved before you start coding. This automates the entire validation loop. Right? Jumping forward a little more time here as we get ready to release our app used on Google Play, we also want to make sure their app is up to date in performance. Modern apps rely on third-party libraries to implement critical features, and these libraries take advantage of other libraries themselves, which can quickly make dependency management a challenging task, especially for large code bases. Upgrading one can often fall in a web of seemingly unrelated changes. We first developers just how time-consuming these updates can be, and Gemini Studio is able to help you with that as well. So we're able to automatically apply dependency updates for you. If you just right-click on your version catalog file, you can ask Gemini to update all of your dependencies. Gemini will then analyze your version catalog, identify any stale library versions, and proceed to inspect the documentation for those libraries to identify any likely changes that need to be made to your source files. And now with agent mode, we're able to build and test your app to make sure everything works successfully after migration. So let me show you that in action here with a demo. Right? So we now have our application that we're getting ready to update. And you can see here I have a whole range of dependencies that are out of date. So I can just right-click here, go to AI, and say update dependencies. It'll then begin scanning through my version catalog, identifying which dependencies need to be updated. And in just a moment here, it'll be iterating on that. But for the sake of time, we'll jump forward to complete the version of that. And you can see here that it's gone through, analyzed my project, began reading through the release notes of all the different libraries that we need to update, and began changing the underlying Kotlin code to make sure that everything is able to be updated successfully. And at the end here, you'll see it deploying that to the emulator and testing it to make sure everything works successfully. All right, we're going to jump back to slides here. So we talked about updating third-party library dependencies, but you also need to upgrade your AGP version over time. We now have the AGP upgrade assistant built in the studio, which can provide deeper assistance with AGP migrations, again, using agent mode to help migrate to the new AGP DSL. To take advantage of this, we leverage a new feature called Android skills. For supported workflows like this one, all we need to do is ask agent mode for help updating our AGP version, and the skill is invoked automatically. We'll also enable planning mode here, and as before, Gemini Studio takes extra time to think about the project, and comes up with its recommendations and next steps. Again, we're using Android skills here to enable this, which is a powerful new capability we just added to Android Studio, bringing deeper knowledge of a wide range of Android best practices into the Gemini environment, even for topics outside the model training cutoff. To give you a deep dive on how agent skills work, and how they augment agent mode, let me turn the stage over to my colleague Simona.
So delegating your AGP upgrade is one of many things that can now be handled for you using a powerful combination, Gemini and Android Studio, with one of our own Android skills. And we have a lot more of those to share with you, but first we have to understand what exactly are skills, how do they work, and how does Studio leverage this new capability. Let's use one as an example. Skills are the open standard markdown file skills.md that represents modular instruction sets for AI agents and tools. They provide technical specifications for a task, grounding the LLMs with up-to-date and domain-specific information. They enable execution of specialized workflows and expertise through added knowledge and context. So how do you use them in your day-to-day work? Generally, you fetch skills from trusted source, and you place them into a dedicated repository, like a local project root or a user home. Using Android Studio as an example, skills can go to a workspace-specific or a global directory. After that, agents are aware of all of the present skills by keeping a list of the skills metadata and sending it to the LLM on every prompt. When the user sends a prompt, or you, the LLM tries to match the skills metadata and the description with an executed task, and then find and activate the most suitable skills. Skills are designed to trigger automatically, so there's no need for you to manually manually search and attach them and force their usage, but you can, of course, if you want to. So now that we kind of understand the basics, how do we make the most out of this concept for Android development? You heard about it in the developer productivity keynote, but to better support you and your Android development with AI, we launched the official Android skills, a dedicated repository of AI-optimized instructions to help models better understand and execute specific patterns that follow our best practices and guidance in Android development. To install skills easily and update them regularly, we recommend using Android CLI, so check out its documentation for more. You can also check out the GitHub repo for the latest updates. With Android skills, we kind of wanted to tackle a few challenges we realized happen when working with LLMs. LLMs often lack context on the newest Android frameworks and changes due to their training cutoff date. If you ask it to migrate a legacy mitigation, they often won't know anything about the latest frameworks. Skills allow us to deliver these changes and updates to AI tools instantly. Similarly, you might ask LLMs to analyze a project setup, and it can often invoke provide result that's unstructured and not always really fully helpful. Android skills guide LLMs in executing the more complex but really important workflows while also following our best practices. Traditional documentation can be descriptive, conceptual, and high level, and while that's perfect for our learning, it can be less performant with LLMs that require precise and actionable instructions. Standard documentation teaches humans how to think and the whys, while skills tell AI how to execute something, what and how to do it. Knowing all that, our focus is on publishing Android skills, where our testing showed that LLMs need more grounding and steering. So in workflows such as AGP9 and XML compose migrations, adding navigation 3 to your project, migrating from nav to analysis of your RE config, enabling edge-to-edge support, and a lot more. So Android skills can be roughly split into
two, procedural and specialized workflows. So something that demonstrates a step-by-step custom process to complete a specific task, like the RA config analysis. They can also be reference and knowledge based, so serving as a collection of resources or pointers to other supporting files, grounding the LLMs with more knowledge and expertise, like how the edge-to-edge scale teaches the LLM how to implement support for it. And they can be hybrid, so integrating both procedural and knowledge-based elements. The XML to compose migration scale does exactly that. Android scales are supported by Android Studio and Android CLI, but are also designed to be reusable across any AI tool or agent of your choice that has support for scales. So Google Android Gravity, AI Studio, or any other. For Android Studio, selected subset of Android scales are directly preloaded within by enabling them in settings. These are available in Agent Startup and get activated automatically, so no need for you to manually download and activate them. You can of course add more scales manually by checking out from our repository or Android CLI and placing them in the dedicated directories for Studio. You can check out the documentation for full information. Android CLI also offers full integration with Android scales. You can install them to your dedicated directories for specific agents. You can also specify which scales you want. You can remove them, list them, find them, and so on. You can even tweak or write your own. But if you're going to write your own, let me share a few tips that we have from our own experience of writing Android scales. Don't insist on scales for user journeys that the LLM is already pretty good at. Scales are meant to supplement the default knowledge of an LLM. So forcing scales for tasks it already knows, it adds unnecessary overhead. So rely on testing thoroughly to figure out which scenarios require scales. Don't use LLMs to generate scales from scratch without providing any additional sources or knowledge. If an LLM already knows a topic and can generate a scale for it using its default knowledge, it doesn't need a scale. Think about what to add to agents.nd and what to add to scale.nd. The entire content of an agent.nd is sent as context for every user prompt, while scales are activated on demand, so only when they're needed. Good scale candidates are usually brand new APIs or version behavior changes. So information that is so recent that the LLMs know very little about it. So things like custom domain and specific workflows are also good candidates. Large procedural migrations, etc. Less is more. Find the minimum scope and the length of a scale that provides the maximum benefits. Generally, succinct scales perform better than the very, very lengthy ones, because LLMs start forgetting if you throw too much context their way. And finally, always use scales from trusted sources and validate them before running, so sources like Android CLI. Let's look at one particularly handy Android scale for a larger task. So if we're talking about opportunities to modernize an app, the first thing that comes to mind is migrating from XML to Compose. As you might have already heard in what's new in Android, we are now Compose first. This means that we're now advising you to write new code and features in Compose, as well as migrate old XML views, because views are moving into maintenance mode. Basically, we recommend you write all of your Android UI into Compose across all form factors. To support you in this, we published an XML to Compose migration scale to better guide any agents and tools of your choice in this migration effort. So now we're going to see one of these scales in action. Okay, we can cut to the demo. So here we have one of our older samples called Sunflower that's written entirely in views. So before we do anything, what I'm going to start is actually kick off the migration first because it takes a while. And I'm going to say migrate a layout from XML to Compose. I'm going to let it run in the background, and then we're going to come back to it at the very end. So as we see, we have Sunflower here all in views, and we're going to use our scale to migrate it to Compose. So when we first started testing the migration with LLMs from XML to Compose, we realized that the LLMs were already pretty good at doing the basics, so like mapping the basic layouts from XML to Compose, or doing recycler view to lazy mapping, etc. So those very those basics that you kind of encounter in every migration. But what it was struggling with was defining a very specific workflow that is consistent throughout many runs. And that is exactly what we decided to focus on with our scale. So we provide a recommended workflow that is divided into substeps that we can apply across all code bases, and we also define criteria for things like success or validation or analysis of your code base, and we also round it with supporting files which follow our best practices and the latest, for example, Compose versioning and changes that come from these new APIs. So aside from that, some of the most important things to notice in this scale are the open standard specifications or requirements that are needed to make this a scale. At the very top, we see this YAML metadata that is always found on top that contains two most important fields, which are the name and the description. It also needs the main scale file needs to be named scale.md in uppercase. And aside from that, the only other requirement, well, it is kind of a requirement, is to have at least some content in the body of the scale. Everything else is optional. You can write whatever is needed for the scale to succeed or the agent to do a good task with it. But most commonly in scales, you might find things like objectives or goals defined at the very top, constraints or restrictions or requirements for executing the scale, summaries or step-by-step processes and subtasks, things like code snippets, supporting files, do's and don'ts, and all these. Those are the most common ones. Okay, let me just check the agent to see if it's running still. Okay, that was a spoiler. Okay, cool. So now that we kind of went over the focus of our scale, I was going to say that breaking down any larger tasks, so things like big migrations or big refactors, breaking them down into smaller subtasks generally provides much better results with LLMs because they're able to follow a much more methodical way that is consistent across many runs. In that case, using that as our guidance, we realized that there are some steps that are applicable for more code bases. So things like identifying how to identify the optimal XML layout for as a candidate, things like how to create a plan properly or capture the initial XML view, setting up Compose and its theming, and many other steps that you can see from here. So this workflow is kind of sturdy enough and generalized enough so that it works with a variety of code bases, but with this scale, as with any other, it's always a good practice for you to customize it and tweak it to your own production code base. So add pointers or details for the LLM that are unique to your own code pattern. So for example, if we wanted to tweak this, we could say use only layouts from feature module X and constrain it to just a specific module. We can say that we don't actually want to set up Compose because we've already done it, or we can say that for migrating theming, we can provide our own references. So references like design, system, markdown. So something that comes from our own internal documentation that helps us point the LLMs in the right way. And important note though here is if you do decide to tweak an existing scale that you pull from a source, do make sure that you always remember to kind of extract it somewhere else, rename it, put it in a different location, just make it different from the original source of truth, because if you do a bulk update of your scales, your custom tweaks might get actually overridden. Okay, so that's kind of, you got the idea about this. You can see that we have this main scale.md here, and it provides all of the summaries for individual subtasks, but you can also see that our scale directory contains a lot more additional supporting files. And these are any files that supplement the original scale.md with additional context, additional knowledge, other supplemental markdowns, scripts, assets, so anything that the model needs to perform this task more successfully. So one important note to say about this is, as you can see, we provide a lot of supporting files from our main scale.md, but we're always very explicit about when and how the LLM should use these files. The reason for that is because we want to ensure that the LLM is actually able to activate these supporting files on demand as well. So not load them all at the very start, but use them only for specific tasks. And not only that, but it's able to actually also skip specific steps when it realizes it doesn't need to perform them. So in that case, for example, the LLM will actually skip the step of setting up Compose dependencies and activation of this file because it realizes it's already been set up. So let's look at one of these in more detail. So for example, we have the identify optimal XML candidate. So you can see that this subtask was extracted in a supporting file because we wanted the LLM to skip it if the user actually provides and points us to the layout that they want migrated. Aside from that, it also means that we shorten the main scale MD length and optimize for better context usage overall. You'll notice that the language in this supporting file, but also across any other scale that we have, is very concise, it's very procedural, it avoids usages of vague and subjective words, or if we do decide to use a subjective word, which is the word optimal, we always ensure to provide the exact criteria on what makes this subjective word more measurable for the LLM. Okay, I think that's kind of all of the basics I wanted to cover for the scale. I think the most important part now that's left is for you to check out, try it out, provide feedback to us, and see how well it performs. And with that in mind, I'm going to jump into the actual results. So I can see here that the scale MD got activated immediately, and it went into the activation of the supporting file for it as well. Once it realized that that's the first step it requires, there's a lot more information here, but I want to see the results. Okay, so I decided to activate fragment plant detail, and it migrated it into a plant screen composable. Okay, let's give these two a quick comparison, and let's see how they look. Okay, so it's done a pretty good job overall
There are some tweaks here and there that can be modified manually, but I'm pretty happy with this as it looks right now because it's meant to do exactly what it's done, which is to provide the scaffolding for you, take over the more repetitive parts of Android development, and let you take over the more fun ones and build on top of it. So this way, hopefully, layout by layout, it gets you closer to compose first. And you can check out this skill as many other more that we have through Android CLI. It's integrated in Studio as well, so you can try it out already and let us know what you think. So with that in mind, I'll hand it over to Sanya to do everything for us.
All right, folks, we covered quite a bit of content today, and I'm tasked with making sure that you remember all of it. Let's do a quick recap. As a reminder, everything you saw today works not only with the Gemini models, but you can bring your API key for other foundational models like Anthropic and OpenAI models as well. You can also use a local model or an open source model like Gemini as well. No matter what model you prefer, the AI tools in Android Studio are here for you, and they'll integrate seamlessly with the model of your choice. Alright, so today we saw how Gemini and Android Studio can help supercharge your developer productivity and help you at every step of the app development lifecycle. First, we looked at how to prototype a new app with a new project agent. Then we saw how to make it adaptive and to test it on large screen emulators. We also saw how to add a new feature using features like planning mode, using MCP connections to maintain and test your app. We also looked at how to maintain your app with app quality insights and how to test it with journeys testing. Let's see. And finally, we saw how to extend Gemini with new skills as well. Alright. Yes. So all the features you saw today are available in the latest Canary version of Android Studio, and they're coming soon to a stable version. To get started, download the latest version of Android Studio and start integrating Gemini into your workflow. To learn more, please head to d.android.com/studio. Thank you.
Hello, everyone. Good to see you. Yeah, I think it's obvious, but are you having fun at I/O? Fantastic. Good to hear that. Okay, so let's start. For the past 30 years, we've built websites for humans, and we focus on things like UI, performance, SEO, and accessibility. I mean, don't worry, that's not going away. But at the same time, it's no longer a full story. I don't think it's too soon to say it, so I'll just say it. Welcome to the agentic era. This might be the biggest change for us developers since mobile, or maybe even since the web itself. As more people rely on AI agents to perform heavy lifting on their behalf, the websites that are not agent-ready risking being left behind. So it's not about maintenance, it's about staying visible in this AI-driven era. I'm Casper, I am a developer in Chrome AI team, and today we'll talk about how to build and prepare your website for this exciting shift. We are going to answer very, very important questions. How does an AI agent see your website? How to make interactions between website and agent faster and more reliable? What are WebMCP tools and how can they help us? How to audit your website for the agentic era, and last but not least, how to test and debug WebMCP tools. But before we get into the details, let's take 2 steps back. What is an agent? So in traditional computer science, an agent is an autonomous entity that observes its environment, processes collected information, and takes actions to achieve a specific goal, and then continues. What has changed recently is we unlocked new capabilities. We gave agents access to a LLM, the reasoning engine. What is the agentic web, then? In short, the agentic web is a web where primary users are increasingly AI agents performing complex, multi-step workflows on behalf of humans. We are going from browsing to delegating. So instead of you clicking through multiple tabs to find a hotel, find a car, and book a flight, right? You can give a high-level goal to an agent. The agent will do the work, but human user provides the final approval on every important choice and action. That means AI agents are shifting from being simple chatbots to being active participants. They process the page structure, click buttons, and trigger the actions on your behalf. There comes a new challenge. A new challenge for us, developers. Building for humans is no longer enough. Because if an agent can't understand your site, your users lose out on automation, and you miss out on conversion. So how does an AI agent actually see your website? I mean, as you can imagine, an agent does not look at your website on a monitor, right? They use machine-readable representation of your website. And the quality of this representation, the machine-readable representation, determines their performance. An AI agent can receive your website in 3 primary ways. First, it can take a screenshot and use a vision model to interpret it, similarly like a human would, right? So what it sees. Based on screenshot, the agent recognizes that the thing at the top is most likely a global search, text fields in the middle, most likely form fields, right? Visual cues can also be helpful, right? Because agents can use color, size, and proximity to determine importance. For example, big red remove button will be treated with more caution than a small help link down below. However, analyzing screenshots can be slow and expensive in terms of use tokens, so it works when the structure itself is confusing. Second, the agent analyzes the DOM and reads text directly. What it sees, the nesting of elements. For example, a button instead of a div, the logical hierarchy of the DOM tree, specific attributes like IDs, classes, that define structure, and of course, raw data strings, the text, the informational backbone of your website, if you will. Reading DOM helps the agent understand the relationship between elements. If a buy now button is inside a product container, the agent knows the button belongs to that specific product. The third method, accessibility tree. So this is a browser-native API that distills the DOM into what's most important, the roles, names, and states of interactive elements. It's the page's semantic summary. It's also what screen readers use. And it's very, very important to mention that accessibility is for humans first. Agents just happen to benefit from it. For AI agent, the accessibility tree functions as a map that ignores all the visual noise to focus on pure utility. So by interpreting this tree, agents can understand the functional intent of every button, input, and slider. What should we do then? How can we help agents see our websites better? First big question. So first, let's talk about visuals. Make actions visible on UI. In fact, make actions extra visible on UI. Why? Human users will have to switch their focus from any agentic surface that they are interacting with and your website. Yeah? So it also means that we should not expose functionality to agents that only makes background changes on the website, because that would result in user having limited options to verify correct agent trajectory. Next, ensure stable layout. Think about your favorite grocery store. You know exactly where the milk is. You walk in, you pick it up, of course you pay, and then you out, right? So what happens when they decide to reorganize and put the milk back in the pharmacy section? Yeah? Your cognitive flow just spiked, because you expected the thing to be right where you last saw it. And yeah, the same applies to websites. So if your buy now button is in different ways for each product category, it creates unnecessary friction and can slow down agents' workflow. Next, do not hide actionable controls. I want to share a term that is used in marketing in UX that I absolutely love, which is the next best action. So it's all about reducing previously mentioned cognitive load. So the next best action should not be a puzzle. In well-designed UI, it should be only logical step forward. Things that are actionable should be ideally also visible in viewport, because it's not ideal if your buy now button requires a few scrolls down. Even for us humans, it's not ideal, right? So if your search bar appears on hover or requires additional steps to show up, or is hidden behind fancy animation, you are making it harder for both agents and humans to navigate your site. There are also certain techniques on how we can tell, how we can hint agents that certain elements are actionable. For example, we can update the cursor in CSS to pointer. It gives pretty good hint to an agent, okay, there's potentially something actionable, but there are better ways of doing it. So let's talk about structural elements.
If you use a semantic button or anchor elements, it's a very, very strong hint to the agent that this element is actionable. The browser also makes such elements focusable via tab key and makes it clickable via enter and space keys. Because if you think about it, if you want to build a fake button, you need to, in using a div, right? You need to manually add tab index, right? Custom JavaScript to handle enter and space keys, and so on, add ARIA and so on, right? Semantic elements like nav, header, footer, they give clear instructions on what an agent can expect to find within those regions and how to navigate the page's hierarchy with precision. Semantic HTML is the backbone of accessibility. So if your website plays nice with screen reader, if it's truly accessible, you're at least halfway there. At least halfway there when it comes to agentic readiness. If you think about it, screen readers and AI agents seek the same foundation, semantic clarity. And the beautiful irony in all of this, everything that makes a site agent ready also makes it better for humans. So, thank you. So we do not have to create a fork of the web, a separate web, to make it agent ready. If you want to build a web that AI agents can actually navigate, we do not need to reinvent the wheel. We just need to go back to the basics. Build it well, build it accessible. Some users will continue, of course, to browse the web as they have always. Others will use agents, and the web has always been about providing the best experience for the user, no matter their device or user agent. However, there's a catch, right? There's always a catch. However, the challenge is still there. So it can be still challenging for agents to solve complex user intents. So when you go to a hotel website, you also need to understand where to look for things. But you do have some mental model where to look for things. Because you in your life probably saw multiple websites that are similar, right? So right upper corner, login, account, right? Somewhere in the middle or somewhere at the top, search. So you trigger the search, and you see some search results. And you might have some preferences like gym, breakfast, late checkout, right? So the journey becomes more complex. And you think of additional steps that you could potentially take. So the more complex the journey becomes, the more complex it is for an agent to synthesize all of those mentioned signals, screenshots, DOM, and accessibility tree into the actionable plan. So the big question is, how can we make interactions between website and agent faster and more reliable? How can we reduce mentioned complexities? Key and WebMCP. So, the WebMCP is a proposed web standard that aims to expose structured tools for AI agents on currently existing websites. What does it mean? It means that when a user wants to add certain kind of pizza to the shopping cart, in addition to analyzing visuals of the website, reading DOM, and reading accessibility tree, agent can use tools provided by your website. Because if there's a tool that can support user intent, an agent can call it, the whole journey becomes more similar. Because agent does not have to synthesize every available signal. The tool is right there. Of course, I wouldn't be myself if I didn't show you some demos, right? And for the demos, I'll be using an extension that we are using during the dev trial. Yes, the developer trial is still ongoing. And this extension is something that you can use today. All right. Okay, so we started with hotel examples, so let's continue with this. So in the right upper corner of the extension, you can see WebMCP tools that are registered in current context. Why do I say current context? Because tools might be available in different contexts. For example, when you have a page that is just a login page, it probably does not make sense to expose add to cart tool, right? So let's do something. Let's trigger some search. Let's look for Tokyo. Let's see if the different contexts will have different tools. Yeah, so filter search results, get current search results, right? So we can register tools where it makes sense. Let's try something agentic. So find me hotel in Tokyo. Filter for gym and breakfast. So what agent did is found tool to call search location for Tokyo, then apply filters for gym and breakfast. In this extension, you can see the trajectory in the panel down below, right? But those are the demos that are usually shown. Yeah, like a find hotel, e-commerce, flight search, right? So let's do something that is non-obvious. Right? Let's maybe try some interface where there are no user controls at all. Yeah, I like it. Let's make a pizza. Okay, so first I want large pizza. Okay, add cheese. Okay, add 10 bell peppers. Awesome, add 10 mushrooms. Okay, those are not the best mushrooms to have on pizza, but you get the idea, right? Okay, so let's try another demo that also does not provide any user controls. Let's play a game. Maze escape, right? So here we can trigger call the tool call manually by clicking execute tool. In this example, we have multiple tools registered to help us navigate the game, like a drop, look, move, pick up, and use, right? So tools are available, and we can do things like move down once. Notice that I'm basically talking to the website using natural language. Okay, now move down, down, and right. If I say it correctly. No, I did not say it correctly. So it cannot move to the right. Okay, so move down, right, down, left. Okay, so what we can tell agents is, for example, we can start the game once again to give the high-level goal to an agent. Because that's the kind of abstraction on the complex system, right? So there is some complex system that provides multiple tools, multiple states, and we give high-level goal to an agent, and we let the agent do the work. Right? Of course, we will not wait until the agent finishes this maze. It will take us a while. But I highly encourage you to see the full demo at our WebMCP demo booth. Okay, let's switch back to slides. Okay, so we've seen great capabilities, obviously, right, of WebMCP through the demos. But these capabilities, they extend beyond the demos. Many companies have already begun testing the WebMCP through a developer trial. These organizations are evaluating WebMCP use cases, user benefits, and technical requirements. And what they find is that it significantly improves the task performance and overall user experience. Let's start with Make My Trip. So Make My Trip see WebMCP evolving to enable deeply personalized travel experiences, including hotels, packages, and more. Users will be able to ask nuanced questions, as I mentioned, natural language, yeah? Is the hotel pet-friendly, kids-friendly, is it suitable for me, and so on. Policy Bazaar experiments with WebMCP to test potential user interactions with finding relevant quotes, but also to compare them, right? Again, users will use natural language, no manual clicking. Sweet. Cyber Agent experiments with their blogger helper extension, and they are checking if they can turn it into the agentic workflow using WebMCP. Yeah, so it seems like WebMCP will also help bloggers write personalized blogs. Okay, before we dig into the details of what just happened, let's address the elephant in the room. How does WebMCP and MCP compare? So WebMCP is not an extension or a replacement of MCP. Instead, WebMCP and MCP address different needs. First, the purpose. The WebMCP is meant to make live website agent ready for the user right now. MCP's purpose is to make data and actions available to agents anywhere, anytime, not bound to the website. Lifecycle. WebMCP is tab bound. It's ephemeral. So if tab is closed, the tools are no longer accessible. Here we are talking about currently active tab. While MCP is persistent, it runs as a server, so it's always available. Being tab bound, WebMCP connectivity is specific to browser agents or any other kind of agent that interacts with browsers. MCP, you can connect to MCP from any device, anytime. UI interaction. WebMCP is browser integrated and DOM aware. DOM aware in the sense that the tools can be created in a way that interact with the DOM, right? Also, the agent interacting with the website inherits the user logged in state, so like session cookies, security context, because those tools are being executed in currently active tab. And I think it's an important bit. Yeah, like the MCP server tools availability is not affected by the state of your website. As we said, it's just a server, always available. How does discovery happen? For WebMCP, tools are registered on the website, and they are discovered during the user's visit. While for MCP, you need to specifically point your agent to a given MCP server. Use cases, MCP is at the protocol, and agent uses to talk to your backend infrastructure. WebMCP is how the same agent can interact with your front-end interface and active user session right inside the browser tab. So now you have a pretty good understanding how those two compare. Okay, let's do a quick technical deep dive. How to define WebMCP tools. You have two ways of doing this. You can do it in an imperative way, using standard JavaScript, or in the declarative way by adding specific attributes to HTML forms. Let's take a look at a example of imperative API. Yeah, that's it. So in order to register a tool, use Navigator Model Context Register Tool. The tool should have name, description, input schema, and execute block. The execute block is what will happen if your tool is called. Parameters as execute patterns, they are defined in the input schema. You might ask, what is app to do item? It's your real JavaScript function that you have on your website, or we have in our abstract website right now. So any JavaScript function that you can call. At the end of the block, you see the return statement, which is basically what is being fed back to the model when the block finishes. To unregister the tool, you can use abort controller and pass it as a part of the register tool down below. Signal, controller, signal, and later, when the tool is no longer needed, you can just do controller abort. Then we have a declarative API. So if you already have a form, it's actually very simple. There are just two required parameters, tool name and tool description. When you provide them, your form will be seen as a WebMCP tool in the browser. Tool parameter description is optional, but it gives agents needed context about how to use this input. And I think that's a very interesting thing to remember, actually. So the way you name your tools, the way you provide description or description of tool parameters, this is not just a technical detail. This is being consumed by an agent. So this is very important context. How to use your tool and when to use your tool. On the right-hand side, you can see how browser would translate the declarative tool into internal imperative representation. And that's how you would write the same thing using the imperative way. Arguably, adding few parameters to the form is way simpler. So you have tool name, tool description, and tool parameter description. Very cool. Additionally, you can add tool auto submit to your form. What it does is we say we allow agent to submit the form after it finishes filling it up, right? And it will automatically submit it. Of course, the default behavior is that agent will just fill in the fields. It will not submit it, right? There's also special attributes that you can check on an event. Agent invoked, so it will be true when the form was filled and invoked and submitted by the agent, right? So what you can do here is you can basically give some additional context to the agent, right? And can we quickly switch to the demo? Because that's what we exactly did, for example, for the French pistol demo. If you look for the form, you can probably see the tool name, tool description, right? And then the tool is just visible based on the form field. That's this. Okay, so you will find more details, for example, about event handlers and more in our developer documentation. So it was published literally this week, so you're first to hear about it. Okay, so let's now review some good practices of building your tools. Number one, ensure clarity of scope and intended use. So we have to distinguish execution from initiation. For example, if you want to create events immediately, the tool should be called create event. But if you want to start the process of creating events, it should be called start event creation and potentially redirect to UI form. Give positive and clear descriptions. So this tool can create a calendar event scheduled for a specific date and time. For example, do not use this tool to check the weather. Number two, minimize cognitive compute for the model. So we have to accept raw user input, and we have to anticipate what user might want to type for our tools, for our website, right? So we should avoid asking the agent to perform math or transformations, right? Any calculations. So it should be all within your WebMCP tool logic. If user says from 11 to 15, the tool should accept strings 11 to 15. Do not require the model to calculate minutes from midnight, right? This can end up badly. Explicit types and business logic. So ensure that all parameters have specific types. Strings should be strings, enums should be enums, numbers should be numbers, right? If user is ordering a product from your website, use shipping express, regular, instead of shipping type 1, shipping type 2, right? It becomes easier for agent to make a proper decision on what to put into the parameter. Turn failures into corrections. So we have to return descriptive errors. The schema constraints are helpful, but they are not guaranteed. So you should validate constraints within your function code and return proper errors. This allows the model to self-correct and retry with valid parameters. Good example, product name has to be a string shorter than 100 characters. Bad example, parameter. How can we recover from this, right? Graceful failure for rate limits. So tools should allow for reasonable repeated use. For example, when comparing prices or doing search, right? If rate limited, return meaningful error. So not a bad error, right? Something went wrong. Very hard to recover. And last but not least, create non-overlapping composable tools. So tools should be atomic and composable. Each tool should have single responsibility. Avoid similar tools with nuance differences. When two tools are very similar, you can actually combine them with a single tool with some input parameters that can control them, right? The tool registration management. Provide tools where they make sense. We did touch on this before. On a login page, it doesn't make sense to have an add-to-cart tool. And there are also certain things to consider when working with WebMCP. The browsing context is required, right? So since tools are called in and handled in JavaScript, a browsing context, like a browser tab or a web view, must be opened, right? UI synchronization. So for a satisfactory end-user experience, we must ensure UI is updated to reflect the current app state, regardless of whether the state update came from human or a tool call. And there is a potential complexity overhead. So in cases where your website UI is very complex, you most likely will need to refactor something, right? Or add some JavaScript that handles additional states. Okay, you might say, right, that's a lot to remember, right? Screenshots, DOM, accessibility, imperative, declarative WebMCP, best practices, and so on. So how cool would it be? How cool would it be if you would have a tool that can check some of those things for us? Very cool, right? Guess what? We do. So starting from Chrome 150, you can run live audit that is tailored to agent web to check your website agent readiness. It covers things we discussed today, like visual readiness, accessibility, all the WebMCP tools, content shifts, etc. And it's the first call to action today, so it's still evolving, and we're really looking for feedback. We're looking for your help. So please join discussions on GitHub, and yeah, let's build this together. And that's a beautiful segue into testing and debugging. So WebMCP is still very fresh, and we have added an agent to a user journey, right? So how do we make sure that WebMCP tools we created actually work well with agents? You know? Yeah, so we are used to testing the deterministic code, right? If A, then B. And here, we are dealing with something new. AI agents that will interact with your tools are non-deterministic, right? And we'll need different techniques to make sure they work well with our tools. These techniques are called evaluations, or evals for short. And while evals involve new workflows, your existing testing experience carries over directly to building great evals. The thing is that I would need another session for evals alone, so I really encourage you to take a look at our materials for evals, and for inspiration, you can check our experimental repository with evals CLI for WebMCP. And yeah, we do showcase different sets of evals for different types of use cases there. Okay, let's now take a look at debugging. So in this testing extension area, we show details of tool calls, available tools, and so on. But not all integrations, not all agents might offer that. So what would be a great place to have all of those details? What would be a great place? Thank you, DevTools, yes. So we are adding the support for WebMCP in DevTools. Yeah. So first you see which tools are getting called during the user journey. It also means you see which tools were not called during the user journey, and that can actually help you with evaluations. Yeah, so the status of tool calls is clearly visible in the upper section of the tools panel. You can use tool invocation counter to verify how many times tool was called. It's especially useful to verify, again, if certain tool was not called or called too little times or less times than you expected, right? If there are too many tool calls in activity log, you can filter for declarative, imperative, status type, and even search for certain strings. Exciting. For each tool, you can also review input and output. So the output here is what is returned by WebMCP tool. If a tool was called by the agent, then the output is what will be returned to the agent. Last but not least, you can also find where tool is registered in sources in case of imperative API, and where it lives in elements in case of declarative API. Make sure to visit our demo booth so you can see it live. Yeah, there's also experimental support for WebMCP in Puppeteer, which can also come in very handy when you'll be doing any kind of testing automation. What you can also do is you can use Chrome DevTools MCP, which has experimental support for WebMCP to interact with your WebMCP tools. Yeah, so the tooling's already out there for you to test with. The road ahead. So as discussed before, WebMCP goes beyond demos, and companies are actively participating in a developer trial. And yeah, let's review some more demos. Here we have Red Bus, and here you can see the experimental improvements to bus booking journey. So show buses from Pune to Mumbai with AC and sleeper for a certain date. Now user wants 2 window seats on the highest rated bus departing in the evening. Yeah, quick and simple. Nika experiments with WebMCP to create AI-supported purchasing journey. Review history. Add last purchase product in the cart. Apply coupon if available. Then proceed to checkout. Easy. Gadgets Now is experimenting with WebMCP to help users find mobile specifications and apply relevant filters accurately. So, user's query, 5G phone under 30,000 Indian rupees. Yeah, awesome. You can start experimenting with WebMCP today. Everything you saw today is controlled by those 2 Chrome flags. And what's great is our trial, which is coming soon. Yeah. So yeah, stay tuned. And yeah, let's summarize. We began by understanding how an AI agent sees your website through a combination of screenshots, analyzing DOM, and leveraging the accessibility tree. We discussed that the agentic readiness starts with a principle we already know. Build it well, build it accessible. We have reviewed WebMCP, the proposed web standard that aims to expose structured tools for AI agents on existing websites. I really encourage everyone to start experimenting with WebMCP and join the upcoming Origin trial. And finally, we discussed the live test audit for the agentic web, reminder, we need your feedback, and debugging your WebMCP tools using the support in Chrome Dev Tools. Yeah, the agentic web is not a future trend. It's already here. And the developers who embrace it will build websites that are ready to use for everyone, human and machine alike. Thank you.
Yeah, this was fun. We discussed it in our Google and AI community developers workshop in Lucknow, in our city. And we had a 30 minutes session on web MCPs and the applicability of it. So yeah, the things that you saw, we already covered that and how it happens behind the scenes architecturally. So if you want to know more, you can ping me anywhere and we can take it forward. Now, we are done with the Google I/O sessions. We have completed all the sessions. This is my YouTube live streaming. There I have approximately 40 videos detailing my projects that I have worked on. I wanted to know about Marvel and what they're doing. So let's get through that.
Please welcome Marvell Chairman and CEO, Matt Murphy.
It's great to be here to kick off day 1 at Computex, and it's great to be back here in Taiwan. You know, the first time I came here was nearly 30 years ago. It was my first business trip to Asia. And I remember back then visiting some of the key technology companies here at the time. Many of them were still young, small companies, emerging companies. And today, those same companies have become the most important technology leaders in the world. Now, I've had the opportunity to come back many times and see Taiwan continue to grow in importance as one of the world's leading technology centers. And today, so much of the future of AI infrastructure is being built right here. I have a question for all of you. What defines the performance of AI infrastructure? Now, maybe you're thinking about the processor, the GPU, the XPU, or maybe it's the process node used to build it. 3 nanometer, 2 nanometer, or soon A14, A16. Those are great metrics. They tell you a lot about the speed, the efficiency, and the density of the compute. And AI workloads are certainly compute intensive. But that's not the whole story. Now, you might say, well, what about memory? AI workloads are incredibly memory intensive as well. More memory, higher bandwidth, all of that matters. It's all critical, no doubt. But that's still not the defining characteristic of the system. Because one processor, no matter how fast it is, no matter how much memory it has attached to it, is simply not enough for today's AI workloads. You need tens of thousands and eventually millions of processors working together as a single massive compute engine. That's why computing at this scale is fundamentally a connectivity challenge. And increasingly, it is the architecture and characteristics of connectivity that defines the performance of the system. Now, look, we've seen incredible breakthroughs in accelerated computing, and we've seen the emergence of high bandwidth memory to meet the AI challenge. But I'm here to tell you, the next major wave of innovation and scale will come from the underlying connectivity of these systems. And as those connections move from copper to optical, they will unlock new architectural possibilities. So today I'm going to explain why connectivity is becoming one of the defining characteristics and challenges of the AI era, and why this technology transition matters to optics. Now, this isn't something far in the future. It's happening right now, this year, next year. We're in the ramp. And at Marvell, we've been preparing for this moment for nearly a decade. We built the company very deliberately around the infrastructure required to move data at massive scale. And to understand why we made that bet, let's go back in time, 10 years ago when I joined Marvell as a CEO. So prior to Marvell, I spent 22 years at one company, Maxim Integrated Products, which is a leading analog semiconductor company. And one of the unique things about working at an analog company is that your products go into virtually every piece of end equipment, every electronic system, every end market in the planet. So over those 2 decades, I had a front row seat to just about every major technology trend. First personal computing, then notebooks, digital still cameras, smartphones, eventually data center. And I watched wave after wave of technology reshape the whole industry. So I joined Marvell, and I didn't start off actually thinking about, well, what products do we have? I reflected on where the industry was headed. And it seemed clear to me, even at that time, back in 2016, that the next major growth cycle for semiconductors in the world really was going to be driven by the data platform companies. Back then, it was still the same ones as today, companies like Google, Amazon, Microsoft, Meta. And more specifically, the semiconductor technologies that were required for those markets to move data, store data, process data, and secure data, do it at massive scale. That was the vision we had. But when I looked at the products we had at that time, very few of these were actually exposed to that trend. It was kind of a problem. Less than 10% of our revenue 10 years ago was coming from data center. That's it, a couple $100 million bucks. But more than 60% of our revenue back then was coming from consumer. And so it was an exciting time. We were in virtual reality headsets. We were in gaming consoles, streaming devices, wearables. In fact, our claim to fame back then was Marvell was designed into the first Wi-Fi connected Barbie dream house. That was our big design win. It was real. In fact, the first week I was at Marvell, they team briefed me on what a great design win this was. So that's where we were. So we had a vision. There's a pretty big gap, though, between the reality that we were facing and where we saw the industry heading. But we had conviction. So we decided to bet the whole future of Marvell on it. So to do that, we needed a clear vision. And our vision at the time was pretty simple. And by the way, this is still the same vision that we have today, 10 years later, which is build a best-in-class, pure-play company focused on semiconductor solutions for data infrastructure. Now, at that time, data infrastructure was not a recognized market category. It was the term that we used to describe the infrastructure that was going to be required to move the world's data, store the world's data, process the world's data, and secure it. But like I said, we were not in that business yet. And frankly, we didn't even have a lot to work with as we went after it. We had some. So my team and I came to a conclusion, which is that we would need to build these capabilities internally, and others we would need to build through strategic M&A. And we had to get focused. Because when you're transforming, it's not just deciding about what you're going to do. It's equally important to decide what you are not going to do. So that strategy in place, we got to work. We began systematically building Marvell around that vision. And it wasn't just one move. There was a series of deliberate choices. We looked for the premium assets in the markets that mattered the most, the best companies, best technologies, the best teams with the strongest market positions. Now, we first started by divesting businesses that weren't aligned with our strategy. You can see some of those there. Then very quickly, we acquired Cavium to strengthen our compute and networking capabilities. That was back in 2018. 2019, we divested our Wi-Fi business. Again, we were focusing. But we acquired Avera to establish our custom silicon business, and then Aquantia to bolster our connectivity portfolio. In 2021, we followed all that up by acquiring Inphi for $10 billion. It was our largest acquisition to date, and we got world-class data center connectivity technology into the company through that. And we acquired Novium the same year, adding high-end data center switching capability to the portfolio. So then we took a break. We took a few years to digest and focused on unifying and building out our whole technology platform to address the data infrastructure opportunity. But over the last 12 months, we fired up the M&A engine again. We divested our automotive Ethernet business, again, power focus, and acquired Celestial AI for its photonic fabric technology and XConn for scale-up switching. So if you add it all up, over the last decade, we've invested roughly $22.5 billion through acquisitions. We spent $18 billion organically inside of Marvell to develop the platform, and then we divested approximately $4.5 billion worth of assets. So all in, we've invested roughly $36 billion investing in this platform. Let me show you the result of some of these investments. First of all, we have built an incredible technology platform, and it all starts with the advanced process node. It's one of the most important decisions we made, actually, was to become a process node leader. Now, Marvell, Cavium, and some of the companies we acquired had all been fast followers, meaning you're like a node or two behind on everything you do. And that's largely a result of just not having enough scale. That's usually why people do that. But as we integrated these businesses, we made the decision that if we're going to compete in data infrastructure, we had to be at the absolute leading edge. No choice. Now, here's a little known fact. Marvell skipped 7 nanometer completely. We made a full node jump at that time from 14 and 16 nanometer all the way to 5. I mean, nobody does this. Nobody takes that kind of a risk or a bet, but we did, and it worked. It worked really well, flawlessly, actually. Our engineering team did an outstanding job executing this transformation. So in early 2020, we released our first world-class IP platform, complete with die-to-die interfaces, custom SRAM, high-speed SerDes, and more. Now, SerDes is a good example of how we built this platform. It combined Marvell's own core engineering strength with exceptional talent from Avera, Aquantia, Inphi, and others. Now, today, that is a 1,500-person organization at Marvell, second to none in terms of engineering scale and capability. So to support the process data portion of our mission, we built a best-in-class custom compute platform, working in deep partnerships with the world's leading hyperscalers. That business has been doing very well for us. In store data, we built a whole portfolio of storage controllers, CXL-based memory poolers, and near-memory compute. But here's where we really went all in. That was in data movement. And this is where our high-speed connectivity portfolio, and when you look at Marvell's data center business today, the vast majority of our revenue actually comes from connectivity. From high-speed optical interconnect inside the data center to long-reach optics between data centers to high-speed switching infrastructure. So today we are the undisputed connectivity leader. And when you step back and look at what we built and where the market ultimately went, I think the results speak for themselves. So back in 2016, Marvell was a $2.3 billion company. As we embarked on the transformation, actually in the first 5 years, we doubled the company, $4.5 billion in revenue. Over the next 5 years, our growth accelerated. And according to consensus estimates on Wall Street for the current year we're in, we're set to grow about 2.5 times over the last 5 years to $11.4 billion. But in the recent couple of years, if you actually drill down, Marvell has been growing like 40% a year. So the growth rate is actually accelerating in the last few years. So at this point, Marvell is off to the races, okay? And based on the outlook that we shared in our earnings call last week, consensus estimates have come up, and they expect us now to deliver $16.4 billion in revenue next year. So as I said earlier, when we started this journey, data center represented less than 10% of our revenue, and we bet the farm on it. Last quarter, it was over 75% of our revenue and growing very rapidly. So it's a very different company than we used to be, and the thesis is largely played out. But we're still in the early innings of this infrastructure build-out. The next phase is all in front of us. We'll have a different set of requirements, and that brings us back to connectivity. So for the past several years, as AI has created new demands on the infrastructure, we've seen the industry solve one major bottleneck after another. And first it was compute. And the industry needed dramatically more compute to enable modern AI. And NVIDIA did an incredible job leading that revolution, and along the way became the world's first $5 trillion market cap company. Congratulations to Jensen and his whole team that's here. It's just a phenomenal result. Next came the memory bottleneck. Larger models required enormous amounts of memory and bandwidth, and the memory companies are scaling aggressively now to meet that demand. And just recently, we've seen 3 new $1 trillion market cap companies emerge in that market. But the bottleneck is shifting again. Now it's connectivity that will define the limits of the infrastructure, just like with compute and memory. The industry will rally to meet this challenge. Now this isn't just me saying this. This is what we're hearing from our largest customers. The world's largest hyperscalers are now reimagining their entire network architectures. They recognize that scaling AI infrastructure is now, first and foremost, a connectivity challenge. As reasoning models, mixture of experts architectures, agentic AI, it all continues to evolve, more data has to move across the infrastructure, demanding higher bandwidth and lower latency. And as workloads no longer fit within one data center, guess what? They need to build larger data centers, or full campuses full of data centers, and all the high-speed connectivity between them. Thus, the connectivity becomes a critical enabler of scaling compute. And increasingly, our customers recognize that optics is the way forward. And they're looking to leaders like Marvell to help them build larger, faster networks and at scale. So when you look across the semiconductor industry, at the leading companies supporting this infrastructure build-out, it becomes clear each of us is focused on a different part of the infrastructure. And that shows up in the revenue mix. Some of the companies are compute first. It means the vast majority of their revenue is tied to compute, with some of it tied to connectivity, but most of it's compute. And it's obviously a critical part of the stack, and that's why we have several trillion-dollar-plus companies in this group. Then you have the companies focused on memory, and again, all trillion-dollar market cap companies at this point. It's unbelievable. Then you have Marvell. We're different. We're unique. Today, the vast majority of our revenue actually comes from connectivity. So we built this company around data movement. And today, the vast majority of our revenue comes actually from connectivity. Now, this spans a broad range of technologies. And even the portion of our revenue that's from compute, which you can see, is fundamentally because customers embed our connectivity in their compute engines. So this gives us a unique position and perspective on these technology transitions that are happening. And it creates a very different relationship that we can have with the rest of the ecosystem. We partner deeply with the compute companies. We partner deeply with the memory companies. These are very strategic relationships. And in many ways, we are the Switzerland of the industry, and we work with everybody. Now, one of the best examples of the role that Marvell plays in this ecosystem is the recently announced strategic partnership and expansion with NVIDIA. And as part of this announcement that we made a few months back, NVIDIA invested $2 billion into Marvell. And we're expanding our partnership now across multiple dimensions, including optics, photonics, NVLink Fusion. And I'm thrilled to announce that Jensen himself is here today. He's going to join me on stage. We're going to spend a few minutes chatting about the partnership, and we're going to see where AI infrastructure goes from here. So with that, let me please welcome to the stage Jensen Huang. What's up, Jensen? How you doing?
Boy, that's a huge stage. Run a long way.
You got a breath? You okay? I know. Let's fire up. Good to see you. There you go. Yeah. Congrats on a great kickoff yesterday, GTC. You guys are off to the races this week.
Thank you. Thank you.
Look, maybe you heard some of what I just said. So we're talking about connectivity today.
The next $1 trillion company, ladies and gentlemen.
Whoa! That would be exciting. Let's do it together. Yeah. Let's do it together. But it really all starts with what's happening today in AI infrastructure kind of more broadly. So how do you see that, like just from the big picture standpoint, we're at this extraordinary moment, customer demands through the roof. How do you see connectivity playing into this and the interconnect that's required?
Yeah, that's really great. You know, yesterday I said that useful AI has arrived. It's the reason why your demand is going through the roof. It's the reason why my demand is going through the roof. Yeah. And this new computing pattern that makes it possible is called agents. And these agents has a particular computing platform, a computing pattern that is disaggregated and distributed. Mm-hmm. When you take a computing problem and you disaggregate it into a lot of parts and you distribute it across the entire data center, what's necessary is connectivity. That's the reason why Matt's doing so well. That's the reason why Marvell is so essential. We've distributed and disaggregated computing so that it runs across these enormous clusters so that we could we're aggregating the total compute, the total memory, the total bandwidth that we have. And what makes it possible is connectivity.
Yeah, we're seeing it. And then
as you think, they're going to be the next $1 trillion company.
We got a little work to do, but we're on our way. We're on our way. Thank you, Jensen. Well, let's talk about scale. I mean, we used to talk about tens of GPUs and CPUs and XPUs connected, now thousands, now maybe millions at some point. So as you scale the compute and you scale the connectivity, I think we talked about things like agents, but how do you think about that, across data centers, within data centers? How do you think about connectivity at large playing that role, and what kinds of technologies do you think are important there?
Well, at the foundation of it, the agent computing pattern requires an orchestration system that allows the large language models, the computing, to be able to think and reason and come up with plans, but it also has to use tools and browse the internet, access memory, access long-term memory, deal with short-term working memory. All of that requires a lot of connectivity. But it's also the case, and if you look at the way we introduced Vera Rubin, Hopper was designed for training. Yep. Grace Blackwell introduced NVLink 72, our first scale-up fabric. It introduced the idea of extremely fast inference for MOE models that are very large, mixture of expert models that are extremely large. And so Grace Blackwell was for inference. Vera Rubin is to run agents, which is the reason why the Vera Rubin system includes, of course, the Vera Rubin thinking AI, but it also includes Vera CPUs for orchestration. It includes Vera CX for storage acceleration, for managing long-term memory. And the way that I think about these systems, sometimes maybe the CSP wants to design their own custom chip. And between us, we also partner together on NVLink Fusion, which makes it possible for you to use the same system architecture. And with Vera Rubin inside, some of your semi-custom chips, a lot of your interconnect, silicon photonics and optics and technology such, and we can create essentially a disaggregated, distributed, and heterogeneous data center. And so that's the big idea. And yet their system architecture is identical. Their networking technology can leverage a lot of NVIDIA stack. The CPU could be Vera, and yet it can leverage a lot of your stack. So NVLink Fusion is about taking NVIDIA's technology in our platforms, Marvell's technology in and we fuse it. That's why it's called Fusion.
Yeah. No, I think about the partnership. We've been working together a long time. I think memorializing it with the investment, which we really appreciate. I think it's been huge for us. We're honored to have it.
Who doesn't love making money? It's nice to give.
It's done well since you invested. So
I love getting rich.
Just follow him.
Give Matt all my money and just watch him make money.
That's what I'm doing every day.
Love that.
That's what I'm doing every day. But I think these things you talked about, which we brought to fruition, NVLink Fusion, working together on optics. I mean, I think the era of agents and kind of your new platform now, I think it's ideally suited. I mean, NVLink Fusion, we had this idea years ago, right? But I think it was a little ahead of its time. And now, and I wanted to see if you agree, when you think about kind of your platform and then some of the custom networking and compute needs that our customers have and the ability and the need to interoperate and work together, it seems like the time is now between Marvell and NVIDIA to really go enable our customers to have that flexibility that they're looking for and really use the era of agents to scale our platforms together.
Yeah, ultimately, I do think that if you buy nothing but NVIDIA, it's okay. Okay? I mean, but if you absolutely must design your own ASICs, we're still happy having NVIDIA be inside that data center. And so, you don't have to buy everything from us. Just buy something from us. We're happy to support you and support the customer. And so I think that between the two of us, you have the benefit of a general purpose, very high efficiency, a system that is very well built, starting with, of course, Vera Rubin. But anything that you want to extend to specialize, you can do so as well, which is the reason why your customers and mine, NVIDIA's in AWS, Marvell's in AWS, NVIDIA's in all of the clouds. And it's wonderful to see Marvell expand into all of these different clouds.
Yeah, great. Thanks. Hey, one last one for you.
Just leave some business for me.
Look, we're your best salespeople right now. We're
your best salesperson.
Working together. Final question for you. A lot of my talk is about some of the transition, especially as you go inside the rack from copper to optical. It's obviously not going to be a 1-0. It's going to take there's time, there's different use cases. But how do you see that playing out right now, the transition from copper to optics, and maybe how we can work together there too?
Well, we should use copper as much as we can for as long as we can, but copper has its limits. Copper has its limits with bandwidth and also with distance. And so ultimately, the right strategy is to scale up with copper as long as you can. After that, you scale up further with optics, and you scale out with optics, and you scale across with optics. And so you use optics wherever you must, you use copper wherever you can. And so I think that intersection is going to continue for a long time. Here's the bottom line is, in the next 5-10 years, we're going to use a ton of copper, and we're going to use tons and tons of optics. And so these data centers are part of infrastructure now. And the reason why I say that AI is now useful AI has arrived, is because now AI is profitable, and tokens are profitable. When token production is profitable, everybody wants to make more tokens, which is the reason why, Marvell's demand is so high, our demand is so high, because everybody wants to produce more tokens because it's used all over the place by agents.
Yeah, absolutely. Well, I think you touched on a bunch of things I'm going to cover later. If you want to do the rest of my presentation, you can.
Yeah, so ladies and gentlemen,
these beautiful slides,
just sit right there.
You take it from here. All right, Jensen Wong. Good to see you, brother. All right, take care.
Okay, guys, thank you.
Thank you, Jensen.
Bye, Marvell.
All right, outstanding. Super fun to have Jensen here, as always. All right, so we've been talking a lot about connectivity. Jensen and I just covered this, so let's dive in now, right? Let's go one level deeper. So AI infrastructure spans every distance. It spans from hundreds or even 1,000 kilometers between data centers to just millimeters inside the package. Every one of those distances, it requires a different solution. It's a different technology, different engineering team, it's a completely different set of experts. And in many cases, it's a different supply chain. So these are not variations of the same problem. What you have here is fundamentally different engineering challenges, and that's what we're going to walk through next. All right, so let's start with the longest distance. Jensen referred to this. This is scale across, connecting data centers together. Now, every major cloud provider has hundreds of data centers around the world. All those data centers need to communicate with each other. This is fundamentally a long-distance connectivity problem. We're talking about links that can span hundreds or even 1,000 kilometers. This requires very specific, very complex technology called coherent modulation. At the heart of it is a specialized digital signal processor, or DSP. It's designed to push enormous amounts of data across fiber optic cables over very long distances with extremely high reliability. There's only a few companies in the world that build these coherent DSPs, and we're one of them. Marvell has been a leader in this technology for many generations. We build optical modules that contain all the electronics needed to drive and modulate the laser and transmit data over long distances. So I got a little show and tell here in my pocket. I'm not holding up a chip this time, I'm holding up an optical module. This is one of our coherent optical modules. This is an incredibly complex piece of engineering. At Marvell, we build the entire module. This is ours. It includes the advanced node CMOS DSP. It's among the most complex chips, just the DSP alone, that we designed at Marvell. But it also incorporates inside our 4th generation silicon photonics technology. That's inside here. And we've been developing that technology and in production for a decade on silicon photonics. It also includes our own broadband analog components that we designed, which is designed in silicon germanium. So Marvell pioneered this technology starting with 100 gigabits per second a decade ago, then moving to 400 gig, and now shipping 800 gig in volume. And later this year, we'll be sampling the world's first 1.6 terabit, 2 nanometer coherent optical solution. And that couldn't come at a better time. Demand for bandwidth has never been greater. All right, now let's go inside the data center. So these data centers can be very large, spanning hundreds of meters, and they contain racks and racks of compute servers. Now each rack typically has a switch at the top with servers connected into that switch. Those rack level switches connect to the spine and then the core switches. This creates a network fabric that ties the entire data center together. And all of that is connected through fiber optic cables. Now once again, optical modules drive data transmission over those fiber optic cables. But this time the modulation scheme is different. Instead of coherent technology, we use a more power optimized modulation technology, which is called PAM4. So the two key semiconductor solutions for this part of the market are the PAM4 chipset inside the module and then the cloud switching infrastructure that ties the data center together. Marvell builds both. Starting with the PAM4 chipset, we build the industry's leading PAM4 DSP solution. And also the high-speed analog components that go around them, including transimpedance amplifiers or TIAs and laser drivers. These are also in silicon germanium, by the way. And we've led the industry through every major transition of PAM technology, starting at 50 gig, 100 gig, 200, 400, and 800. Then last year, we began ramping Marvell's 1.6T 3-nanometer PAM4 solutions, leading the industry's transition to 1.6T connectivity. Now, for Ethernet switching, Marvell has a similarly complete portfolio of products, from 12.8 terabits to 51.2 terabits. And today, we announced our new 100T Ethernet switch, specifically designed for AI data centers with the industry's lowest power. Special announcement for Computex. We waited. So you put it all together, we provide a complete solution for connectivity inside the data center. Now let's move inside the rack. The goal here is to connect the largest possible number of processors together in a full any-to-any configuration. In other words, every processor can communicate directly with every other processor. And Jensen talked about this. The first company to bring this architecture to market was NVIDIA with NVL72, named for the 72 GPUs connected together inside a single rack. And this required a completely different approach to connectivity. It was a different class of switch and the ability to drive very high-speed signals over copper backplanes inside the rack. So today, this is not the domain of optics. This is the domain of copper. And the core differentiator here is the electrical SerDes technology, not the optical. Now, Marvell also has leading electrical SerDes at 200 gigabits per second today. And we've demonstrated already over the last couple of years 400 gigabits per second for the future. So we're building the SerDes technology into our customers' custom silicon and their XPUs, and also into our own scale-up switches. All right, now let's go all the way inside the package. Here we're not talking about meters anymore, we're talking about millimeters. And you might not actually think about this as a connectivity challenge, but today, most advanced chips have multiple chiplets inside the package. So when you have 2.5D or 3D packaging, it's fundamentally a connectivity technology, actually. And it allows these chiplets to sit very close together inside a package and communicate through ultra-high-speed, short-reach die-to-die interfaces. And Marvell has leading die-to-die SerDes and leading capability in advanced packaging, allowing our customers to build some of the most complex, unique multi-die chips in the industry. So as you can see, connectivity for AI data centers requires a very broad portfolio of technologies. Each distance requires a very different solution. And Marvell has the industry's most complete portfolio, from millimeters to kilometers, every hop, every distance. And it turns out having all of those capabilities under one roof is unusual. It's unique. When we go and compete, normally there's a different set of companies that we compete against in each one of these categories across these different distances. But this is what makes us unique. We're the one-stop shop. We're the leader across the entire connectivity stack. And that brings us to the next major challenge facing the industry. So what you probably noticed as I described these different solutions in the last couple of slides is there's different solutions for different distances, and that some of those connections today are optical, and some of those connections today are electrical. And it's actually defined by distance. And so the connections on the left side of this chart are optical today. That means they use fiber optic cables to transmit light, with complex electronics on either side of the cable to drive and modulate the laser that's transmitting that light. The connections on the right side of this are electrical, so they use copper cables, or just copper traces that are printed on the circuit board, or even microscopic copper routing inside the package. So the common theme here is copper. And in the middle, you see the wall, the copper wall. And the wall is defined by the longest distance you can transmit a signal over copper. So before you have to move to an optical connection. So this is an important distinction because copper is simple and it's low cost, and as Jensen said, you want to use it for as long as you can. It's very practical. But optics is more complicated. It requires lasers, photonics, complex electronics. So it's a bigger lift, but it's going to be needed. And the copper wall, what I'm here to tell you today, is it's about to move. It's going to move again, and it's going to take over the rack itself. So this is creating an explosion in demand for the optical industry. Incredibly complex engineering challenges are coming along the way. So why is this happening? So it's not just somebody's preference to go do this. This is physics. The distance a signal can travel over a copper cable is inversely proportional to the bandwidth. So every time you double the bandwidth, you have to cut the distance in half. Today, the highest speed production systems in the world run at 200 gigabits per second per lane, just to give you an example. So at that bandwidth, the cable length is limited to roughly 2.5 meters. Now, by comparison, systems running at 100 gig could use about 5-meter cables. And the height of the rack is about 2 meters. So once you account for all the routing inside the rack, 2.5 meters is right at the limit. So when we move to 400 gig, we can no longer fully connect the rack with copper. So the wall is moving, and it's moving now. And going forward, even the connections within the rack will become optical, and the whole industry knows this is coming. So we've been preparing for this moment, not just Marvell, but the industry. And you see this in Taiwan, by the way, in the supply chain and the ramp-up that's happening. The ramifications for this are actually enormous because each time the wall moves one step to the right, the number of connections that you have goes up by at least an order of magnitude. So it's creating this explosion in demand, as I mentioned, and the optical supply chain needs to scale up massively and be ready. Well, we've seen this movie before, okay? I mean, 20 years ago, and I remember this when state-of-the-art was 10 gigabits per second inside the data center. It was 10 gig. And we used copper cables all across the data center. Optics back then was reserved for just very, very long distances. It was essentially like a telecom technology, but when the wall moved, the optics industry actually rose to the challenge. And today, all the hyperscale data centers in the world, they're all optically connected. And as we saw in that transition, it did require new solutions. You couldn't use the same power-hungry kind of telecom approach, which is where PAM4 came in. It was optimized for power, density, and reach, and requirements specifically tuned to inside the data center. And Marvell was one of the key innovators there. So we're about to see the same wave of innovation needed as optics moves inside the rack. And that's what the technology called co-packaged optics, or CPO. You hear a lot about this now. I'm going to tell you more. CPO is a technology where we bring the optical connections all the way to the package itself, right next to the compute, either the custom compute or the switching silicon. And the fundamental challenge we're solving with CPO is density and power. Now remember, the number of connections inside the rack is like 10x the number of connections between the racks. So if you just try to use the same optical technology used across the racks in the data center, you wouldn't have enough power, you wouldn't have enough physical space, you cannot fit all these standard optical modules and cables as they are today. It just doesn't work. It's not possible. So the industry has been inventing this co-packaged optics concept, which brings the optical fiber right to the package. It tightly couples the electronics that drive the signal over the fiber directly with the custom compute or switching silicon. So this is a massive change, and it's hard because you're combining some of the most advanced technologies in the chip industry, leading-edge CMOS, silicon photonics, advanced packaging, optical interconnect, all manufactured in a small, tightly integrated system. So the complexity is very high, but it's the only way to continue scaling bandwidth and overcome this limitation that I talked about with copper, while reducing power at the same time. So this is where the industry's headed, and this is one of the reasons that Marvell has invested for more than a decade in silicon photonics, optical DSPs, all the analog broadband components around it, and all the advanced packaging you need to pull this off. It needs to all come together actually in CPO. So this isn't some futuristic thing, guys. Okay, it's happening now. And in fact, I brought a couple of Marvell examples with me today, so let's do a quick show and tell. Okay, so over here you have a traditional Ethernet switch. This is our 100T Teralink switch that we announced today. And you guys are the first to see it, actually, everybody here in the room. You can see the switch in the middle of the board. Copper traces inside the PCB carry the signal to the front panel, which is here, and this is where all the optical modules plug in. Now let's move over here. This is a CPO-based switch right here. Now notice that there's still the switch silicon in the middle. That's right in the center of the die, of the package. In this case, this is our 51.2T switch, and all around the edges are 16 3.2T optical engines.
So the 16 times 3.2, you get 51.2. So this is the fiber is directly attached now to these engines. It's not to the front panel. So we've completely eliminated the copper traces on the PCB. Light comes directly out of the package. Okay, it's a very, very complex piece of engineering, and it was very cool to be able to show this off today. Okay, so co-packaged optics is here, and the industry is scaling up to meet the challenge. As we've seen time and time again, every time we reach a physical barrier, we break through it with technology and innovation. In this case, by replacing copper with fiber, because unlike electrons traveling over copper wires, the distance that photons can carry a signal through glass is largely unrelated to the bandwidth. So as AI infrastructure demands even higher transmission speeds and needs to scale to larger and more complex systems, spanning millions of processors woven together now, not thousands or hundreds, optical connectivity will increasingly become the de facto solution. So the real question becomes, what does it take to deliver optics across the full AI infrastructure stack? What's it going to take? Well, it starts with recognizing there is no single technology for the entire data center. It's not how this works. There's no one-size-fits-all solution. There's no shortcuts. There's no easy way to the end here. There's not a single architecture, modulation scheme, frequency band, unique technology that's going to do it all. There's no free lunch. That's why we are pursuing a bunch of different unique optical paths across every distance to get here. Each one of these technologies that I have up here is optimized for a different design point. Each one enables a critical part of the infrastructure and addressing different requirements for density, bandwidth, and power and integration all across the stack. So if optical interconnect is the underlying technology for which next generation AI infrastructure is built, then Marvell is building the broadest portfolio with the deepest bench in the industry. But no company can deliver this transformation alone. And as Jensen talked about earlier, right, it takes an ecosystem to get here. So like I said, technology innovation is great. It's part of the challenge, but not all of it. But demonstrating this at scale is really what matters. And at this point, if you're just operating on a PowerPoint or a demo, POC, press release, it's not going to get you there. Customers need solutions now that are ready, they're reliable, they need to be manufacturable and be ready to deploy at scale. So Marvell and our ecosystem partners have been doing this for a long time. We've already shipped hundreds of millions of DSPs. We've accumulated through our volumes tens of billions of device hours of data in the field. This experience matters because these products have to work not just in the lab, but in the world's largest data centers at very high volume and very reliably for years. So that requires investing ahead in the manufacturing ecosystem. You've got to build the capacity and the supply chain infrastructure before the market arrives. This is why the ecosystem matters so much. And it matters a lot here in Taiwan, by the way. Now, one of our most important partners at Marvell in this journey has been Advanced Semiconductor Engineering, or ASE. Now, ASE is one of the world's leading semiconductor manufacturing companies. They have more than 100,000 employees with operation in Asia and actually all around the globe, with a decades-long track record of helping enable pretty much every major technology transition we've gone through in the semiconductor industry. Now, leading ASE through this period of transformation is someone that I know quite well. He spent more than 25 years helping shape both the company and the industry. Today, I'm thrilled to have my next guest speaker come up, which is ASE CEO, Dr. Tian Wu. Tian, please join me on the stage. Thank you. Hey. Tian, how are you?
Thank you for inviting me to Computech.
Great to see you.
Yeah.
It's an honor to have you on stage.
Well, it's my honor.
Look, we've been working together a long time, and when I became the CEO, we had a set of ambitions. We talked to a lot of our suppliers. I've known you even before I was the Marvell CEO, when I was an executive back at Maxim, and we worked together there. But part of what, and maybe explain to the audience too, that sometimes people don't realize is that as a key supplier into this ecosystem, you have to make bets. Right? You got to make bets on the companies you work with. You got to make bets on who you think is going to be successful. And we really appreciate that ASE bet on Marvell very early. And we've seen great success actually based on that. But I'm just curious if you could share your perspective maybe on where Marvell was, what your thought process is, and then where are we today in our journey together. So it'd be great to hear from you, Tian.
Look, I think the best way to describe this is a gradual process. The first decision was not difficult. Marvell, a fabulous company, has a very good reputation, has gone through a lot of transition. So the track record of Marvell has already been there. The product set was a little bit obsolete at the time when you joined. So the first one is the business model needs to be aligned. Taiwan, ASE is in the manufacturing sector. So we're looking for bet, not only on betting on your success, we're also betting on somebody who can provide the insight for the next generation architecture and also the technology requirement. As you know, the Taiwan company invests infrastructure and capex 10 years ahead of time, big bet. We're only counting on whatever capacity we put it in will be needed and will be utilized. That's how we make money. So betting on company that we believe will give us very good insight well into the future becomes very important. So that's how the decision was made at the very beginning. And for the last 10 years, I'm just really happy. Everything that we talk about, it was a dream 10 years ago. It was a dream. And today, we are going to ship it. And you just mentioned that you're going to have 40% growth for the next few years. I believe you're going to beat that. So we're busy now preparing the capacity for you.
Yes.
We also appreciate that over the last 10 years, we have gone through a lot of strategic discussion. Right? You make commitment to us, we make investment for you, and over time, we're going to produce more of your parts. I think that's the really a short story for how the decision was come.
Yeah, no, it's been a great story. Maybe one more for you. The ecosystem here in Taiwan is so unique, and like you said, it takes like a decade of investment before you really can see the return. And there's just such a power that's happening here. How do you describe it to the people here? And also, there's a lot of people around the world watching. And then, what makes it possible here? Why is it unique? And then, what also makes it difficult to replicate this in the rest of the world? Okay. But at the same time, there's globalization. So, how do we think about those dynamics? I think that'd be an interesting one.
I think the reason why you're asking the question is there's a lot of competing forces and also uncertainty across the world. So, I think my belief is any business needs to have vision as well as long-term alignment on value. So, in the business model, the whole Taiwan sector is built on capacity utilization and also innovation and technology investment way ahead of the curve. That's what Taiwan's value. So with a fabulous company or with a specific IDM company, that business model aligns. Beneath that will be the economy of scale. Taiwan accumulated 40 years based on the PC transition to wireless, to mobile computing, to the data center. Now we're into HPC. So that 40 years of experience accumulated 350,000 semiconductor employees, also accumulated 1.1 million high-tech employees, and many of them are here. That experience becomes extremely valuable combined with the economy of scale as well as the cluster efficiencies. So when you think about the workforce with years of experience behind it, when you think about the cluster efficiency, when you think about the capacity, economy of scale, we already put it in. But one more thing, I think Taiwan, good or bad, we had fewer choices than the other region like the United States. So most of the engineers, when they come out, they have few choices to make. Semiconductor, IT industry becomes a attractive choices in Taiwan, not necessarily in the other region. So with all of this combined, I think this ecosystem is very, very difficult to replicate. It is not impossible, but would take years.
Right. Great. Well, thank you so much.
Okay.
I appreciate the partnership so much. We're off to the races. Tian, thank you. Tian Wu.
Thank you.
Okay. So, like we said, the future of AI data centers is all optically connected infrastructure. And you heard him say it, right? This is going to drive a tidal wave of growth, innovation that's needed in scale in manufacturing. But what does that inevitable future actually look like? I mean, if you just take a step back for a minute, and you actually don't think about right now, think about 10 years in the future. And it's a world where a lot of the copper connections are gone. And just think about a world where data transmission now, at some point, is all optical. This is a world where then distance doesn't matter actually. And that's a profound change. Servers, racks, and overall data center architectures today have all been designed around the constraints of distance. And software workloads actually have also been optimized around those same constraints. But what if distance no longer matters? How might the architecture itself change? And what new capabilities become possible when the infrastructure is no longer constrained by distance? So let's start with the scale-up network in the rack. As we discussed earlier, this is where we can connect the largest possible number of processors together in a full end-to-end configuration. In the past, the size of this domain was limited by the length of the copper connection, but with optics, distance doesn't matter. So now we can change the size of the scale-up domain from 72 or 144 XPUs or GPUs to 1,000 or more, all optically interconnected. The implications for workloads are enormous. Today, AI workloads must be broken down into smaller subproblems that fit within the scale-up cluster, because communicating outside the cluster today is slower, at much lower bandwidth. But optically interconnected systems can manage workloads on an order of magnitude larger. And it does not stop there, by the way. What happens when the optical connectivity comes inside the server itself? Modern AI servers are composed of a certain number of CPUs, XPUs, memory, and network interfaces. And the reason they're all in the same system is because of distance. CPUs and XPUs need to access memory at very, very high bandwidth, which means they need to sit right next to each other on the board, with copper traces serving as the connections between them. But in a future where these connections are all optical, distance actually doesn't matter. You can imagine a completely disaggregated architecture. XPUs in one system, memory in another, agentic CPUs in another, which unlocks another possibility. In today's systems, the ratio of CPU and XPU or GPU is fixed. So these ratios have to be defined at the time the system is built and deployed. But no two workloads require exactly the same ratio. Jensen talked about this actually, which means at any given time, some portion of the computer memory could be underutilized for a given workload. That costs money. But once we decompose the system into separate pools of compute memory, and they're all optically interconnected, we can then decompose dedicated systems on the fly, which are then optimized for whatever the workload is. So imagine future data centers, a globally optically interconnected data infrastructure. These rigid boundaries we have today in the systems we have, they begin to disappear. Compute can now be pooled. Memory can be pooled. And infrastructure can be composed dynamically at scale. For the first time, architects can begin designing AI systems around the needs of the model, not around the limits of the interconnect. So this is where AI infrastructure is headed. It's a data center without distance, where compute, memory, networking, and photonics operate as one unified system, where millions of resources across the data center can work together as if they were one machine. An architecture defined by the needs of the workload, not the limits of the connectivity. We believe this is the next era of computing infrastructure, and Marvell is helping build the connectivity foundation that will make all this possible. Thank you very much for your time today.
This was cool. So the Jensen got on stage and their different partners, and they discuss about the connectivity that they're doing, how they upgraded from copper to optical, and what they're doing now. Let's now go to NXP.
Good morning. Welcome back to Computex CEO keynote. As AI moves beyond the cloud and into the real world, technologies at the edge are becoming more important than ever. From automotive to industrial systems, from smart devices to intelligent infrastructure, NXP is helping bring AI into the real world. Today's speaker has spent 30 years shaping this industry, from Motorola and Intel to Broadcom, and now leading NXP as president and CEO. He is the architect of NXP's Edge AI strategy, and one of the most respected voices in the semiconductor world today. Ladies and gentlemen, please welcome Rafael Sotomayor. Welcome back, Rafael. Thank you, James. Thank you. Well, let's start. Eight days from today, the best footballers on the planet are going to get together, and they're going to play in this tournament that mesmerizes nations. You know, when their team plays, countries stop. Billions of people watching. Years of preparation. The players in the field are elite. So what makes them elite compared to the rest of the players?
It's not fitness, because they're all fit. And it's not knowledge of the game, because they know, all of them know the game. It's the mastering of the task. It's executing at the highest level, with the highest level of pressure. That is what elite looks like. So here in Computex, and I walk the halls, there are plenty of examples on physical AI. They're everywhere. So I pondered the following question. If we're going to bring all these intelligence systems and devices into our lives, what does elite look like for them? What is the equivalent of a world-class athlete for a machine? I'm going to need you to follow me here, because that's the question we're going to answer today. If you are a fan of football, you probably see Messi play. Now, if you're not a fan, watch Messi play and you become one. But he's very smooth. The way he handles the ball so effortlessly. When he was about to kick the ball, it seems that waits the last minute to whether he's going to go left, he's going to go right, depending on what the opposing goalie is doing. In that gap, that tiny infinitesimal gap between trigger and response, is probably one of the most sophisticated feats of intelligence in the planet. And yet, he doesn't think about it. His reflexes take over. We all know excellence is not about thinking harder. It's about mastering the task so deeply that thinking becomes unnecessary. Let me give you an example here with you. What's happening with you? And I see a lot of you here. What's happening with your body? Some of you guys are already adjusting your posture. You're fidgeting with your hands, your feet, and you're doing this without thinking. It turns out that most of our daily tasks, or 95% of the things that we do on a daily basis, we do it without any conscious thought, without any effort, with very little energy expenditure. I mean, think about that. That is brilliant. What we spend most of the day doing costs us very little. So, if reflexes dominate our daily life, then the reflexes are foundational for robotics, are foundational for physical AI. You see, that's the key. Reflexes are hard. And that brings us to Moravec's paradox. This concept, Moravec was the first one to highlight at the time something that seemed very counterintuitive. Why it's really, really hard for human beings, reasoning, solving complex problems, playing chess. Those are things that are really easy for machines. But what is easy for humans, like walking, like folding clothes, that's not so easy for machines. So, reflexes, not language, not reasoning, but reflexes are the hardest thing in robotics. So I want you to hold this notion of reflexes being difficult for a moment, because we're going to get back to it, because that's key to unlock the full potential of physical AI. Now, right now, it's fascinating times. I mean, it feels it. Here at Computex, all you guys are here. We're living through the fastest technology evolution ever. I know you feel it. Daily, I forget about daily, almost hourly, something amazing gets disclosed. Something amazing is happening and it gets released, whether it's new stuff in agentic AI, or new developments in software-defined vehicles, machines that speak any language and solve all sorts of complex problems. It's amazing. And a lot of that is coming from the innovation that is happening on AI in the cloud. But now AI is available and moving to the real world. And it's touching and transforming everything. And the real world is what we call at NXP the edge. And the edge, that's where we shine. The edge products is what we do. These are fit-for-purpose products. They have real-time performance needs. That they are low latency, low power, high level security, high level safety. Products that go into software-defined vehicles, smart factories, smart infrastructure. Those are our products. And so as we move intelligence from the cloud to the edge, what is so exciting is now all these devices get intelligence. You get to create use cases. You have the ability now to create devices that are making decisions. They're independent, maybe autonomous. But in order to reach full potential, we still need to solve the Moravec paradox. So now I'm going to talk to you about how NXP is very well positioned to provide a solution to it. So in order to get the clues of how to solve Moravec paradox, we need to start at a place that already solved the problem of reflexes, which is us. Now, if I were to ask you a question today, which the following question is, where does intelligence reside in the human body? I would guess that over 95% of you would tell me the human brain. And you will be partially correct, which means you're partially incorrect. So let's start with the greatest physical AI ever built, the human brain. And the cerebrum is the largest part, representing 80% of the mass of the brain. And this is where reasoning, conscious thinking, learning, decision-making, this is all works here. But this is not where the fastest responses get resolved. Let me tell you what happened to me this morning, and this is actually real. The NXP office is really a few blocks away from here. And listen, I'm a little jet lagged, and I was a little distracted, and I crossed the street, and I was this close of getting run over by a scooter. I mean, it was this close. And it woke me up. And I'm looking at this 300 milliseconds of response time by the cerebrum. That's an eternity. Okay? What happened to me this morning? I jumped like a cat. The cerebrum didn't help me at all this morning. Now, the good thing about it is that the cerebrum doesn't work alone. It has a companion. And so underneath the cerebrum, it sits the cerebellum. And think about the cerebellum as the coprocessor for motion, for motor control, for position, balance. It's still faster than cerebrum, but not fast enough. Not for me to avoid the scooter this morning, tell you that. So we gotta go a level deeper. So we get to the spinal cord. And this, life-saving reflexes don't originate in conscious thought. They don't even originate in the skull. They live in the spinal cord. I mean, you can see the stats here, right? 40 milliseconds, lightning fast. And this is nature's decision in design by choice. Because in this case, latency is more important than intelligence. This is what saved me this morning. So, the spinal cord processes, decides, and acts independently. Let me give you an example to make it more concrete, other than me trying to avoid the motorcycle this morning. And I know you will relate to this. You touch something hot. The stimulus reaches your hand and sends a signal to the spinal cord. The spinal cord gets a signal and says, whoop, and sends a message, a muscle command control that says to remove the hand. And now the hand is away and safe. Meanwhile, the brain is still processing. And then eventually touches up. And you realize, oh, that was hot. Ouch, that hurt. And now you can see the spinal cord allows us to act before we think. The spinal cord keeps us safe. Now, before I move on, I want to highlight another design principle. I want to highlight it. Nature, on its infinite wisdom, decided to put reflexes where the action is. Okay? So essentially, the spinal cord is a stack processing center that runs along your back, placing, sensing, and processing to the nearest possible point. Again, brilliant. Closer means faster. Faster means safer. And also means that it's the lowest possible energy use. I mean, what evolution is showing us here is billion years of optimization. So where are we? So we started with this conversation of biology looking for clues on how to solve Moravec's riddle. Okay, so what are the takeaways? The takeaway says that you don't scale intelligence by making the brain bigger and bigger. You scale intelligence by putting intelligence at the right place. And there are three fundamental requirements of intelligence in real life. You need to have ultra-low latency responses to actually be able to live in the real world. You have distributed control, so there's no single points of failure. And you have energy efficiency, extreme energy efficiency. So you actually manage strict budgets to be able to expand life. This is the playbook. This is the blueprint. So we contend that this is what is needed in physical AI. So we now take this principle and apply it to robotics. And this is what we call at NXP the neural axis architecture. Intelligence has three layers. The reasoning layer, the coordination layer, and the reflection layer. 3 layers. Independent, but highly coordinated. So now, let's see it in practice. We have 3 different form factors here. All of them in which NXP participates. 3 different implementations. So let's look at the first one, drones. Drones, you can see also, the neural axis maps very nicely here. You have the reasoning layer doing all the flight planning, path optimization, and then you have the cerebrum managing flight balance and performance. Both of them need to be operating independently, concurrently, and this is not a nice to have. Okay, this decision of having this independence is what makes this device trustworthy, safe. Now, the reflex layer, which is now these nodes at the outer edge, they're connected to more controls and actuation, and these are fast, reflexive. They don't wait, microseconds. So at NXP, we deliver this full system. All the KPIs, all the things that are needed to build a world-class drone. And see, to give you an example, we tracked a metric that we call glass-to-glass latency, which, think about it, camera captures, processes, transmits, the controller responds, then the drone reacts. All that loop, 20 milliseconds. Miss it, drift, instability, potentially even a crash. Hit it, you're in control. The drone feels alive, safe. This is NXP's implementation of the neural axis in the drone. Now, maybe this one we're a little bit more familiar since we have a lot of customers in automotive, but the self-driving vehicle is also a great example of the neural axis. You have the reasoning, obviously ADAS, navigation, what is the vehicle going to do next? Then you have coordination, which is this is a separate compute that manages vehicle dynamics, ensuring the car always has stable motion. And this is an area where NXP has created a leadership position with a central compute 5nm S32N family of processors. Processors and products that are like any on the market. Now, on the reflexive layers, we have the sonos, which are managing mission-critical functions of the vehicle, like braking, like suspension. This is another area where NXP has created a leadership position in the sono architectures with S32K family of products. Now, this separation, both logical and physically, of the 3 layers is what makes this car reliable. Because in a vehicle with lives at stake, you don't have margin for error. And the reason NXP has created a leadership position in SDV is because we created a leadership position in the neural axis for SDV. Now, humanoids, which is the most complex implementation of all. And I contend, because this is a nascent market, and you hear a lot of different topics and different conversations about the architecture of humanoid, but our belief is still very firm. If you're going to deploy, if this neural axis architecture is good enough for life, it's good enough for humanoids. Okay? I don't think it's a conversation. Now, let me maybe bring this alive with an example. Imagine a robot walking in a warehouse and is carrying a very valuable, very fragile package. Halfway down the hall, somebody drops a pallet, and he kind of brushes up the robot and kind of loses a bit of control. Now, think what happens now. The robot needs to recover balance, make sure that, confirms he's got still the package, adjust the grip, understand where he is in location, recover, and continue walking. And all that needs to happen within 40 milliseconds. No cloud call, no waiting for the model to respond. Okay, intelligence at the body, at the joints, at the hands, at the feet. They must own the moment. You see, the neural axis architecture is not a nice to have. That is existential. And so today, you see usually humanoids with a separation of the reasoning part, with the separation of the coordination, because robots continue to learn and continue to learn new use cases, but you don't want to disturb motion of the robot. Motion needs to be stable. And then instead of a spine, you have all these distributed controls at the end, at the nodes, and these processors own their function locally. They own it. Hands know how to grab, ankles know how to balance, not waiting, not asking for permission, acting, making sure the humanoid survives. So we just walked to three examples. 3 different form factors, 3 different levels of complexity, 1 system. 1 architecture, 1 blueprint. 3 layers of intelligence. So, what's the takeaway? Intelligence is not about a bigger brain. Stop thinking about a bigger brain. Think about a neural axis, 3 layers of intelligence. Okay? Now, we talked a lot about motion, but now I'm going to introduce you kind of a new wrinkle. Motion and movement is not the same as understanding. The fact that a robot is able to execute a perfect reflex doesn't mean they understand why. And I would say that not understanding why in a world as complex as the one we live in, that's not okay. So the question is, how do we teach a robot not only how to move, but how to understand? So let me go there next. We're not born, even though some of us may believe so, that we were born walking. We were not born knowing how to kick a ball or grab a glass of milk without spilling it. We learn slowly from mistakes. But this process of trial and error didn't only build a skill for us, it created a physical model of the world in our head. Okay, we learned the concept of gravity because we fall and it hurts. So we don't want to do that again. We learned the concept of heat because we touched something hot and we got burned. And so, but obviously the way we learn, that doesn't work for robots. You can't just let them in the wild and say, okay, go ahead and learn, come back. Right? We'll be not safe, probably reckless. So we have to take a different approach. Now, the one thing robots do very well, and I tell you, they see remarkably well. Let me use this example with my back here, with the robot looking at the cough syrup, probably looks and identifies the bottle, understands, that it's got liquid inside, probably reads the label. But does it understand what it's holding? Does it understand that the bottle is full? Does it understand if you tilt it a little too much, you are going to spill the liquid? If you don't understand inertia, it's really hard to estimate force. If you don't understand friction, you don't know how that syrup is going to pour. And without that understanding, the robot won't act in a safe manner. So you need a bridge between perception and understanding. Perception tells you what's in front of you. The understanding of the world tells you what is going to happen when you interact with that object in front of you. So we need a bridge. So the question here is, how do we teach robots physics? And so today, we do it ourselves. And I really mean it. Like individually, we do it ourselves. People teach the robots how to pick objects, how to move. They mimic, the robot adapts, learns. It works, but it has limitations. It's slow. It's very expensive. So this is where world models come in. The ability now to teach a robot to really estimate outcomes without going through the process of experience in it. It's like you literally inject knowledge into the robot. Think about the Matrix, right? Inject knowledge into the robot. So you think about it. You inject knowledge, you inject experience without having to go through the physical act of acquiring that experience. And this is a fascinating field. World models are feeding VLAs. And VLAs, I'm getting really, really, really techy here. VLAs stands for Vision Language Action Models. And it's the bridge between what the robot sees, what is told, and how it moves. This is the bridge between these 3 different layers. It creates the bridge that it needs to be able to see and perceive, to understand. And this is one of the most fascinating research areas right now in both academia and industry, VLAs. Now, VLAs are happening and they're getting better and better and better. And so the question right now is, okay, so how do we take these VLAs that were created in the cloud with essentially unlimited resources, and you move into the edge, because the edge is a constrained environment. It's a constrained environment with power, with latency, with memory, with processing. A VLA model in a research notebook, it's not very helpful for a robot in a warehouse. Right? So you need to bring those models into real processors at the edge. And so our answer to that challenge, to that problem, is right here, our toolkit, our EIQ toolkit. This is a software that allows to grab those models, imports them, quantize and prune them, compile it. Essentially, you grab the model and you tune it for the target hardware and for the target use case. Our goal is to remove objections from a customer. All these things are complex. So as we look at the challenges, we want to make sure that we remove objections. We remove friction for anything that prevents physical AI from being deployed. Now, where are we? We talked about the neural axis as the architecture, and we talked about VLAs as the understanding. All these 2 things come together and make the robot useful. But is that enough? Is useful enough? Because useful and trustworthy are not the same. And for physical AI to get really adopted in the market, trust needs to be solved. Now, trust for a human being, you earn it with time. You invest in your reputation and your rapport and your track record, months, years. You can't have a machine trying to develop rapport with an operator for a year. Okay? We don't have the time. So you can't design trust. You can't earn. The machine cannot earn trust. It has to be designed in from the beginning. The machine needs to be trustworthy from moment 0. So trust is important. Nobody likes to think that things are going to go wrong, but they go wrong. I mean, when I look at these pictures, and you could probably cringe when you look at them, I can't help myself to think about 2 laws. Murphy's Law and Finagle's Law. Murphy's Law, anything can go wrong, will go wrong. And anything can go wrong in Finagle's Law will go wrong at the wrong possible time. And that is the moment where trust gets defined. Trust doesn't get defined when everything is going great. Trust gets defined at the worst possible moment. So how we look at trust. Trust can actually be compromised through external issues, through external triggers, or through internal triggers. External triggers could be changes in the environment. It could be malicious people trying to attack the system. Internally, you have design flaws, model limitations, sometimes wear and tear kind of creates a different behavior in electronics. But these are important issues because as physical AI gets deployed, more and more mission-critical functions are going to rely on them. So dealing with this is massively important. Now, we at NXP don't come to physical AI from the cloud. We come from the edge. These are the things that we're already working on. This is part of what we do today. And now it's just, for us, it's more valuable. Some of the assets that we have in NXP to take care of trust are even more important with physical AI. So let me tell you how we, as a high level, discuss trust. Because we have a framework today that just right now is getting enhanced. And it's a very simple one at a high level. We contain. This means that we isolate the problem, we create redundancy, and we don't allow a single point of failure. We protect. We have hardware injected directly. Sorry, we have security injected directly into the hardware. We protect execution of the code. We protect tampering. We protect credentials. And guess what? We're also post-quantum crypto ready. Because the threats today are not the same as the threats 5 years from now. So this future-proofs our devices. The next primitive is verify. Some of the certifications that we have on SAIL and ASIL, this is not just paperwork. This is how trust gets measured. Our Safe Assure program allows a hospital or a car OEM to get the one thing that is really, really important for them. Assurances of how the device will behave when things don't go right. And obviously adapt. Nothing stays still in this market. Threats continue to evolve. Environments continue to evolve. So we need to evolve. We need to have the mechanism to constantly update these devices. But these devices at the edge, stay at the edge for a decade. So you need to make sure that these devices are constantly integral, secure for years and years to come. We take trust very, very seriously at NXP. Mistakes and errors in physical and at the edge, they're not digital, okay? You cannot do a software patch for a broken bone. You cannot do a system update to deal with a collision. And I know we cannot design systems where nothing goes wrong. I know that. But we can design systems where something goes wrong, still goes right. Trust is the core of our DNA. And the reason why is because we know this, because the real world has no undo button. Now we get to a part where I start kind of landing now what's happening with physical AI today. Because our job right now is not really to push physical AI before our customers are ready for it. Our job is to actually making sure physical AI has a place to be. There's a reason why physical AI gets adopted. The title here is earning the right to be useful. I get a lot of questions right now from customers who are trying to adopt AI. And one of the questions I get often is, hey, Rafael, how smart can physical AI become? And I just ponder on that question because I don't think it's the right question. I think the right question is, where can physical AI be deployed today that it can be done in a safely secure manner where they create value? And I think the answer to that question is unraveling right now. Let me give you some examples. In factory automation, even today, in factories where physical AI-enabled robots are being deployed, already having 40% productivity enhancements over regular automation. Regular automation is pretty high already. This is on top of the 40%. And obviously, we don't work alone. We work with our customers. We're very proud of working with one of our customers here. I'm showing you Boston Dynamics, where we combine our hardware and software with the phenomenal robotics platform they have to make sure that robots and humans can cooperate in a productive manner in the factory floor. Now, healthcare, and this is where safety and precision are super important. They define outcomes. Already in 2025, diagnostics and lab robots increase sales by 610%. This is not a trend. This is a signal that the healthcare says physical AI, if deployed responsibly, will save lives. And we're doing very proud of the engagement that we have with GE Healthcare, where they're actually deploying intelligent systems and anesthesia, where precision and safety really, really makes a difference. And their products, NXP is at the core of it. So now this is the time that I always do when I come to Taiwan, because it's truly amazing, the ecosystem in Taiwan. Because we know we can't do this alone. NXP, without our customer and our partners, we're too small. The reason NXP punches above our weight is because of you. We can't do this on innovation alone. We do it with collaboration, with co-creation, and delivering the market. The people here in this list are not just customers and partners, are the lifeblood what makes physical AI deployment into the market and makes it a reality. So for the companies who are here, and the companies in this list, thank you, because we do this together. So I started with Messi, and I'm gonna end up there too. You know what makes this player so amazing and so elite, and this body does these incredible things, it's not the things that you see. It's all the things that you don't see. Put aside, right, it's an incredible commitment to his craft, but all the things that you see. The invisible architecture in his body that we call the neural axis, which is the same for physical AI robotics, just engineered by men. We start with a question, what is elite for a machine? What is elite for a machine? I think we answered that question. Elite for a machine is a machine that executes reliably in high performance in the real world, under real conditions, and when things go wrong, this machine keeps assets and people safe. Machines and systems, these elite systems have three non-negotiables: low latency, low power, and high level of trust. Remember, you don't scale physical AI with intelligence alone. You scale it by placing intelligence at the right place, using the neural axis as a backbone. So for the push of physical AI into the market, we at NXP, we're ready. Thank you.
Yeah, so Raphael explored the physics AI, compared it with Messi's to the balancing of reasoning, coordination, and rapid response reflexes. and that was called good too. Cerebellum, and spinal cord, and how it interacts with your day-to-day, everyday reactions and actions, be it on the pitch or on your daily life. So that was good. And yeah, I think so. They will be doing great in the next years. I think so. I will take a look at the Supermicro next. Then we will take a look at Microsoft Build, because Supermicro is very much kind of in the data center portfolio, and they kind of are involved in making many of the components, including their most important memory. So let's go.
Engineering ingenuity has driven us to the cutting edge of a new industrial age, and AI infrastructure is accelerating the race with unprecedented speed. The pace isn't just increasing, it's compounding. The scale has changed, the complexity has multiplied, and the innovation isn't slowing down. To move at this speed, everything must be dialed. Not only bigger systems, but smarter ones, modular by design. A new approach to infrastructure, flexible where it matters, precise where it counts, built to scale from the start. This isn't a collection of systems, it's a single machine, one continuous system moving at full throttle. And this isn't just theory. This is deployed and proven with clear momentum and a first-to-market track record. Performance isn't added later, it's engineered into every phase, from the ground up. Superscale, micro-focus. Every design optimized, every component built for speed. When every layer is connected, when every system is dialed, when everything is built to accelerate as one. Acceleration isn't a feature, it's the foundation. Supermicro, built to accelerate. Ladies and gentlemen, introducing Chairman, President, and CEO, Charles Liang.
Thank you. Thank you. Thank you. Welcome everyone to our Innovate and Compute Text. I'm very happy to see you all, especially here in Taipei, to our partners, our customers, and all our press friends from over the world. Thank you all for joining us today. The AI revolution has only just begun. Every day, we see many new AI applications and new adoptions to improve almost every aspect of our work and our lives. Aggressive partners are coming to Supermicro, and they all are asking us for help to develop systems and solutions that can accelerate their LLM, NeoCloud, enterprise AI, sovereign AI, or other AI applications. As the AI revolution continues to grow everywhere, for every application, and looks never ending, I'm super excited to share our latest experience, our new innovations, and our total solution with you. Most importantly, I want to invite you to grow at our speed, at our pace, or even much faster. You know, in this incredible AI era, most people are racing as fast as system and your data center. 6 months ahead, I'm going to show you how can we work together to achieve that.
Not too interesting. They're just going through the data centers and marketing solutions.
System level building block solution configuration, which
how will they ship it?
many kinds data center flow have a L to A, liquid to air, like 250 kW, 500 kW, and then you can run your DLC rack in
TCB, BS subsystems, rack cooler, Helios, racks, coolants, battery energy storage systems, water coolants, dry coolers.
additional data center right over 1,000 times higher electrical impedance. The system will be shut down. Those support all of those director. We know hardware delivery and software support.
I thought
full strength.
This was the company that made memory
Yep.
and things.
Truly efficient. We have to optimize our architectures all the way down to the silicon level. Supermicro is deeply
discussing about that
committed to the silicon to system synergy, and we work closely with the world's leading chip architects to enable maximum density and green computing efficiency.
to talk about this next wave of for system level, for rack level.
Yeah. And then maybe
Coming.
bottleneck, that is the agents can't silicon for what AGI can deliver to us. But it also
To that next level of power efficiency.
Yeah, and I've told you and I've told Charles multiple bring to bear. And I think that combination
already. So and also data center, let's bring it back to with all those
Let's get to Microsoft.
Right. Good morning. Morning. It's fantastic to be back in San Francisco at Build. It's always fun to be at developer conferences at times of great change. Developer conferences are always about understanding tech shifts, understanding the new stack, but it's also about really coming to grips with the new opportunity, right? For us as developers, for the companies that we work at, as well as the broader world. So today we're going to unpack this. This conference is all about that. And if there's one key takeaway, it would be this: how do you all participate fully in this frontier intelligence ecosystem? Right? It's not about any one piece of technology that you'll hear about or even the platform itself. It's about the value that you can build, you can compound, you can create on top of the platform. That's what a developer conference needs to be about, and that's what we will focus on. So let's kind of get into it. Let's take a look at this AI stack that this conference is going to unpack in a great amount of detail. It starts, of course, with the compute fabric, right? That ubiquitous compute fabric that spans the edge and the cloud. You then have this layer, which is the emerging layer, where you have the models, you have context, you have the tools the models can access. And then on top of that, you have the runtime, where you deploy your agents and applications that you built on top of the context layer, on top of the model layer. And then, of course, you have the best tooling to do all of this. And then you have the security, the compliance, and the governance, right? That's the simplest form of the tech stack. But let's kind of start where it always starts, which is infrastructure. And in fact, let's start at the edge with Windows. Because when you step back, the amount of compute there is at the edge is actually astounding, right? I mean, think about every NPU, GPU, CPU even, every PC. If you sort of aggregate that, that's a lot of compute power. So we ask ourselves one simple question, right? If we can deliver unmetered intelligence to every desk and every home, right? It takes us all the way back to the very beginning, but that's what we said. Can we do that in this era of AI? And in fact, we're in some sense delivering that already today. Right? When you look at something like, say, Outlook Summarize, it's actually using onboard AI locally. Same thing with PowerPoint Alt Text or Teams Super Resolution. It's just not Microsoft stuff. For example, Adobe After Effects or Premiere are both using Windows ML across NPUs and GPUs for local processing. And so today, one of the things that I'm really excited about in order to tap into all this compute power is to expand the scope of Windows ML and Windows AI, right? So you now have the full install base of GPUs that you can get to. So I'm really thrilled that every developer out there can count on building for local onboard AI and then have it run across all of the install base. Now, we're also announcing two very cool new models that are all going to run on Windows Inbox. The first is a new SLM, sort of a more efficient model, Ion Instruct, and it's a great reasoning model. And then we have the planning model, Ion Plan, which is a local agentic loop. I mean, think about it, right? You now have a full local agentic loop. You can give it tools access and build a fully onboard agentic applications without having to round trip to the cloud. And of course, we said in order to really push the limits, realize this unmetered intelligence, there's also a lot of hardware that's evolving too. And so we're thrilled to see the innovation across the Windows ecosystem, right? It's AMD with their Ryzen processors, the Panther Lake stuff from Intel is just exciting to see. Qualcomm announced two sets of things which are great. One on the high end with Snapdragon X2 Elite, and then on the low end, even for sub 500 PCs with Snapdragon C. So it's great to see all of this. And of course, that brings us to NVIDIA and RTX Spark. This is a next generation SoC for PCs. It brings together the CPU, the GPU, as well as the AI capabilities into a single SoC. And that's the exciting part. And it includes unified memory architecture and also the integrated DRTM, right? So you now have all of the systems innovation and the SoC coming together. And we're really thrilled that one of the first devices that we built was the Surface Ultra, right? It's a beautiful device, and it really brings the power of NVIDIA together with the design and the craftsmanship of Surface. It's 128 gigabytes of unified memory. It's a beautiful 2,000 nit display, and it has an all-day battery life. And so we're very excited to see this later this fall. And it's also wonderful to see all the designs from all the OEM partners who are building, taking advantage of this new SoC and the new platform, and bringing out some pretty exciting machines that's going to be all available come this fall. And so, of course, we said, okay, this is fantastic. What can we do next? So we said, let's try and push this and push the architecture to its limit for developers, right? What if we could just max the compute, max the memory, build out that developer machine that's the dream machine? And that's what we're announcing today. Surface, RTX Spark, DevBox. Let's roll the video.
I was born to you, like water to the moon. You swell that I use only when you want to. Cause I'm funny, but I loved you still. I'm a wonder. Did you really ever love me? I'm the only man. I'm good, nothing I'm good. What do you think about me? Think about me. Think about me. What do you think about me? Everything's in bloom.
All right. Yeah, it's truly a dream machine. It's got 1 petaflop of AI compute, 20 CPU cores. All of those things have 128 gigabytes of unified memory access. So super excited about this coming in the fall, and you can join the waitlist. I'm on the waitlist as well, so we'll get there. So then we said, why stop there? We said, what if we did one more thing?
Let's subscribe to this. So I will keep pushing code and develop, and I will keep developing, and I think some of the companies should be able to reach out to me to offer me their machines to test it out, so that I can put them through their paces and make it go burr.
Thing. And in fact, I think Jensen did that already when he said Windows is coming to the DGX station. So a new, I describe it as the desktop data center, which you can have right there and running a 1 trillion parameter model locally. I mean, just to sort of put it in perspective, it's pretty close to what perhaps we had when we built GPT-2.5 or 3, right? When it was one of the first supercomputers. So it's pretty crazy to think that we've come this far where you can now have a data center on your desktop. And of course, we're extending the developer endpoints even to the cloud. Windows 365 now has the developer distribution that's optimized for developer productivity in the cloud. So that's the Windows 365 that I use every day. And it's simply about making Windows, whether it's on the laptop, the desktop, the cloud, wherever, the best place to build. And so to that end, we have tons and tons of updates, right? We're starting, by the way, with one of the favorite things for all of us, which is distraction-free dev environment. We're also introducing an intelligent terminal, which has got built-in GitHub Copilot, right? Terminal with sort of the Copilot intelligence. And of course, there's lots and lots of Linux love across Windows now. So you have 70 plus utilities. So grep in full glory is now available for regular Windows access. 70 plus utilities, as I said, all of that is coming to Windows. We're also bringing things from the Mac that you love, things like Starship, Z Shell, Homebrew is going to be native on Windows as well. So you'll be able to switch to Windows. And today, we're announcing WSL containers. This is, I know, been a point of pain where you're managing all these environments, switching all the mental gymnastics of trying to keep this straight. So having first-class support for containers will really help us be in the flow when you are building and deploying locally. And to show you all of this on our new...
Yeah, WSL containers will be a huge help in my workflows.
New Surface RTX Spark, I wanted to invite up on stage Kayla to just take a spin through all the dev tools. Kayla, go ahead.
Our team has been working hard to make Windows a great place for development. And today I'm going to show you some major improvements and delighters you can try out today. So what we have here is the default experience on the Surface RTX Spark dev box. Right away, it feels calm. There's no newsfeed, no widgets popping up, no notifications, and of course, we're in dark mode. I'm immediately ready to start development. Well, there's one thing I'd like to change. I like to put my taskbar on the left, so let me jump into my taskbar settings using the new run, which is built leveraging the architecture of PowerToys command palette. No, I want it all the way on the left. There we go. After popular demand, we're excited to announce that vertical taskbar is now available in Windows Insider builds. The new Surface RTX Spark also has a bunch of key dev tools already installed, like Python, Node, and many more of your favorites. All the developer goodness all in one file. And if you want to get the same experience today on your device, we're making this file available to everyone right now. We have a public repo set up with a configuration file and instructions for how to apply it using winget configure, which will make the adjustments to Windows and install all the tools. Now, one cool thing that I have running here is PowerToys' new utility called Grab and Move, which lets you hold Alt and move the window around from anywhere. Another tip is that you can enable end task, which lets you end process without having to open Task Manager. So let me jump into my dev drive. Dev drives run on REFS with Defender running an async and are optimized for performance when it comes to development scenarios. Also, File Explorer is Git aware. We got stuff like last change author name, last change message, the status of each file, plus my favorite is that the branch name is on the bottom left. So now let's get started building and open our terminal. This is an experimental experience called Intelligent Terminal that makes working with agents even more seamless. When you first install Intelligent Terminal, you're greeted with the option to pick your favorite agent. I'm going to use GitHub Copilot for today, but you can use whichever agent speaks to you. Now here in Intelligent Terminal, I have a regular terminal pane at the top and an agent that's listening on the bottom, and I can work between them while the agent helps along the way. So for example, here's an error being generated. My agent pane is able to detect it and provide a fix, which is great when I don't remember the syntax, especially for something like regex. So I'm going to work on OpenClaw, and I've already built it using WSL Container. WSL Container is a native container experience on Windows, plus it can leverage the GPU, which is perfect for the Surface RTX Spark. It can also reference your existing container files, just like the one in the OpenClaw project. So here's one of the files open in Microsoft Edit, which ships in Windows by default and just got syntax highlighting in its latest version. And then you can also just see your containers running with a simple container images command. And since we're on the topic of WSL, we're providing a WSL profile that's designed to feel comfortable for those of you who use tools like Starship, ZSH, and Homebrew. So it comes pre-configured with all of your favorite utilities, and it's available in the repo that I showed earlier, and it also includes one of my favorites, BTOP. So the Surface RTX Spark is designed for developer-heavy workloads, including serving large local models for coding. I've already done some development with a 120 billion parameter model that most machines can't even load. So here's a quick view of my usage, and we can see how many tokens I've used locally. So we're looking at about 3.4 million tokens leveraged on the device itself. Now, we can kick off multiple sub-agents using Fleet, and just so we don't have to watch me type, I'm going to use Copilot's voice feature, which is also leveraging its own local model. So I'll just hold spacebar and tell it what I want it to do. Find any console.writeline or debug.writeline calls in the Tray and Node projects and convert them to the standard logger used elsewhere in the codebase. There we go. Now the main agent will delegate sub-agent tasks of appropriate complexity to the local model, utilizing my GPU and making it more cost efficient. Now, as developers, while we're debugging, we're often looking through log files to diagnose any issues. Sometimes finding the location of the log files is a challenge. I'd love to be able to just type something like grep log and find them all. Ah, sweet. So on top of already adding curl, tar, and sudo to Windows, now we're adding over 75 command line utilities like env, head, tail, and touch for those of us who love to live in the terminal. So I found all my log files, but now having to parse them is the second challenge. Well, I've actually had Ion Instruct proactively performing analyses on my log files this whole time. Now I can quickly diagnose anything that's gone wrong in my development, plus I don't have to worry about token usage because it's all local.
We can even take a look at our machine's resources. The models are loaded, and you can see 90 gigs of RAM being utilized by the GPU, truly showcasing the full power of the Surface RTX Spark. We were able to use 3 local models simultaneously, unmetered, while going about our regular dev flow without a hitch. That's huge. So I know you're going to love what the team's been working on. We hope it gives you a glimpse of what's possible on Windows today and where we're headed next. Thank you. Back to you, Satya.
Yeah, that's really the beginning of this idea of unmetered intelligence, having those models and having the agents using the models work in parallel to what you may be doing along with the cloud as well. And that, I think, is what the platform enables as first class. Now let's move to the cloud. The driving equation for us remains the same, which is tokens per dollar per watt. How do we optimize around this, right? So when you think about the systems problem, we think about electrons coming on one end and tokens on the other end. And how do we think about the systems optimization end to end? It starts with the data center design itself, right? The core compute, storage, network, all the accelerators that go into accelerating each of those components. How do you even think about the DC to DC connectivity and the networking, as well as the offload to something like the local compute, right? That's the sort of systems challenge. But before we even get into all of the systems and the technology and the innovation, perhaps the most important design criteria for us is how do we earn the permission from the communities in which we're building these data centers? And that's where these principles ground us and focus us. How do we ensure that the DCs do not increase the electricity prices? Making sure that we're replenishing all our water use, creating jobs in the local communities for the local residents, adding to the tax base, making sure we're strengthening the communities by investing in local training and the nonprofits in the area. Only when we live up to these principles, do the hard work around it, is when we earn the permission to go ahead and innovate and build. And we've been doing a lot of data center build out. Today, Azure spans more than 500 data centers in 80 regions. It's the most expansive, we have the most expansive hyperscaler footprint out there. And we've added more data center capacity in the last 18 months than the first decade of Azure, just to put that in perspective. But more importantly, what we are building is also very different. In fact, the first 15 years or so, we built out the commercial cloud infrastructure for a set of heterogeneous workloads that spanned the enterprise. But now when you look at what we're building, right, when you think about all the gigawatts that we're going to come online, really they have 3 dominant workloads. There is training, there's inference, and then there is the agent runtime. Right? These are 3 dominant workloads. And in fact, when you look at Fairwater, it was sort of our first AI super factory. It spanned 2 regions, Georgia and Wisconsin. The entire system was designed from the ground up for AI. Right? We worked, in fact, very closely with even NVIDIA on this. And it's a 2-story architecture that lets us essentially place racks, obviously in 3 dimensions, and pack the maximum number of GPUs densely with network access. That means you really got fantastic higher performance networking, lower latency, and more effective bandwidth across the entire cluster. And we're rethinking even the power delivery, right? So we started, okay, how do we deliver hundreds of kilowatts per row while minimizing all the loss, right? Which is the conversion loss that happens from the grid to the silicon. So we basically sort of even took a new approach to it. And all of this also changes with the cooling system, right? And water. So in fact, the cooling loop is filled once and the data center can operate effectively with 0 water consumption. In fact, the daily water usage over the course of an entire year is roughly equivalent to what a single restaurant would use, right? I mean, that's... And when it comes to the systems and the silicon, again, we have a lot of choice. We have first-party silicon, we have partner systems. We were the very first cloud to bring up, in fact, NVIDIA's Vera Rubin system for validation. Very exciting to see that. We're working closely with AMD. We worked with them on MI300. Now we're working with them on their next generation AMD GPUs. Maya 200 is continuing to scale. In fact, it's live in Iowa and Arizona. We'll deploy it internationally later this year. It delivers 30% improved tokens per dollar compared to sort of what's the leading GPU today. And we have validated it with 5.5, GPT-5.5, and we're going to use that to power Microsoft 365 Copilot. And so when it comes to running these agents, the interesting thing now is it's no longer just about having an AI accelerator or a GPU. The CPU is really critical. In fact, the ratios may be even coming to 1:1. And that's why we're innovating with Cobalt. We're announcing the preview of Cobalt 200 VMs, our next generation ARM-based CPU designed for both cloud native and agent workloads today. So it's exciting to see Cobalt make progress as well. One thing that we've been trying to make sure is that it's being optimized for these new workloads I talked about, right? These new agent workloads. So in fact, Cobalt delivers 50+% better performance than Cobalt 100 on cloud native. But we started benchmarking them using the GitHub Copilot traces, these agentic traces, to see because the call patterns are so different. And we're now seeing 33% lower latency for the agent calls, 14% faster speed, 23% higher throughput. So this is about the co-design of both the AI accelerator and the CPU for the agent. And of course, when you talk about AI workloads, you need scale, you need reliability, and that's why the network becomes super critical. We have innovated with the MRC architecture and rebuilt how traffic across Azure moves to support AI workloads, which are fundamentally synchronous data parallel workloads, right? And so therefore they span tens and thousands of GPUs. And so you need to have them coherent. That's what the next frontier is for us to make sure we're able to keep scaling the network architecture. And of course, it's not about just inside the data center, it's also about connecting across the data centers. And every Fairwater data center, for example, is connected through our continent-spanning AI WAN, forming this truly fungible compute fabric. And all this innovation is exciting, but when you think about innovation, designing for AI, and I would say deep understanding of systems, there's no better company than NVIDIA, and there's no better person than Jensen to talk about it. So I want to invite, live from Taipei, Jensen Huang, CEO and founder of NVIDIA. Jensen, thank you so much for being at Build again. I know it's late for you in Taipei. I really appreciate you staying up. I've been looking at social and everything people have been talking about since your keynote over the weekend. And suddenly, this concept of unmetered intelligence right at the edge is so hot again. So maybe you want to talk a little bit. You thought about this, talked about this, and now of course with RTX Spark really delivered, I think, what's a breakthrough system for AI to be much more ubiquitous. But maybe Jensen, you can just share a little bit your vision around where you see this going.
Well, this all started about 3 years ago between a conversation between you and I. And we were talking about how we could build a new class of PCs that's incredible for designers and creators, and it would be incredible for artificial intelligence, and it would be one of these systems that has the processing capability, but also the software stack that's integrated into the world's design packages and creator packages, and of course all the things that we're doing with AI. And here we are, 3 years later, we built an incredible new chip, and this system is supported by all of this new software that we created for Windows, and we now have the ability to have essentially an autonomous agent running on the PC. Now, when you take a step back and you think about what does that mean? For 40 years, or some 30 years we've been working together, we went from inventing DirectX together to creating now this incredible computer that has autonomous systems running. The PC evolved from being an incredible tool to now being a tool that's used autonomously by an AI assistant. And so the idea that I could be traveling and I'm on a phone and I could text my PC and ask my PC to get some coding done or some idea that I have, and it would fire up the tools on the PC. And it would make the modifications or the changes or the design that I told it to do, and it would iterate with me while I'm away from the PC. My PC became an assistant. Well, I'm saying that, of course, that this PC would be my great assistant as well. And so this idea that the PC evolved from a personal computer to a personal AI is just really exciting. And to see it come to life, Satya, to see it come to life and actually doing that, so I'm super excited about it. Spark, you mentioned earlier, has all these incredible capabilities, a petaflop of AI performance. It has a petaflop of NVFP4, this numerical format that our two companies worked on together that allows us to take advantage of this 128 gigabytes of memory and fit maybe a couple of 100 billion parameter model. A couple of 100 billion parameter model is state of the art. And so I think the days of having a really smart assistant running autonomously on the PC is here.
Yeah, no, it's so awesome. And in fact, I'm also excited about Windows coming to GB300. And so that's another thing, that it's kind of the data center right off your desktop, and it's so exciting. But talking about that data center side, obviously, this entire thing got started when we built the first supercomputer together to train the GPT models, and we've come a long way. In fact, even I was talking about the Fairwater design. It was custom built essentially for the Grace Blackwell era to be able to max the data center design with the system design you had. And now, of course, we're validating Vera Rubin. We're very excited about it. Maybe you want to share a little bit about sort of what happens even on the cloud side with how you're pushing on the systems innovation.
Well, our journey is incredible. We built the first AI supercomputer together. That was based on Ampere. Of course, Hopper was an incredible success. Those first 2 generations were focused on pre-training. Grace Blackwell came along, and all of the folks moved to post-training, reinforcement learning, which allowed us to have reasoning models. And these reasoning models, based on mixture of experts, were incredibly intelligent, energy efficient, but it requires giant systems. And so we created NVLink 72, and the entire rack became one computer. We had evolved from one node to now one rack. Well, Microsoft deployed the largest number of Grace Blackwells in the world today. The fastest and the largest number of Grace Blackwells in the world. Fairwater is just a magnificent system to look at. It's just a miracle of engineering. It's just an incredible feat. It's completely liquid cooled. You mentioned something earlier that I'm very proud of as well, that it's closed looped, basically uses almost no water, and it's incredibly environmentally friendly. It's energy efficient. We're able to increase the token generation rate and reduce the cost of token generation by an order of magnitude, some 30 times over Hopper. So that was a huge achievement. Well, Vera Rubin was created for a world where these AIs are now agentic. And so whereas Hopper was created for pre-training, Grace Blackwell for training, post-training, and also inference, Vera Rubin is designed to run agents. It's agents, as you know, this computing pattern is exactly the same computing pattern we're going to run on the RTX Spark. It's exactly the same agentic system, except of course it's going to be much, much larger when process an enormous number of them simultaneously. Many of them are going to be from different customers and different partners. And so the entire path, the entire coding path from storage, which is the long-term memory, the working memory, is encrypted. The data is encrypted in transit. The data is also encrypted in use. And so we're going to really innovate in the area of confidential computing. And so this entire disaggregated distributed computing system, you mentioned CPUs. Vera is a revolutionary CPU designed for agents. The past CPUs were designed for humans. And we're just more patient than agents are. And agents want low latency, just as you've been working on as well. Vera was designed for extremely low latency. And so Vera Rubin is just completely revolutionary. I can't wait to show it to everybody. You've already stood it up. Yep. Our two teams have been working very closely. Almost long before the chips taped out, long before the systems were brought up, our two teams were already completely aligned. And so the data centers were created for Vera Rubin. Vera Rubin is designed and integrated into your complete stack, into your networking, into your security. And so the moment that our systems were rolling off the lines, they were being stood up at Microsoft. So I'm incredibly excited about collaboration.
Yeah, no, this speed of light execution between the teams is fantastic to see. And of course, all this is to power the ecosystem around us, right? I mean, you and I, having grown up with the PC, the server, and now with AI, have always thought about ultimately about creating the opportunity for every developer, every organization to build on the work that we do and the platforms we create. And speaking of that, there's a lot of software that NVIDIA builds that's also coming. For example, we're going to have your models in Foundry, your tooling in Foundry. We're going to have, in fact, your software even help us with accelerating our workloads when it comes to even the data warehouse. We're going to obviously have stuff in Windows. Just talk a little bit about that broader vision of what does it mean for as an opportunity, right? Because everybody talks about this one model, one piece of tech, but it's about the broadest, biggest opportunity for people to create value. Maybe you want to share a little bit about that.
Well, we've been prepared for this moment. What happened in the last several months? We've been working for a decade and a half together, getting ready for really what happened in the last several months. All of a sudden, because of agentic systems, the convergence of these really great models, AI is now useful. If you just look at GitHub, the commits into GitHub is completely parabolic. In the last several months, the number of commits increased by a factor of 3. It's clear that agentic systems are useful, that it's doing productive work, and also tokens are now profitable as a result. And so the amount of demand for compute between the usage of the AI and the computation that's necessary for agents, the compute demand has really gone through the roof. Well, one of the things that we've been doing together is making sure that all the tools that agents are going to use are fully accelerated. Fabric, for example, is now fully accelerated. We're accelerating data processing, SQL, Spark, semantic-based, vector-based, graph-based. We're going to make sure that all the tools that are available on Azure are going to be fully GPU accelerated because the agents are going to be impatient. The faster we can get the answers back to the agents, the faster they can iterate, the faster we can generate tokens, which are ultimately what the developers, both our customers would like to do, is generate a lot of tokens that are really profitable, that are highly intelligent.
Thank you so much, Jensen, for the partnership and the leadership and the innovation that you bring to this entire ecosystem, and really thrilled to be working closely with you and the team and bring all this to developers here and beyond, and look forward to seeing what the next sort of few months and the next year bring in terms of the innovation that gets built on top of the platform. So thank you again for joining this late in the night from Taipei.
Thank you so much, Satya, for your partnership. Thank you.
So far, we've talked about the edge and the cloud. The current form factors, right? I mean, when I saw that Jensen picture from the weekend where he had all the desktops, I felt like, man, I'm back in the 90s, right? Because it was so cool to see the lineup of all the machines that I loved and I grew up with back yet again with new functionality, right? The same form factor, but unbelievable new functionality because of the onboard AI capability, right? So that's sort of what we've seen with the laptop, the desktop, and of course with the cloud. But it also sets up that next question. If you have that capability, which is new function, and you can put it into existing form factors, can you even purpose build new form factors for the new function? Can you build a new platform even for the agent era? And that is the motivation behind Project Solara, which we're introducing today. And to talk about this, I want to invite Stevie on stage, but first let's roll the video.
First, there's you. Then, everything in front of you. We get it. The noise, the weight of it. So we've been building something. A new chip-to-cloud platform for an agent-first world and for new agent-first devices. You come close, it's ready when you are. You speak, it understands you. What matters comes forward. Everything else falls away. And when you want it to keep going, it keeps going. Your call. Sometimes it sits with you. Sometimes it goes with you. Sometimes it sees what you want it to see. It doesn't decide for you. It just lights the path. tries to clear the way when you need it to. And that's the idea. A whole ecosystem built to clear the way. So all that's left is where you need to go, wherever you are, whenever it matters.
I am so excited to be here. It really is great to be back on this stage. Now, before I talk about those awesome new devices you just saw, let me start with the why. Back at Build 2023, I talked about the outside AI application structure, where AI moves from operating within the application frame to operating globally, working across multiple apps and services to connect, coordinate, and maintain context across entire workflows, devices, and timescales. What if there were an ecosystem of devices specifically designed for that new type of application structure, for those types of agents, for that transformational interaction technology? That is the impetus behind Project Solera. But with so many possible forms, which one do you pick? What is the next device? You see, the big aha for us is that it's not about choosing one specific form factor. It is about creating a system that extends your agent across a constellation of devices. The next frontier is not one device. It is all these devices working together as one system, with agents showing up closer to where and when you need them. To realize this vision, two challenges immediately show up. First, many specialized form factors already exist, but often rely on custom one-off apps and fragmented stacks that are difficult and expensive to build, deploy, and maintain. And second, across every industry, people and organizations are already building their own agents, deeply specialized and instrumented for their work, but the impact of those agents is constrained by how and where they can exist. Project Solera addresses both by giving organizations a way to extend their agents onto new, purpose-built, easy-to-manage form factors designed to reach the nooks and crannies where conventional computers either do not exist or are not optimal. It's a turnkey solution for building unique agent-first devices enabled by three pillars. First, it's enterprise-ready, enabled by the AOSP-based Microsoft Device Ecosystem Platform. Second, it has an agent-driven interaction model with just-in-time UI that adapts to the form factor. And third, it has extensibility so you can bring your own agents. And tying it all together is Azure, unifying the system across cloud and device. Okay, that's enough of that. Now let's talk about the devices. Today we're previewing two very broad categories. The first is stationary and the second is portable. The first device is designed for your desk and it's built on MediaTek silicon. With Hello for Business, just walking up to the device securely signs you in, giving you direct access to your agents, just like Nathan's about to show you here. For the information worker, this means frictionless yet protected access to Microsoft 365 Copilot grounded in WorkIQ. And with a simple glance, it serves as what matters next in your workday, helping you think, plan, and even act by delegating tasks to your agents with a simple tap or just using your voice. Think of it as a dedicated, secure agent device for work. It even supports experiences like handoff between devices, acting as a companion to your existing Windows PC. Or it can even let you access your cloud PC through Windows 365 and a connected monitor. How cool is that? Now, the second device is portable. It's reimagining a wearable that millions of people use every day, the Access Badge. Built using Qualcomm silicon for wearable, this digital badge is a lightweight form factor designed for agent interactions on the go. And then it's adaptable across a variety of verticals and workflows. All right, I have here an early prototype of the badge. And using my fingerprint, I tap to unlock the device, and I have access now to all my agents in a secure manner. And would you look at that, I already have a task. And it says, gather content for your social media post for today. So why not just do it right now, right? So I'm going to hit record, and then now the device's camera is recording. I'm going to pan across. I hope you don't mind me taking shots. Yes, thank you. Copilot, find some good shots from this, clean them up, and then send them to me for me and my team to review. All right. And then there you have it. Now my agent's off, running through multiple tasks to actually clean this up and send it to me and the team. That's pretty cool. Okay, I know it's a simple demo, but it's all agent-driven, and there are so many verticals, so many opportunities. I mean, for example, imagine in healthcare, from the moment you pick up the device, the right agent shapes the experience around the role and the workflow, helping with check-ins, patient records, and critical insights, all through enterprise-grade secure access. And with the built-in microphones, the nurse can start a hands-free voice-based documentation, including diarization and annotation. And the side-facing camera can be used to verify documentation vitals, or even scanning medications and help verify workflows. You know, these are just a few examples of how this small, purpose-built wearable can bring intelligence directly in the flow of patient care, helping nurses access and gather and even act on information while staying present with the patient. And while both the stationary and portable concept devices represent a specific expression of agent-first devices, their core hardware and software are designed to be highly flexible. I mean, just with a few changes, loading a different agent, adjusting the shape, the screen size, the sensors, or even input methods, the same foundation, the same software can be adapted for many verticals and workflows, such as retail, industrial, hospitality, financial service, legal, and so forth. I mean, that is the power of the platform, that flexibility. So whatever your scenario, there are thousands of untapped opportunities to bring agent workflows into places where computing has not naturally fit before. And while this is an early look, we're really excited that AccuWeather, Best Buy, CVS Health, Levi's, Target, and others are working towards exploring how specialized agents and devices can improve their workflows. This is the broader opportunity for the ecosystem. Agents moving outside the app and taking shape in devices designed for a specific scenario, a specific customer, and a specific place. And for all of you, this is the moment to imagine where your agents should live, what form they should take, and what new work they can unlock. Last week, Satya sat down with Cristiano Iman from Qualcomm to discuss his future. Let's roll the video.
Cristiano, it's so wonderful having you here at Device Lab and to talk about these new reference designs.
Very happy to be here. I have been to this Device Lab a lot recently.
You know, one of the things that you and I have chatted for a while is how there's a real platform shift. We're moving from building operating systems, devices for apps to agents. You want to talk a little bit about how you see this?
Yeah, absolutely. Every generation of technology transition we've seen a shift. And I think this one seems to be a very big one. Agents really changes the whole nature of the device in itself. Starting with the fact that, you know, if AI understands the world the way we understand it, it's going to be closer to our senses. It's going to be closer to our eyes, to our mouth, to our ears. It's going to be things that we wear. And it's changing the nature of the computing. I think you need a computing that is now geared towards real-time context and from silicon to cloud.
I mean, this is sort of one of the reference designs we have, which I love. There's stuff happening at the edge here on this device. There's things on the cloud. You want to talk a little bit about the core systems and silicon implications for such a new ecosystem?
You need a very power efficient CPU. The whole silicon is designed for you to have a cloud-native experience. And then you have a lot of sensors.
Right.
A lot of sensors for context. It's a much more personalized and bespoke experience than an app in itself. And I think that's changing the nature of devices. And even the definition of a wearable platform is changing in itself. And you start to see these incredible new form factors.
That computing platform, one of the things that you and I have talked a lot about is how do you build it such that there is an open ecosystem, right? Because it's not about one agent. It's about any agent.
This is what makes it very, very interesting and exciting. Because the smartphone today is at the center of your digital life. The job of those devices today is to be extending the functionality of the smartphone. And because of that, you actually saw that many of those platforms became vertical. It was a natural thing to have a vertical platform from the same company because the phone was at the center. That changes dramatically when you think about agents. And agents becomes the center of your digital experience. And I think the industry is going to be looking for an open horizontal platform that actually enable the agents to be interacting with the best possible device for different applications. And I think that's what's exciting.
And we want to make it possible for anybody who's thinking of an agentic system to not just be bound to current devices, but to imagine that there can be many, many devices that carry that intelligence in different contexts. And so that's the open ecosystem we want to build together. And again, it's so great to be partnered with you to get this started.
That's awesome. We're very proud of this partnership, and that's just the beginning.
Thank you very much, Stevie and Cristiano. We're very excited about Project Solera. It's sort of a new platform, but perhaps more importantly, it's a set of new platform rules that don't, you know, in some sense, hem in what you can imagine, the type of form factors, where your agents live. I think always whenever these new platforms have come, you get to rewrite even the rules of how new platforms operate. And that's what we're trying to get done with Project Solera so that you as developers and enterprises have the flexibility to imagine the form factors that you want and have your agents be ubiquitous. Now let's go up the stack to the next layer. We are building a new intelligence layer, bringing together the models, context, as well as the tools. It of course starts with model choice. Every customer, every developer is going to choose the right model for the right task and their eval mix, latency budget, even COGS budgets. And Foundry today has over 11,000 models. It's the largest model catalog out there, from OpenAI to Anthropic, and of course even MAI models. And just last week, we brought the OpenAI real-time voice models along with Claude Opus 4.8 to Foundry, so we're continuing to bring all these frontier models. The consideration though about the models is becoming now increasingly key. In fact, from the last developer conference to now, when you're building an agentic system, having this context really shaped right is becoming super important. And in fact, it starts right at the data tier. Right? The data state to date has been built for applications that supported these user-facing applications. Right now, you have to change and build them for agents, which again have very different call patterns even to the data tier. Agents are continuously storing, retrieving, reasoning, acting, and learning. Right? That's sort of what's happening in a continuous loop. And you see that today. Agents are using things like Cosmos DB for their memory. In fact, ChatGPT does. Azure Search is used for retrieval of indices and embeddings. Fabric IQ for the semantic models and the ontologies inside of the business logic tier effectively for agents. And also, you have Fabric real-time intelligence for all the observability traces, which now brings me to a very exciting new service, Horizon DB, which is our fully managed PostgreSQL service on Azure. Really thrilled to have this. I mean, one of the things we want to make sure is we built ground up a Postgres managed service which was for high availability, scale out. It's zone redundant with automated failover, 128 terabytes of storage per cluster, 15 read replicas. I mean, the read heavy workloads you can scale with this managed service. And in our internal testing, we're seeing something like, Horizon is delivering 3x throughput compared to any self-managed PostgreSQL setup. So it's super critical when you think about the scale you need. The other data workload we're also changing pretty dramatically is the data warehouse. In a world where agents are constantly querying data, the data warehouse effectively becomes a pretty mission critical. Right? I mean, it's one thing to have it be mission critical for users, but when agents need the analysis done on the fly, bringing GPU acceleration to Fabric is super key, and we're seeing 7x performance gain. So it's really thrilling to see that AI acceleration. So if you sort of have the data tier, the layer above this is the IQ layer that we are building that brings together essentially the model capabilities along with the data, right? So you kind of mix the data and the model capabilities so that you can deliver that right context to unlock intelligence, right? That's where, in fact, when people talk about token efficiency, this is perhaps the most important consideration, right? If you structure the context right and feed the models, then you will, by definition, going to be so much more token efficient. The first domain is the web. Web grounding is so important. You need that fresh, high quality and fast web data. And that's why we are really excited to announce today WebIQ. And WebIQ is built on our global infrastructure that's already serving over 1 billion users, but fundamentally re-architected for the LLM and the agentic workflow. It's model agnostic, it's MCP native, plugs right into any agent runtime. It has web, it has news, images, video, so agents can ground responses in fresh, verifiable content. And WebIQ leads across all of the 3 key criteria, right? It's best in class in quality, it's best in class in speed, as well as in cost. So we're very thrilled about WebIQ being in the developer's hands as you build out agentic systems. Of course, we're not stopping there. Beyond the web, every developer wants to be able to ground their agents on what's the most valuable data across the enterprise. And so we are bringing together Foundry, Fabric, and Microsoft 365 as this unified IQ layer, right? It's a continuously updated understanding of your organization to show you all of this rich IQ in action, building real-life agents. Here's Elijah. Elijah, take it away.
Agents are only as good as the context we give them. Microsoft IQ unifies enterprise intelligence for every organization. I'm here at a Power Utilities Control Center, and we'll start by running a long-running agent. This agent is going to help us assess the current grid operations incident and produce a brief for us so we can respond accordingly. Now I'm going to go ahead and kick that off, and while that runs, let me show you how we got here with context from Microsoft IQ. We built our agent in Microsoft Foundry. It's connected to various tools, and it's also wired to a Foundry IQ knowledge base, a single grounded source that packages our documents, operational data, and people into context the agent can reason over. After building the agent in Foundry, we published it to Microsoft 365 for the whole team. Let's go see it in action. Now, here in M365, I will start with a question about current events that an ungrounded LLM wouldn't be able to answer. I'm going to ask about current electricity prices in SF. For this, our agent pulls in the first IQ in our toolbox, WebIQ, search built for the AI era. WebIQ delivers industry-leading quality, velocity, and efficiency. WebIQ constantly indexes fresh official sources from across the web, and additionally, WebIQ does a great job with semantic documents. And here we can see WebIQ gave us our answer grounded in reality. Now, not only can we deploy our agent here in M365, but we can also embed it in our custom apps. Let's head back to the control center. Let's see how we handled a previous incident. So after using WebIQ to gather external info, we asked for details about our potentially at-risk substations. The real power of Microsoft IQ comes when we combine that external knowledge with our own internal enterprise context. For this information, our agent pulls in the next layer of Microsoft IQ, Fabric IQ. Here is Brightline's grid represented as a Fabric ontology, an operational model of the live grid. And critically, we didn't build this from scratch. Fabric takes the Power BI semantic models used by millions of customers today and lets teams extend them into rich ontologies that help run the business. This model is coupled with live telemetry, so it reflects the real operational state of the grid minute by minute. This is what Microsoft IQ means by enterprise intelligence. Not data scattered across disparate systems, but a single living model of the business that an agent can reason over. Now, turning back to our agent.
Yeah, this is a very good example of how you can, using a single system, a single prompt has agent goes through every possible data sources and builds. I think so this is using their new model. What exactly? I think so we will see it in the future frames.
We can see that it gave us a table of our most exposed substations. That's the agent querying the ontology you just saw. Now, the agent has access to both the outside world and our grid. The last piece is the one that turns a situation into a response, our policies and our people. By asking, what are the steps to respond to a substation trip, we activate the final layer of Microsoft IQ, WorkIQ. This is Brightline's response procedure in SharePoint. It's the playbook the team actually reaches for when something goes wrong. And the important thing is, the agent isn't working from a stale upload or copied snapshot. It's answering from the same source the team maintains day to day. When the procedure changes, the answer changes with it. No re-uploads, no prompt rebuilds, and no stale versions. And critically, this is your knowledge. The assets you create stay with you, no matter what model or agent is reasoning over them. Now, if we return to our agent, we can see the proper way to respond to this issue. Not a generic recommendation, but our playbook applied to this incident. Now, we just saw one situation, 3 questions, and 1 connected answer. Now let's go check back in on our long-running agent. And, let's just check the backup really quick. Moment of truth. And, boom. Our task finished. Here we can see every step the agent took. First, beginning with WebIQ, connecting it to the outside world. Second, Fabric IQ through Foundry, anchoring.
Yeah, so this is kind of cool. The instrumentation and tool when started, when completed, when the Foundry was interjected, the Work IQ Copilot, Web IQ, Web.
It in the real state of our operations. And third, WorkIQ grounding it in our people and procedures. I triggered this manually, but with Foundry routines, this can run on a schedule, turning a one-off response into continuous proactive execution. And
yeah, the scheduler is kind of good.
If we look closely, we can see it even use the power of WorkIQ to alert me directly about the incident. And if we go ahead and check Teams, it sent me an incident brief notifying me of the situation. That's the power of Microsoft IQ. When a crisis hits, the team doesn't chase answers across a dozen systems. They ask a question and get a response grounded in the world, their operations, and their people, all in one place.
Yeah, the grounding is good too. It's kind of necessary, and operations and people and the world models and search that is required, because these models hallucinate quite a lot.
In trust. Back to you, Satya.
All right. Thank you, Elijah. And now, let's sort of move up from this context model layer to deploying these agents and thinking about the runtime. And when you're building a first-class agentic system, you need a first-class agent runtime and a platform that we are going to ship both with Windows as well as part of Foundry in Azure. We want Windows to be a fantastic place to run and scale agents. And agents effectively are a new execution environment, right? It's a new paradigm even. They reason continuously. They generate and run code dynamically. They take actions across files and devices as well as across the network. Obviously, there's a lot of power in it, right? The fact that it can generate code and act on it on a long-running agent that's autonomous. But obviously, it creates new risk. And that's why today we're introducing Microsoft Execution Containers, or MXC. MXC is a new policy layer that lets Windows apply isolation and containment using AI native, or rather, OS native primitives. Right? You need to bake this into the operating system so that the containment is enforced by policy. You can have process-level isolation for lightweight agent actions. You can have session-level isolation.
The Microsoft Execution Containers, session-level, micro-VM level, process-level isolations.
For user separation. So Windows and Linux virtual machines, in fact, are also great, including WSL, for much stronger boundaries. And in fact, if you want full isolation and containment, Windows 365 for agents for maximum isolation in a separate managed environment effectively. You can pick the right containment option for the workload, and Windows will enforce it via MXC. And so I think this becomes pretty critical as you think about deploying agents at scale on your Windows desktop. We want to ensure containment is enforced, of course, regardless of who builds the agent, right? So this is why you want to bake it into the operating system. To that end, we're working with many partners to ensure that containment we are building supports real developer workloads out there and also addresses the needs. In fact, NVIDIA is bringing OpenShell to Windows to securely execute autonomous AI agents. And today, we are really thrilled to announce that OpenClaw runs on Windows leveraging MXC.
OpenClaw on Windows leveraging MXC.
Yeah, we are very deeply engaged with the team to make OpenClaw run super well on Windows. And so let me hand it over to my colleagues, Scott and Samantha, to show you OpenClaw on Windows. Scott, Samantha.
Hey friends, OpenClaw came out in November of last year and it took the world by storm. And for the last several months, I've been using my OpenClaw to stay on top of my health. My Claw can help me manage my blood sugar and it gives me even proactive notifications via heartbeat. I've got mine triaging my personal email, it's doing my GitHub issues and tracking packages, and it even buys me movie tickets. So Samantha, what are you using your Claw for?
That's cool, Scott. I turned my OpenClaw agent into my triathlon coach. I'm nowhere near ready for my race in September, but Coach Claw developed a work-back plan for me and is using my Strava data to notify me on how I'm progressing and to keep me accountable when I'm slacking.
Now, we both found our Claws to be super useful, and that's why we're working closely with OpenClaw to make them successful and even more successful on Windows. We've been collaborating in the open on GitHub to bring you all an OpenClaw Windows Companion app. It's going to help you set up your own Claws or connect to existing ones, whether they're hosted in Windows or in WSL. And the Windows Companion, we're going to sandbox the OpenClaw tool calls to keep you and your system safe.
Yeah,
Sandboxing and the process isolation is required, yeah.
See the OpenClaw Windows Companion app running right now in the background. Go ahead and right-click on it, Scott.
All right.
That looks awesome. You'll notice immediately it looks like a native Windows
This looks cool.
app, because it is. It's written in WinUI 3. It's got all kinds of information about my gateway, other machines that are participating in my Claw, my sessions, and my usage. I've also got quick access to things like chat, Canvas, the main dashboard, and more. Let's jump into companion settings. Within the app, we've got full chat support with tool calling. And you'll notice down here in the corner, We've got lots of permissions options, along with our sandbox configuration.
Now, this sandbox is really interesting because this is using MXC, the Microsoft Execution Containers, and for this, we're going to be using process isolation. Now, newer versions of Windows are going to have even more containment options, so you're going to want to keep an eye out for more news with MXC in the future. Now, I can see that I've got one-click security option settings, but Samantha, talk to me about custom folders.
Yeah, you've got full support about what files and folders you want OpenClaw to have access to, and really granular security features like clipboard access or talking to the internet itself. Now, I've given it read access to your desktop folder. OpenClaw already has a rich safety layer, and that layer is only augmented more by appropriate containment that can be managed by me or policies applied by IT. Now, for the purposes of this demo, I'm going to do something really scary and ask OpenClaw to delete all the files on your desktop.
That's cool, because I have a nice clean desktop.
I think you're keeping the secret. You hid all your icons from the audience while we were on stage. I think we need to show the audience who you really are.
So disrespectful. I know where everything is. Just don't touch my stuff. I know where they are. You know, Sam, I need to make sure that you're clear that a messy desktop is an organized mind. I'm pretty sure that that's the quote, right? So what we've done is we've asked OpenClaw to delete those files from the Windows node, and the only thing that is going to keep from happening is MXC, because we've turned off all of the many layers that OpenClaw offers, but our IT, in this case Samantha, has set it to read-only. So it's trying to go and delete all of those files. We can actually see the different attempts where it's going and deleting and then checking the directory and then deleting again, because it's very persistent. It wants these files gone, and I want them to stay. Nope. The read-only sandbox is there. 94 JPEGs are still on the desktop. Absolutely. My desktop icons are safe from Samantha's reign of terror.
Foiled again.
Oh, my goodness. So bad.
Today we've seen security sandboxing, WinUI 3, and open source brought together all in this alpha release of a Windows companion app. We think this app is a great opportunity to showcase OpenClaw on Windows, and it's only going to get better in the coming months.
That is right. And by the way, I want to note that we're doing all this development work on this calm Windows development machine with all the tools that I love, like WSL, containers, and containment. And I've even got GitHub Copilot with multi-model support ready to go. Now, this is literally how the team and I have been working on the OpenClaw app on GitHub. Now, people might wonder how all of this came together. Turns out that over the holidays, I got a DM from this random guy on the internet, and it took me a couple of days to get back to him. And then when I did, we just had this kind of cool idea that maybe he should come to Microsoft Build. Now, I think there's one more person that we all want to thank for bringing the next generation of agents to the world. Everybody put your hands together for the Clawfather himself, Peter Steinberger.
Samantha, stop showing off my secret DMs. I'm so excited to see OpenClaw native on Windows. You know, watching a claw try to delete all your desktop file and just fail made me really happy. Because 6 months ago, that totally would have worked. You know, I built OpenClaw to have access to everything. You know, my files, my machines, my chats, always on and fully open source. That's what makes it so powerful. And that's what also makes companies a bit nervous. You know, what I kept hearing was, Peter, I love my claw. Can I use this at work? And that's what we spent the last few months on, with Microsoft, GitHub, OpenAI, NVIDIA, just to name a few. We added observability. We added auto mode for permissions. We changed how access works. It's not all or nothing anymore. You can pick which folder should be read-only, which one should be write or hidden. So here's the news. You can totally run OpenClaw inside your company now. And we even made the harness itself a plugin. You can bring your own. Copilot, Codex, whatever you already trust, and your rules come right with it. And then you put OpenClaw on top of it. You get persistent memory, heartbeats, and you get a claw right inside Slack or Teams. It's been really exciting to see OpenClaw grow into something much bigger, a global movement and a community. And I started the OpenClaw Foundation, a real nonprofit, so it stays open and neutral. Any model, any operating system. Because we're entering a new era of building these agents. More capability for the people who don't code, and more power for those who do. And we get to do this. We get to build it together in the open. So my task is simple. Come build with us. Thank you.
Fantastic. Thank you very much to Peter. Thank you to Samantha. Thank you to the companion app team for their hard work. Thank you to the OpenClaw community for giving everyone here a workstation of their own. And as we walk out, I want to remind you that that's the first time you've ever seen OpenClaw running on a Surface Laptop Ultra. Goodbye.
All right, thank you so much, Samantha, Scott, and Peter. It's so wonderful to see OpenClaw come to Windows and have all of that capability in terms of the security and that comfort to be able to have these long-running agents and unmetered intelligence come together. So now let's move from the Windows side on the edge to the cloud with Foundry. And we're building Foundry into this full application platform for the agent era, right? I mean, every era of platform shift, when we moved to the cloud, we had the cloud-native app stack, and now we have the agent-native app stack in Foundry. We're particularly excited about the Foundry-hosted agent as a runtime for long-running agents. Agents now have, so if you're building in Foundry hosted agents, you can have all the IQ layers, you have the tools, you have the durability and the memory and the state. You have your own sandbox. In fact, it's a super fast sandbox that you can spin up. You can generate the rubrics and the evals. You can, in fact, have all the safety and the guardrails around your agentic system. And in fact, even one of the coolest things in Foundry is it's a continuously improving loop even, right? It's got that self-improvement loop built in, right? So you build an agent that's continuously getting better. And I'm really also excited today to announce a partnership with Fireworks AI, bringing, in fact, all of their open weight models to Foundry. That means giving you as developers more choices, as well as their great inference stack to build the next generation of these agentic applications with all the enterprise rails that Foundry has, as well as the governance Foundry has. So really excited about that partnership. And so now that brings us to the tools. GitHub itself is at the heart of all this. In fact, Jensen spoke to this. GitHub is not just about the code repo. It's becoming the control plane for all the agents. And nearly everything we measure on GitHub, whether it's repo creation, PR activity, API usage, actions, all of them are growing faster because of these agentic workflows. This new scale is driven by humans and agents collaborating together. And we're exposing our tooling across every form factor. In fact, we've seen tremendous growth in CLI, driven the approachability of a CLI form factor. It's always been great to go to a terminal. And now, though, when combined with the power of the models and natural language, CLI has become the thing that everybody goes to. But at the end of the day, when you have hundreds of CLIs, it becomes pretty complicated. It doesn't scale, especially the cognitive load that I have when you have 100 CLI sessions open is such that you kind of need something new. And so that's what has led us to build we need like this tool essentially that has the speed and the flexibility of a CLI, but has the capability of an IDE and the ability to scale to infinite number of agent sessions. And so today we're taking that next big step, introducing our new GitHub Copilot app. And we realize that it's not sufficient, right? Because you still have a backend to deal with, right? Code is easy to generate, but what about the backend? So you need to contend with identities, storage, database schemas, and that's why we're really super excited about Rayfin. Rayfin is an agent-first SDK that connects your agents to a backend as a service, and we're bringing this to everywhere you build. That's why I'm, again, super excited about Rayfin and the partnership with Replit. You can now build apps in Replit while you can build the app in Replit while the app and data are deployed into the enterprise managed fabric tenant thanks to the Rayfin SDK. And so this Rayfin SDK is available now for anyone else to be able to use with their tools as a backend and essentially have this backend service. And now to show you all of the Foundry and Rayfin and building agents and long-running agents, let me invite up on stage Cassidy. Cassidy, take it away.
Hello, everyone. I'm so excited to be amongst my fellow devs today. This has been a long day. Fix your shoulders, sit back, you're ready. I see a lot of you sitting up. Great, great. I know you're drinking from the fire hose of information today, so I want you to go into the next few minutes thinking, what can I try out on my laptop later today? So as Satya said, we're going to show you Rayfin, but first, I can't wait to show you the new GitHub Copilot app.
Yeah, have been in touch with her since a long time. I don't know. It has been around 6 years, 7 years. I don't know. It's all public, so you guys don't have to go in any of my DMs to find out where. But she kind of is crazy about keyboards and is quite good with the work she does.
This app is your home base for development and operations on your computer, and we think you're going to love it. So let me show you around. When you open up the app from the start, you see this home screen here, where you can kick off a new agentic coding session. But also, before I get into the serious stuff, you can drag Mona around, and there's a game. Look, it's so fun. Okay, I'm not very good at it, so let's just get back to, you can kick off a new agentic coding session. So I started off one a little bit earlier here, and it gave me a review of a bunch of release blockers. Which one should I fix? Call it out. 8, 3, the critical ones. You know what? How about we just do all of them? Let's go. This app will now kick off a separate session for every single issue here. I don't have to worry about stashing or coding complex or anything because the app takes care of that with Git work trees. Git work trees are isolated environments for each session that you run, so your agents can work in parallel without stepping on each other. But you still have to merge them, right? So Copilot has your back there too. If I head over, not to this one, but to this issue here, I can run agent merge. And when I enable agent merge, Copilot will continuously babysit this PR through CI checks, code review, and merge conflicts. Okay, let me keep showing you around while those are still running. Now, if I head over to my work, I can see a focused view of all of my activity and just projects loaded in the app, issues and PRs, everything here. And then under automations, I have a bunch of reusable sessions and workflows I can run locally or on the cloud. You see there's issue poetry there, that is real, and that is load bearing. Okay, and now under sessions, like I briefly showed earlier, these are sessions. If I want to add a new repository, I can click that button here and it can pull from a local repo or from a GitHub repository. And then if I were to just add one, I can add a session in Pocket Cal. This is an open source repo. I can start a session anywhere and it just loads it. I don't have to clone, I don't have to pull, it just works. Now, when I look at a session within this repository, let me look at this other one over here. I get an integrated browser, there's a terminal, I can see the chat, it's all loading. I can even toggle light mode and dark mode in here. And there's also this great button, pick and polish, where if I click that, I can pick and polish anything in this app, and it adds it to the chat, and I can say, hey, I want you to add reordering to this list, and it'll just work, all living in there. I have access to all the most popular models via my single GitHub Copilot subscription, including those from OpenAI, Anthropic, and Google. You can see all of them in our model picker. And having model choice is great. Not only can you pick the right model for the task, but for bigger features, Copilot can request a rubber duck review. So in this session here, for example, I was using GPT 5.5, but if I scroll up, it actually requested one from Claude Opus 4.8. All models have blind spots, and the power of the Copilot multi-model approach means that I can catch them earlier. And this is all very cool. But working with AI...
Yeah, rubber duck approach requested. She is using GPT 5.5. Rubber duck requested from Claude Opus 4.8. Blind spots are kind of being fixed or asked for using a different model. Interesting.
AI in 2026 should be more than just chat. You just saw me scroll on that. There's so many words here. So today, I'm very excited to show you the concept of a canvas. I'm going to open one right there. The canvas is how an agent can build a custom UI to communicate with you. What if your AI could see? Everyone say, demo gods bless us. Okay, let's see if it works. Here's a fun canvas where, if I get the camera going, okay, the agent shows your PRs down here, and I can toggle it with a thumbs up or a thumbs down. Let's approve it. Hey, it's so fun. And you can go so much deeper if you want. This is just the beginning of what you can do. So again, I kicked off a bunch of different sessions earlier. This is a Signal Box app. It's 100% agent built. It's containerized with a database backend. Would you be able to deploy this to your enterprise with no questions asked? Be honest. No, yes, exactly. No, but you can with Rayfin. And that is very, very exciting. Let me open up a new terminal over here. All I have to do is type Rayfin up. And then, demo gods bless us, come on. It will maybe deploy. Blammo, it's happening, yes. And all hosted on Microsoft Fabric. Okay, I know that's a lot. With Rayfin, your agents get complete enterprise backend, so you can deploy with confidence in the way that's best for you. But this is the key thing to remember. This app is not just another session manager. Yes, it is. It manages a lot of sessions, but session managers just make it easy to create work. But GitHub Copilot helps you to finish it. Thank you so much. Happy Pride. Back to you, Satya.
All right, now we're back to IDEs that have UI. That's sort of so cool. it sort of comes a full circle. Now let's talk about how you can observe, govern, and secure these agents. Agent 365 is the agent control plane. Agent requires their own identities, access controls, even when they're working on your behalf, right? You just want that work on behalf identity to be enforced. So we extended Entra. Agents need real-time defense, so we extended Defender. Agents require this always-on data protections and compliance, so we extended Purview. And these agents can be hosted anywhere. They can be on AWS, GCP, not just on Azure, or built with any framework. And today we're announcing a number of updates, including the GA of Agent 365 SDK, and we're expanding it to your local agents running on Windows and elsewhere, and the clause you just saw earlier. And let us take a look at how all of Agent 365 composes. Over to you, Amanda.
Everyone is building agents, but that's not the hard part anymore. The hard part is integrating them into your business and governing them at scale. Today, I'll show you how Foundry makes this easy. Let's start locally. I've already built a LangGraph agent, and now I'll show you the value Foundry adds. First, tools. Agents need tools to get work done, and with Foundry Toolbox, I just add my tools once, and any agent can consume them through a single MCP endpoint. And because tools live centrally, that means governance does as well. I've applied a guardrail, which blocks PII from leaking into tool calls and tool responses, and all I have to do is apply this once, and all my agents are protected. Now, let's make this agent enterprise ready. To deploy this agent to Foundry, all I have to do is add this one block of code, and then I push my changes, and GitHub Actions takes it from there. Once deployed, I can actually use this agent in the same Foundry extension I showed you earlier, and let's now test it out. I'm asking it to track a few open items from a stand-up I had earlier today, and what's actually happening right now is Foundry is spinning up a dedicated micro VM just for this session, and the session even gets its own persistent file system. What you're going to see in a minute here is if I go to the Files tab to track the open items, the agent's actually writing to a file. Pretty cool, right? Plus, Foundry now has server-side traces and built-in evals to show me exactly what happened on every run. But how do I know if my agent's doing a good job? That's what Foundry's brand new rubric evaluators are for. It's super simple. With just one AZD command, Foundry reads my agent and then generates the evaluation criteria for me. In other words, it creates a rubric personalized just to this agent. Now let's check out this rubric in Foundry Portal. Look at these dimensions. Governance outcome correctness, prescribed source usage. I didn't write any of these. Foundry generated them from production traces. And with this rubric, I can score my agent and run evals, but we can do so much more than that. That's where Foundry's brand new agent optimizer takes over. Here's how it works. It tunes 4 things: the model, instructions, tool descriptions, and skills, and then it generates improved candidates and scores each one using the rubric I just showed you. Here, I can view the candidates, I can see the strategy used, I can see their scores, and I can actually view exactly what changed. This candidate, for example, improved its score by updating the model and the system prompt. Foundry then makes it super easy to deploy the best candidate as a brand new agent version. But this is not a one-time thing. Every run feeds the next eval, and every eval tells the optimizer where to improve next. So your agents now get better the more they're used. But now, let's put this agent to work. I've published my agent to Teams and M365 Copilot, and right now I'm going to ask it to just catch me up on what I've missed, because I've been offline all morning, but my agent hasn't. While it works on that, though, let me explain what makes this agent different. This is an autopilot agent, which means it has its own identity and productivity license, so it can work across M365 on its own behalf. Earlier, you saw me using this agent by myself, but shipping a feature in a new release takes a whole team, and that's why this agent lives in our team's group chat. Now let's check out how it did. It summarized all updates and called out the key features I need to be tracking. But to put an agent like this actually to work in your enterprise, governance needs to come first. And that's why every autopilot agent requires admin approval. Here, admins can review all critical details, and they can even choose who has the ability to talk to the agent. But it doesn't end there. Even after approval, admins can continue to monitor the agent and block it at any time. But governance cannot apply to just one agent. Every agent in your organization needs to be managed with the same rigor as users, apps, and devices. And that's exactly what Microsoft Agent 365 provides. So let's zoom out. Today we saw Foundry accelerate development, take your agent from local to enterprise ready, and put it to work in M365. Foundry makes it simple. You build the agent, we handle the rest. Now back to you, Satya.
Thank you, Amanda. What you just saw was how we're building security for AI. But there's also one other critical aspect, especially the news today is all about how do you defend yourself using AI against attacks that may in fact be using AI, right? So last month we announced our multi-model agentic security system, M-Dash. That's essentially an agent harness for security, essentially, that we built. We're bringing together 100 agents across the frontier and custom models to really find these exploitable bugs better than any single model does. In fact, when we debuted this harness, it was on the top of CyberGym benchmark. So I want you to take a look at what you can do with M-Dash to really defend against AI attacks and defend the entire digital estate. Over to you, Sarah.
Satya. Now, we all know that security scans can take a while, so I'm not going to do one live. So let me show you the result of an M-Dash scan I already ran on my code base. Now, the system runs as a standalone CLI, but today I'm using it in my GitHub Copilot app on my local dev machine. The scan is broken down by vulnerability domains and severity, and it's also an additional to finding traditional issues like coding errors and...
Yeah, this is cool. The defender scan has 63 findings. CWE78, CWE502, CWE208, and the high impact and the others. So this, I think so, will plug into Mythos when it is publicly launched.
Hard-coded secrets. It's also identifying AI-specific vulnerabilities in the code base. Now, what happened under the hood is that over 100 specialized agents are working together to discover, debate, and prove exploitable vulnerabilities end-to-end. And when the scan finishes, it generates both a SARIF log and an HTML report that I can give to my management. Now, the Defender Details command allows me to dig into these vulnerabilities, and I can see what the vulnerability is, where it is in my code, and the severity to help me prioritize. And from here, of course, we're going to fix it. Now, using the Defender Fix command, the system will remediate suggested fixes directly in my local dev environment. And when that's done, I can check out the diff. So I have full transparency about what the harness has done, and I still have a human-in-the-loop check. But, of course, everything I've shown you so far has run locally, but I can also create a PR to plug into my existing workflows and push up to my repo, and I can take the serif output from the scan, and I can upload it to tools like GitHub Advanced Security and manage everything alongside my other application security findings. Now, I've shown you M- working on my code, but let me show you a vulnerability our security research teams identified using M- that you can go and look up yourself. So the TLDR, because this is a lot to read, of this bug is that WASM time reads an out-of-date map of an object, runs off the end, and then it crashes the host. So this is exactly the kind of bug that the harness was built for, because the flaw is spread across 3 different parts of the code base. So no single file looks wrong on its own. They look absolutely fine. And we can even see here, which is probably my favorite part of this bug, a very confident statement from the developers claiming everything is fine. Now, this is exactly the sort of reassurance that fools normal scanners and single AI models. But M- wasn't fooled. One team of agents spotted the suspicious gap, another team argued it apart, and a third team built a working example that actually triggered the crash. And it did all of this in an open source code base. And this is the kind of joined up reasoning that previously required significant manual security research effort. This is M- helping developers create secure code from the start, coming soon to your CLI and the Microsoft Defender portal. Back to you, Satya.
Hi. Thank you, Sarah. So that was the stack. Before, though, we move to unpacking more of the opportunity, I want to do something different. I want to introduce 2 people whose LinkedIn profiles were both super impressive and slightly perplexing. Under current role, it says they're general partners at Mantis VC. Under previous role, it says they sold out Madison Square Garden. Please help me welcome Alex and Drew from the Chainsmokers. Alex, Drew. So wonderful seeing you, Alex. Thank you so much. One of the things when my team came to me and said, hey, we're going to have Chainsmokers at Build, I thought maybe that's what we're calling our new GitHub Copilot app. But it's so I thought maybe they're your fans. But tell me about how you got into this. I mean, you've been at it now for what, 12 plus years as venture capitalists or angel investors first, and you had your firm now for 7 plus years, and you even picked what I would have not thought is the natural place, which is B2B SaaS even as the first place. But just give us a little bit about the backstory on this.
Sure. Well, hey, I'm sure you guys are wondering what timeline you're on with the Chainsmokers are at Microsoft, Bill. But hey, how are you? We've been in the Chainsmokers for 14 years, and when our music started to take off in the mid 2000 teens, we got to play a few events like this, and we met a lot of the founders from the consumer mobile cloud era of startups, and they taught us a lot and gave us a front row seat into what early stage investing was like. We fell in love with it. We found we had a lot in common with these founders, and the way they built their business was the same way that we thought about starting the Chainsmokers, and kind of breaking through the noise there. And we got to participate in a few of their deals. We're very lucky, and we decided to institutionalize in 2020 and start our own fund.
That's so cool. And when you sort of hear about all this AI stuff and what's happening, obviously there's a lot even going on, even in your portfolio. We were talking backstage, things are changing. How do you sort of see the opportunity going forward?
I mean, there's so many vectors you could talk about this on. Of course, there's the creative output side, which we've been experimenting with in music, but always important to have your authenticity when it comes to creativity. But on the investment side, I think we're moving from producing outputs to producing actions, which I think presents like a very interesting opportunity to kind of reimagine the entire architecture of the way software and enterprises have been built. So instead of humans, producing outputs, it's machines producing outputs, and rethinking what that entire space looks like in that context.
Yeah, no, it's fantastic to see that. And maybe just to close out, any sort of as artists who have had great success, when you look at a founder, what sort of is the advice you give them when you're creating, you're bringing something new, and it's a creative process. So what are you looking for in founders? What is it that you're giving them as advice?
Totally. I mean, there really are so many parallels. Maybe it seems like that, maybe it doesn't. But I mean, it's really difficult as artists to really find, I guess, what your sound is, what's authentically you, what you can continue to do over and over, because with this much competition, you have to be moving authentically. You have to be connected to the product that you're creating, and because you're going to have to iterate and keep it going and have consistency for a long period of time to kind of lock into your fan base and make something that's special and unique. And we try to advise our founders to do the same thing.
Fantastic. Thank you both for joining us. Are you game for playing for us this evening for our closest friends here?
We'll be there.
6 o'clock, 6 this evening. Thank you so much. Thank you. Thank you. Thank you. We'll be right here at 6 p.m. Tonight, and really looking forward to it. So that effectively sort of talks a little bit about the developer stack. So now let's talk about what is the opportunity for every company, right? At the end of the day, we are institution and organizational builders. Whether it's an AI native company, whether it's a SaaS company, whether it's an enterprise, the first thing we want to do is make sure that as you build things like plugins or agents or your AI apps, we want to make sure that they're discovered throughout the Microsoft ecosystem. That's job number one for us. That's why we're doing the things we're doing in Windows or the Microsoft 365 Copilot or in Teams or in GitHub. We want to structure them such that your applications, your agents, your plugins are discovered. Customers are also building lots of line of business applications, line of business agents, then using Copilot Studio, and we want to make that all discoverable again as part of the Copilot experience. And Teams, in some sense, has become this destination for multiplayer human-to-agent interaction. We want you to be able to find agents, interact with agents right in Teams. And we're supercharging all of this. Copilot continues to evolve very quickly. It started first with chat, with some of the best models, with great access to WorkIQ. We didn't have the name WorkIQ, but now that's kind of where it got started. Then came CoWork, a new way of working and generating these stunning artifacts and solve these multi-step problems, right? So you assign multi-step tasks to CoWork. You saw GitHub. GitHub has continued to evolve as well. And now, as come summer, you will be bringing coding to all knowledge work within one Copilot super app, right? That's going to be really exciting to see, yeah? So you'll have chat, CoWork, and code all in Copilot. But today, we're introducing something completely new. Autopilots. We can think of autopilots as enterprise-grade claws. These are autonomous, long-running agents with full enterprise compliance that run in your tenant. Autopilots can have a name, personality, custom connectors, context, and memory, and they're a totally new way to reduce toil and get you back to what you love. To kick things off, the first autopilot we're introducing is Scout. Let's take a look.
Scout.
All right.
Autopilot is for.
As you can see, Scout works where you work, joining group chats and teams, handling threads in Outlook. Starting today, for those of you who are on Copilot Frontier, you can try out Scout. And in the coming months, we will build this out to a complete digital team of autopilots right inside of Copilot. Right? So you can go to the Copilot app. Scout is the one that comes by default, but you can build more of these autopilots. And so that's the future of what we think of as the Copilot ecosystem itself. And so far, we've talked a lot about what you can do to build your own agents and how these agents are discovered in things like Copilot and Teams and Windows. But when you think about what makes any organization, any enterprise, any company unique, it is its tacit knowledge that it's continuously compounding through its operations. So the key consideration at some level in an AI age is to ask the question, what's the future of the firm? How do you continue to preserve and compound that tacit knowledge in the age of AI where models can learn anything from the data and the trajectories they see? To do that, we believe that every organization, whether it's an AI native company, a SaaS company, or any enterprise, will need to build their own hill climbing machine. It's a system that continuously improves against your objectives, your private evals, compounding your advantage over time, not someone else's. To deliver on this, we're taking the next step with frontier tuning. We've been working with many customers already to help with, really build their own learning loop, the environment, the context, the tools, the rubrics, and even train their own models. And today, we're really thrilled and excited about supercharging that frontier tuning capability with the innovation that's coming out of our superintelligence lab. To tell you all about this, let me hand it over to Mustafa. Mustafa?
Thank you. Thank you. Thank you. Thank you. Good morning, everybody. We really are living in the most remarkable times. Since I started working in AI, the compute that we use to train frontier models has increased by 1 trillion-fold. That's 12 orders of magnitude of computation in just 15 years. It's now clear that a consistent exponential increase in computation leads to predictable advances in AI capabilities. And in the next few years, we're going to see 3 more orders of magnitude of compute applied to train frontier models. Intelligence is now a function of compute. Log linear hill climbing has become the norm. The scaling laws are clearly holding, and it is a remarkable time in our industry. And so in this context, we at MAI are building towards what we call humanist superintelligence, state-of-the-art AI capabilities that are explicitly designed to serve people and organizations and not replace them. Because the type of AI that we create really does matter. We need an AI that places humanity first, that always prioritizes human well-being and human progress. This is the core philosophy and motivation behind our superintelligence efforts at Microsoft, and it shapes everything that we do. And as a platform company, our job and our commitment is to keep you developers building at the absolute frontier. So today, we are very excited to announce a family of 7 new models across image, voice, transcription, and coding.
Oh, 7 new Microsoft AI models. MAI Image 2.5, MAI Image 2.5 Flash, MAI Transcribe 1.5, AI Thinking 1, MAI Voice 2, Voice 2 Flash, and Code 1 Flash.
These are all built with real attention to detail and a commitment to making very practical and efficient tools that are tuned to just how you work in the real world. So first up, MAI Image 2.5 in its Flash variant, 2 super strong models that deliver a step change in quality, now at number 2 on the leaderboard, surpassing the score of Nano Banana 2 on image editing. They give you precise editing with incredible control and consistency. Flash is here for super efficient production workloads, while 2.5 gives you that maximum fidelity and professional grade performance. They're live in PowerPoint today, they're rolling out to OneDrive, and right now you can access them on Foundry at a market-leading quality per dollar. Next up, we've got MAI Transcribe 1.5. This is the best transcription model in the world. State-of-the-art accuracy across 43 languages, beating out Gemini and OpenAI's flagship transcription models. We've optimized it for real-world use so that you can produce highly accurate transcripts for any bespoke use case 5 times faster than all rival models. It's now being integrated inside GitHub, Teams, Copilot, Dynamics 365 Contact Center, and it's now also available in Foundry, where I'm very excited to say it is the fastest, most efficient, and most cost-effective transcription model of any of the hyperscalers out there. So paired with that, we've got MAI Voice 2. This is our latest.
They should have given a few benchmarks, or some numbers would have been great, but I think they deliberately removed it from the presentation.
Speech generation model. It has beautiful prosody, natural sounding delivery, fine-grained emotional control, and it's available in 15 languages with many more coming soon. We're also announcing Voice 2 Flash, and that provides the very best value and speed for ultra latency sensitive voice agents, which of course is a big thing in 2026. Next up, our text foundation model, MAI Thinking 1. This is our first reasoning model, and it's exceptionally strong in our target use cases of reasoning and SWE tasks. It's a 35 billion active parameter MOE with a 256K context window. That means that it competes in the medium-sized weight class, where it's certainly punching above its weight, and independent human raters on Surge prefer it in overall quality side-by-sides versus Sonnet 4.6. It's achieved 97% on AMI 2025, which is obviously the key measure of its general purpose reasoning abilities. But most importantly of all, it's now at 53% on SWE Pro, which places it right alongside Opus 4.6, at least on the toughest coding benchmark that's out there. So we're very happy with that. Now, there's plenty more for us to do as we get this into production and hill climb against real-world tasks and real-world traffic. But what is actually most remarkable about this model, we think, is that it is climbed entirely from the bottom. And that means that it hasn't targeted any of the benchmarks specifically, and it's done so with absolutely zero distillation. And to us, this is critical, because it means that the model is created with an enterprise-grade, clean, and commercially licensed data lineage that means that you can put it into production in a very trustworthy way with complete confidence. Now, finally, I'm incredibly excited to announce MAI Code 1 Flash. This is our new inference-efficient coding model, which has been especially tuned for VS Code and, of course, GitHub Copilot CLI. It achieves 51% on SweBench Pro, despite having just 5 billion parameters. And so it's much closer to Haiku in terms of size, but cheaper in cost, delivering really strong coding performance at great inference efficiency. And it's rolling out today inside of VS Code. Now, alongside distribution on Foundry and optimization for our 1P products, we're also very excited to make our models available on OpenRouter as well as Fireworks and Base 10. So this means that for the first time, you're going to be able to tune the weights directly yourself in an ecosystem of your choice. Now, across this entire family, safety and security have been built in from the start. Our voice models come with protections against unauthorized cloning. Everything is watermarked from scratch. We've reduced our over-refusals, improved representation, including for people with disabilities. We're also publishing a very detailed technical report today to give you a full and transparent understanding of how we put all of this together. Now, one of the things I'm particularly excited about is that we have been carefully co-designing our models with our own silicon. So that means that we've optimized MAI Thinking 1 on our very own Maya 200 chip and benchmarked it head-to-head against the GB200. And so on top of the 30% performance improvement that Satya talked about earlier, we're now seeing a further 1.4x performance per watt gain when we run our MAI models on the Maya 200 end-to-end. And that's huge, because as everybody knows,
this is good too. 1.4x.
at this scale, every watt counts. And silicon and model co-design is a really key advantage that we think
Maya 200 models, RLEs,
is going to help keep everybody here right on the frontier with the most efficient and most powerful thinking and coding agents out there. We're also super excited that these faster and more efficient MAI models are coming to the N1X that Satya mentioned a few moments ago, and we think that's going to be able to deliver the very best performance on Windows in a few months' time. Now, to us, this is what owning the full stack end-to-end looks like. It's the foundation of Microsoft Frontier Tuning, lets you customize the MAI models using our full stack hill climbing machine right where you want it. And it means that the disciplined and very relentless engineering that has gone into building our models is now available to all of you on a platform that you can trust, working on your behalf to create custom agents that you will control. So the really big thing, of course, that's happened in the last year is these RLEs, reinforcement learning environments, these unique training gyms for your AIs. They create company and task-specific agents adapted only to you, built on MAI models. So, for example, within Microsoft, we use our RLEs combined with our MAI models to climb towards the best agentic use cases on Excel. Our MAI-tuned model is now on par with GPT 5.4 on public and private benchmarks, whilst at the same time being 10 times more efficient on cost. Thank you. You know, and many other early adopters are seeing similar results. When we tuned our models on McKinsey's tasks, MAI delivered the highest win rate, even outperforming GPT 5.5, and again delivering 10x greater efficiency on cost.
McKinsey's. Okay. I've made a couple of a series of notebooks on that, which you can find on my GitHub. Ping me if you want to know more details about the McKinsey and companies. Write-up and notebooks and the code that I developed.
So to us, this is the advantage of very carefully calibrated frontier tuning. And importantly, unlike with some of the other companies, with MAI, you don't rent intelligence from a shared model that learns from everybody. Only you
Worklogs, tacit knowledge, distribution, institutional memory, brand.
You keep the benefits of your hard-earned workflows, know-how, knowledge, and your own institutional data. Only you get to control the resulting model. And so with us, the RLEs and the models that you build inside of them, they become your moat. I really think this is distinct. It marks a new era in AI that we're all very, very excited about. Okay, so now just one final announcement that I'm very excited about. We are taking customization and co-creation of our models to the highest level possible on what I think of as perhaps the most important application of AI, healthcare. So today we're very proud to be announcing that we're partnering with Mayo Clinic to jointly develop a new frontier model for health and then deploy it around the world in their hospitals and beyond. So this morning, please help me in welcoming to the stage a physician, groundbreaking researcher, president and CEO of the Mayo Clinic, Dr. Gianrico Ferrugia. Thank you so much for being here, Gianrico. Now, of course, everyone will recognize Mayo as perhaps the leading hospital in the world with an incredible track record of research and innovation and clinical practice. Tell us a little bit more about what you hope to get out of our collaboration.
Well, first of all, thanks for having me here. Thanks to Satya as well. Mayo Clinic is known for being able to live up to our primary value. The needs of the patient come first. We deliver outstanding healthcare. We're ranked the #1 healthcare organization in the world. Yet we know most people in the world will not have access to Mayo Clinic. So 7 years ago, we decided to create a platform, the Mayo Clinic platform, moving all of healthcare from a pipeline to a platform. And with our partners, that platform now is in 4 continents and reaches about 100 million people. It has created the largest, to our knowledge, deepest longitudinal healthcare data set in the world, multimodal, including genomics. So here together now we have the opportunity to do what we do best together, which is create a frontier model for healthcare. What it means if you're a patient, if you're somebody interested in healthcare, you can get clinical and logistical answers to your healthcare. But if you're a healthcare provider, if you're a physician, it can give you insight, it can act as your real-time team member that can tell you what is likely to happen next, but it can also prevent harm and therefore increase patient safety, and giving valuable insights that make the team better at giving you what you need most, which is better healthcare.
Yeah, I think that one of the things that we're most excited about is that the models are already pretty incredible at textbook knowledge. They've read all the journals and all the papers, but what they're really lacking is the kind of clinical practice and clinical expertise of your team and your clinicians that you developed over the last many decades. So how do you think we might go about using that clinical practice to improve the performance of the model in production?
So the exciting part here is we each do what we do best, and we can tackle something that has eluded healthcare for a long time. Trusted, scalable solutions. And to do that, you need to have the right data, you certainly need to have the right people, but you also need to have a very patient-focused lens. And between the two of us, we now have all this together, so we can build this frontier model and then offer safe, secure, trustworthy, and of course effective healthcare solutions for all.
Well, our #1 objective, of course, is to put the patient first, deliver the highest quality we can in a trusted way, and then hopefully share that with the world over. So we're very excited for this partnership. Can't wait to share more with everyone in the future.
Us too. Thank you.
Thank you. So today marks some very, very exciting steps that we're taking on our journey to create humanist superintelligence at Microsoft. We now have an incredible roster of 7 new world-class models to keep everybody working at the absolute frontier. And we're really looking forward to everybody being able to co-create your own unique agents adapted to you that you'll control. I really feel like this is a new era in AI, an era of AI that you control on your terms. So let's build it together. Thank you very much, everyone. And now over to Tanya to show us how frontier tuning works in practice.
Thanks, Mustafa. With frontier tuning, we're making it possible for you to create your own enterprise AI with the models and the harness tuned on your data and your workflows. Let me show you how you can build your own hill climbing machine. MAI Thinking 1 is now available in private preview in the Foundry model catalog. You can go ahead and deploy the model as is, or if you want to go on your own hill climbing journey, you can start by clicking the fine tune button. Now I'm in the fine tuning UI. The first thing I'll do is add my data set. Next, I'm going to add a grader, and that's it. I go ahead and submit the job. A couple of hours in, I see how the model is learning. It generates.
Reinforcement learning, fine tuning. What parameters are these? RLVR or something like that? Or which architecture? What's the technique that they're using here? Or simple fine tuning.
Rollouts, it scores them, and we start to hill climb. Now, if you want full control over your RL training loop, let me give you a sneak peek into our low-level training API. You can see here I have the MAI Thinking model. I can also configure my rollout strategy as well as my hyperparameters to define exactly how I want my training algorithm to work. In fact, I can also incorporate my own RL gym here by defining the tools that this model interacts with. All right, you just saw all the code, but as an M365 customer, you're never starting from scratch. Let's hop on to Copilot. As a part of frontier tuning, we're introducing a new way to build RL environments based on your data and your workflows. One of our customers, Land O'Lakes, one amongst the largest agri-businesses in the United States, is in fact using this to perfect that butter on your morning toast. Let me walk you through their environment. Now, on a high level, the environment consists of skills, knowledge, and tools. But in the back end, we create an entire RL gym for your agents to continuously learn the way that you work. Now, let's look at the butter report generation skill here. These tasks are very complex. They require many manual steps and a high degree of precision. Now, in these tasks, even 80% accuracy isn't good enough. To hill climb to higher accuracy, we're extending the industry definition of skills to include rubrics on what good looks like. But this is just one task. How do I scale this to codify all of the tasks in an enterprise? You spend a lot of time in M365, in Teams, Outlook, Word, Excel, and PowerPoint. We use those signals to suggest skills and rubrics that truly define the way that you work. Next, you can add your organizational knowledge for grounding, like from OneDrive and SharePoint. Now, the environment comes built in with Microsoft tools, and you can add custom tools to it. Because these tools tap into real workflows, we virtualize them to simulate execution, so the model can learn without actually impacting the life state of your business. And now, my most favorite part, the science. By generalizing all of these learnings into the main model, as well as in the embedding model, we're able to hill climb for tasks that require high accuracy. And not only this, we are able to hill climb to more than 90% accuracy for Land O'Lakes tasks using the MAI model. In fact, we estimate this model to be 10x more efficient than the baseline models. Now, with this environment set up, let's go back to butter reporting. Let's run this task, this time using this tuned environment as an inferencing harness. Now, usually this task takes a couple of minutes to run. In the meantime, I will show you a cached response. Now, as you can see here, the agent has leveraged test time tree search with multiple models, including a fine-tuned model. And what you see here is a summary that doesn't feel generic. It feels undoubtedly Land O'Lakes. And that's not it. The task holds itself to high standards, and it continuously retrospects and evaluates itself. This way, with frontier tuning, your agent continuously improves with your compliant RL environment on your data, encoding the way you work. Now that is what I call frontier tuning as smooth as butter. We cannot wait to see the environments you built. Back to you, Satya.
Right. Thank you so much, Tanya, Mustafa, Genrico. Thank you for the partnership here. What you just saw is a pretty significant shift. We believe that time's come for every company to just move from consuming a frontier model to fully participating at the frontier in the frontier ecosystem. That's the transition. You can have your own private evals and outcomes, your private RLEs and traces, your enterprise knowledge, create the scaffolding for models to hill climb. That's what will allow you to create that differentiated IP that you own, you control. But the second salient point is that there is a new operating point at the frontier where you can use a very efficient reasoning model and a coding model and achieve frontier level performance because you've done the hard work of creating that environment, that RLE, that hill climbing machine in which these models with your traces can hill climb to the frontier. So we think that the combination of these two is a pretty big game changer in how people think about what does it mean to operate at the frontier? What does frontier tokens look like? How are you in control? What's the future of a firm? These are the big questions, and really an ecosystem that gets built around as opposed to a few models that just are hungry for all data. To close out though, I want to talk about that frontiers beyond, that push this ecosystem of ours and really say what's the next big thing. Bending the curve, when Mustafa talked about this with Genrico when it comes to health, but building that scientific discovery loop can have perhaps the biggest societal impact, right? Science today still is a little too linear. You create a hypothesis, you form a hypothesis, you run an experiment, you wait for lab results, which is out of band, and then you begin again. But what if the scientific method itself could become more continuous, more parallel, more programmable? That's what we're doing with Microsoft Discovery, right? Discovery brings together the models, the HPC compute, the knowledge graphs of all the scientific knowledge, the automated lab and simulation into one agentic discovery loop. And so today, I'm really thrilled to GA Microsoft Discovery and to show you all of this in action. Let me invite up on David on stage. David, take it away.
Hello. I work in the Microsoft Discovery and Quantum team. Today, to recycle a PET plastic like this bottle, you have to shred it and melt it. The result is degraded. You cannot use it to make this bottle again. It's downcycling. Cambridge Consultants, part of Capgemini, is using Microsoft Discovery to advance that research. Let me show it to you. This is the Microsoft Discovery app. It is based on VS Code because agentic discovery has many parallels with agentic software engineering. Today, I want to do these three things as a scientist. First, I want to write a scientific paper about this topic. I'll explore an existing line of research. Instead of melting the plastic, I can use proteins to decompose it, so you can recycle it again and again. Second, I want to perform the actual discovery to find new proteins. And third, I want to create a lab protocol to test the results in a real lab. If you're a developer, these three steps should be very familiar to you. They look a lot like planning, coding and testing, and deploying to production, but for science. Let's launch it. This will kick off the discovery engine. You can think of this as a team of specialized agents always running in the background, following the scientific method. You can see those agents here, and you can add more. Microsoft Discovery includes a community of agents, models, and tools across many domains. You can use open source, third parties, or create your own. Okay, so this is still running, and it will be running for a while, even hours or days, because the discovery engine, like science, is not sequential. It is exploring hypotheses and performing long-running simulations dynamically. So let me open one that is already completed. You can see the files that it created here. This one is the research paper that I was asking for. To create it, Discovery is using a knowledge graph internally, bringing together public scientific literature and internal knowledge. This is a critical asset because it provides complete visibility of the reasoning, so scientists can be in full control. We can go now to step 2, the discovery itself. Let me open the output for that one. So, how do you come up with new proteins to decompose plastic? This is the approach that Discovery took. First, you need an AI model to predict how good a protein is for that. Then, you need a way to generate new proteins. And finally, you need to identify the most promising ones. So, let's start with the model. Microsoft Discovery trained multiple models and picked the best. And there's no out-of-the-box agent for that. But that's okay. If Microsoft Discovery does not find an agent for a task, it will create one on the fly, which is pretty cool. So, here's all the files that it created. This one here is the YAML for the agent. And this one, for example, is the Python code to train the models. Now we need to generate candidates for new proteins. And that task requires a lot of compute. Discovery is integrated with HPC, so agents can use it for complex simulations. You can see the process here. It started with a seed protein, and then it created variations by replacing small segments. You can see those segments there. Then it applied the model from before to see the
Awesome.
variation helps or not learning in that process. This is done millions of times in multiple jobs in parallel, exploring a huge tree of proteins. The result is 80 proteins that are ready to be sent to the lab for testing, which we said it was like deploying software, right? The problem though is that creating a protein is a little bit more complicated. The most common way is inserting DNA into bacteria, so the bacteria create the protein for me. So Discovery created another file, this one here. This file contains all the DNA sequences to create each protein. I can send this now to a lab, create the proteins, and test them. Or I can go one step further. If I have an automated lab, I can integrate it directly with the agents. Let's do it. So let me go back to the session, and let's just submit job to lab. Go. This will use a custom agent that is sending instructions for the lab equipment. And this is very real. Cambridge Consultants does have an automated lab, and I have it right here. So this is the application controlling the lab. It has a copilot interface, so the scientists can interact with the lab to design experiments, which is, it feels like being Iron Man, but for chemistry. In this case, Discovery is submitting the job. You can see it already here. But remember, you need to grow the bacteria, so this will take some time. So let me open a previous run. And there you go. These are all the steps that the agents are doing. Most of them completely automated with human supervision. How cool is that? This is bringing together the physical world and the digital agents in a unified discovery loop. And this was just one example of what Microsoft Discovery can do. Customers across industries are using it today to embrace a new era of scientific discovery. Thank you. Back to you, Sati.
Thank you so much, David. Talking about scientific discovery, we're also continuing to make rapid progress on our long-term goal of building a scalable quantum computer. We announced last year our first QPU. We created a new state of matter that was only theorized 100 years ago, and we proved it out that it exists. Our vision was to take a very radically different approach to addressing the fundamental barriers to building a scalable quantum machine, which is all about reliability, speed, as well as size. Since then, we've continued to make progress across the full quantum stack with both our academic and industry partners. In fact, in Q North, we will have a quantum computer powered by atom computers, natural atom computers, with our stack in there. We're also working with Algorithmic in Columbia and ETH Zurich. And we ourselves, in fact, use this discovery agentic loop to accelerate the work in quantum, compressing years of research into this last year. And today, I'm really thrilled to announce Majorana 2. And so this is Majorana 2. Majorana 2 implements the next generation material stack that we use Discovery to discover and build and help fabricate. The resulting qubits are exceptional.
Majorana 2. Stack, 20-second mean lifetime, 1 millisecond operations, 1/100th of a millimeter. Okay.
Reliable and capable of maintaining their state much longer. While other common approaches deliver a lifetime of just microseconds or even milliseconds, Majorana 2 provides qubit mean lifetime of 20 seconds or up to even a minute, essentially 1,000 times higher than what we were able to achieve in Majorana 1. And the operations, and this is so key, operations in Majorana 2 are 1 microsecond, enabling pretty complex quantum computation in that lifetime. And all of this in the same qubit form factor of Majorana 1, in 1/100th of a millimeter control, all digitally, which is again a super important aspect, making it all possible to fit 1 million of these qubits in a chip smaller than a credit card. It's this combination of the reliability, the speed, the size that makes the topological approach so unique. With Majorana 1, we had proven out the foundational physics, and with Majorana 2, now we begin the engineering scale. But ultimately, it is never about tech for tech's sake. It's about tackling those pressing challenges of people and planet. It is also the fundamental point of this conference. The question is not whether you can build the next great model, the next great platform, or even this quantum machine. The question is, how do we build this frontier ecosystem together? Because there are really two stories people can tell about this moment. One is that technology concentrates power, reduces human agency, and leaves the society to absorb the consequences. The other is that we use this next wave to unlock opportunity for developers, scientists, enterprises, and every community. And our job is to make the second story true. That's our North Star for the frontier ecosystem. Let's all go build together. Thank you all very, very much. Thank you.
This is one of those rare moments when something that once felt beyond imagination suddenly feels within reach. Quantum is our most fundamental physical theory. It's really the low-level operating system of the real physical world.
For quantum computing to deliver real-world impact, it has to be both reliable and scalable.
Reaching quantum at scale will allow us to take a more direct approach to solving problems in chemistry,
The discovery of new materials,
life sciences,
the way in which we bring drugs to market. It opens up millions of possibilities. Quantum will change the world, and this change is just beginning to happen.
Good keynote. They covered most of the parts that I was wanting them to because of the things that we have been hearing about them, about Microsoft and the things that they're producing. But still, like during the next days, the presentations that they will be giving, it will make things clearer. And these are the chapters. So Grafin, Agent 365, M-Dash, multimodal agent security. This was all in all very good. Well, let's see what is the live coding 8-hour 52-minute.
I'm working on Caduce, which is a company to make better insurance reimbursement documentation for healthcare providers.
I'm working on Grata Health, which is a telehealth addiction clinic that leverages agentic AI in order to increase quality of care.
The mentorship call with Satya was one of the biggest things in helping us determine how exactly we wanted to enter this healthcare space.
I think the big thing that the competition taught me was just exactly how to scale up systems and deploy them.
I hope that this year's winning team gets at least as much out of this Imagine Cup and Microsoft Build experience as we did.
The entirety of the startup and tech world is right there for you to meet, so let's really take advantage of that.
Please welcome software engineer Donna Sarkar.
Hello, Microsoft Build. Who is ready to have a good time today? Everyone. Thank you so much for being here. All right, so let's do the most exciting part of the morning. For 24 years, Imagine Cup has been nurturing founders by bringing together the skills, the support, and the ecosystem they need from cutting-edge tech to global connections, which influence not just what they build, but who they become as founders. This year, along with Microsoft for Startups, their journey was shaped by our partners at GitHub Education and Replit. They help their founders build and ship with intention. Our founders were also matched with industry-leading mentors who scaled products and companies and brought their expertise to support them. 3 startups out of all of them rose to the top from over 1,000 submissions, and they pitched to an incredible group of judges. Our judges this year were Dr. Irina Raiku, who is currently building 2 AI native ventures as a solo founder. Bakari Brock, right there, who's the general manager at Microsoft for Startups, where his team builds and scales partnerships with top venture firms. And third, Taya Mervold, who's a third-time founder and an advocate for women and diversity in technology, along with inclusive and ethical AI. So what's at stake? Right? What's at stake? All these founders have been competing because the grand prize is going to be $100,000 and a mentoring session with Satya Nadella himself. So with that, I'd love to introduce you to the 3 startups who've progressed the Imagine Cup World Championship.
What inspired me to create Copy Flag was when I experienced copyright infringement firsthand as a small independent creator. I realised I'd lost about £70,000. Copy Flag's an AI-powered platform for independent creators and small business owners to detect copyright infringement that's been modified using AI to make it more difficult to detect. It searches across the web for matches or copies of their work and allows them to take action to remove it from online sites. As a result of being successful in taking down content, Copy Flag is also susceptible to fraudsters. So as part of that, we now verify who people ask who they say they are and that the content they upload is owned by them. I think generative AI is such a powerful tool, and I'd really like to see it used as a force for good, so small creators can fight back just as hard as these huge corporations.
Currently, the world does have a food problem, but it's not that we're not making enough food, because we are. It's just not going to the right places. Overall, we hope to improve these supply chain distribution systems so that food can get routed to where it actually needs to be routed. SpoilSafe uses sensors and AI to predict food spoilage before it happens, and this helps operators intervene across the supply chain.
What we're trying to solve is not only reducing food waste on an environmental and monetary scale, but also bring in actionable insight for these warehouse and distribution companies that inventory managers and supply chain operators can use in order to better manage their food inventory and not only prevent spoilage, but help distribute that out to the right retail store or grocery chain.
The vision for SpoilSafe ultimately is eventually bringing this to consumers, because we feel like that is ultimately what will solve like this worldwide issue with food spoilage.
More than half the people going through physical therapy never really get better. You're able to recognize frustrations on both sides of this marketplace. There were patients who wanted care and couldn't get it, and there were providers who felt like they were doing work that could be automated. Revore Health is a platform that connects anyone who's injured with a specialist physical therapist in minutes instead of months at half the traditional cost, while providing support every step of the way. We make that matching process as seamless as possible, but also deeply personalized for both the provider and the patient. If you have any kind of disability, we have a way to meet you where you are, whether it's speaking a foreign language, whether it's gesturing, pointing, voice, text. We save physical therapists a ton of time across all of their workflows, so they can spend more time providing high-quality care and getting people to recover.
Okay, who's ready to meet the Imagine Cup World finalists? Yes?
These are some of the very good ideas and that people have built upon.
Let's see what they built. Come on out. All right. Shall we talk about what they built? Okay. So first up, we're going to come to you, Copy Flag. Patrick, please tell everyone what you built. You ready?
I'm ready, let's do it.
All right.
Generative AI has made IP theft scalable. Copy Flag is the AI defense layer for creators. Simply upload your content and Copy Flag gets to work, fingerprinting, indexing, and searching online for copies of your content. Once uploaded, 5 signals run in parallel, such as AI remix detection, semantic checks, and background swap. Above 0.9, we recommend a takedown to the user to remove the content. Let's see how that looks. In our alert center, you can confirm as a copy and send a takedown straight to the source to remove the content. Now let's look at Horizon, our predictive engine. This uses product history and seller data to predict who, when, and what the next likely copy will be. Now let's go to repeat offenders. This shows a relationship map based on previous cases and allows us to take bulk actions, such as removal, monitoring, or escalation. From reactive takedowns to predictive defense, Copy Flag makes AI the defender for creators.
Amazing. Thank you. As a fellow creator, I thank you for this work, and so do our incredible group of creators right here in the front row. Thank you, Patrick. All right, next up we have SpoilSafe. Rohan, please tell us.
Yeah, I'm ready.
Ready, let's go.
SpoilSafe is a predictive decision layer for freshness and supply chains, combining low-cost sensors with intelligence. This is our main sensor pipeline, operated by an inventory manager at a warehouse. Our sensors are continuously collecting volatile gases, temperature, and humidity from the storage environments and populating this in real time. Let me put in strawberries as a food type, and let's press get decision. And what you get back is an automated time to spoilage prediction for exactly how long that batch has left, in a clear decision, in this case to keep it on the shelf for a few more days. Then, going over to our main sensor dashboard, you can see all currently active sensors. Another way we can analyze is utilizing the compare feature. We have 2 piles of strawberries stored under different conditions, and hitting compare, we can see that our models are predicting very different outcomes. Batch A has over 3 days left to stay on the shelf, while batch B is already down to 21 hours, so our decision engine flags this for discount immediately. SpoilSafe is cheaper to deploy every pallet, fully automated, and provides a decision output that tells operators exactly what to do. Thank you.
Amazing. Thank you. Hardware, software, sensors, AI, no big deal. Incredibly complicated. Thank you, thank you, thank you. And now let's hear from Revore Health. Tell us. Sorry, are you ready? Okay.
Revore Health is a platform that makes physical therapy more simple than ever. First, you tell our AI agent Clara about your injury, and we can find the perfect physical therapist for you. No more long wait times. In just a couple clicks, you're well on your way to getting the care that you need. Now let's fast forward and imagine that you're recovering from a knee injury, and it hurts while you squat. Clara is able to surface personalized insights that help you understand exactly why you're feeling your pain, like you would see in this model right over here. Then, it's as simple as setting up your phone and talking to Clara about what feels wrong, and she provides empathetic support.
Hey Clara, the abs of my knee right here hurts while I squat. Sorry to hear that, Surya. Tell me more about what it feels like, and I can help reduce the pain.
But we didn't stop there. This recovery insight is then sent directly to my physical therapist, and you can see this insight from Clara here that tells them what I've been struggling with, and even recommends a solution. In a click of one button, they can update my care program to add clamshell so I don't feel that pain again. With Revora, we provide instant access, affordable care, and continuous guidance.
Incredible. Thank you. Who could have used that for a knee injury or two back in the day? Yep, that's right. So you've all seen what these amazing teams have built, the architecture, the AI choices, the demos, that hold up on a pretty big stage. But behind every product you ship has a story underneath it. To explore that side of the journey, I'd like to introduce someone who's seen up close how founders make the commercial and technical decisions that tend to matter the most. Please welcome the Vice President of Microsoft for Startups, Hans Yang.
Thank you. Thanks, Donna. So the best part of my job is drawing inspiration from student founders who are wise beyond their years. So let's take a peek inside the minds of these incredibly talented founders from this year's Imagine Cup finalists.
Surya, you first, please. Trust is the currency of healthcare, and it typically takes years to learn. You're a grad student, and you're already running pilots in clinics across multiple states. What's the lesson there for developers who feel like they're targeting an industry that isn't ready to let them in yet?
I mean, you're spot on about trust, Hans. What I've learned from my experience is that trust, especially within healthcare, is actually built from the ground up, not the top down. So when I started, I built validation cycles directly with physical therapists and clinicians, and I was iterating every single day. And what I've realized is that breaking into an industry isn't about having the best credentials or years of experience. It's actually about earning the trust of the people who feel the pain the most. And so to my builders and founders out there, my advice to you is simple. Build with genuine curiosity and deep passion, and build alongside the people who can help you shape the future.
That's great. Co-design with your customers to build trust. That's great advice for a founder in any industry. Next to Vika Rohan. Vika, so after 50 customer conversations, one food safety director stopped you in your tracks with a single sentence. She said, "We don't need more data, we need actions." So how does a founder know when they finally heard the insight that inspires a pivot?
Honestly, you know because it reframes everything you've already heard. We'd experienced versions of the shared sentiment across dozens of interviews, but it felt like separate problems to tackle. When the director said it clearly, it clicked. That's when we knew it was real. Not when the feedback is surprising, but when one sentence suddenly explains everyone else. That understanding completely changed our conversations. Instead of selling visibility, we now sell confidence.
I love that. That pivot from selling information to selling outcome. That's fantastic. I also understand your mom is out there, so do you want to wave to her really quick? Hi, Mom. So Patrick, you have a great story. Well, maybe not great. You lost 70,000 pounds of your own money to a problem that didn't have a solution yet. Creators are having their content copied or stolen, so you decided to build one. What convinced you to go from a victim of a problem to the builder of a solution?
So yeah, unfortunately, it cost me £70,000 to really understand the problem. My designs were copied and resold, and then the insight hit me. Creators and brands are losing money to copyright infringement they can't even see. Detection tools exist, but AI-modified copies slip right past them. So instead of waiting for someone to build a solution, I built Copy Flag. This allows us to turn an invisible problem into a visible one.
I love that point, turning invisible problems into visible solutions. That's great. That's a great way to describe the vision that all the best founders have. Thank you. So each of you provided such amazing insights for all the founders out there, and I really want to thank you for sharing that wisdom. It's so clear why you were selected as finalists for this year's competition.
It is so awesome to see how these founders have grown through their Imagine Cup journeys and all of the incredible support they've received from Microsoft startups and all of you, their broader community. Thank you to all of the mentors and coaches out there. We appreciate you so much. I think it's time to move on to the final stage of the competition. Y'all ready? Yeah. Hans, you ready to announce the winner? I didn't look.
I didn't look. Okay. Are you all ready? Okay. All right, let's do it. Okay, let's see. These three startups have all built with real ambition, skill, and heart. And getting this far, this is already a win. But today, only one of you can be named the Imagine Cup World Champion. And this year, this is a surprise for all of you, Microsoft is backing you more than they ever have before. And so as a surprise, the grand prize is going up from $100,000 to $150,000. So the 2026 Imagine Cup World Champion is Copy Flag. Congratulations.
Right. Good morning. Morning. It's fantastic to be back in San Francisco at Build. It's always fun to be at developer conferences at times of great change. You know, developer conferences are always about understanding tech shifts, understanding the new stack, but it's also about really coming to. We are also announcing two very cool new models that are all
4 million tokens.
Me while I'm away from the PC.
Azure or built with any framework. AI.
Let's graph internally, bringing together public scientific literature and internal knowledge. This is a great.
Please welcome Swix, Saragoa, Aladgil, and Chairman and Chief Executive Officer of Microsoft, Satya Nadella.
Hello, sir.
I'm so excited to be here. Welcome to a crossover episode of No Priors in Lane Space with Satya Nadella. Congratulations on an amazing build.
No, thank you so much, and it's great to be with both of you. I listen to both of you, or both the podcasts all the time. It's great to be on it. Thank you so much.
So you're just talking about these amazing announcements from across the Microsoft estate all morning for I think 3 hours. What is what's the most important reflection or takeaway you have?
I'd say there are, perhaps the biggest one for me is
let's sort of conceptualize this more as an ecosystem play as opposed to a single model or even a single platform, right? I mean, yeah, whenever, at least for me, having grown up at Microsoft, having seen whatever 4 major platform shifts, I sort of fall into that camp where a platform is defined by fundamentally its ability to create more value about the platform versus what's captured in the platform. And so if you view what's happening right now, I think this morning's keynote was, how can any company, whether it's an AI native company or a traditional enterprise company, participate as a first-class participant where they can point to AI they created, right? It's not that they don't use other people's AI. Of course they will. But to me, what's the path? What's the recipe? How do I do it? What does the stack look like? What does the tooling look like? What is valuable? How do you do that? That's it. That's sort of our job to do. Yeah.
Ecosystem strategy is very complicated, right? Because you end up building certain components, partnering for certain components, supporting them. You just announced this big suite of models. Like, tell us a little bit about the training strategy for Microsoft.
Yeah, so the thing that we wanted to do with the MAI models was to build, and as Mustafa talked about, first of all, a great lineage, right? Starting with pre-training, with very good data quality, doing all the ablations, making sure, because in some sense it's become even harder to build a clean lineage model, just because there's so much stuff out there that you truly need to ablate out to be able to have a fantastic pre-trained model. In fact, that's one of the challenges of a lot of the open weight models is they look great on one benchmark or two, but they're not great on practice. So that's why, in fact, even our FDEs are pretty gone really excited about these MAI models, because how the heck can a small 5D model hill climb? And it goes back a little bit to what I think is ultimately the key thing to do, which is try to pursue finding that cognitive core. So to me, starting with a clean lineage, then creating that ability for companies to be able to use this, right? Not just as a generalist, but to create their own specialist by building this hill climbing scaffold around it, right? So it's not just a model, but you have a hill climb scaffold around it, then you will start building your RLE. You will start collecting the traces. Most importantly, you'll have private evals, because we know all the evals out there are good, interesting, but they're not really that critical at this point, because they all can be maxed. And so the point is each company will have its own private eval. And so that end-to-end platform story around our models is sort of what I think is interesting. And then one of the things, Sarah, since you brought it up, is I do feel there's a new frontier. Like, people talk about the frontier, and are you operating at the frontier? Interestingly enough, if you add a little temporality to it, you can use, let's say, in fact, the Land O'Lakes demo we showed was pretty cool. We used whatever, GPT-5.5, right? Then you collected a bunch of traces, and then you took a 5B reasoning model and achieved higher. So that is another aspect of what it means to operate at the frontier.
Yeah, I think, I first of all congratulate you on basically building a front-end neural lab inside of Microsoft in 2 years. I'm wondering, you have all this AI strategy that you're rolling out. I'm wondering, what do you know now that you wish you would tell yourself 2 years ago? 2 to 3 years ago. 3 years for the Jensen partnership, 2 years for MAI.
Yeah, I mean, I think the thing that I reflect quite a bit, right, which is sort of, obviously I got into all this when I got excited by the scaling laws paper, and when even the OpenAI partnership came about, when those folks said, hey, we're going to really throw a lot of computer transformers, and they've helped. Right? The thing that I always go back and say, wow, these things do have capability that they're climbing up. I mean, this crude way of saying it is intelligence is log of compute kind of works. Now, what I think we underestimated perhaps is the real world complexity of deploying these so that they actually deliver the value in the real world, right? So the outcomes as measured by any benchmark is interesting, important, but the true eval is when people out there are able to do unique things that they only can value, and it's very measurable, right? That I wish we had sort of even had more in our consciousness, right? Which is as an industry, because right now I think when people say, wow, I don't want a token max, it's an artifact of us not having thought ourselves as an industry that we are using tokens to create value every step of the way. So I think that's kind of what I wish we had gotten there, but I'm glad we are here.
What are some of the use cases that you've seen that have created the most value for your customers? Because I know that people talk a lot about code, and I think it's pretty clear that that's something that's having very large scale impact. Are there other areas that you find in common that your customers really benefit?
Yeah, I think, to your point, obviously coding is now but it's interesting, by the way, like, to even talk about the coding, right? Which is, coding has worked so well that we now have to rebuild the IDE, right? I mean, it's kind of nuts to see what we launched. It's like, oh my God, I have these 100 agent sessions. The cognitive load it transfers back to me as a human is so excessive that now I need a new UI. And oh, by the way, the chat as the only artifact was also impossible, so that's why we need a canvas. So it's kind of interesting for all the things about where is software needed or where is UI needed. You kind of need that even for code, right? In a fully agentic world. But that said, one of the things that we're starting to see, we start seeing with co-work, but even some of the work we showed with autopilot, right, on what you see with Clause, is a good one, because if you sort of think about a lot of human capital is doing the glue work, right? If you now can augment that with tokens / agents that are long running, durable, right, then your ability to scale, even what is still judgment and glue work, gets amplified like coding does. So you can, I'm positive that 6 months from now, we'll all be saying, oh wow, like all through the night, there was a bunch of stuff that all these autopilots that I have working on my behalf with my delegated authority, so to speak, right? I can sort of given even my identity, did a bunch of work. Then of course I'll need my new ADE to say, what did you do? Like, did I do this work and so on. So I think that's where compressing of workflows, completing of tasks, that's where I think a lot of the value gets created.
I think you raised a really interesting point, which is there's the actual agent that's doing the code, and then there's a harness around it. And that's the environment, that's the context, that's everything you're setting up as a developer around actually a coding agent. What is the harness for the enterprise? Is there an equivalent concept for broader productivity work, or how do you think about that concept sort of?
That's right. So in some sense, you kind of want the harness to define the models, the data, and the tools, and so that you have a loop across those three. And so what we're trying to, first of all, make sure is each of our products that we build, right, whether it's GitHub Copilot or the security Copilot, the stuff we showed with M-Dash, or even the discovery for science, it doesn't matter. All of them are multi-model harnesses with tools access, so that you can do this progressive disclosure of tools even, so that they're token efficient. And then you're feeding it with very rich context, because that's sort of the other hard lesson we've learned in the last 2 years is, oh my God, the amount of work you need to do to prep the context layer such that your plan can execute in the most efficient way is where the magic is. So we have, in our case, we have the GitHub harness, which essentially we're using across all our products. It's available in Foundry, and we're open, like you can use your Llama harness, whatever, or you can use the any open harness or any harness of yours and train with your tools and multiple models and your context. And so that's the pitch. Because right now a lot of dialogue is, hey, if I train the harness plus tools and the model together, you get evals. And what we're proving out is, and the best example of that is what we did with M-Dash, right? Because when it launched, it found bugs or vulnerabilities that were not found by Mythos. And so there is existence proof, I would claim, that you can have a multimodal harness that can in fact be more performant in the real world.
So a premise behind the training at the independent frontier labs is really, we're going to have these models, and we'll have an API business, we'll support enterprises and startups, but a first-party product, be it productivity or code or search, drives the majority of revenue. That's a different value equation than you're describing, I think, with the Microsoft ecosystem. If that's the case, tell me if it's the case, because obviously you have first-party products and you have enablement products. What is the role of the developer? Like, what's going to be hard and the set of skills and value capture the developer has in that world?
Yeah, so I think that there's always going to be the case that someone who's super successful as a platform builder can also have first-party products. It was true with Windows. It was true with the SaaS side and the cloud side as well, with us and others and so on. But the thing that is it should not be a limiter to other people achieving that same success, right? That I think is the core difference, which is the network effects this time around intelligence are such because they learn from data and not really lots of data. It's just a few samples that you have to see to understand what's novel about something. So that's why the game becomes how to protect. So that's why I would say every company having private evals may be the biggest IP, right? I think about it, like what's that private eval that you can then use even a frontier model to hill climb on and not leak the traces? Maybe one of the biggest drivers of IP. Like, so in other words, another asset test is you have an eval that's private. You're using a model A. Can you switch it to model B and climb up? If you can, then you're in control. If you can't, you're not in control. And that's where even the harness decision becomes super important, right? So therefore, having an open harness, letting all models come in, having your evals, your context, your tools help you hill climb, I think is the skills that an AI native startup needs, a SaaS company needs, or every enterprise needs.
Yeah, I think in a very real way, you are Microsoft historically as an operating systems company and then becoming a cloud company. Maybe like the third act is that you're a harness or evals company, whatever the sort of conglomerate of concepts that you want to put together. And I think like enabling every company to have like frontier intelligence or whatever the exact term that you use is the mission, right? That is the platform promise that you build with us. You will get your intelligence for your data.
That's it. To me, that is if there was one tagline for this entire developer conference is, can everybody operate at the frontier with their frontier intelligence, right? To me, that is so important because otherwise, I don't know how you achieve stable equilibrium, right? Which is, how do I then go and say, well, my company is going to have a terminal value because I now know how to continuously compound on top of what's a platform that gets better, right? So when like Windows obviously came out, Adobe built, Autodesk built, or even like take what Jensen said. We built DX, and he built, CUDA on top of it. Right? I mean, I always say to Jensen, God, I got the short end of that, but I wish we had recognized it. But nevertheless, that idea that you can build a platform layer that someone else can then extend out and build their own intelligence layer, in this case, I think is everything, right? Without it, why have a developer conference? I can just come and have you all sort of just worship at the altar of one model. Yeah. That's not a developer conference.
Backstage, we had a discussion about what is IP or what is the value in the company. It used to be the length of human experience at the company. And now it's this other thing, which is the evals, the experience in sort of applying agents to the company. I just want you to flesh that out a bit, Marcus.
Yeah, it's a great way to frame it, right? Because at the end of the day, every company is going to have both the human capital that is still going to be super valuable because humans and their ability to find the gaps that exist at all times is going to be the way we all will create value, right? I mean, so I'm definitely in the camp that this is going to be about expressing new forms of human agency and ambition, even as token capital goes up, right? So let's say any corporation has lots of tokens and a lot of human capital. The question is, how do you compound the two? So if you have if you take in teams, I have a bunch of agents doing work and a bunch of humans doing work, and the traces between those, that is really important context of how that enterprise is creating value. Then that goes back to train, not a generalist model, but to train the company veteran agent, right? That is super valuable again, right? Which is when a company goes says, it should in fact go onto the balance sheet, is how I think about it, right? That's what, in fact, there may be, like human capital was never possible to go put on a balance sheet because you didn't know how to capture the tacit knowledge, whereas now I think you can, with the agents that have learned through time, through all the traces. So that's what at least we think will happen.
I think the SEC is going to have to have accounting standards for token expertise.
You're talking about the equilibrium state and a stable equilibrium where companies have this compounding value and can see terminal value for themselves. Another challenge to the considered equilibrium of, okay, there are applications and workflows that are sort of common to a vertical or horizontal, and this was like the generation of SaaS companies, and Microsoft has lots of SaaS properties as well. And then there are things that are very specific to every enterprise that they're differentiated against. I'm sure you've heard much and participated much in the debate about the end of software because all these workflows are cheap to generate now. Do you think the equilibrium looks different between what agents get built in enterprises versus in their vendors in the future?
Yeah, so I think what's happening there is we had a particular way we captured, I would say, workflow in apps, right? Because we built a data model, right? We schematized some part of some business process. We then built a bunch of business logic, and then we put a bunch of UI on top of it, right? So that's kind of what every SaaS company.
And a little configuration.
So like 20 years,
right? And that was it. So interestingly enough, now you kind of get to relitigate that vertical stacking, right? So I still think, for example, that data model that you built underneath every SaaS application is super good, right? Like why reinvent it? Like my general ledger better be a general ledger. I don't need new schema creation. In fact, that entity relationship is actually a pretty good, robust thing that I want to feed.
And you want to be stable.
That's right. Yeah. Then same thing with business logic, right? If you look at, we have this product called Power BI, right? It was like dashboards galore people created. The beauty underneath that dashboard is a very rich semantic model, right? Someone took the pain to create a dashboard and do all the measures. And you want that, that's business logic, right? I want that to be available to me. So I think the challenge of the SaaS business model is we packaged one way. We now have to learn how to unbundle these things and rebundle in new ways and discover new business models, right? I mean, if you look at it, what's happening today with Microsoft 365 is a great example, right? We have this thing called Worklog. In fact, like what we're realizing is, oh my God, like if you look at, in fact, there's a historical parallel to, right? We sold first Exchange and SharePoint and, before Teams, we had a thing called Link Server and what have you. And we thought, oh, that's all going to move to the cloud. But literally we realized that the number of people who will use servers in the cloud is 10x, 100x, right? Because people are not buying servers, they're just buying a subscription. The same thing is now happening with M365 because with WorkIQ, we have exposed what was perhaps the most important database in a company that never got used as a database because it was only captive to our apps, right? It was email operated on it, Teams operated on it, Word, Excel, PowerPoint, SharePoint. But now, like this is one of the coolest things I get to do with WorkIQ. I go to a GitHub repo and I say, hey, I attended a bunch of design meetings last week related to this repo. Can you capture all that and tell me what changes I should make? I mean, think about that, right? It literally can go look at all those transcripts, come back with a plan to change a code base, right? Previously, you could never have thought of using M365 for something like that. So the value creation opportunity now in the agent world is in fact 10x more. But it does require us to have, for example, there's going to be usage around M365, right? Which is going to be perhaps more than even the end users. And we have to even re-architect. Like in fact, like what I used to serve an inbox or a mailbox cannot be used to serve an agent. And so that's sort of what we're doing.
I don't believe in like permanent business models for any of these domains, but in the near term, do you have a prediction between outcomes-based pricing, token-based pricing, enterprise bundles.
Yeah, the way I think about this is always we've had, like, let's even take the per user pricing. The per user pricing is really an artifact of someone creating a budget needing certainty. Right? Because it's the most important thing. Like somebody wants a budget, they need a per user. And per user is just a set of entitlements to usage. Right? That's kind of what it is. And so the way is the first bundling will be take some usage, bundle it into per user stacks, and then sell subscriptions. So subscriptions I think are going to be there, per user is going to be there. Then the next big thing will be consumption. So people will say I want consumption. And it's also possible that people will say I don't even want to pay for any of the subscriptions or the consumption's outcome. But remember, most people love outcome until they have an outcome. Because once you have an outcome, it's like giving away royalty, right? I mean, like, I've talked to customers who love, outcome-based pricing. I say, I'm all in until they, oh my God, like, what are you talking about? You're sharing in my outcome? No, I want you to go back to per user pricing and I want you to consumption price, right? So I think that debate will go on. And all of these business models have a particular time and a place versus one to rule them all. And if anything, if you're a SaaS vendor or you're a platform vendor, having that flexibility, and quite frankly, we face this with GitHub, right? We just recently announced a per user pricing on GitHub. Because GitHub Copilot was constructed at a per user level before we understood even the intensity of usage of agents, right? It was an interactive way for a developer to use code complete, maybe tasks. It was not like, oh, I launched 10,000 agents that are going on all day, right? So that is what the adjustment is about. So now that we really want, there will always be a per user, but there will have to be a consumption meter.
How do you think about the durability of SaaS more generally? One thing I've observed is in a lot of enterprises internally, there will be teams that almost have agent euphoria. They're so excited about the explosion of things they can build that they're trying to rebuild a lot of applications or going to their SaaS vendors and saying, we're not going to work with you anymore, or we're considering an internal project. And it seems like in 6 to 9 months, maybe some of those people will come back and say, actually, we can't rebuild everything. How do you think about what's durable in this world and what isn't?
I think we have to go through one full budget cycle on this to really see the emergence of equilibrium. Because at the end of the day, there's marginal cost to even generating the app, right? In fact, it can be even a simple way to say it, like if you should always acquire something if the marginal cost of building and maintaining something on your own is higher. Right? That should be like it's a quantifiable, right? A quantifiable thing. And the maintenance part is important, right? Even like you got to remember, like, hey, all the security stuff that now AI will find, you better fix them too fast. Of course, there's a coding agent to help you with, but then that burns tokens, right? So whose responsibility is it? It's kind of like a cycle that you've got to think through. And I think we have gone through the excitement that I can generate a lot of software. I think the next thing would be what software do I really want to generate? What software do I want to use from others? How do I compose these two into some agentic workflow that I have agency over, right? Because I think there'll be very little tolerance for anybody who's inflexible at the vendor level. But at the same time, I think that anyone who has got that flexibility, shows up, delivers the value, will be back again, right? We're selling software, but with just different business models, in fact.
Speaking about building software, one of my favorite moments from I think a previous build, maybe 1 or 2 years ago, was there was a section of you building your own software. I'm curious if you're building anything now.
Yeah, so I think that, first of all, let's face it, right?
So this reason by by Satya Nadella was quite good at trying to figure out how your agent should interact with the models. Let's continue off the query by...
Right, building software has made it possible for even the incompetence of a CEO of a company like ours. You can build, so thank God. But that said, I do feel that something like GitHub Copilot to me, and especially the new Sessions app or the new app, has just made it so much more possible for you to have agency over artifacts that you felt you couldn't touch before, right? So for me as a CEO, even to go to a code base, to be able to learn about it. Like I remember joining Microsoft long back, first, and then you say, man, everybody had to go in and look at, whatever, Cutler's Malloc or what have you to learn how to do good C++ code. So now that ability to be more full stack up and down is so good. But that doesn't mean every one of us should be doing the same thing. The question is, how do you then have the ability to inspect things, learn things, see things? I think it's just so much more. And so to me, what I'm building a lot of is these long-running Foundry agents, right? So there's autopilots. So the easiest thing is, to me, I think I just built one even last week where the idea was, hey, can I have an agent that is continuously monitoring essentially my own chief of staff autopilot, right? We're going to have that obviously in Scout. That's what we showed. But it's so easy and trivial to build. I took WorkIQ. I said, take WorkIQ, go and build a Foundry long-running agent, store all the memory in using Rayfin, right? Basically at my backend as a service. And lo and behold, it built it. And not only built it, I could say publish to teams, and it published the damn thing to teams. So the ability to have some end-to-end project like this complete is just pretty miraculous.
How do you think that impacts the different types of engineering roles that exist in the future? Because right now I think there's a dozen different types of engineers that you can be, from QA, front end, et cetera. There's a big swath. I've heard some people argue that in 4 or 5 years we'll basically end up with 4 engineering roles. It'll be people who are managing agents, it'll be 4 deployed engineers or FTEs, it'll be security engineers, and then people working on large-scale infrastructure for a small number of services, and then everything else just collapses into the agentic world.
Yeah,
I think that's a correct view of the world.
Yeah, I think we'll have to experiment our way through it. But what you said is there are some very at-scale things. At LinkedIn, they did structurally change and it basically built up a new discipline called full stack builder, right? So they went and said, hey, let's bring people from design and product management, front-end engineering, all put them together, but also have an edge, right? It's not like the design person still doesn't have the design edge or the front-end person doesn't have the front-end edge, but you can give yourself bigger scope in roles so that you're not confined to one role. And then equally, infrastructure has become very critical, right? So in other words, RLEs, one thing we've realized is, even for the Excel team, for example, building the RLE in which a reward can be learned is actually one of the hardest sort of infrastructure problems. And so you kind of need even new talent, right? Distributed systems people, even in what was considered an end-user app team, because it's a different skill set. So yes, infrastructure science is the other one, obviously. So I think we'll see how these evolve, right? Where's the real, always the world will have a bunch of specialists. I think the generalist role is going to be the most exciting, right? Because the leverage of a generalist is where we're going to see the maximum returns, right? When you say, hey, are you coding? I'm now I basically translated knowledge work, right? Which I did, where I created a Word document or a spreadsheet or even, and now I can build an app. right? It's in the same sentence, right? That idea that, oh wow, my generalist skills have gotten higher leverage, I think is what we're going to see across the board.
Music to the ears of CEOs and VCs are like a little dangerous at a lot of things.
Idea people.
Idea people, yeah, a lot of agency. If you take an idea of personal agency and you just zoom it out to the organizational context, my partner Mike Rinal, who actually started his career at Microsoft, just wrote an essay where one of the big takeaways is it's an age where you can be much more ambitious, and you need to be given the pace of the environment and how quickly actually users and companies are open to adopting new technologies. How do you think about? I feel silly asking this of somebody running a $1 trillion plus company already, but how do you think about how Microsoft can be more ambitious now?
It's a great question. I think that the thing in these type of transitions is to have a conceptual model of how work can change to go after outcomes that you could hardly imagine previously, right? In fact, Kevin Scott has this nice line, right, which is when you can make the impossible, like when you're making hard things easier, that's sort of one point of leverage. But true ambition is about making the impossible possible. So now the thing that is missing a little bit in all of our organizations is what is that new conceptual model of what can we build? What was impossible and what can we build? And I'll give you one example of this, right, which is I take great inspiration from sort of the people who were managing the Azure network. And they came to this is from even last year. We were scaling. You saw that I talked about sort of how we built in the last 15 months more Azure capacity than we built in the first 15 years. I mean, it's crazy,
wild, yeah.
Right? It's pretty wild. And it's the same team. So they saw that and they said, "But this just ain't going to work if we don't reconceptualize our work." So they built. Essentially, they said, our job is not to do Azure networking. Our job is to build the agentic system that does Azure networking. Right? These are the folks managing the 500 plus fiber operators managing the WAN, right, all over. And fiber operations ultimately is a physical operation. Things get cut. Things get have to be repaired. We have fancy words called DevOps and so on. Basically, emails are coming in and you got to go respond to them, take care of it. So they built this agentic system. They even have a character for it. It's called Miles, and it sort of does all this stuff. Right? They started sort of screaming for more tokens and so on. And so they were saying, look, we don't need headcount. We need tokens in order to be able to manage our operation. That reconceptualization of what their work is, right? They basically took their work and made it meta. Right? That meta work is now their new work. Right? In the 80s, if somebody had come to us and said, 4 billion people are going to get up in the morning and start typing, my model would have been, we need 4 billion typists, but we're not doing typing, we're doing knowledge work. So that to me, I think is it, right? Which is, whether it's Microsoft or whether it's any organization, is to give ourselves permission to do new types of metacognition, meta work, using these new tools to change the outputs that matter, and then really make the impossible possible. So completing that dot, or the connective tissue across those, I think is where a lot of the enterprise value will get created.
We talk about data centers? Yeah, please ask. Oh, okay. Well, this leads nicely into the data center build-up. I would say I'm just impressed with the sheer scale of the build-up from Microsoft, but also everyone else. That this is redefining what it means to be a hyperscaler. And I just feel like that is unprecedented scale on finances, on the way you run the company, but also the communities that are impacted. Let's just talk a bit more about what you're seeing on the ground, like when you visit your...
Yeah, I think there are two aspects of it. Obviously, the build-out is extraordinary. Nothing like this has happened, and it's great to be one of the participants in it. But you brought up the other part, right? I think at this point it's clear that unless we as an industry are very principled about ensuring that the benefits of all the stuff we're talking about are felt in real ways at the community level, right? Because this is not just a campaign, right? It has to be real, where people are saying, look, this is not changing the prices on energy for me. In fact, if anything, it's bringing down prices because long term there's going to be a better grid, there's going to be more energy. Water consumption is in fact not sort of, in fact, water is being replenished, right? You got to really educate folks on truly what's happening, the closed loop systems we're building. We have to invest in the training, the jobs, the tax base. In fact, the least talked about stuff is the amount of jobs that get created during construction, after construction, what's the tax base that's there in the community. And all this has to be real. And if that is the case, then we will have permission. If it is not, we won't have permission. It's as simple as that, right? Which is, I think we have to take it as an industry pretty seriously. I think it's good for communities to be skeptical, ask the hard questions, for us to do the hard work, earn that. But at the end of the day, if we can really be the producer, I've always felt like in human history, if you use a lot of energy but also create a lot of value for society, the story has been fantastic. If you don't do that, it's not been that great. And this time around, I'm a firm believer that ultimately, if you do have a token economy that drives productivity, that drives economic growth, that drives broad spread, participation, better health outcomes, then I think we'll be in a great place. And that's at least what we all have to be focused on.
Yeah, it makes me think actually that with all this initiatives that you're doing, maybe easier to see ROI in the communities first before in enterprise.
I think both sides. In fact, it comes back together. It has to be the people in the communities are going to be employed, are going to be participants in the real economy, right? That's I think the question is like if the broad economy is doing well and the communities are doing well, the dots get connected. It's sort of the market forces are such that we will connect the dots, and that I think is it. Like you got to be able to see the evidence. You can't be about any one company, but it has to be broad economic growth and broad community permission.
What are you most optimistic about currently, or what have you most updated your personal models on regarding societal impact of AI?
So you're saying what's what
have you updated most on in terms of societal impact of AI?
I think the most critical thing is the first question we even started with, which is we need to tell the story and make it real, that everybody has a real shot to participate as a first-class participant in this new economy. But that's kind of, I think, in the next 12 months, 18 months, we need a way for people to say, oh, wow, I get it. Right? There's going to be tremendous capability, tremendous amount of infrastructure, but I can see what's going to happen, whether it's the benefits like health outcomes, or my ability to create a startup, or my ability to run my local sort of store more efficiently. It's just happening, and I see that benefit myself. Right? That, to me, earning that permission in a path-dependent way, we can't wait. So the one thing that I've now learned is, I think the world is going to be very skeptical of tech and tech companies that say, trust us, we've got it, the future is going to be glorious. You kind of have to deliver tangible benefits. And frankly, politicians winning elections because they have advocated for that. That will be at least my adjustment. Because without it, thinking that somehow, because it's too important this time around, it's too much of the economy for it not to be the case?
So one very simple framework I have for what is going to be the broad benefit of AI beyond the communities just working in technology are sort of wealth creation. It's going to happen in a ton of different companies, startups and large companies. Then you have healthcare. You had amazing demos today. There are companies like Open Evidence. I think that is happening. Education seems like another one that's an obvious good, where we haven't seen as much impact as I'd expect. Do you have a hypothesis on why that might be, or if it'll come?
Yeah, I mean, I think this is where, again, how we think about education, how, recently I met with the founders of Alpha School and learned a lot about what they were going about. It is fascinating to listen to how to even rethink what does education really look like, because I think it's actually very important. And I'm not saying anything traditionally being done is less important, right? I was even looking at it's fascinating to see, I forget which Stanford class it was, the Asian guidelines for CS something. Because you still need people to learn. Like it was an interesting AI class that they were making sure people were learning how to apply softmax appropriately versus saying, hey, fix my training run. So I think learning concepts is important. It's going to be critical. But the way we create the incentives, what are the credentials, how we value those credentials, what is the employment opportunity for those credentials. So I think that there's a complete change that has to happen, given the way to get to information, way to educate yourself, way to continuously keep yourself updated has changed so much. So I think, interestingly enough, maybe the next big startup and success story could be someone who builds a new university or a new pedagogy even of how to get someone to go through a curriculum and find economic opportunity. That's highly valuable.
Well, that has felt perhaps impossible for a long time. It's a great note to end on and something that might be possible. Thank you, Satya.
Thank you so much. Thank you. I appreciate it. Thank you all.
Hey friends, I'm Scott Hanselman, and I'm here with Mark Rusinovich, who has absolutely no idea what is going on today. Have you been prepared or prepped in any way?
Zero.
Okay. Is your mic even on? Is it? It is on. So Mark does not know what's going on, and this is exactly how I like it, because he makes me uncomfortable on our podcast, Scott and Mark Learn To, every week. So now it's our turn to make him uncomfortable, because this is Scott and Mark Learn To Vibe Check. So here's the deal. Nobody likes AI slop. Nobody wants an AI to create applications that are not awesome. So we think that there are three kinds of applications. There's AI slop, there's vibes, and then there's AI engineering, proper AI augmented software engineering, which you're a huge fan of.
Definitely.
So what we've got here, my friends, is four wonderful creators from out in the community who have created applications, and in the style of Penn and Teller Fool Us, they're going to come up here, present their applications, show us how they made them. They're going to show us their code. We're going to judge the applications, and we're going to guess, is it slop, is it vibes, or is it AI software engineering? And it's going to be awesome, and the points don't matter.
And we can ask them questions about how the code works.
Exactly. We're going to ask them questions. We're basically doing live interviews on how they made their stuff, because we want to make sure that everyone is doing great work with things like Copilot, with things like Claude, with things like Codex. Can we make quality software, or are we going to be gaslit by the community? Are these people going to fool us? And we're going to find out. It's going to be pretty cool. We also have to thank our sponsors. We've got a lot of folks that put a lot of work into making things like this happen. When we have crazy ideas like this, it's our sponsors that make us possible. So we're going to shout out to our sponsors, and we're going to come right back with our first guest.
Here we are at Microsoft Build in San Francisco, and I'm coming to you from the wonderful AMD booth right here on the show floor. I'm really excited to talk to Adrian because there's so many fantastic things that are happening to really empower our entire developer community right now. Adrian, welcome.
Yeah, thank you. I'm excited to talk about it. There's so many things happening in the space. I'm sure we could talk for a long time, but let's cover a few highlights.
Let's do that. What's really important about the partnership? Why does the partnership between Microsoft and AMD matter to this community?
Well, we're going to talk a lot about the technical innovations that are happening in the space, but tools and technology isn't enough without a strong ecosystem. And that's what we're working on together with Microsoft, is building a community that's going to nurture and foster that innovation.
It seems like there's this crazy pace of change. It has completely altered the way that we think about work and work forms and these platforms as a whole. Where I know experimentation is something you're passionate about. Tell us a little bit about that and how we should be thinking about that.
I think that's the most exciting point here at this conference today, is that the rate of experimentation has really blown up. People have so many more choices, not just the technology they're choosing, but the capabilities and models and platforms, the choice of where things run, how well they run, and what runs. All of these are new experimental choices that designers have to explore with.
That's amazing. And there's a cost impact there as well, isn't there?
Well, the cost function is something that they now can control more readily. Before, they had to make hard commitments on the choices they were making. They had to plan for them. They had to commit to those decisions. Now, the cost to explore is zero, really.
That is so empowering to people. It can be a little overwhelming too, but I'm excited by the opportunity that is happening there. And I know that there's going to be more that you're going to be talking about here. There's another conversation and there's assets. So I just know you have so much to offer. Thank you for the partnership you have. This is fantastic. It's such exciting stuff. Now, if you really want to dig deep into everything that's being talked about here, you're going to want to visit AMD's sponsor page on build.microsoft.com. That's where you find all the resources, links to the sessions, and everything so that you can get busy right away. All right? Make sure you do that, and I'll see you again soon.
Hey friends, we are back. Thank you so much again to our sponsors for making this happen. This is Scott and Mark Learn To Vibe Check. Our first guest today is the wonderful Steve Sanderson. Steve Sanderson is an extremely well-known programmer. You've probably heard things like Knockout.js. He's worked on Blazor. He's done amazing things on the internet. And he has brought us something today that we have not seen. No one here has seen this before. We don't know if it's completely bespoke. We don't know if he wrote it in a caffeinated Copilot session. It could be slop. It could be vibes. It could be AI augmented software engineering. What do you have for us, sir?
All right, yes. So what I'm going to show you today could be pretty momentous. So I need to start by putting it in slightly historical context, all right? So the human journey, right? We've come a long way, stone tools, language and culture, mathematics, computing, and these things are all quite good, but I don't think we've really reached the pinnacle of what we could be as a species yet, or at least until what I'm about to show you just now, okay? So I know you're probably all thinking like, oh, he's going to reinvent the whole software industry, we're not ready for all this. I know you've all had a lot of change to deal with recently. You know, we've moved from this world where humans write code into a world where AI writes code, and I know that probably feels like quite a big deal to Mark and Scott, but for a true visionary like myself, I'm already thinking about where we're going next. And in fact, I'm already there. So I'm going to show you, and I need to introduce you to a completely new operating
system that's going to change everything about how we work. So, introducing Vibe OS, okay? It's the world's first completely hallucinated operating system. All right, and I'm going to show it to you right now. So, firstly, it is a real operating system. I can boot it. It's a VHDX file here, about 1.3 gigabytes. Could probably make it smaller. I didn't bother. I could boot it on bare metal, but I'm not going to. I'm going to boot it in Hyper-V. And so you'll see that boot up nice and fast. It's very efficient. And when that comes up, you'll see it's got a beautiful user interface that allows our user to be highly productive. Okay, so here we go. We're ready to get started with that. It's a bit hard to see there, so let's just switch to a full screen view. And we're going to start by running a few of the applications that are built in here. So we'll get some of the classics going. So we'll have Notepad, we'll have Calculator, we'll have Internet Explorer. And the thing that's unique here, the thing that you'll never have seen before, is that in these applications, there is no code at all. Everything in all these applications is being hallucinated in real time by the AI. So there's no buttons, there's no event handlers, there's no logic to say what to do, but the application works. So if I do 5 divided by 3 and then equals, if I can find that, so there this time, it's 1.6. Okay, so it works, right? But I didn't write any code, and neither did AI. There's no AI written code either. It's just producing UI exclusively with nothing behind it. We've got Internet Explorer here. Unlike the boring operating systems that you use today, this solves one of the big problems that people have, right? People are always wondering when they're on their internet, is it AI or not? But in Vibe OS, you don't have that problem. There's no question to be answered because the answer is always yes. Everything is AI. So if I want to, I can go to, I don't know, let's see if we can find whether Scott Hanselman has a Wikipedia page, shall we? So I'm going to go to google.com here, and let's do a search for Hanselman Wikipedia. And we'll do a Google search there. And I don't need to remind you this, but all of the content you're seeing is completely hallucinated, right? So it's just coming directly out of the model, and the UI is being updated in real time as we go. And here's a beautiful picture of Scott Hanselman. I'm not sure about that one. All right, but it goes further, right? We're not limited to these built-in applications. We can search for any app that we want. And everyone always does like to do app demos. So anything that I search for, I'm going to find. And it will just be created for me on the fly, all right? So let's see what else we could find in here. Let's go for one of the classics, Encarta 98. Everyone loves that one. But it's all about Mark Russinovich, all right? And so we can get a fully customized version of Encarta 98 on whatever subject we're interested in. All right, so lots of facts and figures about Mark here. Let's see. Selected facts. Russinovich has a talent for turning internals into Worklog. Great, I assume that's true. I don't know. All right, and other applications that you would want, but normally it's too difficult to make, so like Command-XE, but it's always rude to you. All right, so that's the sort of application that I think is a genius idea, but it's difficult to get someone to implement something like that. So let's see what we've got on this machine here. And obviously this is always different every time. Okay, there's something suspicious. Let's see if we can run bash in here. What's it got to say to us? Bash, you're somehow offended. Okay, fine. All right, so you get the idea, right? This is a pretty revolutionary way to do computing because we don't need to write any code for any of our applications anymore. Is there any software you would like to try out within Vibe OS? Anything you can think of? Microsoft Money 95. Money 95.
Yeah,
utilization peaked at Microsoft Money 95.
Money 95.
Oh, but Scott Hanselman has a lot of money.
Oh, but for Scott Hanselman.
Yeah, you can say Scoot as well. That's totally fine.
All right, so let's see what what Scott had in 1995. Okay, let's see.
Okay, and this is
Scott checking
what model is in the back of
dear
this?
Scott. It's been a tough month for you, I guess.
Where are the tacos?
There we
That
go.
is amazing.
All right,
Okay.
so
I want to see paint with a drawing of Scott on it.
paint with a drawing of Scott.
I'm
All right,
also.
let's do paint
For your haircut.
but with pre-installed pencil.
And you've got this is Copilot SDK that's doing this.
This
joint?
is using Copilot SDK, believe it or not, behind the scenes. I can show you a little bit about how it works if you want. So it says it's got a very normal picture of Scott Hanselman for some reason. I don't know what it means by very normal. Okay, there's a normal picture of Scott Hanselman.
That's your cage.
That's my cage. That's the cage you keep me in. Okay, this is insane. Wow. Okay. Could it? This is Vibe OS. Can it have nested OSs? How many OSs deep can we go? Can you simulate like an Altair 8080? That's like a terminal emulator. So when you terminal emulator
simulate a whole
that's going in,
different
it's like shushing into a Altair.
Totally. So we can get an iOS simulator in there. We can. What else could we have? We could have.
This may be the greatest thing I've ever seen in my life.
Me too. Well, fair enough. All right. So what have we got? Oh, it's difficult to see on this screen size, but yes, we've got a fully functional version.
Right. I love that it uses the appropriate Windows CE buttons that you are likely to see in an iPhone. Yeah, it's very legitimate. So okay. So did he write this from scratch, or did he's vibing vibes?
My mind is blown by this.
I know. I told you it'd be fun. You have questions, please. You have 3 minutes.
Define hallucination.
I'm sorry.
Define hallucination. You call this a hallucinated operating system, right? It's hallucinating everything.
Are there sound people able to make the sound come this way?
Sorry.
As well?
Could I- louder? Can you hear this?
Not really.
He says define hallucination for you.
Define hallucination. Okay. So basically, all right. Let me show you the code. Right. So behind the scenes, what we've got is inside our editor. Right, so what's happening here? I went through a few different ways to try and do this. First way I tried to do it was by just generating raw bitmap images using like Stable Diffusion, that kind of approach. And it was sort of able to produce images of the desktop operating system, but it was rubbish because it took ages. And when you click on it, all you can say is like the user has clicked at these coordinates, and it doesn't really know how to update things. So then I switched over to generating a structured representation of UI. I tried a few different versions of it. I made a custom DSL. I tried this thing called Qt, which is a native UI thing, and I could generate a DSL for that. But it didn't do a very good job. The thing that really suddenly was able to do a great job was when I switched it to just be plain HTML, because these models have seen so much HTML, they can make that up very, very easily. So what we're doing here is every one of these windows is a separate iframe, and when it pops open, each one of them creates a separate Copilot session within Copilot SDK, and it gives it instructions like this. So it's saying, you're simulating this application UI. I want you to produce some HTML that represents it, and it advises the model to put IDs inside all of the elements. And then whenever the user clicks anything, all we do is we send a message back to the AI saying, the user has clicked the element with ID R1 or whatever, now produce a diff that I can apply to the HTML. And so then the model produces the diff, we apply it, and the UI updates. And you get this kind of like fake statefulness because it's all happening within one Copilot session there. So yeah.
See, the irony here, and this is where Steve is very clever, is that he is using his AI augmented software engineering abilities and skills to create slop. And that's the genius. It's absolutely brilliant. I love it. I am
Intentional slop.
Intentional slop, but only one that an AI engineer could possibly do.
Yeah.
Do you think you could have done this?
Do I think
How
what?
long do you think this would take you to do? Yeah.
So this vibe coded thing.
Yeah.
How long would it take?
Yeah. A minute. It's a while. This is
Few
work.
hours.
Couple hours?
Yeah.
How long does this take you, sir?
I took a few evenings, so yeah,
Few evenings.
I played with a few different approaches.
Yeah. So total time you think? And you were probably multitasking while you did
Yeah,
it?
total time, maybe 5-6 hours or something like
5,
that.
6 hours. I would say this is 2 notches past vibes, heading towards AI augmented software engineering.
I agree, yeah.
All right, fantastic. We're going to give you an award. We brought you an award. I'm going to get up, and we're bringing you this award.
Thank you so much.
Congratulations. That was some amazing vibes. We're going to go to our sponsors right now, but shout out to Steve Sanderson for an amazing opener. Isn't that cool?
That was
Big hand
really
for
cool.
Steve, everybody. All right. We'll head out to our sponsors and we'll be right back. Thank you, sir.
This is awesome. Did you see the dynamic app and the content it generated via the SDK? So I'll have to take a look at the code here. Audience, like for the people who are watching it online, if you do have any queries, please put it on the chat and I will talk about it. So Steve kind of works in Microsoft on the GitHub Copilot team, and he's from UK. Based on the accent, yeah, we figured that one out. But he hasn't released the code on the socials right now. Just wanted to connect with few guys. Pramad Mishra's GDC, yeah, that was cool. Just taking too much time to load the feed here. Yeah, I was in this event. Here I am. Let's accept. Yeah, Sarkar AI. This was a great project and we awarded it the first prize. So there was a interesting story that it was a tiebreaker. And we had to kind of judge based on the impact. Yeah, this is a clip from the talk that is on YouTube.
We want to do is that we want to know how this motion happens by seeing different frames in the videos and figure out the object relationship in these videos and also the motions in these videos. So our solution is to build a fully automated data accretion pipeline that can construct such motion data. One simple idea we first try is how about just use a large language model to label those videos, and then hopefully we can get high quality motion data, because large language models are so powerful nowadays. But it's not reliable because, for example, we just try to upload a video that's showing a driving car is trying to change its lane to pass this white taxi or a white car. And we upload this to the Gemini 3 Pro. And the question is, what's happening in this video and what's the motion about this driving car? And the Gemini will just say, this vehicle appears to stay within its lane, which is just to ignore the major movement or the major scene in this video. And the Gemini will also tell some wrong thing like another vehicle, a white and a red taxi. And actually, this car is white, not red.
Yeah, you can watch the full session here. I will paste the link. Share. How do I share this? How do I share the link? Copy link to the post. Okay.
All right, we'll head out to our sponsors and we'll be right back. Thank you, sir.
Maybe he would have put his code out in GitHub or something like that. GitHub. It's all in Copilot SDK, and yeah, it's all his pushes on contributions on the Copilot SDKs. So nothing here. Am I thinking? Pages. 108 pages. 109 pages. It's I think so complete. It is trained from scratch on 8K GB 200 GPUs. And 35 billion active, 1 trillion total sparse MOE model pre-trained. Are the weights on Hugging Face or this is good. Share this to my Voxart Slack. So this is a very good research paper. I haven't seen this detailed report up until now of 1 trillion parameter paper that has spammed that have like gone through every little detail, and it performs on the level of Claude Sonnet 4.6. Hill climbing machine in RL without distillation from third-party models. And the data curated things that it has taken care of. Yeah, one of the very good models. I got to read it fully, and maybe I will talk about this in some of my talks later. Very good model. Good job. Kudos. Yeah, she's VP of Microsoft AI. Almond Tulu. Of this research. I think so. You should go through some of my emails first. LLMs, AMDs, and CPUCI. Low tokenizer. Hackathons, cash prizes. AI augmented right and out.
Welcome back to the show floor at Microsoft Build. I'm so excited to be here at the beautiful Intel booth, and I'm here to have a conversation with Brian, my friend Brian here, who is going to tell us all about what Microsoft and Intel are doing together. Brian, welcome to Microsoft Build.
Thank you very much.
I hear it's your first one.
First time.
Well, we're happy to have you here for sure. What do people need to know about the partnership that we have between our two companies?
Yeah, I mean, Intel and Microsoft have a decades-long partnership, and we've been supporting the developer community Intel has for almost 30 years now. So it's been a very long time, and we're very proud of that. And one thing that we try to do is we try to help developers to optimize their applications across the compute continuum. And what I mean by that is not every workload is optimized for a specific compute type. So there could be CPU, there could be GPU, it could be NPU. So we are helping developers to optimize their code to run best on the right infrastructure for their workload.
Oh, that's good. How do they get started with that? What do they need to know to move forward?
Yeah, so we have 100 million AI PCs, actually more than 100 million AI PCs out in the market that are made to run on or capable of running across those compute infrastructures. So we also have software toolkits to help developers to optimize their code to run best on the infrastructure that's best for that workload.
Oh, that is fantastic. Now, everyone's always really concerned about security. What about that?
Absolutely. I think security, especially in this kind of age of AI, is growing in importance. And Intel has developed a technology called TDX, which enables confidential computing in Azure. So essentially what that does is it allows developers to run sensitive data and sensitive workloads in a confidential computing environment and have the peace of mind that their data is secure.
That's fantastic. You can learn about that and more on the Partner Showcase page. Make sure to check it out.
Whether you're with us in person or watching online, sponsors elevate your experience and help accelerate your goals. Explore how Anthropic extends coding agents across your team with Cloud Code and Cowork in Microsoft Foundry. Combine powerful infrastructure, data, and applications to help your organization innovate faster with Oracle. Find out more about how our sponsors are using AI to solve the issues of today and accelerate the innovations of tomorrow. All you have to do is visit our sponsor directory for the latest advancements, inspiring customer solutions, and special product offers. Sponsors make more possible.
And we are back with Mark and Scott Learn to Vibe Check. We have just seen Steve Sanderson make a vibe-coded entire operating system in a couple of evenings with the power of AI.
Amazing. It was amazing.
You were impressed?
I was impressed.
Yeah.
When I see a project and go, I wish I'd thought of that.
I love that. Yeah, everything Steve does, I'm like, I wish I did that. But now, today, we have Cassidy Williams, who's going to share with us what she has made. We have no idea if it is AI slop, if it is vibes, or if it is AI augmented software engineering. Cassidy, what do you have for us?
Hello, everyone. I have been thinking a whole lot about databases lately. There's so many new ones coming out, so many things. And so I thought it'd be interesting to build one in the browser where it just runs in the tab. And so if you can see my screen here, this is a little query shell. And so right now it's doing select star from ideas. This is a query that you've probably seen before with just this little table here. I could change this to say, for example, select title, and then I have a ranking in here called cursedness from ideas, and then it will filter based on that. I could also add a where clause where I do where cursedness is equal to catastrophic. And then I can run that query, and it'll just work. And so I can continue adding things. I also had a query builder here, so I wouldn't have to keep typing things. So cursedness could be medium. I want to filter by certain things. I want it to descend. I want to limit things. I can do all of that, and then once I minimize this, I can run the query, and it will show. I could even add a drop table in there, and then it'll say, oh no, this is load-bearing. So this is all very fun. I'm also able to attach a sample SQLite database in here, and then if I just run the query again to select everything and not drop that table, it will load, and that's great. You've all seen this before, right? Where you can see a table, it's using WebAssembly to pull in the SQLite DB in here. But there's something that's a little bit more fun about this. There is no database, and there is no query engine. It's done with pure CSS.
Oh, no.
Exactly. Oh, no. All of the querying being done is in pure CSS, where, yes, I use JavaScript to actually load this onto the page, and it's using HTML to show the things. But all of the queries that you're seeing is done with just CSS selectors, CSS variables, if functions, all of that. Should you do this? Probably not, but I did. And that is what I did here.
Why would you do this?
I don't know. I was like, what if I built something for this show specifically where I was like, yeah, this is neat. And what if I made it terrible? And that's kind of where it came from.
That's exactly the spirit that I was looking for this session.
Good.
Do you know CSS?
Oh, I love CSS.
Oh, so
CSS is one of my favorite programming languages to use. And it is a programming language.
When you clicked attach SQLite and that dialog popped up, does that file do anything, or is it empty? Is that a real database?
This is a real data, like the thing that you're seeing on the table is real SQLite that is loaded on.
So you're literally querying.
I'm literally
you say
querying.
SQLite or SQLite?
I say SQLite. It's SQLite.
Tomato,
What's
tomato.
correct?
Okay.
Does anyone know?
SQLite.
SQLite.
Okay.
Anyway, it does that all. Again, JavaScript and WebAssembly loaded onto the page, and then CSS does everything else. All of these checkboxes are using CSS to query and filter things.
I want to see the code.
You want to see the code? I got you. Check it out.
You need to make the code a lot bigger.
I will need to make the code a lot bigger. Okay, 1 second. Let me pull this up so you can see all the
Not
things.
disrespectfully large, just like.
Okay. Cool. And I made it light mode so that way it can be seen, but I'm sorry if you're going blind. Okay, so this is truly just HTML. There's nothing here. You can see all of the CSS, or all of the JavaScript loaded it on the page, and everything else is in CSS. The Chrome CSS file is truly just for styling that HTML, so that way it's pretty. I picked a random theme in there, but everything else is done in CSS. So this table right here, let me hide the sidebar, it pulls in everything as a grid. But then it uses the CSS variable sibling index, and that is used specifically for limiting, for example. Every single query has a CSS variable in there. And let's see, I have...
And you know CSS. You're one of the people that understands it.
Oh, I know CSS.
Okay. And when you use GitHub Copilot?
Yes.
And did you use the Copilot app or do you use the CLI?
So I use the GitHub Copilot app alongside writing things in VS Code, and every single time I was like, this is gross. That's where I used some assistance.
Okay. How much writing did you do versus just yapping to the machine?
I'm sorry.
How much actual writing of the code did you do? How much is bespoke?
How much of this is bespoke? Like handwritten by me personally?
Right. Like
no
you're
AI
like, it
whatsoever.
doesn't understand CSS like Cassidy understands CSS.
I'd say like 20%.
You handwrote 20%? Why?
I like CSS. It's a nice language.
You're one of the people that likes it.
You might be the only one.
I see some people in the audience who I know like CSS. I know some faces.
Yeah.
It's a great place.
I love it. There are people literally nodding their heads
Yeah, I do
next
actually
to
see a
people
lot of
that
people
are like,
shaking
no.
their heads. Come on, it's nice.
Okay, so 20% of this you wrote yourself. Did you steer the AI or did you jump in and say, no, I'm going to do this part?
There were so many parts where I actually had to stop it, where I was just like, this button is terrible, this link should go here, some of these checkboxes aren't doing what I did. And so that's where I would say, okay, I'm going to take care of this. And then I would say, fix.
So faster for you to go in and manually fix than steer the AI.
Yeah, it was a lot of human steering, human ideation, because I don't think any AI would say you should make a
So
query engine
you were
in
watching the
CSS.
thinking trace to watch it, what it was doing? Or just were you watching the thinking trace to see what it was doing? Or did you just
Yeah.
look at it? Okay. And then you would stop it?
I like having it go side by side. So I do have the GitHub Copilot app where I would do some things, but then usually I like using the side chat so that way I can see what it's doing and have a bit more control.
Do you think that Mark and I, we know CSS, like I know that if you say, bang important, it means it's CSS, but you really mean it?
I didn't know that.
You didn't know about important? Yeah, it's one of those things you're never supposed to do in CSS, but whenever anything doesn't work, you just say, no, seriously.
What happens?
You override everything. Because CSS is supposed to cascade correctly.
Everything
but if you
matters
say, no,
in order.
I'm more important than all of you other rules, then important. Do you have any importance in here?
I'm so sorry.
Do you do any bang important? Do you break any
No.
rules? No, she's
I
just
don't
a
believe
purist.
in those.
She's a purist. Show me the part that you are the least proud of.
The part that I'm proud of? Yeah, of course.
No, the least proud of. The part that you think is cursed.
Oh, the part that I think, the whole thing is, to be clear, no one should do this.
I mean, this right here is pretty bad.
This is terrible. So this is a very like nitty gritty behind the scenes. I limited it to 12. You can't add more than 12 queries into one thing because.
Well, you could copy paste that
they're
line
columns.
63 and you could do 13.
I
That would
could.
be truly cursed
Yeah,
then.
watch. Here we go. We're going to add what UI control you're doing.
You're going to type it yourself?
I do know how to type, believe it or not. It does not want me to do that. It's starting to do display none. There we go.
Look at that.
Yeah.
We've successfully extended this application.
It does.
It's part of
Yeah.
yours
We
now.
have added a feature.
Oh, yeah. This is mostly mine now. I'm involved.
Okay, I'll add you as a contributor. I'll add a thanks in the README.
Okay, and which part are you the most proud of? Which part? Show me something you wrote yourself.
Ordering. Let me find it. So one of the things that I was ideating on a bunch was the ascending and descending. And the big fun debate, and I need to find it because I admit I did some cleaning up, was ordering things with Flexbox. Do you guys know Flexbox? I know you said you know important, but Flexbox is
I
a
know
bit
that the maximum number of nested tables you can have in Netscape 4.0 is 32.
Great.
So I do not know what Flexbox
That
is.
is different. So Flexbox allows you to rearrange things on a
Yeah,
page
yeah.
and center things, put things at the front or back or anything. For ordering by ascending and descending, which I don't know where my window just went, that's using Flexbox and just using the browser engine in there to flip the order of things.
Oh, wow. Okay.
Yeah,
so you
it's
not only
great.
used CSS, but you abused parts of HTML.
Yes, that's what I'm saying. It's really not something you should do. And that's what's great.
Did the AI push back and say, really, this is a bad idea?
No, it just said you're absolutely right. I was like, yeah.
Okay.
How long did this take you?
When did you message me? You first messaged me about this
I texted you like a week ago?
Yeah, you told me about this like week and a half ago or something. So yeah, I started work right then.
But like clock time.
Clock time. Probably like 2 hours.
That's 2 hours too long, isn't it?
Probably.
Okay, is this slop? Is this AI? The thing is with both of the folks, if we look at Steve Sanderson, you would need to be an expert to do what Steve did. You have to know and love CSS to do
Do you
what
have to know
Cassidy
CSS?
did.
Do you think you have to know CSS to create this app? You do?
I mean, you have to know enough CSS to know that you shouldn't do this. But yeah, you need to know CSS to at least if I were to not know anything, I wouldn't know how to massage it in the right ways to make certain things happen.
I think this is
It's towards the engineered side of
we're
the
getting
spectrum.
towards AI augmented
Yeah,
engineering,
yeah.
and it's like you can't just vibe this. You couldn't one-shot this. How many turns were there?
Yeah, you can say create a CSS-based database engine in the browser.
Yeah,
It just uses CSS.
it's fully like in the tab. There's no backend. It's just
but
running
you
a
can
single
prompt
HTML.
that and have it run off and come back and no.
All right,
It couldn't do
this
that.
is vibes, but it's two or three notches to the right.
Pass vibes.
Pass vibes.
Yeah, I agree.
Fantastic. Cassidy Williams, we have an award for you.
Yay!
Best vibes.
Thank you so much.
We appreciate you. Thank you so
Wow.
much. That is cursed. Don't ever show anyone that again.
It's
horrible.
open source on my GitHub.
And
You
it's
can
open
check it
source
out.
on our GitHub.
You need to add Scott as a contributor.
Yeah, because I have a commit now. All right, that's fantastic.
Right.
Thank you so much
Thank
for your
you so
hard
much
work.
for having me.
Big thanks to our sponsors. We're going to go to a quick break, and we will be right back with more cursed, wonderful things that we are going to vibe check.
Hello, Microsoft Build, and welcome. Boy, do I have a treat for you. I have Stephen with me from NVIDIA, and he's going to share some of the magic of the things that he's been building. And Stephen, welcome.
Thank you, Caruana. I appreciate it.
We're so glad you're here. Tell our audience a little bit about what you have been building. I know we've had so much fantastic information going on about our partnership together between Microsoft and NVIDIA, but you have something special.
Absolutely. So we have been building lots of things together between NVIDIA and Microsoft, but you'll see a few special things here at Build. And one thing that I have been working on in particular is an integration with hosted agents, Nemotron, and Hermes Agent. So this is going to be on display as part of a talk from Joey Conway. So I highly encourage you to check it out.
Well, that sounds fantastic. I always love to see the demos and the technology that people actually build. I think that's so important. Give us one important thing about this new implementation and why it matters.
Absolutely. Well, it solves a lot of the problems that we see customers have in their agentic deployments. Number one is the control that they have over their agentic environments. Hosted agents brings a lots of opportunity for customization, and Nemotron comes in with the high intelligence, open source, high capability model that brings that strong intelligence to the table. And then Hermes Agent wraps it all up and helps orchestrate your models in a way that brings the most value out of them. So this really is, a 1-2-3 punch with these, technologies all together. So it's a lot of exciting new things, and I'm excited to show it off.
Fantastic. Well, everybody can see it at the NVIDIA Showcase page, and they should check that out right now. Thanks for joining me, Stephen. I'll see you again very soon.
Thank you, Caruana. See you soon.
Hey, friends. We are back at Scott and Mark Learn to Vibe Check at Microsoft Build on the big stage. Right now, we have seen a Vibe-coded OS written by Steve Sanderson. We've seen a cursed CSS SQLite database written by Cassidy Williams, and now we have Swix. Sean, also known as Swix, who is very well known for his AI Engineer World's Fair, a great AI engineer. We're expecting big things from Swix here to see if he can pull ahead of Steve and Cassidy. What do you have for us, sir?
Hey, Scott. Hey, Mark. Hey, everyone. I always wanted to do one of these, hello, sharks. What if there was an app on the market? Anyway, I don't have anything as fun. I brought an app that I'm working on for work. Literally, internal app. You're seeing it for the first time. I'm a little bit scared to show my own sort of dirty laundry, but hopefully I'll clean it up. And I demoed it just now, and it kind of works.
Is this a real app?
It's a real working app for my team. We're actually using it. So I'm responsible for all the issues. That's why I have to be very careful. So what's on screen? You can see what's on screen. Yep. I run a large engineering conference in San Francisco. This is an example of last year's page with 3,000 people and tons of speakers and tons of sponsors. And I thought it might be relevant because we're at a conference, just to see, have you think about the logistics of organizing something like this. For us, we have 10 parallel tracks. And so we have all these presentations of here's where all the sort of events and the content going on that you guys might want to sign up for. But I don't really like the presentation. This is using an external vendor, and it just kind of is ugly and not customizable. For my most recent Europe conference, I actually ripped out the front end layer and started presenting the front end of this, which is much more pretty, hopefully, that you can see here. But the back end was still very much on a SaaS software that we pay for and don't really like. So for this year, we are organizing a much larger conference, 6,000 people, with a lot more speakers and sponsors and what have you. It's just doubling every single year. So I ended up making my own scheduling app, and this is the AIE bot is what we call it. So we have all these. It's basically sort of a bin packing problem where we have all these open slots. We have all these session days. This is a clean data set, so you're not seeing anything proprietary right now. And we have to slot people in days. And it's a very high precision task because basically, if we get it wrong, people are going to show up in the wrong day. People are going to be upset, sponsors and speakers and attendees. We have to sort of coordinate all of them to be exactly a fit. So one thing I really emphasized was, I'm just going to try to demo it, I guess. Let's say put Scott Hanselman into the memory track. I really like the idea of an agentic sort of content editor, like a content CMS thing. And so it's going to give minimal detail, but post and propose changes. And I really like this idea of precision that, that's exactly the track that I intended. I really like this idea of precision in agents, because agents can hallucinate, but if you have humans in the loop, I think it's really the nice mix of UX and precision. So this is something I've been working on. I'm going to put a more open-ended question. But I think AIE bot is just kind of like an agent embedded inside of a web app that you can make, and I think that's cool. But what's even cooler is if it lives within the communication platforms that I already have. So I'm going to go over here where I've hopefully cleared all my data and say AIE bot add Mark Rasinovich. I don't know how to spell your last name. I'm so sorry.
That's right.
To an appropriate track. And it's going to use LLMs, it's going to use web search, it's going to read from my existing Slack. And to me, that's how I work with my team, right? We have so much coordination flying back and forth that I really want to say, okay, the bot already looked him up. It's going to find, obviously he's a Microsoft SVP, so I'm going to put him in that track. I can approve or reject or modify it from there. And I think for me, the last thing is I really want agents in every single surface I operate, including email. So I'm going to approve this and go on over there. I'm going to put my friend Cassidy.
More speakers. We're doing it in the main application. Now you're doing it via email. It's everywhere that you want to be.
Everywhere, right? Because I want your agent should be omnipresent. You should be able. I should be able to text it. I just haven't set up the iMessage integrations. But I put Cassidy Williams. I'm going to put Cassie Do and see if they understand her
Cassie
name.
Do, of course, is her social media name.
Yeah. In I don't know. Let's call it the generative media track. And that's going to go over to here and show up. So I think a fundamental principle I really like to see is just logging and verification across apps. It's going to take a little while, but I sent that email and it's going to reply to me with a confirmation of what it thinks and what it's about to do. I can reply and confirm it here, or I can also see that email I just sent about Cassidy, and it's going to give me the option to reply once it's figured out where to put her.
One of the things I think is worth pointing out is that you're using a mini model here. You're not we don't need to use big models, frontier models for everything. You're using a mini model.
Yeah. I want it to be fast to be cheap. I can choose to upgrade the model if I want to. I just haven't done so. But yeah, I have the model selector thing.
So what's the harness or platform that you built this agent on top of?
The hosting platform, the cloud platform. This is a Cloudflare app. So I like Cloudflare, at least for this vibe coding stuff, because it can host the website, and
then you have an agentic harness. Are you using Pi or Copilot SDK? What's your loop? What's your agentic harness?
There's no harness. It's custom coded. It's a while loop for LLMs. You don't really need anything more than that.
Did you vibe code the while loop?
Did I what?
Vibe code the while loop around the LLM?
I mean, I don't think you have to. You can just do a loop, and I like to set minimal turns. I really think that full unbounded autonomy is a bad idea, and so I like to have that degree of control. So no, I don't think I would trust an LLM to vibe code the while loop.
This is a really good looking app. This is very clever. I can see your face. This is cool.
So how long? I'm guessing you spent a lot of time tweaking and tuning this thing.
Yeah, and I'm busy running running the main show while building software for the show. It took about a week and a half, I would say, just going back and forth. Really, I think what this is, it works out. So this is, you're seeing the grid view is what I call it, days and tracks and all these. I also have the flat list, which is really good for reconciling on a spreadsheet. I also have the raw data where I can sort of look into the exact tables that I have in the sort of D1 database that I have, and I have an audit log with rollback. In case I make a mistake, I can roll back what I want to do. So this is one of those things where I just need a ton of precision just in case I screw something up, because you don't want to mess up the locations and assignments of 500 people.
So it's interesting because you decided to create a custom version of a scheduler instead of moved away from the SaaS product that you were using before. How specialized is this to your needs versus something that other people would also find useful? And then what's the trade-off in cost of something that's not so bespoke versus your cost of implementing this and maintaining it?
Yeah, so there are publicly private equity owned versions of this app that cost up to $200,000 a year, and we're starting. This doesn't do all that functionality, but it does what we need, and it's very custom to us. It only knows the track days of June 29th, June 30th, July 1st, and July 2nd, because that's all I needed to do. So no, it's not meant for other people. I could generalize it, but why would I, right? That's just time spent on things that it's not a business I want to be in, but it's just a productivity thing for my team.
That's the tough thing. You make a product for yourself or your company. It is perfect for you. Is it perfect for N+1? Because I'm looking at this and I'm like, Sessionize and all these folks, they should buy this from you, but you're like, no, it's fine. It's just for me. You just made it for yourself.
Yeah, Sessionize is one of the industry standards, but they don't have a lot of the things that I would want to upgrade to, like a Cvent or an Excel for.
And I can imagine add voice to this. You can just go for a walk and talk to the agent and it makes the moves.
I happen to have an opinion that I think people adding voice into their apps are doing the locally optimal thing, but it's not globally optimal. Globally optimal is your voice should be tied to your OS, kind of, so that you have one hotkey. You don't have to learn 5 different hotkeys. Right now, if I press Command K versus Command P, I have 3 different apps all trying to be my voice layer, but that's really messy and it's not going to really have the memory of what I want to say, not learn on my patterns. So I actually have this I do like having that separation of voice versus the rest of it.
It's like you're using Windows key T.
Yeah, I use Windows H.
Or Windows key H.
Yeah, but I agree that too many people are wasting time adding voice into their agent apps. The OS should handle that. It should be available for that. Last question as we get towards the end here. Is this on GitHub and use GitHub Actions? How does it deploy? Very briefly, how do you deploy the app?
Yeah, Cloudflare has a sort of Wrangler CLI that can push everything, including migrations of a database. And it's all done in GitHub Actions, of course.
I got one more question. How much of the code did you write versus AI write?
Is this the sort of reveal moment?
Yep.
Yeah, it's entirely vibe coded.
What?
It's entirely vibe coded. I was forced to lie about the loop thing. Even that was done by Gemini.
Did you review the code at least, or did you just test it?
I just tested and give it feedback. So you can see all the feedback that I have in Cursor. I had to hide this window where this is the entire history of all the vibe coding that we've been doing.
You've never looked at the code or really worried about the code?
No, I don't know where, where it is.
It's vibes.
I would say I do care a lot about parallelism of agents. And so if you let an agent just run, it's going to do one monster file of thousands and thousands of lines. And that's where I draw the line. I have some skills where it'll keep the code maintainable, but also parallelizable. So I can have 5 different agents running on it at the same time.
Entirely vibe coded. Yeah. Absolutely fantastic.
Thank you so much.
Big applause. Best vibes. We're going to go to our sponsors. We'll be right back. We got one more.
Welcome back to the show floor at Microsoft Build in San Francisco. And I'm very excited to be here in the Fireworks AI booth. I'm here with Vivek, and we're going to tell you all about this amazing technology. Vivek, welcome.
Thanks for having me.
Absolutely. So tell us a little bit about what Fireworks AI actually is.
Yeah, so Fireworks AI is the production AI platform for open weight models. We process more than 30 trillion tokens per day. We serve more than 10,000 enterprise customers globally, including some of the biggest names such as Cursor, Versal, Uber on the platform. And these companies leverage us not just for world-class inference, but also for fine-tuning the model on the platform so that they can truly embed the data mode into the platform. Cursor's Composer 2, Composer 2.5 leverage our RL platform. And yeah, this is the thing they need to actually scale up their applications.
Oh, that is so interesting. So many new things being invented. It's a little hard to keep up, and I'm just loving so much that I'm learning here. What is important about the partnership that exists between Microsoft and Fireworks AI?
Yeah, so absolutely. So we are already providing world-class inference to customers. Now they can access it within Azure Foundry. So they have access to the Azure Foundry's governance, security, reliability, no need to worry about billing and stuff, but they can also get access to world-class inference, which we provide on the platform. And then also we are bringing much wider array of models into the platform, open weight models into the platform, and they can train a model on Fireworks and sub-inference on Azure.
All those meaningful features and simplified billing, you had me there. That's fantastic. And so I know that this is your first Microsoft Build, right?
Yes.
Are you excited to be here?
Super excited. I'm excited to meet people at the booth. I'm excited about the talk on Wednesday, which I'll be doing along with my colleagues who are giving some talks. That'll be a lot of fun.
That is great. Listen, you can find demos of Fireworks AI on their sponsor showcase page. Plus, you can find links to the sessions that are being given so everyone in the digital audience can follow along. So thanks for being with us, and we'll see you again soon. Whether you're with us in person or watching online, sponsors elevate your experience and help accelerate your goals. Build and deploy Gen AI applications with Elastic using Microsoft Foundry's catalog of LLMs, semantic kernel, and AI agents to improve search relevance. Enable scalable AI from cloud to PC and optimize agentic AI apps across Azure Cobalt and Windows on ARM. Find out more about how our sponsors are using AI to solve the issues of today and accelerate the innovation of tomorrow. All you have to do is visit our sponsor directory for the latest advancements, inspiring customer solutions, and special product offers. Sponsors make more possible.
Hey, friends, we are back with Mark and Scott Learn to Vibe Check. We have had some amazing stuff from Swix, from Steve Sanderson, from Cassidy Williams, and now to bring it all home is the legend himself, Simon Willison. You may have seen him occupying the top spots on Hacker News on any given Tuesday, pushing Mark and I to the bottom of the second page. Simon is a legend. You can check him out online. And today, what have you brought us, Simon?
So what I've got today, it's the culmination of 8 years of all of my projects finally come together. The first project, am I shown on screen somewhere?
You're seeing your screens right.
Fantastic. So I've been building this project called Dataset for like 8 years. It's a data exploration tool. Lots of interesting data exists in the world. What can we build to help us explore it? 3 years ago, I started work on LLM, which is a command line tool and Python library for talking to language models. It's got plugins for basically all of them. And I've been blogging for, it turns out, 24 years. So I've got 24 years of stuff on my blog. So obviously, the thing I've been building is an agent, because everyone's building agents. Like the hello world of programming in 2026 is to build an agent. This thing is called Dataset Agent. It's a plugin for Dataset, and it lets me ask questions about my data. So let's do count of entries and quotes and link, and I call them blog marks on my blog. So I'm kicking this off. This is using GPT 5.5 under the hood at the moment, but it'll work with any of them. It has a bit of a think. It looks at the databases and queries that are available, the databases and tables, runs a bunch of queries. It goes, ooh, some of them are draft posts. I have to think about that. There we go. It says I've got 3,000 entries, 1,000 quotes, and 8,000 blog marks. I'm going to say, do a chart. So Dataset Agent, as with everything in Dataset, is based around plugins. One of the plugins I built is called Dataset Agent Charts, and that can do little bar charts of things. I've got other plugins for running bits of Python code in a sandbox, and there are all sorts of visualizations and things that I want to add into this in the future. I will do one more demo, because I've got, that one was GPT 5.5. This one here is the same software running against Qwen 3.5 on my Mac in LM Studio. So let's see if it does the same thing. Count the entries, and let's just do count the entries and quotes. So now this is running entirely offline. This is using, oh, that was quite quick. Very nice. Yeah, it knew the tables, it did the counting. This worked. Qwen, these models that run on a laptop are very capable of writing SQL queries and doing basic tool calls these days.
Okay, and the tool itself, the tool here that we're watching running on localhost is speaking to, it has tools available to all of the things that you have on your blog, or is it, how does it know where the data came from here?
So it is running a copy of my blog's database. My blog is Postgres on Heroku. I export that into, I built another tool called DB to SQLite that exports that to SQLite. So I've got a 100 megabyte SQLite database file on my computer, which Dataset is looking at. And so all it gets is a SQLite database, and then it has to read the tables and get the database metadata and all of that kind of stuff and make that available to the agent.
So first, Simon, I'm a huge fan. I love the Pelicans on bicycle.
I've got a demo about that.
Okay, but I got a question about this. When you say plugins, what is a plugin?
So this is, I built everything in Python. Python is a very good language for plugins because it's all dynamic. You can install extra packages that become visible to each other. So a plugin is, actually, let's pull one up. I'll tell you what, I'll pull one up that I wrote an hour and a half ago. This is a Dataset Agent MicroPython. It is live on the Python package index as of 2 hours ago. And this is a plugin for Dataset Agent that adds the ability for it to run Python code in a WebAssembly sandbox. Because I want agents to write Python code. I don't want to delete everything on my computer. You need some kind of safe way of doing that. And if you look in the code, it is...
And this is what you were working on when I saw you in the hallway.
Exactly,
You said,
yeah.
I can't talk to you. I'm publishing this thing now to Python.
This is exactly what's going on here.
Okay.
And
Go ahead and
there
make
is...
the fonts a little bit bigger there for us, brother.
Here we go. So a plugin just has a decorator called hook impler because it implements hook, register agent tools, and it returns a list of agent tools. In this case, it's called execute MicroPython. It's got a function. It's got a description. And all of Dataset itself has well over 200 plugins now. LLM's got about 40. My little agent thing has got, I think, 5 in the wild already. Plugins are such a great way of building software in this age of AI because honestly, Claude Code and Copilot and things, they can one-shot a plugin for some quite sophisticated behavior if you give them the right kind of information to start.
So plugin instead of a tool.
Well, the plugin is a bundle of tools. Like in this case, I've got one tool that's embedded in a plugin.
But I mean, tool is an MCP tool.
Not MCP, but the same idea. MCP is just a fancy wrapper around the underlying concept.
But you think this model works better? I mean, it's because you're working entirely in Python, right?
Exactly. Like MCP is just tools with extra steps.
Okay.
Now, when you do this kind of work, if you recall, folks need to remember that he's had a blog since 2002. Like we were sending back trackbacks and pingbacks on blogs 20 plus years ago, Simon and I. That wasn't always vibes. When did you start vibe coding? Because you put so much out that is bespoke code. How are you incorporating the vibe coding and then the AI augmented software engineering practices into the work that you're doing?
So about 2.5 years ago, Claude Artifacts came out and got really good at building little HTML JavaScript tools. And so I started vibe coding before anyone was calling it vibe coding, where I just do little self-contained HTML apps. And I put those on tools.simonwilson.net. This is a collection of 215 of these things that I've been building up over the past couple of years. And this is great because it's so safe. Like, you can't shoot yourself in the foot with a static HTML and JavaScript thing on a separate domain. So there's sort of no risk in these being mistakes. And I'm still doing this today. Like, I built this one yesterday. This is just a prototype of what it would look like to build an interface where you can attach files to a text area and like preview them inline like this and copy and paste things in, and all that sort of stuff. I want to build this as a feature in my agent, but first I built the UI prototype. And I built this with, this one was Claude Codex. It was Codex Desktop. Often I use Claude Code on the web on my phone. So I can fire up my phone and say, hey, build me a prototype that does X. Click a button on my phone to push it to GitHub. It gets deployed by GitHub Pages. It's live. So I've been building little throwaway things the past couple of years. Since January, most of the code that I write has been written by an agent for me, because that was the point when the coding agents got good enough that you can pretty much tell them the style that you like, how you like your unit tests to look, all of that kind of stuff, and they do the sort of scut work of actually typing it into a computer for you.
So when you're vibe coding, do you watch the thinking trace to see if it's off the rails, or?
It depends on the stakes. So low stakes things, like a little UI prototype, I don't care. The code doesn't matter. I just want to prove that the thing is possible. Some, like this thing right here is a sandboxing system that runs untrusted code in a sandbox within my system. That's really important. Like, the stakes could not be higher. This one, I watched it like a hawk. I was paying very close attention to the code that it was writing. I then ran all sorts of tricks to try and like stress test it. And I actually had GPT 5.5 try and break out of the sandbox, which was quite entertaining to watch. Found a couple of edge cases that I needed to clean up. But yeah, that's the sort of other end of the scale from just hands off, letting it do whatever it wants to.
So one of the techniques that Scott really likes is adversarial vibe coding, where you have one model propose something or write something, and then have another model go critique it and then have them argue.
I've been doing that a bit. GPT 5.5 is my security blanket. I really like it for security reviews. So until recently, I was doing most of my work in Opus 4.6, and then I'd have GPT 5.5 do a quick scan at the end to see if it missed anything. And it would often find things. To be honest, though, if I'd asked Opus to scan its own work, maybe it would have found them too. It's just, you sort of habitually feel like, you get the sort of vibes of which models have certain strengths.
Yeah, I like to have 2 or even 3, and I make a high, medium, and low. And if all 3 models agree that something's a problem, then that's a high, 2 it's a medium, and 1 it's a low. So being able to use something like GitHub Copilot in the CLI of the app, you can pick 2 or 3 models and have them all fight, and it works great. Yeah. So are you no longer typing code? Are you a typer of prose? Do you type your prompts, or are you a yapper?
I'm still mostly typing prompts. If I'm walking the dog, I might dictate prompts into my phone. But even then, the prompts can be quite short. Like, something I found really interesting is, it used to be the harder the task, the harder you had to concentrate. The opposite is now true, because the task is really hard. GPT 5.5 will churn away for 10 minutes, and during those 10 minutes, you can go and read Hack and News, and you can get distracted and work on other things. There's this weird thing where the more difficult tasks are now cheaper to be distracted from than the easy ones are.
So this is the thing that Mark and I are struggling with, and I think what we'll talk about in our close is this idea that you have to know what you're doing to be successful at vibe coding. You don't vibe into production. There's AI augmented software engineering baked into your process by virtue of how your brain works, because you've been doing this for 20 plus years. Would you agree?
I think AI has made being a professional software developer harder, because it's raised expectations for what we can do, and you can now take on so much more ambitious projects. It used to be we had to stay on our lane. Like, I was a back-end Python programmer with a little bit of HTML and JavaScript because I could only skill up to professional levels on one of those technologies at a time. Now, I'm writing, okay, here's a fun thing. Here's a little app I wrote in Swift UI that helps me see what bandwidth my computer is using, and this is another one that shows me what's using my memory and what's using my GPU. I don't know Swift UI. I have no idea what I'm doing. I didn't even have to open Xcode for this thing. Claude Code is like, hey, no Xcode needed. I'll just build this up and stick it in the menu bar for them. I would not recommend other people use or trust this piece of software because I don't know what I'm doing. But it's also, I've been using this software for like 4 months now. I kind of trust it now. Like, I've realized that the thing I care most about isn't that an expert wrote the code. I care that a real human being has actually been using it for longer than like 2 hours, and it's sort of built up that, like, over time, that trust in the software gets built up.
Fantastic. Well, this one feels like AI augmented software engineering. I agree.
I've got one closing demo. Just
very
quickly,
briefly, we have 30 seconds before I'm going to kick you off the stage.
When did Simon last see a pelican? Because it's got all of my wildlife sightings.
I think it was last week.
Now.
You saw a pelican last week.
And it says I saw a pelican on June the 2nd. That's today. And it's right, because if you refresh my blog, there's a pelican. They're right outside diving into the water. It's super cool.
Very, very cool stuff. Big congratulations to you, sir.
Thank you very much.
Thank you. Thank you very much. We appreciate you. All right. We're going to say a quick thank you to our sponsors, and we thank you all for hanging out, and then there'll be a brief ending here on Scott and Mark Learn to Vibe Check.
Welcome back to the floor at Microsoft Build in San Francisco. I could not be more excited to be at the Qualcomm space. I'm happy to be with you because we've had so much that has happened in the keynote together, and you're going to tell us more about that, aren't you? But first, tell everyone who you are.
Hi, I'm Anna Schaefer. I'm responsible for Qualcomm's developer and partner program, and talk about partnership, amazing partnership that our two companies have had throughout the year. Exciting things that we talked about in the keynote together.
It is really fantastic. Now, what does this community need to understand about the types of innovations that you're really delivering and how we're doing it together?
So this is the age of AI agents, and think of these agents that are context aware, that are taking data from across different devices, from a ring to a pendant all the way up to the data center. This means very new ways that developers can deliver experiences for their customers, as well as different ways that they need to work.
It sounds like that's a lot of new workflows and form factors to understand. How are people going to actually dig in with this and learn?
Yeah, well, thankfully, that partnership with Microsoft includes very tight integration with things like Founders Factory, Windows ML. We, in our sessions and our demos in the booth, we're going to be talking about AI agents that help you port your apps native. We're going to be talking about automation in your workflows for inference, so you save on those tokens. And think of that orchestration that is needed as you make those workloads go across these different form factors.
That is fantastic. Well, I know we're really excited about this, and you know how you can be even more excited. Go check out the sponsor showcase page. Demos, links to their website, all of the new information that's available. That's how you can stay up to date on everything that's happening between Microsoft and Qualcomm. Thank you so much, and we'll see all of you again soon.
And we are back, closing up Mark and Scott Learn to Vibe Check. We have seen an amazing lineup of
So
folks. Were you
fun.
blown away?
Yeah, so
You
fun.
didn't know this was going to happen?
No, I didn't. And those were, each one was amazing and unique in its own way of how kind of it showed what you could do with vibes / monitoring and kind of more on the engineering side of things.
Right. We started the show saying that we were going to see SLOP, we were going to see Vibes, we were going to see AI, augmented software engineering. I did not know, you did not know, none of us saw any of these projects before, to be clear.
I think there was one SLOP.
Which one is that?
The CSS.
I don't know, man.
CSS.
I thought that was genius. I got to shout out to Cassidy for that. But I thought that the Vibe OS was amazing. All of these folks, though,
it was just so pointless and wrong, though.
Yeah. But I think the thing that we can both agree on is that you have to know what you're doing, and that you will always be more successful if you try to apply good software engineering practices
Exactly.
when making your apps.
To have those ideas, like Cassidy saying that she couldn't have done it without knowing CSS.
I don't know CSS. I don't think I could have talked my way into that. Yeah, that was amazing. I want to say shout out to everybody who made this possible. Shout out to our sponsors. Big thanks to Steve Sanderson, Cassidy Williams, to Swix, and to Simon Willison. This has been Mark and Scott Learn to Vibe Check. I want to encourage you to check out our podcast. We do it every week, Mark and Scott Learn To, where we learn a new thing every week. I hope you have a lot of fun at Build, and thank you for spending time with us. We'll see you soon.
Welcome back to the broadcast stage here at Microsoft Build. We're in the beautiful city of San Francisco, and boy, are we talking about innovation at scale and speed. And no one is better at talking about that than my friend Adrian. We're going to have a great conversation. Adrian, welcome back.
Thank you. We sure are. I'm excited to talk about the developer experience with you.
Absolutely. It's really important that we're able to help developers understand what's different for them and make sure to give them real actionable items and help take them deep. Talk to me about something that you're really excited about that we've been talking about here at Microsoft Build.
Well, absolutely. I think one of the most exciting things is the developer experience itself and how that is radically changing. Just in the last 6 months, developers are exploring spaces and trying new things that they practically couldn't do before. And I think it's the confluence of a number of different things. There's technology, there's software, there's agentic AI, there's hardware platforms. I'm really excited to dig into all of that with you today.
I know that you have a passion for the developer community. Do you ever find all of this overwhelming? I mean, sometimes to me, I'm more of a builder than a pro dev, but nonetheless, sometimes I find all the change a bit overwhelming to keep up with and understand. How do you do it?
It's difficult. Certainly, I think the idea was trying to become an expert at things is historically how we've worked. And now it's really just about becoming an experimenter, right? Trying things, not being afraid to take risk and try new approaches to solving problems. That's the time we're in right now. I think that's what's at bear for developers.
One of the things that I find sometimes a little bit overwhelming is all of the changes that are happening so quickly. I mean, I'm more of a builder than a pro developer, but nonetheless, how do you figure out how to keep track of everything that's happening?
Well, I think the key to developers today is that approach to solving problems is fundamentally changing. Whereas in the past, we had to commit to a plan, the cost to commit to that plan and the investments it would make with resources and times was really critical. Now, the cost to explore is zero. And so it really frees you to try different things.
Yeah, and that ability to experiment almost at scale with all the new things. Do you think that's fun? Do you enjoy that?
Well, it's fun. I'm more excited about what comes out of it. And I think that's what engineers and developers want, right? They want the end product. What am I creating? And what's happening right now is the machine has fundamentally changed. So what's coming out of the machine is also fundamentally different. And that is exciting.
Explain that. The machine has changed. What do you mean by that?
So if you look at what's happening with AI coding or agentic AI, it's changing our process on how we approach problems. It's changing the flow that we use, the decisions we make, the choices that we even have at our disposal, which means I can take more risk, I can try new ideas, I can try new tools, and if it sticks, it's great. And if something doesn't work quite right, it's okay to just put that code aside and try a completely different approach. And so that really fosters an era of innovation. And that iteration lets you end up at places you might not have with a traditional design approach.
Yeah, it's almost like surprise and delighted scale into developer.
There is. There's, in music or art, we talk about happy accidents. I think engineers are starting to enjoy this design space as well.
So how does that play out between AMD and Microsoft, and ArtStat specifically?
Yeah, that's really key, because tools and technology are only part of the problem, but you have to foster that community. You have to foster that innovation. And that means having an open ecosystem with open software, open platforms, and really investing in that community of developers so that they can create that innovation that we're all depending on.
How do you do that at AMD?
Well, open source software is really a key pillar to what we're doing. Putting software out in the open source community, exciting the developer community with events like this so that they're coming to the table and bringing their ideas. We have a number of different ecosystems that we participate in where we have more developers coming in and contributing their ideas than AMD may even have developers contributing to that code base. So it's really just how do we create that energy and excitement around the industry.
I think developers also, historically, but now more than ever, they want to get their hands dirty. They want to actually do the things that matter. If there are a few things that you would have developers physically doing, what would that look like?
I think the key is to explore a couple of key modalities in the choice space. So if you think about one of the new dimensions to explore, it's where things are run. Right? So in the past, I might be doing my development simply on the cloud, exclusively on the cloud. Now I have the opportunity to explore something like an AI PC and do significant AI development there. I can also decide where my workload is going to run, but perhaps even a hybrid solution between a cloud and a client device. So that's the idea of locality. The other new innovation that's happening is modality. We now have new AI technologies that can listen to us speak, that can watch our face and detect our emotions, that we can text with them and chat with them, but we can also generate images and rich media content. So the modality that we have choices over is significantly more significant than it was just 6 months ago. And thirdly, we also have new devices that we can explore. So we have CPUs, there are GPUs, there's also neural processing units that are in a lot of these AI PCs. And that gives us a new type of capability that we can explore to trade off cost or power or performance in ways that we didn't have before. So my advice is get out there and explore these different design choices. We have a developer showcase where you can attend and listen to a lot of the sessions and demos, presentations that are here this week to learn more about those.
And what I love about that is you don't have to be right here in San Francisco to do it. Of course, there's a large digital audience for this particular show, and all of these sessions are available online. People can participate in them, and it's really democratizing access to this learning and intelligence, and it's free. Right? I think that changes the way the developer ecosystem can evolve. And what do you see happening in the next 3 to 6 months in that developer ecosystem based on some of these announcements, new modalities that you're talking about, new form factors and compute?
Well, it's interesting. One of the challenges we have with choice is that we are not inside the box, right? Humans are not in there. Our brains are not programmed into the box yet to make some of those choices for us. But we have the emergence of agentic AI, and this is a solution to this existential problem of so many choices. How do we create options? How do we control the technology that we've created? So agentic AI is a new microservice that's evolving on top of our traditional software solutions, hardware platforms, and so this is going to be an interesting space to see change over the next 6 months. I think we're going to see more applications developed in a dynamic fashion rather than static features or static capabilities. We're going to see solutions and software emerge that adapts to the user and the user needs as they're interacting with the software. So.
And I also think about, to me it seems as if developers now have to think also about orchestration, about the multi-agent ecosystem that may exist. Their particular solution may not exist all by itself. It may be interacting with other components that it doesn't even know yet, or maybe haven't even been invented yet. How do you think about that part?
Yeah, similar to what we were just describing, is there's a need to have a dynamic intelligence in the systems that we're building, the software that we're shipping, because there are so many choices and options. We need to refine those choices around, what problem are we trying to solve? Is cost important? Are we resource constrained? The cost of memory these days is a key design choice. So looking at those different cost parameters and making intelligent decisions about the choices that we make. I may choose to run something local simply because tokens are so expensive right now, or I may choose to push something into the cloud because I really want the quality of that result. And that's the opportunity that agentic AI is presenting to us.
When I think about that, I also, of course, think about security. And how are you thinking about, how do you want our developer community to think about security as they experiment, as they think about this explosion of agentic experiences, and as they choose the locations where they're having things run? How do you think about that?
Yeah, there are many layers to that conversation. I'm excited about the work that Microsoft is doing in this space. Security is fundamentally a platform solution. So we need to think about it from the user level, the user's data, all the way down to platform access, networking, file access, and different types of security firewalls that may go onto the platform itself. What I'm excited about are some of the emergent capabilities in routing on the platform. So for instance, if I'm running a workload here on my local AI PC, but I'm also connected to the cloud, I want to make sure my personal information is secure. So we now have technology that has the intelligence to listen to the things I'm asking and route my personal information to remain local on the platform, and still leveraging the power of the cloud and foundation AI when I need it.
What I love about all of this is it feels like our creativity as builders and developers is really being unleashed with all of these new capabilities. How do you think about that? I feel like if I was a new developer, or if I had been in the ecosystem a long time, all of a sudden, basically the sky's the limit. There are limitations, the technology is still evolving, but how do you think creativity plays a part in all the change that we're dealing with right now?
I fundamentally believe in this saying that says the speed of innovation is proportional to the speed of iteration. And I think the faster we move, the more creative we get. And so this is a technology that's making us all more creative just by virtue of moving faster, trying things over and over again, and seeing what comes out of that in a beautiful experiment.
Some of us call that building the plane while flying it, but I love your interpretation of that. I think that is fantastic because I think that
And so this is a technology that's making us all more creative just by virtue of moving faster, trying things over and over again, and seeing what comes out of that in that beautiful experiment.
Some of us call that building the plane while flying it, but I love your interpretation of that. I think that is fantastic because I think that willingness to experiment at speed and scale, there's a certain courage to that, right? That I find in the developer community as a whole, willingness to tinker, willingness to experiment. Tell us about some of the other things that we announced here at Build between Microsoft and AMD and why they matter to the developer community.
Well, one of the more exciting projects that my team is working on is the WinML SDK, and the importance of that is democratizing the platform for developers, right? So there are many different hardware technologies, many different software technologies. The speed of iteration means there's quite a bit of fragmentation in the ecosystem, and so sometimes it's difficult for developers to choose which direction they need to go or where they're going to get the best performance or solution. So the work we're doing together with Microsoft is creating a platform that's scalable, but it's also lowering the friction for developers. So they're not having to make very low level investments in a specific technology. They're able to leverage a rich, robust ecosystem around this SDK and begin their development at a much higher level of abstraction.
Anything that accelerates the work of developers, I feel like is a good thing, because it gets them that much closer to that output that you were talking about. Do you have any advice for how people really understand the quality of their output in these new solutions?
The idea of quality is fundamentally changing as we add layers to the stack. So we used to think about quality in AI as like the simple accuracy of a model. Like, is this a cat or is this a dog? And you could quantify your quality that way. And as we introduced LLMs, the idea of quality changed. Well, is it quality around summarizing my document, or is it quality around answering questions or 8th grade math? And so how we evaluate AI is becoming equally more sophisticated. Now with the emergence of agentic AI, we're having to invent whole new concepts around quality. How do I know if the agent is making good choices? If it's routing my data to the best solution? There's really no
Sorry for the earlier mix-up. I went to the washroom and turned on the music, and here it was paused. Getting it back.
Deterministic way of categorizing that. So we're inventing the idea of quality and how we measure quality as well.
I love that. I find that freeing because I think it was due for that change. So I want to thank you for your time. I love having a conversation with somebody who's clearly passionate about the technology, but also the people who are in the community. That is wonderful. So thank you so much.
Thank you for the opportunity.
You can always go deeper on AMD's showcase page. We want you to go find it at build.microsoft.com. There's articles, there's information, there's demonstrations, so many great things about it. Make sure you go and check it out. And thanks for joining us. We'll see you again soon.
Did anyone in the 90s expect Win32 to be a first-class back in Windows 95 days? I think that one of the reasons it's got the staying power is it's just a fundamental layer inside of Windows that so many apps have built on and so much kind of technologies and ecosystems have been built on top of that it's kind of bedrock. Now, I think that there's been various times in Microsoft's history where we thought we'd reboot the Windows API surface like WinRT that actually didn't play out the way that a lot of people expected it to, given still the separation between the client and Win32 and the browser, which is HTML and JavaScript. But and I'll tell you from first-class kind of related perspective, SysInternal tools, which were founded in 1996, the first tool I wrote, I had no expectation, would never have imagined, would have bet you $1 million that the tools still wouldn't be relevant in the year 2026, and they're actually more relevant than ever. In fact, one of the tools is actually going into Windows, Sysmon, and one of the earliest tools that was developed in the early 2000s, Zoomit, is actually part of PowerToys, and a very popular tool still today.
Hello, everyone. Hope you're having a great time at Microsoft Build.
So these are the sessions that of Microsoft Build that have come online in the past 6 hours. Let me see if there is a playlist for them yet. No, not yet, because it is still uploading right now. Okay, so what we will do is after completing this, I need to be in a meeting right now, so work on one of the EAFC things.
Hello, everyone. Good to see you.
Hey folks, we'll stop the streaming now. We'll get back to you